dense atmosphere back to our eye, but due to light attenuation, angular size of the inverse square law of light, etc., you can't see it.
What about constellations being different at different points of the Earth?
Okay, would that work for a flat Earth or no? And
It
you
would.
can
It
see
should
with the
work
light.
for flat Earth.
I
If
mean,
the Earth was
right?
flat, I should be able to see the same constellations, like in the same order. But I don't. We don't because the Earth is not flat.
Well, the constellations, like are the stars in the sky. The stars in the sky are at different GP locations. That means that, like their zenith, their vertical is at a location, longitude, latitude, over the distance. We wouldn't, we, that distance, as we look over the distance, converges due to perspective, as well as other factors such as, again, angular, Rayleigh criteria, light scattering, and so on and so forth. So you shouldn't be able to see them all at the same time. Uh, doesn't make much sense there. It would be like saying you should be able to see all the clouds at the same time or something. I don't know why you think that would be the case.
No,
But
but
yeah, as
like
you
you can see at different points of the Earth, you can see the constellations, but at different points they're rotated, right? They're they're rotated and they are the same constellation, but they're just rotated. Can you explain that? And we're on a flat Earth, right? I mean, we shouldn't be able. It shouldn't be happening like that.
no, that would be our orientation in regards to like a center point. So it's like I don't know if you drew a circle in your backyard and you put little I don't know cones or whatever in that circle, and then you went to a different GP, right, a different location in that circle. You say, well, now those cones are oriented to my right, but now if I go over here, they're
No,
oriented.
if the
Orient,
Earth was flat, it would all like the North Star would be pointing north, right? But like then all of a sudden you go to some other part of the Earth, it's pointing a different way, right?
no, you're changing your orientation in relation to a point.
No, the constellations rotate based on what part of the planet you're on.
Yeah, that's no problem, right? So on a like so the location, depending on what part of the planet you're on, that is just the GP of the star. That's the location of the star and your ground position in relation to the star. That's the definition of it. So to say something like, well, how come if the Earth is flat, then my location changes when I change locations? That's not really like
No,
that's not
I'm
really.
saying is that do you understand? Like, the Earth is flat, right? The Earth is completely flat. Everything in the sky should be pointing the same direction everywhere on the planet, right? Because it's flat.
I don't know what that means
Well, it doesn't
exactly.
though.
I don't know exactly.
It's
It is
flat. What do
pointing.
you mean? It's flat. All the constellations should be the same directions, the same time, because the Earth is flat. But that's
You,
not the case.
I don't know what that means exactly. The sky spins around
What do you
Polaris,
mean?
or I don't know what that means exactly.
It's got this. The curvature of the Earth, the tilt of the planet. If you go to the north hemisphere, right, you see a constellation, right, and then you go to the southern hemisphere, that same constellation is rotating
Yeah, no problem. What's the problem?
because the tilt of the Earth, the curvature, the tilt of the Earth.
All right, so like, all right, so lay it out for me,
We're
like,
on a globe, dude.
I hear you, but like, lay
We're
it
on a
out for me. Like,
globe.
all right, we're in a big like coliseum or warehouse or whatever, and there's a bunch of constellations on the ceiling, and the ceiling's flat and the floor is flat. What should I see differently?
Right. Right. It's okay. So
Why
you
would
go to the
they would all
north
be in the
side.
same room?
You go to the north side of the warehouse. You look at the ceiling. You see that one constellation. It looks a certain way, right? Then you go to the south side of the warehouse and you look at the same constellation. It's pointed a different way, right?
Well, in this thing, if I had to put this North Star in the center and the constellations around it, so the North Star would be in the center of the warehouse, and that would be north, right? And everything else away from that point would be south, and then east and west would be circles around it, I guess. So can you do it again and tell me about the direction?
It would be the same.
Same as
It would be the same.
All right. So now if I'm standing away from the North Star, which is in the center of the warehouse, right, and then I walk, if I'm standing away from, and I walk towards the North Star, am I going north?
Yeah.
Okay. Now that's in a flat warehouse with a flat ceiling and a flat floor. Okay. How does that differ from what you're talking about with the North Star Polaris in reality?
The rotations I'm talking about are like not as simple as that, like just they flip around, at certain degrees because of the certain curvature and tilt of the planet. It's not just opposite.
It'd be north and south. So north would be towards it, and opposite of that would be south. You just turn around
It
and go
depends
south.
what we're talking about.
Direction. That's why I didn't understand what you meant by when you said everything should be the same direction. Yeah, so like if that was the case, if north was like a center point star, just away from that would be, directly in a straight line. However, we could somehow establish that would be south. And the way we would establish that would be in relation to like the other stars around, the constellations. Say, okay, well, I want to stay between these two constellations. As long as I'm between these two constellations, I'll be somewhere in this longitude line, and I'll be generally straight, and I'll go south between those two constellations. That's how you would navigate. But that's exactly what they do, is they navigate celestial navigation uses the stars and their parent GPs. Yeah, if like it's like the consequence of using a point as a starting point. So if everything is in relation to a point, you're gonna go and you want to stay equal distance from a point. That's just going to be a circle. You can't make a square doing that. You can't make a triangle. It's going to be a circle. Yeah. So I mean, it seems perfectly reasonable. The
What about
the trick the
what about the people that crossed the Atlantic, like Christopher Columbus, Magellan? They took the same routes to go back. Is that possible on a flat Earth?
I would say yes, and I'd also say Magellan didn't make it back. The story of Magellan, who proved the globe, is
Yeah.
that Magellan, he like went on an adventure, right? And then he got his head cut off, and barbarians ate his arms, and he didn't make it back.
Yeah, but the ship made it back though.
Right, like two guys, scragglers. But yeah, I mean, anyway. But yeah, I mean, I mean, like, he didn't make it back, unfortunately. And then Columbus, he didn't exactly make it back either. But so what do you think that that's impossible if the Earth is flat?
I don't think so. No.
I don't think it would be to go. So like if the Earth was flat, how could I go somewhere and then come back? That doesn't seem like a proof of anything.
How does the sun set on a flat Earth?
I would just say convergence instead of parent optical place called the horizon.
But then it reappears on the other side of the Earth.
Yeah, yeah. Like for like that's just like the definition of like like for everybody's sunset. Like for you, while the sun is setting, you're standing at one place. Another person is watching the sun rise, right? So it's like and then another person 10 steps
Right.
backward
How's
from
that?
them as well.
How's that
You know.
possible on a flat Earth?
Well, like
Is
I
there
could I could
another side?
yeah. I mean, it would just side would be in like relation to just location. It'd be like, well, you're on the left side, I'm on the right side. Right side of what? Right? It'd be like right side of the
Makes no
prime meridian.
sense.
You know.
That makes no sense. That makes no sense at all.
What do you mean?
So is there like a border for the sun like we're not seeing? If the Earth is flat and like we're all on the same flat piece of a flat planet, right? Shouldn't we have the sun at the same time or close to the same times? Like
No, I mean,
how would that work? That makes no sense.
well,
It's
they give you
called
the two.
perspective.
Yeah,
Perspective.
there's two options. Like you're mixing up two things. No big deal. You're touching on two things. One thing is that the sun, right? We have the idea that the sun is so big, so massive that the sunlight comes in parallel, straight lines, and the thing that's curving, right, is the Earth, right? So that's one option, right? But directly opposite of that would be that the sunlight is coming in curved and the Earth is flat. Because it's the same. You get the same observation. You have these like you have these longitude lines that are like the sun is kind of curved. You see it traces out a curved path, and you have the same observation. And one person says, well, the light's coming in straight and the Earth is curved, and the other side says, well, the sun is coming in curved and the Earth is straight. So I mean, it's not you're not able to distinguish from those two. Um, that was the one thing I was talking about.
Why does the sun stay the same size in the sky?
It may not. I mean, there's people who have measured it to not do that, right? And then there's others, even on the globe side, they say,
No,
well,
it
the
does
proof.
stay the same size.
Well, I mean, the proof that they say, the proof that the sun is further away in the summertime in the northern hemisphere, what they call the northern hemisphere. The proof that it's further away is the sun changes size. It gets smaller in the summer.
No, it doesn't. It's the tilt.
That's their proof. It's called the what's it called? The perihelion or aphelion? Yeah. So yeah, the in the summer, I mean, everybody lives in America here, most people. Yeah, the sun will appear smallest in like July, around July. Ironically, right? They say that there's this like, and it's not, there's this I don't know, this thing that people like to put out, right? There's like this special day on Earth that occurs like around every July 8th, where they say that half of the world is lit up by, or half of the like inhabited world is lit up by the sunlight. So is that a coincidence? I don't know. I think they say about 80 or is it like 70% of the population, right, which is the inhabited area,
And
is in
you're
sunlight.
confusing a couple of things. In the globe model, the claim is that half of the globe is always illuminated, not on a special day, but on every day. The thing you're
Yeah, and there's a
confusing this
special.
with is that one day when it so happens that 90% of the population live in the part that happens to be illuminated, which is not that
Yeah, and is that?
outrageous given that the distribution of the population on Earth is not uniform. So I'm sure you know 90% of all humans live north of the equator, right?
Oh, 99 to 90% of the population is in daylight. Okay, yeah. So
I
I
know,
wasn't really
but a
confused.
separate statistic for you to process, since you have a problem, I think,
No, I don't
because
have any kind of
you
problem,
can
right? And
think
then
and talk at the same time.
no, I have no, yeah, no kind of
The
problem.
other factoid you may find useful is that
Trying to
90% of
put
all
it up on the
humans
screen.
live north of the equator.
I appreciate, I do
You
troll.
understand that?
I appreciate it. Well,
Okay.
appreciate it. All right.
Resume your
So
stream of consciousness.
yeah, no problem. Yeah. So yeah, there wasn't much confusion. Didn't have the right numbers, but yeah, ironically, on that date, around July 8th, recorded every year, is when they say the sun is measurably smaller, and they say that's their proof that the sun is farther away. So yeah, there's a measurable, according even to the mainstream, a measurable change in the size of the sun. I don't know if like Peter could process all that. I don't know if he was like, keeping up with the conversation, where it was leading, the purpose of it, or whatnot. But he did
The
find this
purpose
basic
of it
goal.
eludes me, but what you just said,
Yeah. So there's a measurable change in the
yeah,
size of the sun. Do
yeah,
you deny this?
yeah. And the globe claim, the heliocentric claim is that's because at that time the Earth is the farthest away from the sun. I think
Oh, good. I'm glad I
its
could teach you
orbit, right?
something. Glad I could teach you. Thank you for repeating me.
Always, always. I'm here to learn.
Got it. Good boy. Yeah, I mean that makes perfect sense. All these things only make, I mean, really make greater sense on in one version. You agree, isn't that correct, Peter? That there's only one
Obviously.
version. Any other questions there, Eric?
Where do you get your information? Like, is there a cult or something? This is a cult.
Mm. No, like some of these things are just like, uh, synthetic truths are a lot more difficult to come by. These are just like coherent within the system that they give you. And you could either take those things and say, I'm going to go test them and see if they hold true in reality, Or you could believe them and say, well, at some point I'm going to stop believing because in my local reality, I know that when it gets hot, the sun, lights get closer to me and it gets hotter. And if they're claiming that lights get further is when it gets hotter, I'm going to stop believing them, or you can keep believing them. Like that stuff's up to you. Those aren't synthetic. That's just within the coherency of the model. But there are some things you can go out and prove for yourself. Yeah, it's
How
like you can
far do you
prove
think
that.
the moon? How far away do you think the moon is?
I don't. I have no. I don't really have much of an idea on that. Nobody really measured the distance to the moon initially. What they did measure was like parallax, like angles and of other lights in the sky, other lights. But they had to assume a couple of things first. So like it's a like don't get me wrong, it's a well thought out, well like established theory, right? With geometry and math and decades, centuries of people working on it. It's going to be difficult for you to say I can defeat this whole model, right? In its entirety, it's going to be difficult. But at some point, you either say I'm going to with that model, you're going to have to at some point say I just believe it or I don't believe it. Like when would be enough? Like when is enough enough? You know. Like is it the sun obviously moves, and then they tell me don't trust your senses. Your senses are not reliable. That you can reason to the correct conclusion, but you're only reasoning through your senses. But your senses are fallible and false, right? Because obviously the sun appears to be moving in the sky, but that can't be true. Maybe we are the thing that's moving. The sun is stationary, right? At what point do you say I just don't believe you?
The sun is not stationary. It's dragging the whole solar system with it and the galaxy.
Yeah. At what point do you say? I mean, how many more stars could I throw in there until you say, you know what? I just don't believe it. Like I'm going to throw in another
I'm
galaxy.
never gonna believe the Earth is flat.
What's that?
I'm never gonna believe the Earth is flat.
Well, we still don't. We still
It's a
didn't even get
ridiculous
that was.
idea.
We never even got a definition of that. So of what that belief is.
Yeah, what is it?
What is flat?
Is it
Like
a
flat would
disc?
just
Is
be.
it an oval?
Oh, all right. Well, then we can define Earth, right? I guess we could. What's your definition of Earth?
A globe?
Okay. Well, where? All right. So where does my definition of Earth is like dirt, trees, rocks, stuff like that.
Well, yeah, I mean, in this context, I mean, it's a globe. But yeah, dirt, tree, rocks, water, nature,
That. Yeah.
animals, people.
How about like a valley, like where it's like high on all the ends and it's really like it goes down in the big swoop like a valley.
Yeah.
That's dirt. That's dirt to me, right? So I would ask you, like, where then, if there's two definitions of Earth, right? One is the valley, and one is a sphere. All right, where does the valley stop and the sphere begin? So that I can test them against each
Um,
other.
at the horizon, when the curvature starts.
It's only but the horizon is just dependent on your distance from it. So the horizon is everywhere, but it's just for different people. Or is that false?
The hor- the horizon is the same everywhere, pretty much. I mean,
Because like
if you're
remember,
standing at a certain point above the trees and shit.
yeah, remember
Wouldn't
there
the
was like
horizon be, sorry, wouldn't the horizon be the furthest point at which you could see?
Yes,
So if I'm in a valley and
I'm
I'm
talking about
looking towards a
the
mountain,
edge. That's not the
my
no. I'm talking
that
about
would be
the
my
edge of
horizon.
the. You know what I'm talking about? I'm talking about the edge of the where the sky
Earth.
meets the land, right?
That's everywhere though.
Right.
Earth.
Yeah.
Yep, everywhere.
The sky. I mean, show me one place on Earth where the sky isn't touching the Earth. Tough. It's tough.
You know. You guys know what I mean, but you play semantics and shit.
Well, that's what I say. There's two definitions of Earth on the table here, and I don't know where the Earth begins and the valley ends. You know what I mean? So that's tough. And then flat. How would you define that? So we can get your flat Earth definition.
I mean, I picture a disc. That's what I picture.
No, no, that's Earth. You, now, but what is flat?
What do you mean? What's flat?
All
I
right, so we got
mean,
two words.
it's
Like in combo,
flat.
you have flat,
It's flat, bro. Like flat. Like what the fuck?
like zero, like zero. Like zero is
Zero
flat, then one.
degrees.
Yeah, right. So who do you think the flat earthers think that there's 0 degrees of Earth of dirt in reality?
I don't know. You tell me.
That would be ridiculous. So that's what I'm saying. If your idea of
That
flat
is.
Earth is that the valleys and the dirt and the trees are all 0 degrees, like no elevation, then yeah, that would be ridiculous. I don't think that's what flat earthers are saying.
Talking about it, the whole planet as a whole being like a disc. That's what I picture you guys thinking about the planet. Is that the whole planet is a disc, and of course, there's trees and mountains and shit. But the planet as a whole, I believe you guys think is a disc.
Yeah. Well, it gets tough because people start to describe like the circuits of the stars and the sun, and it's like, well, that's the disk that gives us our location, right? We say, okay, that's the GP of that star to the ground position, GP ground position of the sun or the star, and those are circles or whatnot. So then it's like, oh, okay, so all locations are defined by a disk, like a circle. I mean, that's what you're picturing, but I don't think that's the definition.
No tanks. Clearly, he thinks it's a disk in space. Please clear that up.
Well,
Like a
it's not a
I
flat
disk
was
in
disk
space.
I was
planet.
just about to ask, do you think that it's like the same
Well, is
model
it?
that you believe in, except instead of us believing it's a globe, we believe that it's just a disc in the same position?
Yeah. What else would you guys believe?
Yeah, well, that's incorrect. We don't believe that.
What do you believe? It's an oval or something? Because an oval is a flat.
I don't
Maybe you
believe
guys should
you
change the
could.
names to like oval Earth.
I don't believe that you could get far away enough to take a photo of the entirety to even make a scale model. So there's known land, and then there's unknown land, right? There's the things that we know. There's the places that we've been and we've recorded, and then there's places that we haven't been and haven't recorded. And so we can only make a map based off of the things that we know, right? A map is not a model. A map is something that you can use. Like you can have a map of a tunnel, you can have a map of a city, you can have a map of all the known area that is known publicly or to yourself, but that doesn't make it in itself an entire model.
There's no land on Earth that's unknown to humanity. You actually believe that there's land left on this planet that's unknown to us?
Well, how did like 4 years ago, like the biggest, what was it, 4 or 6 years ago, the biggest cave in the entire world was discovered? But we don't even know if it's the biggest cave in the world. It's just the biggest known cave.
Talking
And
about
and we're,
surface land, surface area.
I think that there are places that people have been that is just not publicly, it's not publicly known.
Like what? Can you give an example?
Well, I'm a part of the public and I don't know, so I would be stupid to give an example.
That's
Yeah,
so. I
yeah.
mean, you just believe there's land sitting somewhere that nobody knows about,
No, I
except like
don't believe that there is a true model. That's what I'm saying.
Yeah, so
so
you
the
might
I
like
maps
don't
are
what
wrong.
believe
I,
I don't
what I was
believe the
pointing
sun
out,
is
Eric.
93 million miles away. So what makes you think that I would believe in a disk floating in space with the same exact everything going on with your theory? Why would I apply only a shape of the entire model into your model? Makes no sense.
I mean, you can disagree with this, the way the maps say that there's a globe, but it doesn't change, what it represents, like the land and the oceans,
And the map is all I pointed out earlier was the map or the model is the same thing, and it's just your location in relation to the stars, and that's it. So
You know,
if
Japan found like 7,000 new islands last year or 2 years ago.
5 years, 6 or 7.
Really interesting.
Yeah, unknown land. They found a bunch of land. Nobody knew about it. But yeah, like the map, and the model are the same thing, right? And the model is just the map of the stars in relation to your position. So let's say you only know where you are in relation to the stars, the GP, the star, in relation to the ground. And they say that's all that there is. That's the universe, right? So they're going to tell you that's that each star has a ground position, and everywhere there's a star, there's a ground position, and when there's no more stars, there's no more ground position. Then you have in reality the stars going around you in a circle. So that for you in your mind, you're saying, well, that has to be a disk now floating in space because space is what they told me is existing in the sky, and locations are only relevant in relation to stars, and stars go in a circle here, so it must be a disk in space. But it's mixing together two models and the definition of locations, which is in relation to the stars. But yeah, but in reality, everybody ever has only ever observed the stars in the sky, and the sky has always been above them. And the place where they say that the stars and everything else goes below them is that place called the horizon. And the horizon is where the extension and the limitation of where you cannot see. So nobody sees anything going below, down under, right? They just see it going towards the horizon, which which appears to rise towards eye level. Um, and then the interpretation is when they can't see the star anymore that it must have gone down below, right? But that's just the interpretation. All you have to do is take 100 paces towards the star and you'll see it again. And and they'll say, well, just wait a second. There you go. You can't see it again. It's gone below it. But that's an interpretation.
Okay.
But we
What
can do
about
this.
the edge?
Yeah, that's just the end. I don't know where the end of. I don't know where the end of. Like all I've ever. This is what I'm pointing out. All I've ever experienced in reality is the sky above me, the earth below. The ground below me, the ocean being held in by the ground. Held together by the ground, the rivers, all these things, right?
Someone should have
And
found. Someone should have found the edge of the planet at this point. It was flat.
But
maybe
you're
they did.
assuming that there is an edge already, so you have a presumptive thought of what you believe the model
Or
is. None of us know or are claiming to know.
Yeah, I don't know, man. All I was going to point out is
or
I've never experienced Eric the end. I've never experienced it. I don't know. Like and then so we have these things. Like I'm
why
here on what I'm here on the surface of the earth. I
why wouldn't
experienced
you
this.
think it's a globe?
Oh, real quick, right? Well, I can tell you why in a second, right? But I experience these things in reality, and I've never experienced an end to reality. So when somebody says, "Well, where's the end?" They're just saying, "Where's the end of everything you've ever experienced in reality?" And I don't even know what that would look like. You know what I mean, would it be made of something? Would it be made of nothing? You got me. If it's made of something, right, then it can't even be the end because there would be something more, right? But then if it's made of nothing, how can nothing be the thing that everything is resting against? That's crazy talk, right? So I don't know. You got me, man. And then what was your question?
Why would you think it's not a globe?
Oh well, a few reasons. Because I don't know. A few reasons would be that perspective pretty much handles the apparent, elevation, declination of all the sun, moon, and stars. Um, and because in reality I can establish 3 points and multiple points of equal elevation using the surface of water at rest as a horizontal plane of reference to measure elevation change from that reference. Why I don't believe it's moving, right? Is because it's observably not, but then B, I don't know. I could say like I could go to physics and say, well, all motion requires an inertial reference frame, something stationary to create forces such as friction, and so on and so forth to gain speed, momentum.
Wait, you don't think we're moving right now?
When I'm not moving, I know we're not moving when we're not. That's by definition.
The planet. I mean the planet.
Yeah, like motion requires an
Earth is
inertial
not
reference.
moving. That's what you think?
Yeah, all motion
Uh,
is relative to the stationary Earth. That's how we measure motion. Like I say, it's like, okay, well,
Why
how
don't
fast
you
are
think
you
we're
going?
moving?
Because A, it requires an inertial reference frame. B, there's no observation. There's no observation of the totality of reality moving.
Why
And
would there be an observation of that? We're so small compared to the Earth.
yeah, so why would you think you're moving? The reason that people think that we're moving is because they watch the stars move. And so they say, well, it's not the sun's not moving, I'm moving. But motion requires an inertial reference frame. So,
The sun is moving. The whole solar system is moving, and the Milky Way galaxy.
well,
We're
I've
moving
given you
right
that one,
now.
right?
Oh,
Well, if that
yeah.
was true, that would mean that we're moving. Like there's a point that's moving around, and if there's a point, right, that we're moving around the sun, then that would dictate that the surface of water at rest would be radial to that point. But in reality, I can use a tool such as a water level to establish a horizontal plane of reference, right? Which is therefore disproving that the vertical change is measured from a radial reference, measured from a line or a plane. Therefore, disproving the Earth in motion. Because if the Earth was in motion, right, it would have a point, right? There'd be a point that was moving around the sun. If there was a point that it was moving around, that would dictate that the surface of water at rest would be radial to that point. And I mean, I'm just repeating myself, but do you understand it?
Kind of.
Yeah, like if
Well, why
it's
wouldn't
just
gravity hold the water? What do you think about gravity?
yeah, like if gravity was that's the thing I'm really kind of talking about. If gravity existed as a point as a force perpendicular to a point, that would cause a radial um, measurement of the surface of water at rest. And since you know what I mean, since water at rest is flat, horizontal with a shared orientation over distance, it can't be radial because radial would change the orientation over any and all distances. Right? You can imagine like if you're on the top of a basketball, right? You're like, okay, I'm on the top of it. You're standing there, you're looking at it, and you're like, okay, that's horizontal, right? As you kind of move your finger down over the basketball, it would change its orientation in relation to that initial point. So every point on the surface would be a change in orientation. But in reality, I can look at you and you can look at me, and we can both be standing in a horizontal orientation. That's it. And we can back away from each other and still look right at each other. And that just proves that orientation is maintained over distance, disproving that it's radial from a point. Yeah, so we can't be moving around the sun. It's impossible.
Why not?
I'm just going to repeat myself if I say why not again. If you say why not again.
I'm sorry. I'm sorry. You know what? This is pointless.
Pointless.
I'm
That was
never gonna
funny. I like
believe in
that one.
you, and you're never. Yeah. Yeah. You know
Well,
what
there
else
would
is
be a
pointless?
fact.
The planet, apparently.
It wouldn't be pointless because those things that, like I'm saying, would be true if it was true. Like it would just it would be consequences, right? It wouldn't be the same. They'd be different. So, like, you can come to a conclusion, you can come to knowledge, and you can know it because you know that two things that are different are not the same. And then once you lay out what would be the consequence of this, model or whatnot, then you know which one's true.
Eric, how do you know that
It's
the
just
Earth
so
is
crazy to
moving?
me. What?
How do you know the Earth is moving?
Because we have a
Because
24-hour
it is.
day.
Hold on,
Why do
Caleb,
you think?
what?
Why do you think there are 24 hours in a day?
Yeah.
Why do you think that is?
Because the sun moves?
It's because it's how long it takes for the Earth to rotate one full day.
Yeah, how do you know the Earth is rotating?
It's because it's what preschoolers know. Okay, it's kind of like everybody on the planet knows this.
Well, I'm asking how you
Yeah,
know. Like,
dude.
how did you verify the story that the Earth is rotating once every 24 hours?
How did you verify
I
the
see
Earth
it.
is flat?
Yeah.
Measured flat. I'm asking about rotation right now. We can get to the measurements after.
Why is there a 24-hour day on a flat Earth?
Because the sun moves.
I just want to point out there's not like I don't know. It depends on what you're talking about with a day. 24-hour day. It was so a year had to occur first for people to then divide it up into 360, yada yada yada. Because every day changes its length, so on and so forth. Just wanted to point that out.
Well, there's still 24
Can I
hours in
ask
a day
something?
within 365 days. So one day, 24 hours, would be the time it takes from the sun to go from the position that it is currently at around to the position or the same position
No.
where it was at the prior day, right? That would be 24 hours. Same thing with the stars, right? It would take the stars 1 year to go from the position that they're at tonight to be at the same position that they're at tonight. It would take 360 some odd days, you know?
Well,
So it's as
Brother,
simple as that.
everybody's aware
well,
of the story. We all know the story.
yeah,
We're
well,
asking, how did you validate
What
know
that
is
that
story?
if
hold
you
up.
know that it's 24 hours to rotate, that's why we have daytime and
I
Yes, we
didn't say
know the
rotate.
story.
I
I
just said
already said
24
everybody
hours
knows
right?
the
in
story.
positioning.
Everybody knows the story.
Yeah.
Yes, everybody knows
Explain
the
daytime
story.
and nighttime, dude. On a
I
flat
said that the
Earth, how
sun
does
moves.
daytime and nighttime work?
I said the sun
The sun
moves. So now I'm
moves.
asking you, how do you know the Earth is moving? You're trying to obfuscate right
Because
now.
we're
I'm asking you how
rotating.
you know the sun moves. Or how do you know that the Earth
He
is
just
moving?
explained it. He just explained it. You can tell by the stars.
Yes, but that could either be the stars
Obviously.
moving or the Earth moving. How did you validate that it was the Earth that is moving?
That's crazy. That's crazy.
Are you asking me? I didn't say the Earth was moving.
You
I
guys
simply
like
said it would take
reincarnated?
time.
Brother, you understand that
Yo,
a car
you
could
flat
appear to be
earthers
moving to me.
reincarnated from the 1500s.
Like if I'm on a skateboard and I roll past a car, it appears that the car is moving, or the car could be moving, right? It could be driving past me. How do I know which is which? I'm asking you how
How
you
do you
know
know
the
it's
Earth
moving?
is a thing that's moving.
You would
Because
have
you
Why
can
to
don't you
see it
just leave?
moving.
see
Why
a
don't
mechanical
you just leave a
component
camera out?
moving.
Like go live, like put the camera out, right? Let it stream for like 24 hours, right? And then take a look at it. You'll see that it's entirely like that the
Yes.
Earth is spinning on its axis.
Well, you know those 24-hour live streams are fake, right?
Oh, of course, bro.
I'm
Of
telling
course.
you to do it. I'm not saying to look. I'm talking. You can do this.
Well, no, you know
I
what?
just
You know
want,
what's actually really fair? That's true. You know what's funny? The Earth does not spin underneath the gas, even though they are independent of each other.
can I point out the Glover mistake that they made just a second ago? They claim that the sun returns to the same spot in 24 hours. I did point out earlier that's incorrect. It's every year. Then you divide that year had to occur first. You divide it up. It's a new
Yeah,
place
that's
every
correct.
Yeah,
day.
it moves
Yeah.
because the tilt moves and this
Okay.
seasons and shit.
Oh, bro, we know the story. We know
Okay,
the
well,
I'm
we
just
can
story.
pointing out
agree it'll
they
be
don't
on
know
the
what
same
they don't know what a
lateral,
day is.
although
That's
it'll
all.
be on a different longitude, right?
Yes, it moves between the tropics. That's fine.
Okay. So it takes 24 hours to go from one
He's gonna say it
of
again.
the
Oh my
it would
God.
move. It would take 1 day for it to go back around to be on the same latitude, right? But the
Longitude.
longitude would differ, right? Day to day. Although if you took the same day on a different year, it would still be in the same on an x-axis. On a
It takes a
sorry,
year
on
to
a
get
graph,
back to
like
the
almost like
same
a graph, right? You have a
latitude.
graph, you have your positive, you have your negative. It'll always cross one line 24 hours, but it won't cross the other line. It'll cross it twice a year.
Oh yeah, 6 months. Yeah.
Yeah.
All right. So where's that validation that the Earth is the thing that's moving?
If you're asking me, I'm a flat earther. I'm not claiming that the earth is moving. I'm claiming that the sun is moving. I
Okay.
don't
Well, I mean, from
experience the
Eric
earth to move.
or knowledge, I guess those guys are the ones that are claiming that the
They're
Earth is the
both
thing that's
moving.
moving.
The Earth and the Sun are moving. We're
Okay. So let's
rotating
start.
around. We're
Let's start with the
orbiting.
Earth.
We're revolving, and the Sun is moving and dragging the whole fucking solar system in the galaxy.
Oh, okay.
And
All
everything
right.
is
Let's start
moving.
with the Earth then. How do you know the Earth is rotating? Go ahead.
This is third grade shit, bro.
Oh, but you should be able to
Well,
explain it to me then. How do you know that the Earth is moving?
I haven't been in third grade in over 20 years.
Yeah, so you could say you were told it and then move on.
Yeah, if you want to
Because
just
that's the
believe it, that's fine.
extent. Yeah, that's the extent
You want me to take
that
over
you know it.
for you?
You were told it and you believed it.
Well, I mean,
Well, yeah,
if
either
you look
or. This
at
is like a
if you look at
WWE tag team as
here,
well.
I'll answer for him. Like if you look at just like the Coriolis, right? Like because the Earth is like spinning, right? In the middle, like the
My
equator,
bad.
like it moves much faster than the top, right? Than the north and than the bottom, right?
Wait, what? Each latitude on the equator should be spinning at the same speed.
no,
Mm-mm.
he's talking about at the equator. It's spinning at what 1,060 miles per hour, whatever they claim. And then if you're, for example, where I'm at, if you take my exact positioning right now, I'm more north of the equator. It's
1,000 like
spinning at
37.
758 miles per hour, supposedly where I am. But it's spinning faster at the
Okay.
equator, and as you get closer to the poles, it spins even slower and slower because that's how spinning something works, right?
Okay, you were gonna validate that how knowledge?
Hmm?
Or are you just gonna expunge more of your lore of the globe to me, or are you gonna like back it up with something? Or
I was just answering for the other guy.
Bro, are the seasons a hologram or something?
no, seasons are real. I'm just asking you how you know they're caused by the Earth
How do they
moving
exist? How do they exist on a flat Earth?
as the sun moves.
The sun causes the seasons.
Yes.
This is going to be a huge problem for
You're
you. You know
crazy.
why?
You're crazy.
You keep saying the sun moves.
Yeah. Well, do you observe anything different?
Well, I mean, if the sun moves,
Well, I
if
mean, this is just
if
a
Antarctica
really
if
easy
Antarctica
guess.
is at the center on your flat disk, there are no nighttime cycles on your fucking model. You're gonna run into a huge problem when you keep saying that the
What
sun moves.
model? Yeah, the sun does
Antarctica
move.
would not be the center.
Yeah,
That's
okay,
not
yo, check this out.
How?
If I
Listen,
have a light source above a
listen.
flat surface and I hold it up above there for 24 hours, does it change the shape of that surface?
Antarctica is at the North Pole is like at the center of the flat Earth model,
Brother, it doesn't
and
matter. You understand that I can have 2 points of rotation in the
that's the
sky.
reason why you guys
3,
claimed for years that
4,
there was no
5,
24-hour sun in
6,
Antarctica. Do you
7.
remember that?
Yeah.
Do you remember?
Well, not me. I came into flat Earth after that, so I don't claim any of that shit. But you understand how none of that matters, right?
It matters a
The
lot.
surface will never change depending on how many points of rotation we have in the sky.
If you have a 24-hour sun on a
Yes,
flat
we could
Earth
have
model,
24-hour,
right? When you're talking
48,
about like in December,
72. It doesn't matter.
which is like solstice, like right, it would light up the entire globe. There would be no nighttime cycles on your model.
Brother, it doesn't even matter if we don't even have nighttime anymore. The
Is there
Earth's not going to
nighttime?
be a ball all of a sudden.
Can
I'm
I
just
can I
saying
ask
if
you a
we didn't
question?
even have
Is
one
it nighttime
anymore.
where you are in December during solstice?
Well, it
Nighttime?
depends on the time.
There shouldn't be any.
Well,
Knowledge.
sure, I
That's the
receive.
problem for you.
Are you gonna elucidate some kind of knowledge, or are you gonna just keep asking questions that you don't have answers to?
We talked about this before.
I mean, I hope that you understand
There
that
are
points of
no
rotation do not
nighttime
equal shape.
cycles on your model if there's a 24-hour sun in Antarctica. It's just not going to happen.
Okay, so good thing I don't claim a model then, because the light won't change the shape of the floor anyway, will it? Because you
But
understand that I can have
you said that it moves.
I can
Right?
have 14 points of rotation in the sky for a globe. I can have 14 points of rotation in the sky for a flat Earth. The object will never change. So this is not something that is exclusive to a ball or flat.
Yes, it is. Because like
Crazy, I know.
when the Earth is like rotates on its axis by 23 degrees or whatever it is, that's we claimed that for years, right? We said there's a 24-hour sun in Antarctica. We can prove this, right? We had a whole back and forth with your guys' crew online, right? We went at it for years. We finally did the final experiment.
Dude,
We invited the flat earthers down to Antarctica. They all witnessed the 24-hour
I
sun. They
remember when you
all said
jumped
it
in
was
this
Okay, and I
Discord
would have asked,
for the first time,
brother, I would
like,
have
and you
asked
didn't know
them
this.
the same thing. How does a light
well,
prove the
well,
shape of an
you
object?
can go ask
It never
Jaren then.
will.
Jaren's no longer a flat earther. He's not part of
Okay,
Glowbusters
I
anymore.
don't even know who that guy is, dude. I've heard
Do
of
you know
him.
who Eric? Do you know
I
who
don't
Eric
like.
DeBay is?
Okay,
No.
it's one guy that went with a group of people. He was one flat earther out of a group of flat earthers that claimed to see a 24-hour sun in Antarctica. None
Yeah.
of the other ones claimed to have seen it. They said they did not see it, and then
They
he
said
went
that
off
they've
and
seen it and
became a.
that they're
Hold on,
wrong, but only
no,
Jaren
because
like left flat earth. The others they
he
didn't.
left and became a anti-flat earther. He didn't become a glober. He became an anti-flat earther, and none of the other people that went with him experienced the 24-hour sun. He was miraculously the only one that even stated it. The other ones literally stated that they did not experience it. So you have multiple people disagreeing with one person. Are you like that's first of all, if you're just going off a belief of what someone else is saying, that whole experiment made by these other people should be null and void to you. You should go do it yourself.
I'm more like maybe this is like petty, but knowledge. When you jumped
Hey,
into
brother.
this Discord server like not too long ago, you didn't know the radius of the Earth, the circumference. Are you telling me you've been in this argument for years and years? Is that what you're telling us right now?
I know it. It just I don't respond well to certain people.
Mm-hmm. Mm-hmm.
Yo,
How was that even an
let's go
answer
back
to
to
his
seasons, dude.
question?
Let's go back to the
Okay.
seasons, dude.
All
Yeah,
right, awesome. How was the Earth
Why
rotating
is it
again?
you
why
can
is it
talk to
winter
Eric.
time in Australia right now and it's summertime in North America, bro?
Because the sun
Because the
moves.
sun has moved more north.
Oh,
Actually,
Eric is still here. Insane.
It's
and the
crazy.
sun will
The sun
soon
is
start to
moving.
move south, and it will be 24/7 dark
That's
past
crazy.
the 72nd lateral north, right? That's what we experience.
That's crazy.
Awesome. So how have we validated that the Earth is moving?
The Earth is there's a tilt to the Earth where it changes.
God,
Okay,
this
how
is
do you
like
know that, dude?
How did you
Brother, we know
validate
the
the tilt?
story. Holy, we know the story, dude.
you're coming off as like a beaten like housewife or something. You
I know,
too.
even little
Like
kids know the story. Isn't that funny?
everybody knows that my mom loves me. My dad loves me. He hits me because he loves me. That's what you guys sound like. Can you give a reason like how you know what you know?
Explain the seasons in the flat Earth, dude. How does it happen? The
Brother,
sun
we
really
just
is
told the sun
Who said
moving.
that the
moves.
sun
Oh,
moves?
The
yes.
sun
Do
moves
you
like a
experience
few
anything
degrees.
differently? Do you
The sun
experience
moves
something
a few
different?
degrees. Then the sun
Yes. Do
moving.
you experience something different?
So we're not moving right now.
No. Do you experience something different?
Why when it becomes nighttime here, it becomes daytime somewhere else?
Because the
If
sun
we're on a
moves.
flat Earth, because the sun moves. But we're
How
Yes,
on a
the
come I
flat
sun is
can
Earth.
see?
moving.
How come I can see the sun is setting right now for me? The sun is going to set in about, oh, I don't know, 3 hours, a little less than 3 hours. But for my friend over in the Philippines, who's 14 hours in the future for me, given time difference, right now the sun has already risen for them. They're seeing the sun as well. Like, how do we see
Yeah,
the
we're on a
sun at
flat
the same
Earth, by the
time?
way. Flat Earth, by the way.
Yeah.
Yep. Welcome.
I mean,
No,
unless
flat
you
Earth,
want to
dude. Like,
say that
when
a
we have
light
the
in the
sun, like
sky.
at the same time,
That the what?
wouldn't we all have the sunlight at like the same time if we were on a flat Earth?
No.
Why not?
Remember, Eric, you were given I gave you the two different options. You remember, right? Like, so they say that the light comes in. The sun is so big, so enormous. You're like this tiny marble, and the sun is like your house. And you're like the sun comes in parallel and straight, and they measure, right, like an arc of light on the ground. They say, well, since the sun's coming in straight, it must be the Earth that's curved. Or you have the other option that the sun is diverging from, right? The divergent light from the sun is shedding its light onto a flat surface, which would give you the same apparent, measurement. You remember this, or you forgot it, or?
I forgot.
All right.
But still, I think nobody really knows. I mean, but the argument leans towards globe Earth.
You haven't even given us an argument yet. I'm still waiting to know how you know the Earth is rotating. I've been asking this for like 10 minutes already.
Dude, stars, bro.
Yes. When you look up, what do you see the stars doing?
But it's a hologram, though, right? It's a hologram.
Are they moving?
Sometimes they're in different positions.
Awesome. So we see the stars move.
Right.
How do you know the Earth is rotating again?
How do you know it's not?
Because if the Earth was rotating, the gas moves independent of the Earth.
We have an atmosphere
Yeah, that's the gas I'm talking about. Yeah.
that keeps the air in. Why do you
The
think we're
gas
not like
keeps
in
the
space
gas
right
in.
now? Do you know how the atmosphere works?
Yeah, it's just a mixture of gases. Yeah, they call
You
the
know what the
atmosphere.
magnetic field is? You know what the magnetic field is?
Hold on. Are you saying that magnetic fields cause the gas to stay pressurized on the Earth when it's adjacent to that area of lower pressure?
Apparently. What do you think it is?
Show us the M in, show us the magnetic field in gas law, dude.
We only know of one independent variable that has been verified through the scientific method to pressurize this gas adjacent to a vacuum or an area of lower pressure. Only one, which is a solid state of matter as a container or barrier. Now, if you want to prove magnetism, gravity, temperature, hot coals, whatever, you
So
need to
Lats, can
use
you
our
finish
that.
compass
this?
is fake? Our compass is fake?
What the? What happened to your gas, dude?
I know, Lats. Maybe you could finish that
Yo,
that
yo, yo, yo.
syllogism
Keep on this compass thing.
for
Like
knowledge
maybe,
and for
maybe,
Eric.
maybe we can teach him how a
Knowledge.
compass
What's wrong with
works.
you, dude? Didn't you hear me talking? Okay.
Hmm? No. Keep bringing up the compass thing because this is important.
All right, but Lats was giving a syllogism, right? He's saying he started off. He said, I think he said, and he could finish it. I don't want to steal it from him. He said, gas moves independent of the Earth. If the Earth were moving, I guess the gas would be displaced. I don't know if he wants to.
Oh, yeah, sorry. I was just going to say that every object detached from the surface would be drifting
No, but
to
how
the
do
west.
you explain compasses? How do you explain compasses? Are they fake?
No, compasses are not fake.
Really?
Okay.
Explain how they work
What's your
again.
explanation? Yeah.
They work on a flat Earth.
Do they really?
Yeah, because the
It's
Earth is measured
crazy.
flat. I mean, they can't work on a
So
globe Earth because there's no curvature measured, right? It's the same
no,
thing with
north
computers. How
and
do
south are
computers
straight
work?
lines that run from pole to pole, right?
Yes, computers work
Their
on a flat
longitude,
Earth
like east,
because the
east and
Earth is
west,
measured
are
flat.
like lines
Yeah.
of like the latitude that run perpendicular to them, right? So like if you have like
Ones
a
that were
compass, right,
derived
and
from angle
if you
measurements.
walk like if you walk like due east, right, like
Okay.
like right, you're walking in like the circle around the Earth's like axis of
Okay.
rotation,
Okay.
right?
Yeah. But what's wrong with walking around a circle? Can you not have a circle on
Because
a
on the
flat
globe, like
surface?
your local horizon, like it curbs like beneath your feet, right? And like that's what the compass does, right? Like the compass
It
adjusts
does.
like to that curvature, right?
No,
It's
the
keeping you in
compass
line with
adjusts
like
to magnetic
it's
north.
keeping you in line with like the planet's like magnetic field, right? That's how the compass works.
Okay, so did
You
you
know that?
not know that if you walk east or west, it's going to be a big circle around the center point? Can you not have circles on a flat surface?
So like on like the
So
equinox, right? Like, wait a minute, go ahead. Is that you, Eric?
no, go ahead.
Okay, do you know what the equinox is? Like the sun is like
Oh,
far
so
away.
scattergunning, man.
Brother, what happened to the compass? You were on gas, you were on rotation, now you're leaving the compass now too?
No,
Do you want to concede anything before we move on? You're just going to keep going? Like, what's going on here?
compasses don't work if they don't follow the curvature, bud. Everybody
Oh
knows
my
this.
goodness gracious. Brother,
Like you wouldn't know
imagine,
what
okay,
north, south, east, or west is.
That's
I
the
want you to
biggest
place,
stupid claim I've ever heard.
I want you to place your hand on a light pole. Okay.
Because look, okay, like the equinox, right? Like the sun is like
Hold
so far
on,
away,
brother,
right?
real quick. I need you to understand this point because you're sounding really dumb right now. I need you to place your hand on a pole. Okay, you don't have to do this right now, obviously. Do this when you get a chance. Now, your hand is going to be the needle pointing to the north. The light pole is going to be magnetic north. Okay, you can walk in one direction, east or west, around this pole. You're going to have a circle. Yes, you're going to end up back in the same spot because your hand never leaves this pole. Now, you can extend this by tying a rope around the pole and tying it to your waist, maybe like 10 feet away. Now, you can repeat the same thing. You're going to walk in one direction while the rope stays taut. Okay. It's going to be a big circle around this center point. The rope is going to
This is a
represent
bad
your
way to try
needle
to explain
north.
how a compass works.
Yeah. Why don't you
Oh,
just
This
start
is
at
bad.
how?
like if you can just start at the equator, right? Like those they
Yes,
run
it'll be the
perfectly
same
parallel
thing
to the
around
ground.
the equator. You can have this rope extend all the way to the equator if you wanted to. It's still going to be a big circle around the center point. If that rope is going to be representing north, as you walk with that rope taut, you're going to notice you're going to end up back in the same spot, making a big circle on a flat surface.
I don't think so.
A compass
Yes.
wouldn't work on a ball.
So like when you're talking about like your circle path, right?
A compass wouldn't work on a ball, dude.
The whole point of the compass is to be perfectly like aligned with the magnetic field, and it bends to the curvature, dude.
It doesn't bend anything.
Brother, that's the story.
It's not the
Or then
story,
if you
it's
want to
how they
bring that
work.
up, if you want to say that they're curving around, right? These magnetic field lines are curving around the curvature of the Earth. That means that curvature would be capable of being measured on the surface of the Earth. And we'd be asking for those curvature measurements, which I know you don't have.
Yeah, like what we said, right? Like at the equator, like the magnetic field lines, they run like perfectly parallel to your ground, right? Like your compass needle like sits completely
No, they
like
don't.
flat, right? Yes, they do. Like when you're
No, they
moving
don't.
north or south, right? Like they like your the right? They're pointing exactly into the ground, like at the magnetic poles. Okay.
They're pointing in the ground at the equator. You're telling me if I bring a compass to the equator, my needle will point into the ground.
Did you know
It would
that?
have to on a ball.
Do you know that a compass? Why do you think a compass points north? Why do you think it does that?
So wait, you're telling me that you've been to the equator to verify this story, that your needle will point into the ground 45 degrees
Hmm?
to the
No,
North
I know how a
Pole.
compass works.
Oh, jeez.
Know
So you're telling me
exactly how
that
a compass works.
compasses are inoperable
Have you
is
done
that
it?
at the equator? Is that what you're telling me?
Have you done it?
No, me personally, no. That's why I'm asking.
I've
I'm asking
done
you
it in
guys.
Australia, and they definitely don't point towards the ground.
They
It's not even how it would
point
work.
to the
That's
strongest
not even how it
signal.
would work if it was a globe, bro.
No, this is the
You're
Yes,
first
it
time
funny.
I've ever heard this in my whole life, dude. This shit is crazy. Like, you want to say flat earthers are crazy,
You
bro.
know,
You want to say
I've
that
heard,
this needle's
They
pointing to the.
do.
dude. The only time I've heard it is like if
If they
flat
will.
earthers like butcher how magnetic field lines work, and they're like, if it was a globe, you should have to point it down to the ground if you're in the south. But I've never heard a glober say it before. That's kind of funny. You're funny, Shane. Knowledge.
no.
Your name's not
So
Shane. Knowledge. You're a funny guy,
the
man.
magnetic field is not parallel to the surface of the Earth. It has an angle to it, depending on your latitude.
Okay, bud.
You know, I want to see if there's any footage of this somewhere where somebody's in the southern hemisphere and they're.
Hmm?
Pointing the camera towards the earth, like towards
It
the
would be
ground. It's
most
the north's
parallel to
pointing
the equator.
into the
Like you
ground.
get a
That would be fun.
steeper incline at higher latitudes.
Yeah, rumor has it Magneto lives at the equator now.
Rumor has it you don't understand how a compass works.
And then when you questioned it, he asked you if you've ever done. Have you ever seen it?
I've used a compass before. I know how they work.
So you're telling me you've pointed it in the ground before?
Apparently you don't.
I asked you, why does a compass point? Do you think it always points north? Why do you think it does that?
That's where.
This
What are you talking about, dude? That's what compasses do. They do point towards the
This is
magnetic field in the north. They follow magnetic north.
poor guy. Like, is there
is
another
funny.
topic? You're probably better at least.
Right.
No, you might be better at another thing. I don't even remember what you were. It's water under the bridge. What were we talking about? Maybe not compasses. Definitely not compasses. What else are you good at? It's not this.
This is a commercial pilot that studied at Princeton University, by the way, fellas.
No,
Is this
it's
as
not.
believable as John D?
That's what he says. What's that, Mansky? Did you say something?
Is he as believable as Dr. John D, who we still know nothing about?
No, not at all.
You guys hate appeal to authority unless it's Dr. John D.
We don't appeal to his credentials. He could be a garbage man and still have those same observations done.
Oh, come on, you guys ham it up so hard.
But you
Dr.
guys like to appeal to
John.
credentials, so sometimes we mention that he's a PhD in optics, right? Which would actually be helpful for this type of thing that he does, because he's done years worth of laser tests, and
Have you
he has
verified that?
videos about refraction and the inner workings of how laser beams work and blah blah blah.
So have you
And
verified that?
he also openly puts his email out
does
there,
it.
so you can contact him anytime you like.
Have you verified his PhD? Do you know where he went to school?
No, have you verified
Oh.
anyone's PhD ever?
Your
No,
friend,
we're
you
talking
didn't go
about
to
Dr.
PhD.
John D.
So you're appealing to credentials now.
This is like Dr. Kent Hovind type shit, dude. Like with flat Earth like creationists.
No. You can just contact him and ask him. See, ask him if
people have
he's
tried. He
lying
doesn't
about
tell
his
you.
I
credentials.
know
He
people
even
with
mentions
PhDs
he
who
even
deny
mentions that
evolution.
my
It doesn't mean
credentials
anything.
aren't important in this case. What's important is my practical, real world recorded demonstrations that have been done. He states this himself. He doesn't appeal to his own credentials. He's like, look, though I am a scientist, it has nothing to do with these observations that are being done, right? This is real
Yeah.
world testing. Anyone could go and repeat these tests themselves, and countless amounts of people have done that and repeated the tests and had similar results. You guys don't have any tests.
You know, I'd rather trust Dr. John D over somebody telling me to point a fucking compass in the ground. I'll tell you that much.
Dude, I mean, that was a good point, DJ. To point. This guy's a commercial pilot following a compass heading at the equator. You better watch out, guys. Don't board that plane.
Dude, I told you this guy makes me even more scared to fly. I have to fly like across the ocean very soon, and hopefully it's not someone like this guy behind the plane wheel.
All right, since you don't know nothing about compasses, you want to go back to rotation or gases or anything? Anybody?
DJ, when are you going to unpermaban me from English Hub?
When you start acting polite and civil, it doesn't seem like today's the day.
Oh, I'm just asking about Dr. John D.
Yeah, but you're being like an asshole and a douchebag, so it's not gonna happen.
Yeah,
Well, you're
because these
acting like
people
that,
don't
bro.
write. They don't write peer-reviewed papers. Homie, they work for like institutions like the Discovery Institute, like these bullshit like institutions that like are
You
mocked
don't know
by
where
the
he
actual.
works. You're just
I'm
making things
saying
up.
everybody you know, kid, all of your PhDs, all these people, they don't fucking write peer-reviewed papers. They don't write in like academic journals. Okay, they're mocked
Yeah,
and
he's
marginalized in the community.
you don't even
I
know.
guarantee you, if I look this
You're
guy
just
up, I
making up
guarantee you
people.
he's a
You don't
pariah,
even.
just like all the creational star, right?
Okay,
In the
bro.
scientific community,
Okay,
I guarantee you they're
sounds
mocked.
like you need some of Yoda's butthurt cream.
We all know this is true.
Well, I'll tell you what.
Dude,
I'd rather
what's
read.
true is that you don't have any idea how compasses work, and you just made such a fool of yourself on the live stream again. More clips from the
You know how
pilot,
compasses
the
work.
Princeton pilot. That's gonna make a funny video title when I clip these out and put them all over the internet.
Who
But
cares?
I'd rather read an
Nobody's
unpeer-reviewed
watching your
paper.
video, dude. You're laughing. You are more mocked than a Trump supporter. That's how bad you are.
I think you're going to be more mocked
Like, I think
as somebody who points a fucking compass in the ground.
Trump supporters are more popular than flat earthers. That's how.
You know that Trump supporters don't point compasses in the ground?
Hmm?
How does that make you feel? Did you know that Republicans and liberals,
you fucking idiot. What are you talking
yeah,
about?
Republicans and liberals do not
I
point
didn't say
compasses in the
point the
ground.
compass at the ground. I was
You are
talking
the
about how the
only
magnetic
one.
field, the line. You said
You're
there's
the
no
only
curvature.
one.
Hey, you said there was no curvature, homie.
Yeah, the Earth has no curvature.
Hey,
That's
retard,
correct.
why don't you Google how a compass works?
If you
Can
want
you
to say
do
that
that real quick?
the magnetic
Hey, do
lines
me a
are
favor.
arcing over
Google.com
a curve,
compass.
all I said was that the Earth would
I'll do
have
that for you right now.
measurable
Let's see.
curvature.
Let me go on it right now. Let's see if a compass follows like the curvature. Let's see if that happens.
No, what do you want? Do you want to win or you want to be right? Which one do you want? You want both? You want to win and be right? Or
Let me. I haven't Googled it yet. Let me see if I'm right.
After you're done Googling that, go Google if Republicans point needles in the ground. Go ahead.
We were talking about the magnetic field.
Yeah, you said that you point your compass towards the ground.
No, we were saying how like the magnetic field.
I mean, I didn't say that. I don't want to put words in your mouth, but I'm just quoting you.
Don't care.
You know.
Good evening, gentlemen. Who's the dumb fuck tonight?
Literally a dumb fuck who literally said.
Knowledge. He says that the way that he uses compasses, he points the needle towards the ground.
God damn. Did you actually say that, bro? What's wrong with you?
Yeah, it was about 5 minutes ago. If you want to go back and listen, those are pretty funny.
I almost don't.
Do me a favor, DJ. Restore my side project back.
All right, let's hope he redeems himself. Have at it.
Oh, damn. This freaking thing that you posted in the side chat, Yoder, is like an infinite zoom picture. Holy. Kind of fun, actually.
You guys are mocking whoever was talking about the magnetic field, but you can definitely see that
I'm not
the
talking about the
magnetic field
magnetic
has a
fields.
vertical component. Are you saying it's just horizontal? You think the
I
magnetic
was
field lines are
talking,
just horizontal?
I was just specifically talking about the use. He said that he uses the compass by pointing it in the ground.
We were talking about the magnetic.
How is that relevant to the argument?
Yeah.
I was
Like
talking
it
about
says,
east and
look
west using a
here.
compass.
We go to says
He was
yes,
saying that
compasses
you
naturally
cannot
follow the
have
curvature of
circles.
the Earth because they align with the planet's three-dimensional magnetic field. Yes, that's true. The invisible
Awesome.
lines on a like they field bend, curve, and arc across the globe,
Okay.
guiding and along
Awesome.
the surface, just
Yes.
like
Mr.
lines of.
Flat, white dead
We
ass
were
fat.
we were
We know
talking
the
about the
story.
lines of latitude and like the longitude, like right. That's what
We
we
know
were
the
talking
story,
about.
dude. Yes, we
No, you
understand the
don't.
story. We
You
do
just
know the
told
story.
me. You told me they
If
don't
that
do that. You
statement,
stupid
listen,
motherfucker.
brother. If that's
You
if
said
that
on a flat
statement
Earth there is no curvature. Then a compass would not work.
if that
What are you
statement
talking
is
about?
true, right, then we should be able to measure
How
that
does a
curvature on
compass
the
work on
surface.
a flat Earth if there is no curvature, bud? They have to. It has to follow
If that
like these
statement
lines.
is true, then we should
It
measure
is true.
curvature on the surface. So where's that surface curvature measurement at then?
Hmm? You do it.
He's spurging. He's spurging, lads. He's spurging.
You're the one that makes a positive claim that the Earth is curving. Where's the
We
measurements
just
at?
talked about it earlier, dumbass.
So where's the measurements at?
The measurements? You want me to do the I can't post them in the side chat.
No, I'm not talking. Just send it to me. I'll post them up for you.
You took away my side.
I didn't take away nothing from you.
Yeah, because they know I'm right. That's why. Because they don't want me posting it.
Who's they?
You.
I
You're
mean, I didn't even mute you, bro. I'm trying to talk to you. I'm trying to get information from
Can
you.
I
Why
ask you
would
a
I mute
question?
you?
How does a compass work? Explain it to me.
I mean,
Without
you don't.
following the curvature we talked about, like the longitude and the latitude.
Yeah,
right?
they work on a
like
because the Earth's measured flat. Just like computers work on a flat Earth.
Is there curvature?
And the
Is there
Earth's flat.
curvature? Is there curvature?
No. If there's
You're a
curvature and you're
dumbass.
making a
The
positive
compass
claim of
would not
curvature,
work, buddy.
okay,
You
so show the
understand?
curvature then. Where's the
Can you
curvature at?
Google a compass? How it works?
Brother, where is the curvature at?
Where's the curvature?
Yes. That's the
Do you
whole
not
point
know
of this. This
anything
isn't
about? Do you even know
24/7
about? Do you even know what
compasses.
Einstein is?
This is 24/7 flat Earth. We're looking for
Okay.
curvature measurements that
Okay.
disprove that statement.
Okay.
Yes.
Where's the curvature? Well, time is fourth dimensional, right? Like, have you ever heard of it follows like the metric tensor, like
Oh,
that's what
dude.
gives rise to like the differential manifold, and that is that's what creates like the geodesic. Like that happens when like time and space are interconnected, and they're kind of like that's what the warping is. Like right when you put like a mass like object like in space, right? It warps space and time, that fabric, right? That's what the curvature is. If that's what you're asking.
Okay, awesome. So now we have a claim that bendy warping
What
space-time is
is
going to
the
be
metric
warping the
tensor
Earth
and the
into a
differential
ball,
manifold? No. Let's
right?
talk about time being fourth dimensional now. Like, since you want to
I
talk
get.
about fucking curvature,
Well, you
Can I
want to
get
talk
some of
about
that
this
space
concepts?
time?
dumbass literally just told me that there's no curvature, but in order for a compass to work, it has to follow the curvature of the Earth, right?
Can I get some of that
No.
space time from you? Knowledge?
Space time.
Yeah. Can I get some of that?
Yeah.
Brother,
You're
you're trying to
you're
talk
bending.
about
We
You're
can talk
bending
about
brother.
time
concepts.
dilation if you want to. Like, we can talk about
You're
GPS if you want
bending
to.
concepts. You're claiming that you can bend concepts.
You're an idiot, though. Go back. What was it? Let's talk.
Brother, says the guy that's pointing compasses in the ground. Okay.
We're
Dude,
talking
listen.
about like the magnetic field.
Yes, they
Is
work
there
on
an
flat Earth
actual
because Earth
flat
is
earther
measured
here?
flat.
Or
Yes.
are you guys
Like
just
70% of
who's
us
a
in
flat
here are flat
earther?
Earthers.
You said there's no curvature. The compass would not work. The compass
Wait,
is designed with curvature in mind, you stupid fuck. It does not work.
who's a
The
flat earther
compass
here
is
actually? I thought this
designed with
was
curvature?
It's
What the
designed.
fuck are you talking about, dude?
I'm
who's an
saying in order
actual flat earther here?
all of
I
these
just said
people.
70% of us are flat Earthers in here.
Why do you guys
This
believe
guy.
that the
Since
earth
the
is
Earth
We
flat?
can
is
go talk.
They're
To the compass.
measured
delusional.
flat.
They're stupid.
Yeah, but
Earth is
why?
measured
But
flat.
why? What makes you believe that? If you're refusing
Earth
science, what are
is
you believing?
measured flat.
By
There's
who?
no curvature detected. Everybody that
Who
measures
didn't
the Earth.
detect it?
Everybody that measures the Earth does not
These
detect
guys on
curvature.
Discord.
Yeah, are you like a rage raiding here? Is this what you do? You come here to rage raid?
It's a troll channel. These are all trolls.
Yeah, well, you're gonna notice very quickly that when I ask these guys for measurements of drop over distance or rate of change of slope, that there is
These guys are actually
none
worse
on
than
the
trolls,
surface
to
of
be
the Earth.
honest with you. Like
Okay,
this is
lads,
like the lowest of the
if you
lowest of
actually
society.
believe that the Earth is flat,
No, you don't have to believe.
take a plate, put some water in it, and
Okay.
spin it. What happens to the water? It goes outside of the plate. So it would make
Okay.
no sense for Earth to have water if it's actually flat, unless you
How
don't
do you know
think
Earth?
it's
Do the
spinning.
same with a soccer
Okay, you know
ball.
what?
They
Uh-oh.
don't think it's spinning. They don't think we're moving at all. They think the sun is moving. It's crazy.
Guys,
Yeah,
what?
did you do
Genuinely,
the same
okay.
thing with the ball?
I have. Yeah,
Take a ball, you're
that's
gonna
a.
spin it with water on it, and then what? Where does all that water go?
That's different though.
How was that different?
It's different though,
Mm,
because the water actually stays kind of on the plate.
no, it doesn't. No, my point wasn't that it's just. My point is that it's gonna fly off. My point is the center wouldn't have water. So unless you're gonna prove to me that the center of the Earth doesn't have water at all, then your point doesn't make sense.
What are you talking about? How do you know the Earth's moving?
So are you arguing it's moving, or are you arguing it's not moving?
It's not moving.
Okay. Why is Earth
How do you know it
flat
is
if everything
moving?
else is round? I mean, what are you talking about? How
Are you just gonna
do we have
bombard me
night
with
and day if it's not
questions, or like,
moving?
are you gonna answer
How do we
any
have
questions
change
too? Like,
of
how do you know the Earth is
what's the
moving?
question?
How do you
Because
know the
we
Earth is
have
moving?
night and day and we have change of seasons.
Okay, so how do you know that's because of the Earth moving?
That's the explanation that we have. Is because the
Yes,
Earth is
that's the
spinning.
story. How have you
So
validated that story?
what do you mean it's a story? You have a story that it's
Yes,
flat.
that's a
You have no
story. No,
validation.
we can go outside and
What?
validate that the Earth is not curving.
What are you talking about? You go high enough. Have you ever been on a plane?
Yes, I've been on a plane.
Does it look flat to you when you look down?
Yes, it does look flat. Even if, right, check this out, even if I was to grant that you did see curvature, I would say, let's go to the surface and validate if that curvature is actually there.
Okay,
Because you could see
people.
one
What do
thing,
you think about people that go to space and then they show us pictures of Earth that is round?
it's fake because there's no curvature detected on the surface.
So is this like some sort of is this a way for you to feel better about yourself, being like, oh, look at these people believing the Earth is round, but look at me, no, everything's fake. Go to space or
No, I'm not just
or
saying
just
it's
send
fake
fake
just
photos.
because I feel like it's fake. You understand that
This
those
doesn't
pictures
make
and
any
videos,
sense.
they
You
show
believe in
curvature in the pictures and videos. You can validate the
okay.
contents of the picture to see if there's actually curvature in reality. If there
I have a
is
question.
none,
Do you believe in?
then you have to ask yourself if reality is real or the pictures and videos are real.
I have a yeah, but oh my god. Okay, I have a question. Do you believe in physics? Do you think physics are actually accurate?
Yeah, I love physics, love science, love geometry.
Okay. Do you
Awesome.
know any of the equations that relate to gravity and how they work? And why they work?
They don't believe in gravity.
Wait, so you're telling me you know the causal mechanism of gravity?
Do you no, my question wait,
Oh,
so do
okay.
you or do you
Wait,
not
what
believe
are you
that
saying?
gravity exists?
Yeah, I see things fall down.
Okay, that wouldn't
There's no
You
work
just
contention with
fuck
if
you
that.
we
just
don't
fuck
also
yourself with
that
the
would
flat Earth community when you say that, right? Because
so
if
that
gravity
wouldn't
exists,
work because
everything ends up in a spheroid, right? You just fucked yourself,
exactly.
lads. Shut your
Okay,
mouth,
There's
so if
no
idiot.
that's the
point
case,
if
listen, check this out. If gravity is pulling everything inwards to a center, that means that there would be curvature on the surface. Why do we not measure curvature on the surface? It always goes back to that same question.
what do you mean curvature on the surface? Do you want us to actually
Yes,
take a rope, spin it
you
all
know,
around Earth? It's so big.
no. You can measure
What is
drop
it?
over distance on the surface with the size of the Earth that they give us. You
Okay, I
understand
have
this,
a
right?
question for you. Take a pole, okay? Put a light on
Okay.
top of it, like say 50 meters away, 50 meters up. All right, go like 100 meters away from it, and you will find that the light does not go on a straight line because the Earth itself is curved, and it might take more distance. But I'm pretty sure this has been done before by flat earthers, and they were
Are you
proved
talking
wrong.
about
But
perspective?
it's not
You know that when you,
perspective. The light
it is.
physically doesn't reach the other point at the same height. Why? Because
Wasn't
there's
done by
actual
flat
curvature.
earthers, dude. It wasn't done by, well, there was an experiment done by a claimed flat earther. I wouldn't even call it an experiment. When their laser broke, they used a torchlight, yeah? But there is many, many laser tests of very long distances that show that there is no curvature. And that's also how we survey the Earth as well.
No, see, if that was true, then you'd be able to see way farther than we can. The reason we can't see,
We
you can't
do.
see it like a far. No, okay, but we all almost always, even if it's like a really sunny day outside and there's no fog or whatever, we're always going to see at around the same distance because the actual curvature of the Earth is going to physically block the light from reaching any more.
That's false.
First, that's not false. I don't know. Your whole argument is that show me the measurements of the curvature. What do you want? The diameter? The
Yes.
circumference?
Because the Earth being a ball is a geometric
Well,
claim. So we're going to require
okay.
measurements. Yes?
There are measurements of the diameter and the
Okay,
circumference of the Earth.
perfect. Please provide those.
You can Google it.
I have Googled it.
I got a quick question for Nine.
Go ahead.
Why do things get smaller when they move further away from
Because I believe it's because there's less light that reaches them. I'm not quite sure. Why though?
you? No, it's called perspective and a term called diminution. All right, like as things move further away from you, they get smaller and smaller in your field of view. They take up less angular space.
That doesn't
That's the
have
reason
anything to
why
do
you
with
can't
that.
see. That's the reason why you can't see the Eiffel Tower from New York. That's the way you can't. That's the reason why. One of the reasons why you can't see China from Los Angeles or Tokyo. Things just get smaller as they
Okay.
move further away.
All right. That doesn't work. I think so. The ocean is
Well, you
huge.
would
Why
think
can't I
that
see it
doesn't.
from? Okay. The ocean is huge, right? But if I go to a really high point up, and I'm really far from the ocean, if it's actually flat, shouldn't I be able to see the ocean?
Well, how high up do you want to go?
Just high enough so you don't get blocked by actual like trees or shrubs or whatever it is.
It has nothing to do with trees or shrubs. It just has
No,
to
but
do with things like why can't you see a penny from a mile away?
because the penny is tiny. I'm talking about the ocean. The ocean is huge. No way you're telling me
All right.
like perspective
So,
distorted
okay,
enough so
so
that.
for the same reason you can't see a penny a mile away, same reason you can't see Tokyo from California, which is 5,000 miles or however long it is.
Yeah, but Tokyo and Penny aren't the same size, are they? Back to the original
Oh,
point. The
but
ocean is much bigger than a penny. No.
things that get further away get smaller in size. Do they not?
Okay, that still doesn't. We still there's a limit that you can't see further away from,
If
despite
something
the
got
size of
so
whatever you're looking at.
small, if something got so small that you could no longer perceive it, right? Like a light, right? It would appear to be extinguished to you, even though it would still be above any physical blockage.
Yes, I get your point, but I'm saying that this means the physical limit of how far you can see should be adjusted to size. So if I can't see a penny from a mile away, then there's a limit though. The limit is because of Earth's curvature. What? Okay. Is
Yeah,
this? I don't
is the
understand it.
air?
I have
Bro.
a question. I have a question.
Is it?
Like
Hold
a
on, hold
genuine
on.
question.
Is the air almost transparent or completely transparent?
Don't know. Is this like a semantic question?
Well, does the air have any density to it?
Yes.
So, do you think you would be able to see forever horizontally through the thickest part of the air?
That's why I said. That's why I said when it's. I don't get it. Are you saying that the air itself blocks the light from reaching through?
Yes.
My point still stands. I'm saying sure you won't be able to see a penny from like a mile away, but shouldn't the physical limit be adjusted for the size of things, regardless? Unless you're saying the physical limit is because of air.
Well, air is one of the key contributing factors. The longer something goes through the air, the more likely it will disperse, diffract, and eventually dissipate and extinguish.
Okay. So if there was no air, you believe we would be able to see things from really far away? It's like huge
I mean
things. There's no ocean.
that would be a theory, right? But you still have to deal with the angular size of things. That as things get further and further away, they just get smaller and smaller and smaller.
Okay, I just don't understand this. If all of science and almost all people say that the Earth is round, I don't understand why are you guys going against it? Like because you can't see the curvature of it currently? I mean, you zoom in enough on a circle, it's gonna start looking flat. Isn't that the whole point of calculus? Any curvature you zoom in enough to it, it's just gonna look like a straight line, which is why it looks flat.
The shape of the Earth has nothing to do with science. So if all of science says the Earth is ball, then they're in the wrong category.
No, it does have something to do with science. There is a.
What do shapes
I
have to
don't.
do with science?
Do you know what calculus is?
What do shapes aren't calculus?
Calculus is. Calculus is.
Oh, no. All right. No. Explain to us what
This is
calculus
like a
is,
very
please.
stupid question.
Yeah, it is very stupid.
No,
Explain to us what calculus is, please.
Can I explain calculus to you?
Explain in one sentence what calculus is, please.
Well, it's a study of. It's a differentiation integration, basically. Listen, you guys are going to tell me to explain things to you.
Whoa. Hang on. Okay? You're on to something there. Okay?
Yes?
It's a study of the rate. It's a study of how
change.
things change, right?
Yes.
Thank you. That's purely mathematical. Right?
Okay.
Okay. So how tie that in to science, please. Not in a way where you can tie it in where, okay, we use calculus to study things, right? But how calculus itself is a form of science, because that's what your argument stands on.
No,
right?
Whether this is a philosophical question. This is not what
No,
my
it's not.
argument stands for. You can ask
No,
what my argument stands
hang
for.
hang on, dude. Think about it, right? You were asked. Well, Sheepdog, you care to repeat your question, please?
My question?
What?
I'm asking what is.
No, for me. It was for me. It was for me. What science deals with shapes?
Yeah. So which scientific field specifically deals with shapes? And you said calculus.
Well, to be fair, certain people, whether math is a science or not is debatable. I believe again, this is all semantics. But my whole point was that
semantic argument.
with
Not a semantic argument. It's a categorical. There's a strict categorical difference. Okay. So when we're asking you, okay, what science deals with shapes? You invoke calculus. That is a false statement. Period. Calculus is not a science, dude. Okay. Now you can argue that it's a very rigorous study, right? That is highly used in scientific fields. There's no question about. But to say in and of itself, by itself, is a form of science, right? You're treading down the slippery slope of eventually maybe having to basically defend the notion that almost everything can be argued as being a science. Okay, so tread lightly.
Yeah, sure. Thermodynamics deals with. I didn't think you guys were going to take. My whole point wasn't what it's a science, whether it was a science or not. My whole point is we can't judge the things or whether it's round or not based from our perspective currently. Because don't interrupt me, please. I didn't interrupt you.
Hang on a second.
I didn't interrupt you.
Do you remember how?
I didn't interrupt you, and I muted you.
Do you remember how we got to? Do you remember how we got to this point in the conversation?
No, but there's a certain respect that goes on. I let you talk.
I can tell you. I can tell you. All right. You guys were talking about the shape of the Earth. You said something to the effect of.
I answered to your question. I'm trying to clarify my point, and you're not letting me clarify.
Yeah. You didn't seem
Is
like
this
you're
how
doing a good job. So let me help you, right? But you said all scientists or scientists agree, or something to the effect of something like
I
that,
said
that
most.
the Earth is a ball, the Earth is a sphere, and you were asked, what does that have to do with science? And you invoked calculus as being a science, basically trying to back your statement that it's valid for scientists to have a take on what the shape of the Earth is. Do you
No, my
recall
whole
that or
point. No. My whole point about perspective was that you can't judge how things look because if you take a circle and you zoom it
We're not
enough,
talking
it's going
about
to if it's
we're
going
not
to
talking
essentially
about
be a
Earth,
straight
man.
line. Is your
I have
whole
to correct
point
you.
just being like is your whole point zooming in on what I say and like on purpose
no?
misunderstanding? My point was
No, I
clear.
got you. I
And if
got
you're
you. Yeah, yeah,
asking
yeah.
if
No,
you're asking if
I
you're asking about a
understand.
science, there's thermodynamics that deals with shapes the whole time.
Okay,
But our
I
point
have
here
to
isn't what
correct
What?
you.
science deals with shape, right?
what the
I
hell?
have to correct you.
Thermodynamics deals with.
Oh
Can I
hell
correct him
Yes,
here
no,
real
it
quick?
deals with shapes.
Hold on.
Wait,
brother.
Let me
what
Go
did
for
correct
it.
you. Hold
Go
on.
for it.
Let me correct you. All right. When we're talking about
correct me?
shapes, we're talking about geometry. All right. We're not going by how it looks. We're going by measurements, right? We're going by arc. We're going by radius. We're going by diameter. We're going by circumference. We're going by pi. We're using all of these things that we know exist in geometry. We're not talking about science, right? We're talking about measuring a tangent over the edge, the circumference of a sphere, and then we're looking for the deviation from that tangent as you go distance over the sphere. That's all we're asking for.
Okay, how do you think this could be done with Earth? What is the measured flatness of Earth, for example? If it is,
That's
I
a
don't
good
know what
question.
shape you guys think it takes. If for correct me if I'm wrong, I don't know. Do you guys take it
It doesn't
to be as a
have to be a,
circle?
it doesn't have to
Okay,
be a
so
shape.
in the same way that you're questioning what science or what field deals with shapes, which is the one, which field you guys believe in that reaffirms that Earth is flat?
It's geometry, the lack of curvature, right?
And
If
I
the surface of
explained the lack of curvature. I told you
if
that the
the,
lack of curvature is that if you zoom enough on a circle, which or a
right,
globe or whatever,
right. How far away is the horizon from a 6 foot observer standing at the ocean?
how
How
far is
far is
the
the ocean? I'm sorry. How far is the horizon from an observer that is six? Sorry. How far is the horizon from a 6 foot observer standing at the ocean, at the water edge?
I don't know. How far is it?
Well, according to geometry, it's 3 miles away because they say the Earth is curving at roughly 8 inches per mile squared. Because 8 inches per mile squared, the parabolic function, right, calculus, uh, it it matches the geometry of a globe Earth with a circumference of 24,900 miles or a radius of 3,959 miles.
Hey, Nine, I got something in the chat for you. 59 minutes past the hour. Did you see the the three snapshots?
Yeah.
There you go. So if you're curious as to how all that was calculated, feel free to dive in there. And I'll
Okay,
post some
you
more.
still didn't answer the question. Which field of science is the one that you guys believe in, or I don't know if you do believe in it, that deals with shapes that then reaffirms the belief
It's
that
not
Earth is flat?
science. It's not
Yeah, dude,
science.
that was already answered, dude. This is
So
not
it's
a
math.
scientific.
So we're back
This
to
is,
math actually.
yeah, this is a geometry question, dude. You've been
Okay,
told that
so
at least
we're
5 times at this point.
no, I wasn't. But anyways,
Yeah, you
so if
were.
we are
Excuse
talking,
me. My apologies. It was 3 times. Okay.
okay,
All right.
whatever.
So yeah, this is a math question, bro.
Back to the point. I heard someone, I don't know who I heard, but somebody was saying that the you guys, oh, I don't know who this person is, but I'm not gonna say that you guys believe in the same thing that this person said. But they said that the reason they don't believe that the Earth is round is because of it doesn't look round right now. Correct me if I'm wrong, but does it have to look round for it to be round?
It's
No.
a good starting point, right? If you
I'm
look
just
at it and you
asking
say,
questions.
oh, Yeah. Think about this, right? If you go out and you see something and it looks flat, is that indicative of you that it's actually curving, or are you going to start with the question of maybe it actually is flat? Now, I'm not to say that you can't consider the possibility that it is actually curving, but just at a very, very shallow rate that you can't perceive it as curving. Now, that's not an invalid question to pose, but to say outright that, oh, it looks flat, immediately it must be curving, there's something wrong there, right? So when we look
No,
out and we
I'm
say,
not.
oh,
No. I'm not
yeah, I'm not
saying
saying
that
you're saying, I'm not
because.
saying you, hang on, I'm not saying you're saying that. I'm just saying, reaffirming what you said before to some degree, right? That if you heard somebody say they think it's flat because it looks flat, I mean, it's a very shallow answer, right? I would say, it would need further investigation, but to say that it could be flat since it looks flat, I think that stands as a valid statement, wouldn't you say?
I have to think about that. But okay, what is the one reason for either the rejection that Earth is round or the reaffirmation that the Earth is flat? You can give me either one reason or one reason for both. But like the one thing that is you guys believe is you can't debunk it or it's absolutely true, whatever it is.
Yeah, that's a good question, man. When we look out over the surface of water, because NASA shows us water, not water. NASA shows us the Earth from outer space, right?
Okay.
So when we see those pictures, we see all this blue stuff stuck to the outside because of gravity.
Okay.
So all that blue stuff is what?
Water.
And the surface of water, the very top portion of water at rest, is flat or curving.
It's flat.
It's flat. If it's flat, then welcome to flat Earth. Because if 70% of the surface of the Earth is made up of water, that 70% of the surface of the Earth is made up of water, and water is all flat everywhere, then the Earth cannot be a ball.
But this again brings me back to my main point. It looks flat doesn't mean it is flat. Like zoom in enough in a circle, it's gonna look like a straight line.
Right. Water's supposed to be curving.
Covering around the whole entire Earth, but you can only see such a small portion of it.
How
So if
much?
your whole I don't know exactly how much, but not enough to see all of Earth, and not nearly enough for you to make a assumption or belief based on that, I think.
So we have observations, right, of an Earth that would basically make it 10 times bigger. Not even 10, probably more than that. I think we got one observation that makes it where the circumference is 1.5 million miles all the way around, when it's supposed to be 24,900 miles all the way around. Like these observations are impossible. There's no way we should see this much if the Earth is a ball. Not only that, but we have lasers that shoot horizontally over the surface of the Earth, and lasers go straight for the most part. Sometimes they bend upwards, but for the most part they go straight. And what they end up doing is they end up hitting their target 10, 15, 20 miles away, and then I don't know what else to say to that, man. We're
I mean,
supposed
how
to.
does gravity work, flat Earth?
I don't know, but if the Earth is flat, then gravity only works flat Earth.
So everything else must be flat as well. Do you think the sun is flat?
No, we're not in a solar system, man.
What? What are we in then?
So here's the thing. Have you ever heard of the cosmic ladder?
No.
Right. So the cosmic ladder starts with the Earth being a ball, and then because the Earth is a ball, the Earth goes around the sun, and because the Earth goes around the sun goes around the Milky Way galaxy. Because the Milky Way galaxy goes
Okay.
around, you see how it works, right?
Yeah.
It scales up as like once you figure one thing out, you get the next thing. If the Earth is
Okay.
not a ball, the entire story is wrong. whatever's happening in the sky is only happening over a flat Earth. And sure, those planets may look spherical, but it's not in a heliocentric paradigm. From all observations, it looks like everything only moves above the Earth, and it looks like that we're basically like the floor of the entire universe. Whatever's going on, how high up everything goes, have no idea. Nobody's ever been that high up.
So
Oh
you'd
yeah,
rather believe that we are so far down that we can see a lot of things above us, rather than just believe that the Earth is round and everything that comes with it. That still doesn't answer my question though. How does gravity work?
I don't have a belief about the lights in the sky. I don't know what the lights in the sky are doing, whatever they are. I know the Earth is not a planet because, by definition, a planet is, in the old times, it was called a wandering star. That's what a planeta was. But a planet, by definition, is a celestial body, and we're not in the sky the last time I checked. So
That still doesn't answer my question of how does gravity work.
To look up in the sky and say, "Oh, Mars is round, so the Earth must be round. If the Earth is round, then Mars should also be terra firma." That's the most ridiculous thing I've ever heard in my entire life. I have no idea what Mars is. Whatever they're feeding us, I don't know. I don't know why they're giving us what they're giving us. But the images they show us don't match the real world in what we see.
How does
You've
it
never
not
seen
match the
the
real
Earth.
world if you see and you look up and it's round and then they show you pictures that are round?
I've never
So if
looked up
anything,
and
what you're
seen the
telling
Earth
me
round.
doesn't. You've never looked up in the sky at night or seen a star, the
I've
moon.
never looked up and seen the Earth round.
How are you gonna see the Earth round if you're in the Earth?
Exactly.
Wait, but we have photos from people that aren't in Earth. So you're telling me I can't say that the Earth is round because I haven't seen the Earth being round. But when people show you photos of the Earth being round, you're saying no. Well, how can I trust those photos? Right? They could be fake.
They told
So
us the Earth is a certain size, and when we went out and measured for that over distance, it doesn't match the story they're telling us. I don't know why they're telling
who's
us that
we?
story. All of us here, and many more
Yeah,
in the
but
world.
who's that? Okay, but who are the actual people that are measuring these things? And
All of us
by how are they measuring them? Like
going out over large bodies of water.
in measuring light or like their angle that reflected
No,
light is at, or
going out over large bodies of water and then saying, "Oh, we shouldn't see that because the Earth is a ball and the horizon should be getting in the way." And then we go out and we see the thing that we're not supposed to see.
let me get you straight. You're saying the Earth is round is because if you go, let's say, to the middle of the ocean and you look all around you, you only see water, but that shouldn't be right because of
That's not what I
the
said.
horizon. I'm asking
Nobody
you a
said that.
question. I'm not. I don't understand the point, dude.
I went to a lake that was like 9 miles wide,
Okay.
and I went and wrapped a bunch of reflective tape around my legs, right? Because I didn't have a whole lot of equipment back then. And then my friends did the same thing, and we both had binoculars. And we sat down on our butts across this lake, and we looked at each other through the binoculars at the lake. We had each other on the phone talking to each other, and we were waving to each other, and we could see our feet from across the lake while we were sitting down on our butts.
Uh-oh.
Okay. What is there to say that the lake wasn't more inclined at one?
Well,
Grow up.
if
What
I'm
was to
sitting
say
up
that the
on,
lake wasn't more inclined at one
because
spot than the other?
water is flat on the surface, right?
It water takes the shape of the surface that it's at. So we can't go back to water.
No,
It has to go in.
water takes the shape of its container, and the physics of water, as that water at rest with no other force acted upon it, will be flat.
Yeah. Okay. Let's say you take a balloon and then you take the inside of the, or take the
Oh,
outside of the balloon
you're
actually.
getting
Let me
away.
finish what I'm saying. Take the inside, take
You're
the outside
getting
of the balloon.
away from what
Put
I
like
was
a
telling you. Nine.
put,
You're getting away
oh my
from what I
god.
was telling you.
I'm
Please
responding to
listen.
that guy. I
All
am
right,
listening.
listen. So I'm sitting on my butt. When I'm sitting down, I'm about 3.5 feet tall. Okay,
Okay.
3 feet, 3.5 feet tall. From my eyes, when I look out over the water, the horizon should be roughly 1.7 to 2 miles away. But I'm looking at my friend 8 miles away, and there's nothing in the way.
Wait, you're looking at, I don't work with miles, but that's like way more than like 10 kilometers as far as I know, right? You're
All right,
seeing
so
somebody from 10
eight
kilometers
miles
away.
away. 8 miles away is roughly 13 kilometers, 12 and a half kilometers.
Okay.
So I'm sitting on my butt. I'm roughly under 1 meter tall, right? You
Aren't you
get
the
what I'm
same
saying?
person who said you can't see something, you can't see a penny from a mile away? Are
I
you
had
seeing something from 8
binoculars.
miles away?
I had binoculars, and I could see my friend sitting on their butt across the lake, waving to me.
Okay. And
Uh-oh.
am I supposed to believe you because
Um,
you, the
I
person
don't
who
want you to believe me.
believes
I
in
want
Earth
you to go
flat?
do it for yourself. This is something you could do. You could take you and somebody else and go to a large body of water, preferably around more than 5 miles wide, at least 10, maybe 15 miles. You stand across that water. Both of y'all have a mirror in your hand, and then you mirror flash each other. If you can see the mirror flash, either the earth is flat or you can see over 200, not even 200 feet. It'd be roughly anywhere from 60 to 150 feet of curvature, depending on how far away you are, if not more.
Okay, so you're saying that okay, and your proof that it's not inclined is because the water is flat.
Well, the water should be curving around the ball because of gravity.
Okay.
and to be
Okay.
clear, sorry, Ship, I just want to clear something up.
Go ahead.
And when you say incline, are you talking about like a slope, like
Yes.
a
It's
slide?
the
Okay,
definition of an incline.
water doesn't do that,
Yeah,
right?
but that doesn't mean the land underneath it isn't inclined.
That's fine. You can have an inclined
So
ground, but check
okay,
this out,
it
right?
was
If you take a cup, right? Take a cup and fill the bottom up with some substance, whatever, sand or what have you, right? And pack it up on the side of the cup so it creates that incline or that decline, depending
mhm.
on your perspective, right? If you pour water in the cup till it fills the brim, and you look through the transparent cup, you'll see that the water, where the water touches that substance, sand or whatever, it'll kind of conform to that shape, but the top of the water is still flat, right?
That's assuming that the cup itself is still flat. Like it's assuming that the
No,
inclination is
You
a
can
perfect
tilt
straight
you
line.
can
You can
tilt
still
a
have an
cup.
inclination that
what are you
You
talking
can
is
about?
tilt
not
a cup sideways and it would still be flat on the surface.
because the
Tilt it
we're
tilt
assuming
it
the
around.
end of the cup, the bottom of the cup is flat.
You can tilt it.
Because
So
the cup
you're
is okay. That my point is,
no,
you can
hold
tilt it.
on.
The
No,
water at the water at the top
no,
is still
dude.
flat, right? Can
The
you
water,
let me
the water
finish?
will.
We're still
No,
assuming this is
you're screwing it
okay.
up, dude. You can tilt the cup any which way, right? So it's to slant that slope that you created any which way. The water will conform to that slope, but the top of the water will find horizontal again.
It's worse than that. Look at a swimming pool. Look at a bathtub. The surface of the water is still flat on top, even though it's tilted. You could throw a boulder into a swimming pool or a bathtub, and the surface of the water is still going to be flat.
you guys got me questioning. Well, how you guys believe those are there? Like this is good. I'll
Well,
start
just
googling,
think,
but this is still
just
gonna
think of it,
be.
just think of it this way. If you shoot a tangent horizontally over the surface of a ball, eventually the surface of that ball should start to curve down and away from the tangent. And that tangent should be higher and higher up, right?
Yes.
Right. So we have laser tests. I say we, like the community has some people that have done laser tests with expensive lasers, and they have leveled the laser horizontally and found no deviation from the tangent. The laser is at the same height at the other end of 15 and 20 miles and more.
Okay, but I still have one main question that so far no one has answered. How does gravity work?
We did answer that.
No, you didn't.
And we answered it with a we don't know. Now, it
So
might
there's
not be as
one
satisfactory.
huge gap in the theory that you're trying to present to me, and I'm supposed to just be like, well, it's okay, we don't know that.
Well,
when other
well,
forms of
here's the
science
problem,
where
right?
it is believed that the
No,
Earth is
well,
round, this gap doesn't exist.
yeah, I got you. Yeah, so here's the problem, right? So they operate, more often than not, people will operate on the assumption that gravity is caused by mass attracting mass. Or in other parts of the community, they might assume that mass bends space-time, and that somehow makes some sort of invisible, four-dimensional funnel or whatever that basically draws masses together in some way, shape, or form. I might be butchering the terminology, but that's in essence what people believe, right? Now, and I emphasize that word believe because that's what it is, right? The math checks out in the way that it's framed, okay, and it does seem to correlate with some observations, but those observations also have underlying assumptions that are basically fitted to make the math kind of work in that instance. Like, for example, they might look up in the sky and see little lights, floating around and assume that these are giant bodies with massive, basically massive volumes, that basically the thing weighs a shit ton, quote unquote, weighs a lot, so much so that it'll attract other bodies, right, that also weigh a lot or whatever. And then they kind of pipe that through the math and it checks out. So they reaffirm this belief that that's the way to go. Now, if you're going to harp on us because we're not going to present to you a belief system as to how things kind of tend to fall to the ground, or why things tend to fall to the ground, well, that's on you. But for whatever reason, you're more than inclined to trust them, despite them never showing you any evidence to support their claim. Right? So when we
No,
openly and
they
honestly
have
tell
showed
you
me
we
evidence.
don't,
I'm just not
or what,
rejecting the evidence.
really, okay, what evidence did they show? Please do tell.
Photos again? Like
Photos of gravity? What are you talking about?
No,
We're
I
talking about
meant
gravity.
of photos of Earth. Oh, gravity itself.
We're talking about gravity. Okay.
Sorry, I was typing in the chat as well, but
Yeah, focus.
Okay, the definition that I was using for gravity is the one that was discovered like a long time ago, and that's the one that would explain why things fall to the ground. You tell me why I shouldn't believe in that, or why you don't
I'm
believe in
asking
that.
you who demonstrated to you that is actually accurate representation of what's going on. Who proved it to you in the first instance? Right? Because let's clear something. Let's clear something
Okay,
up, right?
it's not
Right?
so
If I
much that this person is proving the definition.
hang on. I just want to clear something up, right? If I take a rock, I pick up a rock, I hold it in my hand, I extend my arm out with the rock in my hand, and I open my hand, the rock is going to fall to the ground. Okay? That's it. That's observable. It's repeatable. We understand that phenomena. Okay. The ultimate question is, why does it fall to the ground? Some people will posit that the earth is pulling it down, right? Others will posit that there's like some invisible fabric through which everything kind of just tends to, move together or whatever as a result of all these different bodies merely existing in that fabric. Okay. Like these ideas, they're out there. Okay. Now I ask you, who has proven to you that any of these ideas are actually valid explanations of what's going on and why the phenomena that we witness actually happens. Because the phenomena is the phenomena. Take a rock, you let go, it falls. And we can measure the rate at which it accelerates downwards. That's not in contention. Some would argue that different things fall at different rates because of their density, yada, yada, yada. We can get into that. Okay. But the underlying, the crux of the matter is the assumption that there's a magical force, quote unquote, that's pulling shit down, or from another angle, pushing shit down. Okay. These ideas, we need evidence for that. So we ask you, or I ask you, who presented any of this evidence to you in the first place?
Okay. To answer that question, we're gonna have to take a small detour. Gravity is only one of the form of attractions that happens between two oppositely, or the same thing that happens to gravity. The same equations that work for gravity are the same ones that work with electricity and magnetism, right? So from that alone, right?
Excuse me, sir. I'm not interested in your detour. Okay, I'd like a clear, concise answer as to who presented you any evidence, right, to corroborate their story that there's a magical force that pulls shit down. If you can't name a name, that's okay.
If you let me finish, maybe you would understand.
I don't need your roundabout way of saying I don't know who actually presented anything, but all these things seem to line up.
My whole point is nobody needs to present me anything.
Oh, thank
nobody
you.
needs
So no
to
one
tell
needs to
me,
present
hey,
you
Nine.
evidence. Thank you. So you don't need evidence from those who tell you something.
Personally. No.
Yeah,
you don't
exactly.
need to present it to me. The point is to me. The evidence needs to. Listen, this is not a proper way to have a discussion with someone. I don't know who made you believe that this is okay.
Yeah, you're damn right about that.
No, if somebody's actually curious in the topic.
Hang on.
If somebody's actually curious in the topic.
No, you're not going to do that, dude. Okay, I asked
you. What about asteroids?
Hang on, dude. I asked you, Nine, who presented you the evidence. You say they don't need to. That's all we need to know. Okay? So when you come in here and basically underhandedly slight us because you think we have we're operating by some belief system or something like that, and then we demonstrate to you that you actually are the one operating by a belief system. Okay? Like, come on, dude. Think twice before you speak, all right? You're unmuted. Okay?
No, that's not okay. My point is that they don't have to present this to me. My point is that the same equations that works for gravity are the same ones that work with any force of attraction, whether it be electricity, whether it be magnetism. So by that, if the same equation that work for gravity work for electricity and magnetism, and they can prove to me that hey, positive and negative have attraction, and they can prove to me that oh hey, look, south and north have attraction, by that logic, and if the same equations happen to work, then I don't need them to present to me that gravity works by itself. So I'm actually genuinely curious about this. I wasn't trying to be harmful. I wasn't trying to be like offensive or anything. But you keep. No, dude, I'm not interested in this anymore. I will have my own. I will go do my own research. But you guys have a great time. All of you guys have a good one.
Take it easy.
It's crazy, man. I need an explanation for everything in order for me to change my mind.
You heard him, right? They don't need to present the evidence to me. It seems reasonable because of the other stuff that I've seen. Now, I didn't even state that they actually presented them any evidence for those things either, right? But that's neither here nor there. They don't need to present the evidence to me.
Don't the masses cancel each other out anyway, and it just becomes 9.8 meters per second squared?
Hey, I missed that.
No, I'm saying that don't the gravitational in the gravitational equations, don't the masses cancel each other out, and it just becomes 9.8 meters per second squared?
That's the acceleration. Yeah, the standard.
It's 9.81.
9.81, yeah. Fair enough, whatever. Yeah. So I was trying to tell the guy, it's like, yeah, we can measure that. It's not a problem.
I just came in. I just have a question.
That's happening.
Go for it. What's your explanation for a difference in say a bowling ball and a feather falling at different rates in air, but in a vacuum they fall the same. What do you say about that?
Yeah, why would they fall the same? If one has more mass than the other, shouldn't the bigger thing, the more massful thing, accelerate towards the more massful thing?
Oh yeah, but I mean, how would you explain that? Like, what would be your explanation for them falling at the same rates with no atmospheric drag? Holy shit!
I have a take on that. So this is I haven't confirmed this yet, but I suspect the following. Right. So if a bowling ball, right, your average bowling ball is made up of a certain composition, right?
Yeah.
Largely made up of, let's say, carbon, right? Some sort of formula, some petrochemical, that's largely carbon based. Then you have a feather that is also predominantly carbon based. Okay. If it is understood that things falling at different rates can be attributed to their various densities within the same medium, well, a feather and a bowling ball falling at a similar rate because they're actually more or less made of
it wouldn't be just like
composition.
densities. Like it would just be like also the feather
Right.
having more atmospheric drag for the surface. I mean if it's unless you have like
In
a
a vacuum,
massively difference in size, but like for the same general
You're
purpose,
talking about
right?
in a
Like
vacuum, right?
what's that?
You were talking about in a vacuum, right?
Oh no! I thought you were saying never mind. I thought you were saying
No, in a
outside
vacuum. In a vacuum.
Okay, say it again. I had trouble hearing.
So in a vacuum, yeah. So in a vacuum, where there's basically almost no, atmosphere, no air, right? That would have that impeding factor on the feather, right? The drag and all that shit, right? Where that is limited, you're left with these two objects that are more or less, not exactly, but similarly composed, right? And if it's understood that density has a big role to play in the rate of acceleration, and they happen to be of similar densities, well, you put two and two together, and it's not far to see, or not far to suppose as to why they actually fall at similar rates.
Did you say the feather has similar density as the bowling ball?
Yeah. No, this is a suspicion of mine, but everything else that has been spoken about in here tends to corroborate with that.
How do you make the feather have the same density as the bowling ball?
Acceleration. You have weight, mass, gravity, force equals mass times acceleration. So the mass cancels out, and the acceleration is gravity.
But see, that's a very
talking to me or him?
Yeah, I hear that, Dylan. Now, it's a very simplistic way of looking at things. Okay, there's other evidence that would suppose that the density actually has a part to play, where some objects that are denser or less dense will fall at different rates. Okay, now if you go by that, we could speak about that. Okay, but under that sort of framework, right? Observing the composition of the feather and of the bowling ball being of, more or less the same, not exactly, but largely carbon-based, predominantly carbon-based. Well, if carbon has a specific rate of acceleration downwards in a vacuum, well, put two and two together,
Yeah, I don't know if that would. Yeah, I understand what you're saying, but I don't really think that's the answer.
Well, if you saw the other stuff that I'm kind of like glossing over there, that it might be worth your while to check out. If anyone has the Bremen drop tower stuff available, that could be very helpful. I don't have it on hand, but there's a test that has been done in a sealed container dropped from a very high altitude. Right, the container itself is vacuum sealed, and inside they've got, I think, 8 or 9 various elements, from lithium to aluminum to also all sorts of shit. And you see that in the field of view of the camera, that these objects are kind of floating up at various rates, indicating they're actually falling at different rates because the whole thing is falling. Right.
Does anyone have a source for that? I couldn't find. I could only find the video that you guys have. I can't find it anywhere.
Yeah, the GIF is widespread. The original video on YouTube from which that GIF was taken, I don't have it on hand. I have seen it, but I didn't save it.
Well, I was hoping since the Bremen drop tower is like a science lab that there would be like a paper or something.
There was a paper I wanted to.
Well, I mean, like authenticated paper or just like a random paper found online.
I mean, I would take a random paper. I can't find anything.
Yeah. Well, the guys who did the test published a paper with their findings.
Yeah, I understand what you're saying, but and I mean, you've been polite to me, but like that wouldn't fly with anybody else in this room. Like, there's definitely a paper somewhere. You'd get yelled at. You'd get shouted down.
Yeah.
It's crazy.
I don't have it on hand, dude. I already told you that.
Yeah.
You don't have to take my word for it.
No,
right?
I got you.
But,
No,
but you
I'm
asked
not
the
saying
question.
I'm not saying you're being
Yeah, yeah.
disobedient.
I'm just saying, right? I'm trying to highlight. You asked the question. This is my answer. Wish I could maybe fulfill that answer or that question a little bit more with material, which I don't have on hand.
What was the video?
There's a drop tower. I think it's in Germany. It's called the Bremen, Bremmin drop tower.
BRE.
MMIN. And there's a, I think he might have been a Swiss guy that performed the test. I don't remember exactly, but he had a obviously European last name. But anyway, point being, this is what I think, and there are probably other views in the room.
I think I found
if you guys want to add anything onto that.
There's a German website that has it.
Thank you, Didi. I misspelled it. It's BREMEN.
Is this what you're talking about? This German university?
Yeah, in text chat.
I just sent it.
Perhaps, yeah. Debate Daddy posted something for you if you want to check that out.
I think it is. I think it is what I was supposed to do. German university.
Yeah, it looks like you posted a link to the institution's website itself, I think.
So the video is from the university that I posted. Is that what you're saying?
No, what I'm saying is the link that you posted is a link to the actual institution who runs the facility.
Gotcha.
Right. What we're talking about is a test that was performed in that facility. And I wish I had it on hand. I'll try and find it for you.
Yeah, Debate Daddy posted exactly what I was looking for. Thank you.
All right, I got you in the chat. Good sir, whatever your name was. Naxi. Yeah. 35 minutes past the hour. Quick video. I think it's maybe 30 seconds long.
Under you? 35, 20. Oh yeah, I'm on the website now, but the website's really vague. I'm trying to find the actual article or source from the website itself.
Yeah. Again,
like,
35
it's like,
minutes.
Again,
like
I'm just trying to find more information that whatever's posted. I'm watching the video you posted, but it's like
you
10
saw it?
words.
Yeah.
Yeah.
Oh yeah,
But
it's very brief. It's very brief. Yeah. It's
Yeah.
just the actual demo itself. The
Now,
paper on it, that I have to find again.
is this container a vacuum drop through air, or is there
the container itself is sealed off, and inside the container, where all the elements are.
Now, are these elements inside little containers, or are they raw elements themselves in the vacuum?
It's all in one giant container that has been vacuum sealed, and there are little plastic, right?
Well, this is what I'm asking you. Is so you have the container. The container is a vacuum. The raw elements or materials are within little, let's say, these little containers themselves. Correct? Are those?
I don't think.
Well, that's what I'm saying.
I don't think so.
Is it raw elements, or is it elements within a container within a container?
Oh no. Okay. Picture this. Picture a giant tube, like a giant tube that's like multiple stories tall, right? In that tube, you can drop shit. What these guys did is they took another container, vacuum sealed that container, and dropped that down the tube, right? Inside that vacuum sealed container are little pieces of all these different elements. Right. It's just very interesting. That's all I'm gonna say.
I got you. I mean, listen. I don't believe Earth is flat, but if there's something I can explain, I'll look it up.
Well, this is nothing about flat or round or anything, right? It just kind of a bit of a hole into the I guess overall assumption that many of us have that everything falls at a consistent rate. You know what I mean? That's just this one uniform acceleration that applies to everything. That's not necessarily true, at least based on this. It puts that into question. Let's say.
We do calibrate scales to have a different level of acceleration in different latitudes. I showed that a while back. So it's not always 9.81 or whatever. It changes based on your latitude and your altitude.
Hey, 20, you there?
Yeah, I got it.
Yep, that's something I've always wanted to know. With this relative density or specific gravity, there is a relationship between the density of the two mediums, the one that we're in and the one that's falling. Now, if we were to reverse the densities of the two, so basically have the same difference but the opposite way around, would the item go up at 9.8 meters per second squared on average?
I don't know.
Because if it did, they could kiss their gravity goodbye.
Maybe, but one thing I would suspect, though, and I think this is probably something almost everybody can test, is if you get a body of water, like a pool or whatever, and take various pieces of elements that are buoyant, piece of wood, a basketball, what have you, right? and hold them underwater at the same depth and let them go and see it and try and measure the rate at which they rise.
But I like the line of question there, Matrix. I guess we'd have to try to get the ratios similar, right? That's a pretty interesting question.
Correct. So it's just a matter of just having the same ratio, but just the opposite way around, where the item is the lesser dense of the two, but at the same ratio.
Yeah, that's what I was kind of arguing when people talk about this vacuum drop test. I was in just side chat I typed that to 20K that, you know, when you remove the medium, the ratios become closer between light object and no medium, you know, virtually no medium, and heavy object and no medium. Those ratios become closer than they do in just normal air.
Hey, is 20K up still there?
Yeah,
20K.
Well, hold on. I just want to point something out to Boogie. Do you mean the ratios between the objects to each other, or do you mean between the object, any particular object, and the medium? Because to me, it would seem that ratio approaches infinity, right? You have an object of X grams per cubic centimeter or whatever over the density of the air, which is approaching zero, right? So you take any number, you divide it by a really, really small number, it gets massively big, right? It gets bigger and bigger as the other number gets smaller and smaller, right? So all of them are approaching infinity. So they're right. So you basically neutralize the ratios between all the objects and the respective the surrounding medium by basically nullifying it out by basically making that ratio the same, and then you make that test, whatever you're doing, a little bit more on neutral ground, so to speak. I can see where you're coming from.
Yeah, it's just a thought I had, just something I was thinking about. But yeah,
Yeah,
that is interesting, and I liked what Matrix was saying. That would be cool to measure what these ratios are, and then try to invert them somehow in a lab setting.
20K still there?
Yeah, go for it, dude.
So I'm really trying to find information. It does feel like this. I mean, it was in 2004. It's like it feels like it's non-existent for like whatever paper it was written in. But I believe you, it definitely happened. Obviously, I just can't find much. But what I did find, it says that it's a near vacuum tube with another container that had 1 atmosphere inside the container. So there wouldn't, if you're going by the general understanding of gravity, wouldn't there still be an effect? Wouldn't that not disprove what you're saying? And if there's an atmosphere, it's not a near vacuum inside the container itself being dropped, and it kind of, the way it looks in the video, at least, that they're affected unevenly. It does kind of look like they're affected unevenly because there's atmosphere in there, and there's still a small amount of drag affected on them. Now, unless you're saying that's not how it is, but that's what I could find. But
I don't think so. I think yeah, I hear you, dude. I think it's the other way around. So the tall tube itself is probably pressurized to 1 atmosphere, and then the small container with all the elements inside that big tube, is vacuum sealed. So they can control the environment to some degree, right? Through which the capsule is actually being propelled.
No, the whole point of the drop tower is to evacuate the entire chamber, so you can have an unbiased free fall.
Okay, so what this guy has said, he found they pressurized something.
Yeah, just what I'm reading is that the outside is near vacuum, but inside the container has an atmosphere being dropped through the vacuum, is what I found.
Oh shit! No kidding. Can you send that? I might have it backwards, dude. If that's the case.
Let's see. But that's
inside
what I'm saying,
the container there,
go
you
ahead.
can see the little like tubes there containing each rock, each material. Those were not vacuum sealed. And then also, like, if you look at the screenshot I posted, you can see that one of them is like already far off. The far left one, it's some of the others are still at rest, and that one just got released early. Like, it got the release mechanism wasn't perfectly timed. So like,
Okay. Well,
just look
it's
at it.
not
It
alone
has
though.
so much of a head start,
Well, it's not
which
alone though. Look at
invalidates
the
the
one.
test.
There
No,
is
it
no
does
release
not.
mechanism.
Hang on,
Debate,
hang on a
debate, debate.
second.
Me and you are
Hold
probably
the
on the same
fuck
side, but
on.
I don't think there's a release mechanism
Hold
on those. I
the
think they're free
fuck
float. I mean, I
on.
think they're just sitting there
No,
naked
dude,
for
yeah,
a while.
hang on. Bro, hold on. Debate day. Did you miss the one on the far right too? How did they both have a head start if one was biased? What you
Yeah,
think? Like
well, no,
someone
you
like
can go frame
nick
by frame
something
and
on the
see
side of the thing?
some of them
Yeah,
don't even move, while others are moving
yeah.
already.
Well, here's the
You'd
thing.
expect
How
all
do
of
you
them
know?
to be moving, just at different rates,
Well,
if your thing
yeah.
is
Well,
true.
here's the problem. How do you know that the ones in the middle are not actually moving, but at such a small rate that it hasn't been? It's not capturable by the camera. How do we know that they haven't lifted up a quarter of a millimeter and you just can't see it? We don't know. Look. I'll give you this. There's a lot of uncertainties about this test. It's up in the air, but they just basically hand wave it because you think you found something, offhanded. Like, I mean, I don't know if that's very
You can go
very
frame by
honest.
frame.
Okay.
Have you gone frame by frame? Like, it's
I have not.
pretty clear.
Have you?
Yeah, like, it's pretty clear. Some of them are moving while others are not. Like, you can look at it.
Okay, fair. So
Exactly. It shows the difference in all the mediums. Of course, some are not going to move and some are going to move. It's showing that they're all at different rates. You guys claim that they are at similar rates. They are not. We can see that. Thank you for highlighting it.
I'm going to
But
post
debate.
20K.
It sounds like it sounds like he's trying to throw a wrench in the gears and basically try to invalidate the entire test. Hang on, dude, I'm talking. Right? It sounds like the debate guy is trying to invalidate the entire test and just sweep it aside with some suspicion that there's some like anomaly, like I don't know, some guy knocked the side of the container on both sides evenly, so these two things have a head start and the other ones don't, or some shit like that. I've heard this before. It needs follow up. I'll grant you that. Okay.
So, all right. So 20. Okay.
Go ahead, dude. Sorry about that.
So I just posted.
Can I just quickly say, like,
okay,
like the fact that the tubes themselves aren't pressurized or like vacuum sealed, it basically just means that it was pointless doing it at the Bremen drop tower. Like, it would have been the whole thing fell, but the individual ones, like, relatively would have had the same outcome if you just dropped it off someone's balcony.
The link I sent 20K is from European Space Agency on the Bremen Tower, and the tower itself, that part is the tube it falls through is near vacuum. But
okay, very good.
The capsule is specifically designed. In the second paragraph, it says it is pressurized to normal atmospheric pressure and temperature. 3 capsules are available: short, long, and catapult. So that means they're set. At least this is saying that the inside was atmosphere, outside was vacuum.
Okay, fine.
So they could still
very
be
good.
affected by our version of gravity and
Well, hang on. Well, here's the thing, right? So if there is atmospheric drag on the inside of the thing, it's obviously not enough to impede the rate of acceleration of any of the different elements on the inside.
Well,
right? My system was
if there is drag on the inside, it would change. It might not be as dramatic.
Oh yeah. You're right. It would change, right? The more pressure on the inside, the slower all of the elements would accelerate upwards. Right.
But so
if there is pressure, there is pressure on the inside, right? If there was no pressure on the inside, the difference would be much more dramatic. So the fact that we do see a difference, even if it is pressurized, okay, it goes to show how big of a deal this is. You don't need something sophisticated as a completely vacuum sealed chamber on the inside, right, where all the elements are, to demonstrate such a phenomenon.
Well, what's confusing is that I know this is hard to get a hold of. It seems like, but
it seemed like everybody was so sure 15 minutes ago about this, because I've seen this posted before, but it was a long time ago. Everybody was so sure that it's absolutely complete near vacuum on the inside, and sorry, my mic went out. That it was the other way around. That it was no vacuum on the inside, dropped through a atmospheric tube, right? So it's not that. So it's not that at all. It's actually completely, because I've heard it through here before. So it's completely wrong.
Yeah.
Going by the space agency and the university itself. So
that's fine, dude. I actually appreciate that. I know. I very much appreciate that correction. Now, the thing, what makes it interesting though, is that it adds to our case though. This is actually a breakthrough, at least in my view, because the thought was the inside had to be vacuum sealed so as to actually be able to accentuate the differences in acceleration, right? But it's evident that it does not need to be the case to demonstrate the differences in acceleration because it's not vacuum sealed. So it just means that the entire capsule that was dropped fell at a more approximate free fall speed, and on the inside it was just left to average conditions within that entire thing that's going down at more or less free fall speed. Fair enough.
So what I could find is the purpose for the do you know what the purpose for the experiment was?
The explicit purpose of conducting this, I'm not aware.
So what I'm reading is that it was to judge the reaction of materials in microgravity.
Okay.
So wouldn't that mean that, again, we still have an effect of gravity on atmosphere on these raw materials? I forget what was it, like zinc, copper,
sure about that.
or whatever it was.
Yeah. Zinc, copper, lead, aluminum, also. Yeah.
So the differences in their moving, like how one, like there was no release mechanism. I probably agree with that guy on the main point, but there's no release mechanism. I think they were just sitting there raw, right, just by themselves.
Yeah.
But so, like I said,
so if
you had one,
no release mechanism?
No, like there was no, like there's no, the materials themselves were sitting there free, not the actual container. Yeah. Like I don't think the left, whatever is on the left side, I forget. It kind of started quite a bit. It had like an inch or so above everybody else. I would say that now that we know that there's atmosphere in that container, that's fine. It doesn't, it's here nor there. It doesn't really matter. So both of those two, whatever materials they were, whatever element, those two reacted to the atmosphere inside in a microgravity environment, right? Because like near vacuum doesn't, it's not a complete vacuum. It's as close as we could possibly get it, right? There's still a margin of error.
Sure.
So I would say that it's not proving your point.
Sounds like you're making excuses, bro. Seriously.
I mean, we're having a conversation.
You might not understand what we're putting down.
Okay,
right? Because everything that you've said, like I have no contention with anything that you've said, except for what you're positing that somehow what you're saying nullifies or goes against what we're trying to say.
Okay,
that
well,
part,
then I misunderstood. Can you explain again? Now that we know that there is atmosphere affecting these materials, why does that help the case?
Right. Well, it doesn't necessarily help or impede the case. Okay, I would argue personally that it adds to our case, but that's neither here nor there. The whole point was to take a variety of elements and drop them and measure their rate of acceleration up or down, or the differences in their acceleration up or down, if there were any. Now, traditionally, one would suppose that all these things would accelerate downwards at the same speed because the acceleration downward caused by gravity, so to speak, right, is uniform and affects everything the same way, basically. All the things would basically be at the same elevation, if any at all, unless they all stayed on the ground.
Now,
right?
Wouldn't that be in a complete vacuum, not within a vacuum with an atmosphere in the vacuum moving?
So in a pure vacuum, they would theoretically accelerate all. Excuse me. Yeah,
right,
check this out. Check this out. Watch. In a pure vacuum, theoretically, they would all accelerate down at 9.81 meters per second squared.
Yeah.
Okay, because that's the standard. Now, in a pressurized environment with air or whatnot, right? that would impede the rate of acceleration or have some sort of effect on it. I'm not too sure which way, up or down, or positively or negatively. Right?
Well,
I think if the
whatever.
air below it,
I mean,
if
whatever
the air
one happened.
below it, yeah, if the air below it, watch this. If the air below it was pressurized, then that would slow the acceleration downwards because there would be drag and all sorts of stuff. Right? That's fine. Okay. But also on the inside of the capsule, if it was completely depressurized, there would be no impedance for the things to accelerate upwards. Like there would be no negative drag, so to speak, either. In this case, it was pressurized, so there is a quote unquote negative drag. It's probably not the right terminology for it, but you know what I mean. When I say
I
drag,
understand what you're saying.
you're going downwards and the air down below you gets in the way, so it drags, it pushes you upwards, so to speak, or it slows you down from accelerating downwards. And likewise, if there's air above you, that you would be tending to go upwards with respect to your surrounding environment, right? If that gets in the way of you going upwards relative to your environment, well, that I'm calling negative drag. Okay, it's probably not, again, it's probably not the right terminology, but you see what I mean, right? So in the capsule, because there is air, there is an impedance for the things to accelerate upwards with respect to the camera, right? But they still do accelerate upwards with respect to the camera, despite that, right? So my thought was, if it was completely pressurized on the inside, there would be no impedance for the things to accelerate upwards, and therefore that's why we see it. But now that we know that there
I think
is
they're
an
accelerating.
impedance,
I think they're accelerating upwards because you're dropping a container
exactly,
that's being influenced.
Yeah,
But
what's actually really happening? What's
but they're
actually
still
happening
falling.
is
They're
they're
still falling.
what?
It's the differences
Oh
in the
yeah,
containers.
yeah. Of course they're still falling, dude.
Yeah,
That's the whole point, right?
yeah. It's
The first thing is that by them going upwards in the field of view of the camera, it means that they're accelerating downwards at a slower rate than the rest. That's the argument.
yes. The container itself is accelerating downwards faster because it's in a vacuum. The material itself, though, is in an atmospheric container, so that has atmospheric drag on it. So, what I guess I'm having a hard time because and this isn't like coming at you, but like people that have said it before and 20 minutes ago, the fact that they were all moving at different rates proved the case because there was no vacuum in there and they moved at different rates. But now that we know there's atmosphere in there, all of a sudden it still proves the case. It's like no matter what, it proves the case, which is it's kind of hard to follow now. But like I said, it's still
I see what you mean.
it's still an atmosphere though. So like the real answer to this is just if we took a vacuum and dropped them in a vacuum and they went at the same rate. Like I don't think this experiment is the one to die on, in my opinion. You know what I mean? Like it just doesn't. Now that we know the real cases of it, I don't think there's a point to even like use this one as a prop to show.
I still do though, to be honest with you. To be honest with you, I think it works. I think it works either way because you have different pressures, right? So the surrounding environment is depressurized, so the entire capsule has the ability to fall at a faster rate than anything that is pressurized, i.e., what's on the inside. So if the entire capsule is falling at a faster rate than what's on the inside, and we can still see what's on the inside falling at a different rate because they're rising up, right? If think about this, if the entire capsule was falling in a similar or the same environment, pressurized environment as what's on the inside, one could maybe suspect that these differences, if any, would basically not be apparent because the entire has a similar rate.
You could just, I mean,
right?
to finish this off, you could just take again another tube in a vacuum and then put these materials in another container within the tube that's also a vacuum and drop them. They would probably drop exactly how we're saying they drop all at the same time. They'd probably stay on the bottom of the container without it flipping around and causing an issue, right? Like if it was a perfect straight drop down, they'd probably all drop at the same rate together. Again, I think adding the atmosphere, but that would be one you could do in your kitchen, I guess. I mean, or 10 feet out in your backyard.
I mean, well, I think the whole point of this, dude, is because the differences in acceleration are so minuscule that you need such a wide, or excuse me, such a long distance to drop things to be able to actually notice any of these minute differences. Like if one is falling at 9.8 meters per second square and the other one's falling at 9.82 or 9.81, the other one's falling at 9.79. Like you're not going to notice that. on your tabletop,
Well,
right?
well, I mean, if you're looking for a very, very precise measurement, but like say even in your like high school, college class, right? Like, have you ever done like a vacuum experiment in like a high school science class, right?
Not a vacuum.
Yeah,
The closest we got was taking a bowling ball and a feather.
okay, but so like if you dropped a coin and a bowling ball in this vacuum, you could still see generally, right, in the high school setting, that they both hit the ground without floating. You know what I mean? Like the
They
feather,
don't.
sorry, the
Yeah,
feather.
they don't flutter down.
Yeah,
That's a
yeah.
course.
So, but so I'm saying like you could still do this experiment and just kind of generally be like, okay, like we see them both hit the ground at the same time. I mean, you can measure it down to the precise like meter per second or whatever you want to do. But
Here's the problem. Yeah. Well, here's the problem that I've seen, right? On such small scale, any sort of differences, if they do arise, can be attributed to human error. Right? These two things fall, and they're like.
Okay. I mean,
one,
yeah. I mean, okay. So you build a release
different,
mechanism that's timed
one guy let go, half, 1/100th of a second sooner, all sorts of shit like that, right?
Well, yeah, but that error would be so minute. If you say you went to 9 feet in the air in a classroom setting, and you dropped a bowling ball and a feather in a vacuum, if it was a vacuum, near vacuum, they would still fall. I mean, unless you literally held it for like 3 seconds, there'd be a delay. But if you were within like a couple milliseconds of each other, right, it would still be observable.
But
you know what I mean?
This is the point. Well, this is the tricky part, right? If you're under the assumption that everything is going to fall at the same rate, and you drop two things, and they're actually at different rates, but they fall and they hit at the same time, well, that confirms your bias, right? Even though they actually didn't necessarily fall at the same rate, but you actually let them go at different rates, but it confirms your bias because they hit the same rate. The converse is also the case. If you let them go at different times, even milliseconds apart, okay.
Well, no,
and
you would account. You would
fall at
account for the
different rates,
error. Well, I mean, no. I know what
if
you're
you
saying,
can,
but I think that's facetious a little bit, right? Because
well, no, but my point is, dude, in a tabletop setting in a classroom, right? It's not of a sufficient scale to really be able to take differences.
Yeah, but if you drop the feather from 10 feet and a bowling ball, the feather's hang time would be dramatic with atmosphere. But in a vacuum,
well,
right?
wait, hold on a second, though. All right, what we were talking about before, even in a classroom setting with a 10-foot tall vacuum, right, and you drop a bowling ball on a feather, I mean, that's already been kind of sussed out. My suspicion on that is they're composed of the same material, same sorts of underlying material,
I mean,
predominantly.
Okay.
So they're going to follow similar. That's my view personally.
Are you saying they're all just atoms or carbon?
Yeah, feathers. They're mostly organic material, which is highly carbon based, and then you have petroleum based, products that are also primarily carbon based to make bowling balls.
And say it again. Right? You said they're falling at the same rate because they're similar materials or
similar composition.
Inside a vacuum or outside a vacuum?
Inside a vacuum. Outside a vacuum, right? The differences would be noticeable between the feather and a bowling ball because largely attributed due to the drag.
Yeah.
Right.
What kind of difference between materials are you expecting? I mean, what kind of precision would you need to be able to determine that like these two different materials are falling or accelerating to the ground at different rates?
I don't have any way to quantify it at the moment. What I'm going by is the demonstration that we've been talking about for about 15 minutes now, where it shows there are differences between materials. Now, I haven't looked into it precisely as to which one is more denser than the other one. I think it's a mix, right? It's not.
I mean, a bowling ball is denser than feather.
Is it? What's the density of the composition of a bowling ball?
No, I don't know off the rip the exact measurements of a bowling ball, but I mean, like you could obviously see there's.
You're asserting that without necessarily having the backing. This is why I'm saying I don't know. I haven't looked into it.
I mean, you could say there's obviously more atoms in a bowling ball than there is a feather.
Are you not asserting that objects of like different composition or different density fall at different rates?
This is what is being posited. The possibility that different elements with different densities fall at different rates. Yeah.
You are positing that, right?
Right now, yeah, and backed by this demonstration in the chat that corroborates it. So what we're talking about at what time was it at? 35 minutes past the hour I posted the original video.
So like
But what we're talking about here, right, between the bowling ball and the feather, one of the reasons why they fall at the same rate in a vacuum, I suspect, is because they're composed of similar underlying material, largely carbon based. Carbon has a certain density, therefore, one would expect it to fall at a different rate or at a similar rate.
Would the inertia needed for to move the bowling, like the bowling ball takes more power, like more pull to move faster, right?
Sure, but in this case, we're talking about dropping, right? So they're both suspended, and they're both released at the same time. There's no exerted force to get them.
Well, I mean, if you're saying gravity affects it, would that cancel? I mean, the math I read says it cancels out, right? So would you say it doesn't cancel out? That the inertia and the mass cancel each other out, and it brings them to the 9.81.
I'm not sure I followed it. What we're measuring, right, is the rate of acceleration. Right? You take an object, you let it go, you take time t0, t1, t2, you see the differences in distance between each successive t, right? And then you can plot how fast it might be accelerating. This is all we're doing, right? We're starting from what I'm trying to do here is elucidate the importance of starting from first principles, right? All we know is that these things, obviously, they weigh different amounts, but you put it in a vacuum. Arguably, that shouldn't matter, right? Because they're falling through a medium that arguably, in effect, doesn't actually exist, right? This is the whole point of it. So we have objects of certain specific densities, specific weights, right? And as it sounds like, it turns out, the weight doesn't matter. So what we do have left is composition of each of these materials. Oh, they happen to be very similar. That's very interesting. They're being let go from the same height and they hit the ground at more or less the same time. Well, that's very interesting, right? So it might have something to do with the composition of the material. That's all I'm saying, dude. It's corroborated by what we were just talking about.
I can get behind that. I remember being told that gravity is mass attracting mass, and the larger the mass, the more gravity. So if something has more mass, right, then it should fall faster regardless of whether or not it's in a vacuum. So when something falls at 9.8 meters per second squared, guess what? All they're observing is a phenomenon that they can't explain. They just know that everything falls at an average rate of 9.8 meters per second squared, and they throw their hands up.
You know what's interesting? I've heard something similar to that, right? What I've heard as like the explanation that kind of fills in that gap. It's like, oh, here's this thing that weighs more than this other thing, right? There should be a different phenomena observed because there's a different mass. And the argument that I've heard is, yeah, there is a different phenomena. The actual amount of force needed to move it, right, is much more. And the impact is also much more, right? So it kind of balances out the equation there. Now, it's still a little bit weird because they say our gravity is a pseudo force. It's not actually exerting any actual energy, right, to pull the thing down. So, it's kind of weird like that because you would think, oh, there needs to be more energy to pull a heavier thing downwards or to move a heavier thing, right, than a lighter thing. But if gravity is uniform, then something's weird about that. But then they get away with that by saying it's not actually a force. So I don't know. I kind of hear what you're saying, Sheepdog, and I tend to.
But I mean, like they say, Jupiter is so massive, and so it has more gravity. And if you went to Jupiter, it would crush you because it's pulling you down harder because it has more mass. So why don't the bigger things that have more mass, like a bowling ball, fall faster than a feather, even regardless?
I think the argument here, though, is the Earth is the same, right? So it's pulling the same on everything, no matter its size. Right? The Earth didn't change from pulling down the bowling ball to pulling down the feather.
Right,
That
but the Earth is pulling the bowling ball to the Earth, and the bowling ball is pulling the Earth to the bowling ball. They're supposed to what's the word I'm thinking of?
balance out. So
Synergistically, or like they're supposed to amplify with each other, right?
and I think that amplification that you're talking about is made manifest through the actual force of the impact, not through the speed change in speed. I think I could be wrong on that, but that was my takeaway from the whole thing. It's like this is how they balance out the equation. Here's this other variable that's different from the other two, the actual force of the impact. Okay, that everything equilibrates. Okay, we're happy.
Yeah, I mean, I guess I could go with that. I'd have to
I mean,
play with
I'm
it
trying.
more.
I'm trying to read more into the math equations, but what I'm getting is that the mass of the object makes it harder to move.
That
and
video
it's
you
cancel-
posted, 35 minutes after the hour, like where is that from?
No, we figured it out. That it was totally wrong. They misunderstood the experiment. But now
No,
we're
hang on. No, don't
no,
say
no,
that.
no, no, no,
That's
wait,
not true.
wait,
That's not true, though.
wait.
That's
Hold
not
on, wait,
true.
You have a
We didn't
different
have
argument.
totally wrong, dude. I had one part of the whole thing inverted.
Well, but that was
It wasn't an important
relax.
part.
Wait, it was the main.
It wasn't.
But
It was. No, it wasn't, dude. It wasn't.
Wait, hold on.
No, wait, actually, hold on. Let me rephrase that. It was important, but the converse, right, actually adds credence to what we were saying even more.
I know. Listen. I'm not coming at you, but before the first way was absolute proof, and then the second way, now that we figured out how it actually was, is also absolute proof.
But dude, it wasn't absolute proof because of the configuration.
Yeah.
That's what you're trying to get a win on this notion, on this little slip up, because you think that the configuration itself was the whole thing. The fact that
Where
it's
can I
happening
find more information on this?
Wait, I posted
this
it.
video has been posted so many times. This has been posted so many times.
Fish, go up. I posted.
Can jump in here. I posted the original video at 1 minute past the hour.
Yeah, but I also posted the European Space Agency that explained how the drop tower works, and it says the tube, the container, the actual tower's tube is near vacuum. Inside,
that's fine.
No, I know. I'm relaxed. I'm explaining to him. Inside, when they did the experiment, it was not also complete vacuum. It was pressurized to 1 atmosphere. So it's still, the atmosphere would still. They were testing microgravity, the effects of different objects in a microgravity environment. So it was pressurized at 1 atmosphere inside a vacuum.
Yeah,
that's why they moved. That's why they didn't move separately. I mean, that's why they didn't stay still. They were being affected by gravity outside.
Because that video in isolation just makes no sense.
Yeah, but it's weird, and and listen, 20, again, it's not coming at you, but the lack of information on that website that I've seen posted here before is just crazy to go off of that, and nobody had any extra information about it, so it was just hard to go.
But I have a question for you. What bit of information that you finally sussed out was actually critical to either in the attempt to dismiss or corroborate the argument being
well, it changed fundamentally the whole premise of what was being said, right? Everybody was saying that it was near vacuum with the container.
No, dude, no.
Wait,
no, dude, this is
you
the
could
problem.
disagree. Wait, 20K. You
no,
can disagree,
but it does. Yeah, no, go ahead there, but no, it's not. That's not actually true, though.
Okay, that's fine, but for the benefit of the guy that was asking,
go for it.
Originally, the claim by a lot of people here in the past and present was that the drop experiment was a vacuum tube with a vacuum container with different materials, and when they showed the video on that very sparse website, they say, look, these different elements fell at different rates in a vacuum in this drop tower. But now that we've found a little bit more information, that it wasn't in a complete vacuum. The container that housed the elements had 1G atmosphere. So it changes fundamentally what was being said. I know you disagree, but if you were to say that in any kind of scientific environment, you'd be destroyed.
Yeah. Well, here's the thing. I'd be curious to hear the words of those who before me who you've heard, and how they've put it
It
forward.
was so long. It was so long ago. But I mean, but you did say.
Well, the reason why I say that is I presented it right as if the capsule itself was vacuum sealed, and the tube in which the capsule was pressurized. That could have just very well have been my misunderstanding. I haven't heard. I can't recall anyone else who's presented it like that. Right?
I mean, it
so
could be your misunderstanding. I'll give you maybe you misunderstood, but at the same time, like I've heard other people, and I don't know the names. It was like
but the whole the real crux of the argument
been repeated. It's been repeated a lot, so it kind of sounds like that's what you thought.
Fine. That's fine. But the crux of the argument, the crux of the argument is the elements don't accelerate downwards at the same rate. Period. End story. No matter the configuration, even in the proper understanding of the configuration of the setup, right, that we sussed out, they still accelerate at different rates.
Well, that's because there's an atmosphere affecting them. It wasn't a real vacuum. If you did that experiment in a vacuum, it would do the same thing. It would.
You don't know that. It
wouldn't do the same thing. I mean,
you don't know that. How do you even make sense of that video? Like,
I mean, I would say I do know that.
Yeah, dude. Yeah. Fish, you gotta know the context. You gotta know the context to make sense of it. What you see in the video, granted at first glance, right, you just see these different rocks kind of floating up at different rates. It looks kind of suspicious. It looks kind of weird. Fine, granted to you. But if you know that the entire thing is falling,
different surface,
different sizes, yeah, different surface areas, yeah. Now that's important too to consider. Granted, this one test is necessarily the in the coffin on anything, but it does raise a bunch of questions. Now, if they fucked up the experiment, right, I want to know that too, of course. Right?
I mean, I'll be honest. I still think that like the fact that they go at different rates and there's atmosphere, I think it just nullifies the whole argument. I feel like.
How come though?
The claim is that denser materials fall faster, and why would the lithium be the first one to, I guess, fall versus the lead? Like, if you just look at the video, the lithium and lead start falling at the same exact time.
Yeah, exactly. So let's investigate.
Lithium and lead are not. Yeah.
So check this out, right? If you guys want to do a little test, right, or a little little exercise there, let's parse out the various densities of all these objects.
Well, just look at the periodic table.
Exactly. Exactly.
Lithium is 3.
So let's compare. Okay.
And lead is 82. I mean,
that's the. Wait, hold on a second though. Let's check it. Let's suss this out. Okay, lithium is what? It's 3. Yeah. Okay, that's the atomic weight though, dude. Right? It's not necessarily indicative of the density. Right? If I look up, density of lithium, okay, just for shits and gigs. Okay, the first number that comes up is just about 0.534 grams per centimeter cubed. Okay, now if I look up density of lead, 11.34. Okay, so a big difference. Okay, now if we look at the rest of them, what is there? Beryllium, aluminum,
iron, carbon.
I mean,
exactly.
We don't know. We don't know the weights of each material in here. They could be different weights.
That's another thing too, right? So exactly. So it could be the case that the weight and the density itself, the combination of the two, have a role to play. So we can't really do much here except a very cursory scan of it. For all we know, all these objects weigh the same. We don't know that. There's not enough in this. This is why I say I wouldn't put my I wouldn't die on this hill here. Okay, but all this to say is it is very interesting.
Sure, it's interesting, but I think it's fucked compared to like what
I got a
trying
question.
to claim.
I don't think there's enough information to really say it's fucked though, dude.
20K. I got a question. When you say weight and density, what's your definition of weight?
Just whatever traditional colloquial definition of it.
No,
maybe I should have used the word. Maybe I should use the word mass, right? So the mass time, you have mass, the mass of the object times the gravitational acceleration.
I was like, because
and then you get newtons per pound, right?
I'm nitpicking here, but like, because weight is mass times gravity. So if you
Exactly.
don't believe gravity,
Exactly.
you should probably just stick to density.
No, but here's the thing: these two things need to be sussed out. I could say mass also, right? But you just be doing all you would be doing there. If I want to give you the mass versus the weight, is I would just be doing an extra operation, right? I would have to take out the factor that gravity in the value, right? And it'll give you a mass and whatever. It doesn't matter. It wouldn't matter if I gave you the mass of it. Okay, the mass is whatever 1 gram. Oh well, its actual weight is that with 9.8 meters per second square acceleration downwards adds much more to it. Okay, 1.1. Okay, whatever.
Mass is just how many like individual like say atoms are in an object. Density
Actually, you would think that.
Technically true.
It's not. That's actually not accurate though. No,
Oh,
you can't count the number of. Yeah. I would have thought that too, right? Except the mass is not necessarily the number of atoms. Like you can't look at the atomic mass or the atomic weight or whatever it's called on the periodic table, multiply that by the number of atoms, and then you have an account for the actual mass of the object in your hand. It doesn't actually work like that.
Well, how would you describe mass then?
I don't even know, dude. I ask that question all the time. What the fuck is mass?
Well,
so if we're going to use it,
I can describe it to you.
I mean,
I can describe it to you in two ways.
Well, the closest way. Hold on, though. The closest, the most recent, up-to-date definition I've heard is the resistance to acceleration.
Yeah.
But what the fuck does that even
resistance
mean?
to inertia.
Inertia, excuse me. Or either or, I think.
Or
that's
the
neither here nor there.
Contained within the object divided by the speed of light squared. Two ways.
Oh, sure. But here's the point, right? In this test, all we have is the known density of the material, right? We can weigh the thing on a scale, and then we can do a calculation to somehow parse out or to take out the whatever the gravitational factor in the thing is, and then we get its mass. Fine. Okay, so we have this array of masses and densities of objects, or we can have an array of weights and densities of objects. Fine, we can do that too. Either way, it's all more or less on the same playing field. The point is, in the test, they don't accelerate at the same rate. And the big question is why.
Wait, every atom has a certain amount of mass. Same type of atom.
So I don't know what you're trying to claim, but I have no I have no background of this experiment. I see this video posted all the time, but it's always just this fucking GIF of these different elements falling at a different rate.
Yeah.
I have no idea how it was done. You said you found more information, so apparently it's not in a vacuum. They're in a pressurized container falling.
Close. Yeah, the caps. Yeah, exactly. The cap. Well, this is where the phrasing. They're doing a test in a vacuum is a little bit shallow, right? You could dig into it and say, oh, well, it's a pressurized system within a vacuum. The capsule is pressurized at 1 atmosphere. You can parse that out. There's no problem with that. But the point is, they're doing a test in a vacuum to try and neutralize the effect of the air on the acceleration of the capsule, or on the object, and by extension on the object.
How would that?
Wait, real quick.
It's not true because what they're falling in is pressurized. It has air in it, right?
Yeah, that's what I'm saying too. It's like it's not like a total vacuum because it's just
not a vacuum.
Being like, yeah, it's not a real
vacuum.
vacuum.
Surface area and air resistance does play a part.
Yeah, you're right. But here's the thing: right? The air resistance of the entire thing that's actually falling below them, right, is neutralized because there's no air resistance. So the capsule itself.
But why would that matter?
Doesn't matter. No, because gravity. Because gravity would still be affecting the 1 G of the atmosphere would still be affected within the container.
Well, yeah. Well, this is what I mean, right? This is why I said to you earlier. What's your name? Naxi. This is why I was saying before, right? Because the air inside the capsule is above the objects, right? So they would be quote unquote pushing down against these objects as they're falling, right? Because the whole thing would be falling, and these things, if they're going to actually fall at different rates than the surrounding capsule, right, they're going to lift upwards with respect to the inside of the capsule. But if there's air to impede them from rising up, right, and they still rise up, one could imagine how much they would rise up if there was no air.
Well, they're rising up because the container, the outside container is experiencing a different force of a near vacuum. The inside the container is experiencing the 1G.
Perform the same experiment, but
with 1G,
without the pressurized
Oh,
capsule.
sorry, the 1G atmosphere, right? Yeah,
1G
atmosphere. Yeah, wasn't it? Isn't that the measurement?
Well, you're thinking 1 ATM, but I think there's a
one
more
ATM,
important.
1 ATM. You're right.
I think there's
Sorry.
a more important sort of data point that we're not looking at here, which is that this is the single experiment that they have disproving the principle of universal freefall, and every other experiment ever conducted at the Bremen Drop Tower and everywhere else on the world by all scientists confirm universal freefall.
Well,
so like,
Carl's,
it's
and
fine
that's the
to,
thing. Like,
can
the
we look
original
at
thing
that?
was that
it's
there
fine
was
to
no.
Sorry.
They originally said there was a vacuum. It was a vacuum tube dropped with a vacuum container, but now we figured out that the container itself
ultimately
has
it doesn't.
atmosphere.
And ultimately, it really doesn't matter because this is one experiment done by a crackpot that happened to get access to a lab, right?
Why
Why
use it as evidence then?
What are you talking
Well,
about
they're flat
crackpot?
earthers.
What are you talking about? What the fuck, dude? Okay, hang on. If you've got other evidence of other people doing a similar thing, please put it forth. Bring it forth.
Well, that's what we were
I want
talking about
to-
earlier, right? Like vacuum chambers in high school laboratories. This is
No,
done
dude,
in
I'm saying.
educational
Hang on,
environment.
that's not what you said, dude. You said there are other individuals that have done the same
No,
test
I
in the
said
same tower.
every single experiment ever conducted at the Bremen Drop Tower. If you were
Exactly. That's what I mean. So go get one. Go get one so we can look at it. That's what I'm asking for. Some other guy who's obviously not a crackpot, who's done the similar test, who actually got a different result. I want to see that, dude. Not Professor Mary Jane with her 12-year-old students dropping a fucking bowling ball and a feather in a classroom.
I would actually say this dude is as irrelevant than the kids in the classroom. You know what I mean?
Would you
Like,
say
this
that?
guy's.
Why would you say
there's
that?
no post because he doesn't even post. Like,
There's
you
no
can't even find the
peer-reviewed
actual
paper. He's not
Yeah.
published anywhere. He was completely ostracized after this because he claimed to disprove universal freefall, which if he did, we would have to invent new awards for. The Nobel Prize would not be enough.
Okay, so I'll ask you this. Why was he ostracized? Because he's wrong?
Yes.
Okay, how was he determined to be wrong?
Because
Apparently
he
you
put an
had
atmosphere within. Because it wasn't a vacuum. It was a vacuum.
Hey, check this out. Check this out. Imagine being told this can't be true, or we'll have to change all of physics. So go fuck yourself.
Yeah, exactly.
Okay.
Yeah, dude, that doesn't make any sense. Okay, Tristan, if you've got another set of individuals who have done the same test in the same tower and got different results, bro, it sounded like you're claiming you do have, or at least are at least aware of. I want to see this. If you don't, then shut the fuck up. What are you doing throwing a fucking monkey wrench in the gears here, dude? For what? Suspicion?
No,
you're allowed to suspect, but if you don't have anything to back what you're suspecting, what are you doing?
All right.
No, I'm not
Are you looking for a 1-for-1 experiment, or are you just looking for like objects falling in a vacuum?
I'm asking Tristan about what he said. What it sounds like he was saying other people have done 1-for-1 experiments and have gotten different results. But now it sounds like he's talking about out of his ass.
Well, I would say nobody probably repeated this experiment because.
Then why is Tristan talking out of his ass, dude?
No.
Can you ask him that for me?
Wait, bud, hold on. Listen, we're not yelling. We're not yelling.
I'm not yelling, bro. I'm just I'm animated because
what Tristan would probably say. He can correct me if I'm wrong, but what he's saying is this guy was dumb because he tested. He put atmosphere in the actual container,
and
Why
then
does that
claim
matter,
that
dude? Why do you keep going back to that, bro? I gotta ask you,
because
why is that
okay,
so
wait,
important to you? Because
because
I made a mistake in my expression
no,
of
no,
what
no, no,
was going on.
no. It has nothing. It's not attacking you personally, dude.
No, but
What we're
here's the
saying,
point. The
what we're
point is the
saying
results
about
are
the
the results. Now, think about this, dude. Okay, the results are the results, right? If there's air inside, that's going to impede the rate at which these things appear to go up, because there's going to be drag on the inside, right?
Yes.
Okay, if they are still going up despite the drag, if there was no drag, they would be going up faster, presumably, right?
Well, they're going up, but the container is falling faster,
I
right?
know, dude. I'm saying appear to go up, right?
appear to go up.
The capsule is falling at a certain rate, and these
Yes.
things are trying to keep up with it, and they're keeping up better with the container falling down because the air on the inside is creating some sort of friction that's slowing them down from accelerating at a slower rate, i.e., accelerating upwards from the perspective of the inside of the capsule. This is my point, dude. It does not fucking matter. The whole thing is they still do accelerate. Right now, if you were trying to argue from our position, okay, and you didn't have the results that we do, demonstrating that they do rise up a little bit, okay, and you were trying to argue that, oh, well, the only reason why they didn't actually rise up was because there was air, we would critique that as well and ask, okay, redo the test without the air and see if you get that result. That would be totally legitimate. In this case, we do get the things to rise despite there being air. So I don't know why you're harping on this, except for trying to basically try and nullify the thing because I made a mistake in my presentation as to how the thing was set up. That's the only thing I can conceive of, dude. I don't understand why you're harping on this otherwise.
Well, they're falling because of the container itself in free fall, right?
That's
During
not
the atmosphere. They look
dude,
like they're floating up.
Hold on. The object's falling because the thing below them is falling away is not a surprise to anybody.
I guess I just don't understand your point then.
The point is, dude, if you were trying to say that because there's air on the inside, there's a problem, even though despite there being a quote unquote problem, the results are basically what we're trying to present. I don't get it, dude. Why do you say this is a problem?
Because the claim on this website, right? Let's see.
The actual claim on the table is the capsule falls through a vacuum, and the inside of that capsule is pressurized. Right? I made the mistake in presenting it as the opposite before. That's fine. Doesn't matter. The results are actually the results of the real experiment, not what I say. Right? So I concede I made a mistake on that. Fine, it's the opposite. But the results are still there. Right? In the actual experiment as described by those who did it.
So the website that you linked, right? The archived website. It says
I didn't link anything to the video, dude.
Oh, wait, but this is the one. But this is the video. It's the video that you linked, right? It's the same website everybody here links for this experiment, right? In the paragraph, right?
YouTube. I linked to a YouTube video.
Right. Okay. But okay. So did you see? I'm gonna relink it, right? And
does the description link to something else?
Here it is, right here. This is the link from somebody else in this chat while you were talking about it. And this website's been linked all the time for this experiment page. It's up there. It's right there, 1134.
Yeah.
Right.
Yeah.
So it says the video shows the experiment inside with aluminum capsule. During the fall, the test bodies, lithium ion elements, blah blah blah. You can see the different accelerations between the elements, but the accepted physics says the bodies show all the same acceleration, which is equal to the formation. Inertial mass is equal to gravitational mass. Right. So are you saying that this right here, this website, right, which is what a lot of guys here, go by as their Bible for this experiment, that is he implying on this website, right, that he's attacking the fact right here? It says the accepted physics says that all bodies should have the same acceleration, which is equal to the formulation, blah blah blah, right? So do you think he's saying in a vacuum or an atmosphere?
I have no idea who the fuck is saying this. Is this like just a random article writer writing up on this, or is this the actual words of those who did the presentation?
And this might be a genuine thing for you, right? But
what I've seen people in this place, right, is that it seems like all of a sudden people play dumb sometimes when like
Dude,
this
I'm
website.
not playing dumb. I'm asking you a
Right,
genuine
but I said not
question.
you specifically, right? But this
Yeah,
website,
here.
this
I don't
website
know who.
is linked
Dude, I
all
don't
the time in
know.
here.
Dude, I have no idea what the fuck this AdamSZ.com website is. I couldn't give a flying fuck of what this website is. For all I know, it's a goofball making the wrong claim as to what the evidence is actually trying to portray. I don't know. I'm asking what the actual performers of the test stated about their test and their findings and what their conclusions are. If you can find that, that would be great. If I can find that, I'll present that to you.
Actually,
I do have.
Is this the
I do.
professor's
I
website?
have. I have no idea.
Past the hour, I posted everything I could find on it, including the original video. And the Adam SZ is from the guy who originally did the experiment.
Yeah, it is the professor, right? Yeah, it is.
Is it? Okay, very good. Very good. Thank you for that.
Right. So
Yeah.
in his own website, he did this experiment, and the most he has on it is literally 2-3 paragraphs at best of explaining nothing, which is kind of crazy.
The whole video, he's got a 30+ minute or 40-minute video of that snippet is taken from. That's also posted at 22 minutes past the hour. I kind of put everything into a summary of everything I found, and then his conclusion.
Thank you.
There hasn't been any real analysis of this until 2024, and it looks like some grad students and another professor did a research article on this, and I put in their conclusions in there as well at 22 minutes past the hour. I haven't read it all, so I don't know what all of it means yet.
Fair enough. I will try and find the actual original paper published by the guy originally.
I think it was his website is down. It's not up. I don't think he's trying anymore, or he took it down or abandoned
it is down because the only way to access it is the Wayback Machine or the Web Archive.
Right. Well, on archive there should also be a backup of the initial publication if it was there too. Anyway, look, if we can just reconcile one thing, right? The reason why this came up, okay? Initially, when you came in, Naxi, you asked something about the bowling ball and the feather, right? Yeah. And you asked something about why is this the case? And I posited, right? Perhaps maybe they fall at the same rate because they're of the same or similar composition. Why I said that was because of my understanding of all this stuff that we're talking about now. That's all. I'm not even really trying to put forth the notion that everything does not fall at the same rate necessarily. But if it doesn't fall at the same rate, but these two things do have the similar density, and that's one of the variables that that influence the rate of acceleration downwards, maybe that would be why. Right?
You're saying in a vacuum, or sorry, you're saying outside. You're saying outside of a vacuum. Sorry, you're saying the fact that they're made of the same material, like let's just say carbon, right? You're saying that influences that. You're saying that influences when they're in a vacuum why they fall at the same time.
If they have similar densities, right? Well, they will accelerate downwards at similar rate.
Does a bowling ball and a vacuum have similar density?
A bowling ball, the density of a bowling ball is regardless of the environment it's in. Right?
Right. But that would apply to the feather, right?
You take the total volume of the thing, right? You weigh it, right? You get the ratio between the two. There's your density.
Yeah, it's mass plus volume. Yeah.
Well, it's mass per unit volume. Yeah.
Yeah. Okay.
There you go. So if you take a feather, you weigh it. It weighs like 1/10 of a gram or something like that. Whatever it is, right? But only occupies however many cubic centimeters of volume. You do that ratio, and they come out very similar. Well, maybe that could explain why they fall at similar rates. That's all I was getting at, dude. And that whole kind of thesis, right, stems on this type of stuff that we're talking about now. Now we're digging into this, like if this is an actual, real argument. even though it wasn't really an argument, it was a proposition. You asked a question, I posited a potential answer.
Well,
Now,
real
if you guys
quick,
really want to like die on the hill on whether or not that answer is correct or not,
hold
I
on.
mean,
The feather
why we're
having the
talking
same
about this.
density as the bowling ball. I'm kind of like stuck on. Like, what do you?
Okay, you
What
know
do
what
you?
density is, right? Mass per unit
Yes.
volume.
Yeah.
Okay, right? You know the whole adage. What weighs more, a ton of bricks or a ton of feathers?
Yes.
Right? Yeah, it's stupid, right? Because they weigh the same, but obviously one's bigger or more voluminous than the other one, right? Yeah, that principle.
Right, but a feather is like the feather. There's lots of air trapped between the feathers, right? Like just because of its size doesn't necessarily
Well,
mean
this is
it's
what I
the
mean,
same
right?
density,
Yeah,
right?
yeah,
The
yeah,
bowling ball is tightly packed resin or whatever material you end up with it,
yeah, yeah.
right? So
I get that.
they're
I get
not
that.
they're not the
No,
same.
but
They're
check this
not the
out.
same density in any way.
Well, here's the thing. I haven't measured that. I haven't looked into it. It was a
Oh,
prop mine. But here's the thing. If we take a feather, watch this. If we take a feather and we crush it, right, to get all the air out, whatever, and we have this powdery substance, right? You can get the volume of the substance, and you can weigh it.
right, but if we crushed a
Right?
bowling ball and did the same thing, it would have more volume regardless. It would still.
It would have more
Be
volume. Yeah,
more.
yeah, yeah. But yeah. Of course, it would have a more volume, dude. But take the same amount of volume as you have for the feather, right? Let's say you have one, half a cubic centimeter, right? Of a feather, comprises that when it's crushed up. Well, take the equivalent half a cubic centimeter of a bowling ball and compare them, right? And if they are similar, then they have similar densities. Like it's not
just
hard. Grade
like
6, grade 7 shit.
like you just wouldn't get the same volume or density from a bowling ball compared to a feather. I don't think in any situation.
Do you know that? Do you know that?
I mean, we're talking about like let's say a goose feather,
Do
right? Like a
you
Canadian
know
goose.
that to be the case, dude? You're talking trash. You don't know that unless you do, and if you do, I'd like to see that. I've been pausing this as a possibility because I don't know. I'm suspecting that they might because they're both carbon-based primarily.
So
At least my
we're stuck with we're actually the impasse is
Okay.
actually whether a feather and a bowling ball have the same density.
Do they or not? This is the entire thing, dude. This was the crux of my proposition.
Okay, wait. Let me. What if I classify right?
Hey, can I add something real quick? I actually heard there's a theory out there that weight is entirely based on electrons.
Okay.
So, I mean, like what 20 Cups is asking is not out of the question per se, because there's a lot of craziness out there that just hasn't been verified yet. And that's all he's asking for is the actual work. And he's a math guy, so he's willing to look at all the math for you.
Are there more electrons in a feather than a bowling ball?
If you have more substance of bowling ball, no.
Well, what's the bowling ball made out of? What's the primary substance?
Resin.
Here's
resin.
The thing, right? If they're made of the same let's say a feather is primarily carbon, right? If I have two carbon atoms from a feather, and I have 2 carbon atoms from a bowling ball because it's also primarily carbon based, then there's the same number of what'd you ask? Number of electrons?
That's you're changing. You're breaking it down to 2 of each element.
I get it. But this is my point, right? So if you take the feather in its entirety, you crush it up, right? You got the feather substance, mixture of all sorts of fucking, organic material and carbon and all that, right? And then you can do your estimate. I don't fucking know. I was just proposing the notion that because a feather is organic material. Organic material is carbon based primarily. The substance made that is used to make bowling balls is also largely carbon based. Maybe there could be something to compare there. I don't fucking know, dude. But we can figure it out maybe.
I mean, yeah. I mean, I guess you could do an experiment with a bowling ball and a feather, but I hate to say it like this, but I think it's like beyond obvious which one is probably denser.
Oh, is it? Okay, which one? Which one's more dense?
Obviously, the bowling ball.
And you know that how?
because feathers are light and airy, and there's lots of air between their between the fibers, right? Right. The bowling ball, bowling ball is solidified. Bowling ball is a solidified ball of resin. Go ahead, explain.
Bro, you missed the point. I'm not talking about the feather itself with all the air inside. I'm talking about the substance that makes up the feather, like the skeleton of the feather, let's say.
Right, but okay, so let's just say they're both carbon. There's more carbon in the bowling ball, and there's less carbon in the feathers. Let's just
okay, you know that how? How do you know that?
Less mass. There's less material. There's less matter.
Okay, again, you take a bowling ball, you crush it, okay, into powder. You take a bunch of feathers, you crush them into powder. Okay, now you have 2 heaps of powder, right? A lot of the air is let's say it's mixed in or whatever. Fine, whatever. Okay, you take these 2 heaps. Okay, you take a scoop of each one.
When you say crush into powder, is it turned into the element itself, or is it still crushed up resin?
What do you mean crushed up resin? If you take a bowling ball and you crush it, dude, it's going to be powdery. It's dried resin, right?
It would be powdery resin, right? That's what I said.
Okay, yeah. There you go. Yeah. Okay, so you have the 2 substances, right? You take 1 cubic centimeter of each one, and you weigh it. My question is, are they similar?
If
they
are the exact same weight, the exact same size of powder, then they would be similar.
Hang on, that wasn't the question. You have the same volume of each one. Will they weigh similar amounts? Because we have the known volume of each one, 1 cubic centimeter.
So
will there be the same weight or the same mass or whatever the fuck you want to do?
The feather bowling ball in the chat.
I mean, dude, this is not hard. It's dragging on for whatever reason.
Well, I mean, I'll be honest. I think you're making it more difficult. But wait, so I'll ask you this: are you removing most of the material, most of the resin powder, to equal what you have left of the feather?
Dude, of course you're taking 1 scoop of 1 cubic centimeter of each one, dude. This is the whole point. We're analyzing the density. Do you not get it?
They're the same weight, right?
No, we don't know that. This is the whole analysis, bro. It's like, dude, are you dumber than fucking Dylan? Did you guys not pass grade 7 or something?
Bro, listen.
I mean, fuck me.
Bro, listen. You're doing good all the time. Now you're spurging out. I didn't insult you.
Yeah, I don't mean to spurg out, okay? But this is crazy. I'm starting to ask myself, am I retarded? Because of your question.
Listen, I feel the same talking about the experiment, but I'm not like freaking out about it.
I'm not freaking out either, dude. I'm frustrated. Okay, forgive me. Forgive me for losing frame. Okay, but the reality is, we have in this little test, right? We have we have a heap of unknown quantity of feather dust. We have a heap of unknown quantity of bowling ball dust. We take 1 measured scoop of feather dust. That measured scoop is 1 cubic centimeter. Okay? We do the same thing with the fucking bowling ball. We have 1 cubic centimeter of feather dust, 1 cubic centimeter of bowling ball dust. The question is, do they weigh the same or something similar? Then we can calculate their densities and compare them. That's all.
I'm looking up the elements right now.
It would be great to I mean, I never looked it up. Okay, I'm just it was a suspicion of mine. It kind of just went on ice, put it on ice for a while. But this was my leading suspicion that led me to answer the way I did earlier when you asked the question.
No, they probably wouldn't weigh. They would. No, they wouldn't weigh the same. But
or similar.
But also,
would be the same. I don't think they would be the same.
They wouldn't weigh the same, but also, like, is the crushed up powder perfectly shaped, like, for atmospheric drag? Like, there's no difference, right?
Dude, no, take atmospheric drag out of the question. This has nothing to do with the acceleration rate at this point. We're just comparing the densities. I'm not saying take this cubic centimeter of dust and drop it from a fucking elevation and see if both dusts fall at the same rate or not. It's not the point, right? That's not the point at all. The point is, if you have 2 objects of varying masses or weights or whatever, right? But similar densities, will they fall at the same rate? That's all.
it would. I mean, in your test with the powder, right? So it would depend on what elements, right? Like just because there's volume, it doesn't mean they'd be the same weight, right? So it would depend on the elements in your powder.
Right? Exactly. Like, this is the grand unknown, dude. Right? These are the unknowns. And this is why I'm bringing it up as like a maybe. Right? And even if they are different, how different are they? Is that difference sufficient to really outweigh any of the rest? Like, let's say, for example, the feather is 99% carbon, and there's that 1% trace minerals and shit. And then in the bowling ball, it's virtually 99.99% carbon, and then the rest is trace minerals. That small difference, will that actually be noticed in a drop test? Right? Will that actually influence the rate at a rate that or at an amount that we're able to capture in our resolution of a test?
I mean, I just think
we don't know.
Like, I don't think it's like a true comparison at that point, because you've broken it down so much to the point where it's like you're basically down to like just you're trying to put the same amount of like carbon in the same volume, so you just become this. It's just the same element versus the same element, the same space and same size.
But this is what comparing density is all about, dude. If the density is the key contributor to the rate of acceleration, and we have two things that accelerate at a similar rate of unknown substances, if we compare their substances and we discover that the substances are of similar densities, then we might have a link between the two and why they accelerate at similar rates.
Right, but listen,
right? It's not hard.
If you have, right, say the bowling ball, right, carbon, hydrogen, and like oxygen, right, and the feather is obviously it's a little bit different, right? Maybe it has like sulfur and stuff in it, but at the same time, right, if you start out with a bowling ball and a feather, the bowling ball is going to have more carbon and hydrogen versus if they're both. I mean, it depends on the material. I mean, it depends on the material for some, but you still have more mass and more density.
Yeah, I know.
With the feather.
Hold on. No, the density would be the same.
The bowling ball. I meant the bowling ball, not the feather.
The volume would be different, obviously, because it's a bigger object, but the density of the object is the same. It's akin to if you take a tennis ball and a basketball, and you both hold them both underwater at the same distance from the surface, and you let them go.
You say the density would be the same?
Hold on. Wait. Hold on. Okay, let me draw an analogy for you. Okay, if you take a tennis ball and a basketball, okay, they're both, the volumes are primarily comprised of air entirely, right? You take both of them.
Yeah.
A tennis ball and a basketball. Forgive me if I misspoke. Okay. You suspend them underwater, the same distance from the surface. If you let them go, will they rise to the top at the same rate? And if so, why would that happen? Well, you can compare them. One test could be compare their densities. Is that a contributing factor? If you look at it, it's like, shit, both of these things are comprised mostly of air. And the rest, of course, is plastic and shit like that, of course. Right?
I think you have to look at the density of the water. That's what would be affecting them rising to the top more of the density of the ball, because it's the density of the water that's going down versus
sure.
And how much air is trapped?
Air going up.
Yeah, the rate of acceleration or upwards or downwards or whatever. It's the relationship between the object itself and the medium, of course, right? But what we're talking about is two different objects, right? That either do or do not have the same rate of acceleration upwards or downwards in a medium. And if the density of these objects is the key factor in determining the rate of acceleration and explaining why they may or may not accelerate up or down at the same rate within the same medium. So I was describing
within a vacuum or outside a vacuum.
Exactly. And in a well, this is the thing. The vacuum would be a medium, but it would be a medium of virtually zero density. Right? So this is kind of what neutralizes the playing field a little bit, right? This is why I was asking you. This is why I was talking about the bowling ball and the feather. If they happen to be made up of similar densities, right? How could we determine that? Well, that's when we got into the whole powdered, fucking feather and powdered bowling ball discussion.
I mean, if you had
so we could actually weigh these.
If you had a bowling ball that was a similar density to a feather, I mean, it's not what we'd be talking. I mean, it's not really what we're talking about. You'd just be talking about a fake bowling ball shaped, an object shaped, just made out of carbon and hydrogen, shaped to mimic the weight and the volume of a feather.
No, dude, you're not getting it.
Bowling ball made out of.
No. What was that, Viking?
If you put it in a vacuum, though, you're taking away the. No, I'm saying like for apples to apples, you could say a ball the size of a bowling ball, but made out of styrofoam, versus a bowling ball made out of rock.
I mean, that would be the volume.
Marble,
that would be volume. That wouldn't be the density.
Yeah, the volume. Yeah, in that case, the volume would be equivalent, but the density would. Like, for example, the real equivalent, right? Or the real analog would be if you take a shit ton of feathers and you stack them all together, so tight that they fill up the same volume as a bowling ball.
But wait, we know what density. We know density is, right? Again. Mass and volume,
this is my
right. So if you took I still understand how you're saying that the feather in any way, right? Like a normal Canadian goose feather versus a normal size like 8-pound bowling ball, right, or 10-pound bowling ball.
Yeah.
Well, he's saying like if you turn it into like powder form, so you have the substance that is the feather in the density. If they're both condensed into the same density, they would fall at the same rate, regardless of the medium.
If you turn it into a powder, you'd be turning it. If you turn it into a powder, you'd be breaking it into billions of separate new objects, right? But even if you took one piece of that, if you took one piece of that resin bowling ball and then one piece of that feather, right? The bowling ball would still the piece of powder of the bowling ball would most likely, as long as it contained, right, in equal parts of the hydrogen, carbon, and I forget whatever else it was, but if it contained equal parts of that, and the feather contained equal parts of its own 5 or 6 elements, if that was true, the bowling ball would still be heavier because it has more of those elements.
No, dude, come on. You're not. No, bro. Okay.
They'd be the same density because you're breaking them down into the.
No.
This is the argument. Yeah, but hold on. Let me. Let me sit.
That powder. Wait, if you break it down,
wait, dude. Bro, hold on. Because Viking came in a little bit later, right? We're gonna give him some context, right?
Wait, I think I got a 20 cups.
Oh,
it would be equivalent of having like a 20-gram lead ball versus a 1-gram lead ball. They're both the same density. They just different weight.
Yeah, exactly. If you took a 20-pound lead ball and a 1-pound lead ball and you drop them from the same altitude, they're going to fall at the same rate, despite the fact that they have different weights. At least in this conversation, what we're trying to dissect is whether or not this actual density relationship is the key contributing factor. Because
if you're equaling their density in every way and there's no atmospheric drag and it's a perfect shape, you've broken them down to what they aren't anymore. You're equaling them out to the same elements, right? One for one.
Well, watch this. This is the thing, right? So when you came in earlier and you asked about the bowling ball and the feather in a vacuum, why do they fall at the same rate or similar rates? I posited maybe because they have similar densities. And then we got into this big discussion about how would we determine the densities of these objects so we can compare them.
But
and that's when I went on about
is what they're made up of. If you break them down into individual parts.
No. When I mean density, dude, I'm not talking about the density of the object necessarily in its original form. I'm talking about the density of the elements that object is comprised of. So you can break up,
but
right?
You're breaking it apart. Wait. So
you're
what? Wait, listen. We're comparing the density, right? Is the matter, right? The elements on how much. Well, that's more mass, but
whatever,
right? Mass and density, right? But how much of those elements, right, become packed into this bowling ball, right? There's more carbon and hydrogen in this bowling ball than there is in the feather. You can measure that, right? You can measure that, but if you break them down into powder, they become separate objects. Yes, you you've created billions of separate.
Bro, no. The comparison would be more like this. Again, if you take a shit ton of feathers, you grind them all up, and you take a scoop of it, right? And you do the same thing for a bowling ball. You take a bowling ball, you grind it up, and you take a scoop of it. That's when your analysis would start as to how many carbon atoms, hydrogen atoms, oxygen atoms, or whatever are contained within that fixed volume. That's what you would compare, not of how many would exist in the entire volume of the bowling ball in its original form compared to the feather, because obviously the bowling ball has more substance to it. There's no comparison there.
But it's
right?
not even the same density
Can I
anymore when you
ask a
break it
question?
apart. It's
Can I
different
ask
now.
a question?
Please do, man.
Can I
It's
ask
getting
a
weird.
question real quick? Okay, I just want to ask a question.
Oh,
so
yeah, we're waiting.
we know that a ton of bowling balls and a ton of feathers weigh the same, right?
Yep.
Which one has more density?
This is what we're trying to ask. Now,
Well,
at a first
no,
glance,
wait. The answer to that is, I mean, they're not combined objects, right? But if you're saying how much density, it would probably, right? If they're
If
equal,
you have a ton of feathers laying on a pallet, and you have a ton of bowling balls laying on a pallet, side by side, which one has more density?
Well, they're not
Density would be
combined.
the
It's just
bowling ball.
it's a loose connection of objects, right? They weigh the same, but the volume is going to be massively different because you're going to need a tower of feathers to equal whatever amount of bowling balls you have. So it's still not a one to
the better comparison though, Shiba, and this is what you're asking is analogous to what I was trying to suss out by taking all these things and chopping them up and getting them powdered and all that stuff. Because by doing that, you're eliminating any of the extra empty space between each of the feathers, right? A better analogy or a more precise analogy of what you're talking about would be if you take all these feathers that weigh a ton, put them next to the bowling balls that weigh a ton, but you take those feathers and you vacuum seal it so all the feathers are compressed together and minimize the space between the two. At that point, the question would then become, would that total volume of feathers in the end, after having taken out all the air, would that be of a similar volume as the bowling ball? That would be another way of approximating the comparison between their densities. That's equally valid also, right? But we have to make sure that we take the air out because we're trying to compare the substance.
Any object at all, if you broke it down to its simplest form, which would be the molecular compound, you're then going to be like, does one atom of oxygen weigh the same as one atom of carbon? I mean, you're going to be comparing like, and the quick answer is yes. I mean, because it's going to be like
that's what he's trying to ask. Is he's like, do these things have per cubic centimeter the same amount of carbon, hydrogen, and other elements combined together?
No, yes, but if the elements are separated, right? They would be equal. But the thing is, they're combined in these states. So yes, they would be. The bowling ball would still be more dense, right? Even if you broke it down, unless you broke it down into its individual elements, then
per cubic centimeter. Per cubic centimeter.
Sure.
If I crushed up a bunch of feathers, and then I scooped up a cubic centimeter of feather dust, and I crushed up a bowling ball, and I scooped up a cubic centimeter of bowling ball, how would they weigh the same or would they weigh different?
Should weigh the same.
That's the question, right? And it would seem reasonable to suspect they might weigh the same because they fall at the same rate. And if density again is the contributing factor, well, if they're falling at the same rate, they might have the same density. This was the entire question.
Like to make a simple,
they're not that dense anymore because you're breaking them down again. You're breaking them down into their smaller elements when you do that.
But no, that doesn't matter. Because it's substance itself though it's in question. I mean, you can pack them together. You can take a compressor and pack it into the smallest form that you want, right, to eliminate any of the air between the two. You can do that. But whatever you do to one, you just make sure you do to the other, so they're on an equal playing field. That's all.
Like for easier comparison, what if you said like aluminum, like a brick of aluminum versus a brick of steel. You know, obviously in their natural form, at the physical attributes that we see as aluminum and steel, the steel is going to weigh more by volume. But if you were to, that's because the aluminum is more porous, you know, it contains more air. But if you were to take the elements that compose aluminum and, you know, compress them into that brick versus the steel, does the steel still weigh more at the same volume than the aluminum? I mean, it's easier. I think it's just easier to say you can break down the aluminum into dust and the steel into dust versus a feather.
Right. Well, that's the thing. We don't know the entire molecular makeup of the feather, and that's what 20 Cups is trying to get to. Is it the same molecular makeup and the same density, even though it's spread out and it's airy in the feather? If you crushed it all up and scooped up a cubic centimeter, would it weigh the same as a corked bowling ball? Because that's what a bowling ball is made out of. It's made out of cork.
Right.
If that doesn't
It's made out of
matter,
resin.
resin, whatever. If that doesn't matter, then the bowling ball should always fall faster than the feather, because mass attracting mass, they should synergize together.
Right. That was my next thing. Like, so if you, let's say you take all the other variables out and you've got this cubic centimeter of feather dust, cubic centimeter of bowling ball dust, they, according to the rules of, or like the comparison, you said like a 20 pound ball and a 1 pound lead ball, and they fall at the same rate. That kind of denies the theory of gravity, because gravity's saying the larger the mass, the more attraction there is, but we don't see that. The 1 pound
Wait, are you
lead
saying in a
ball falls
vacuum or
at the
outside
same
of
rate.
a vacuum?
Outside of a vacuum.
If you take and it's the same volume of dust.
Well, no. Like the 20 pound lead ball, 1 pound lead ball, they're the same molecular structure. They obviously weigh different, but they should fall at the same rate.
Not in atmosphere.
Well, even if you
Okay, now when you put it
in
in
a
a vacuum, hold on. Now you put it in a vacuum, and they fall at the same rate. But like when you have a bowling ball and a feather, they're falling at the same rate. They shouldn't be falling at the same rate, because the bowling ball has more mass, which means it has more gravity. So the gravity of the bowling ball should be pulling towards the Earth gravity faster, because the two are synergistically working together more than the feather and the Earth.
I mean, I can pull up the math if you want me to post it, but basically, the mass of the bowling ball takes more energy, right? Gravity has to act more onto the bowling ball's mass to move it, right? Because when you have a bigger object, it takes more to pull it, right? But its own mass cancels it out. So that's why they end up falling at the same time.
I mean, that just seems like a washout, in my opinion. That's a cop out.
Well, mass attracts mass, supposedly, right? So, like, let's imagine you have two bowling balls
Wait,
hanging
mass
1,000
attracts
foot
mass,
from the
but it's still harder, right? If you're going with that, right, you still need more pull, right, on that mass. The bigger it is, right? It would be easier for the Earth, right? Like say there's two asteroids flying by. One's the size of a feather, one's the size of a bowling ball. The bowling ball, right? It would need more mass to pull down. It would take more to pull towards it than the little feather, or the little feather size one. The little feather size one would be, the gravity would affect that one easier because it has less mass to pull.
All right. Can you guys hear me?
Yeah.
Okay, check this out. We're gonna fucking settle this. This is insane. And it's largely my fault in this. Take it with a grain of salt.
I am going to
Continue.
go in a minute. So whatever you post, I'll count it as a win. I just got to go in a minute.
Hold on. Well, if you gotta go, you gotta go.
No,
but
I'll see whatever you're posting.
Okay. We're gonna settle this. Okay.
God.
In the end, both of them can be estimated to be approximately one gram per cubic centimeter. Okay, first image, core mixture of a bowling ball, right? Polyurethane, the urethane, whatever. Hold on.
It's resin.
Urethane, resin, all sorts of shit. Overall ball density can be as low as average density as low as 0.67 grams per cubic centimeter, or while heavier balls can exceed 1.0 grams per cubic centimeter. And the next stat, for feathers, the mixture of bed keratin, protein mix, blah blah blah. Okay, if you're calculating the density of the mixture of elements, carbon, oxygen, nitrogen, sulfur, strictly as solid protein blocks without air, use approximately 1.3 grams per centimeter cube, but they can range between 0.67 or 68 grams to 0.8 grams. So it's all in the same fucking ballpark. Okay? My suspicion was probably correct. Now, it's not exact. There's a lot of variables at play, but to say that, this doesn't play a part, I think would be disingenuous. Okay? Here we were talking for like an hour, and everybody just looked up in 5 minutes.
Well, with the theory of mass attracting mass, think about this. Like, those balls that they use on a crane for like demolition, those huge metal balls? If you had like two of those hanging, they're each hanging from their own like 1,000-foot long rope or chain, and you space them so they're like 2 millimeters apart. According to mass attracts mass, should they bowl themselves together?
Well, no, not. I mean, technically they would have a pool, but it would be semi-nude. Like it has to be like gargantuan in size for them two to pull each other like that.
Well, let's imagine the ball is 1,000-foot diameter. I mean, I understand this is like not possible.
I mean, I don't know that math. I don't know the math right off the top of my head, but that's the answer to that. Is that they're not big enough to see an observable effect.
Anyway, so this kind of settles the whole fucking density.
I haven't even read what you posted because I was listening.
Okay. They're in the same ballpark, to sum it up. So I wasn't too far off in my suspicion. And it's especially tricky because there's a range, right? It's not exact. It's not like you're taking a single compound with an average, known density, right? Like water or whatever under certain atmospheric conditions, right? This is it's a mixture of things. There's different feathers and there's different bowling balls. If you get that wide range, they overlap significantly, right? So there may be cases where you get the exact same densities between these two objects. You pick a bowling ball that happens to be at whatever density, and you get a feather that's the same density. It's statistically likely because the ranges overlap.
Well, if you're giving them the same density, then you're artificially changing them, right?
We're not giving anything. We're taking these two objects that are of specific masses or weights, right? And then we're dropping them. They happen to fall at the same rate or similar rates in a vacuum. We analyze why that might be the case.
Yeah, but
right?
do you
and
understand?
Just so happens to be that these things have the similar chemical composition or elemental composition, such that they actually have the same density. That could be a contributing factor as to why they fall at similar rates. That's all I'm saying, dude.
No, I understand what you're saying, but again, the density of the bowling ball, right, as it is combined, right, is more than the feather, as is.
For Christ's sake, dude, no. The mass of the overall bowling ball is obviously greater than the feather. No shit. Right?
Density is, again, what? Mass times volume.
No.
Hey, you know what you didn't take into consideration?
You messed up, dude. It's mass divided by volume. Sorry, Sheepdog.
When you suck the air out of the vacuum chamber, right, you're effectively sucking the air out of the bones too of the feather.
Exactly.
And so all that's left is the elements that make up the feather.
No, well,
exactly.
Well, when you remove, well, no, that's what we talked about earlier. When you remove the vacuum, right, then it's just the mass of the object, right, versus the pull of gravity. So it takes less to move the feather. It takes more to move the bowling ball. Their weight divided by here, wait, I can get the math for you. Hold on.
What? No, dude, that's kind of what you just said is kind of what Sheepdog just said, but you worded it differently.
What did he say?
Say it again, Sheepdog.
About the density, about the vacuum.
Yeah.
So when you suck the air out of the vacuum, there's air in between the bones of the feather.
Yeah.
That's why the feather is so much lighter than the bowling ball in a half. But if you suck the air out of the vacuum, you're going to suck the air out of the bones also, and all that's going to be left is what's left of the feather, the density of the feather.
Yes, the density of the feather is left, and same thing with the bowling ball. But if it's in a vacuum, right? Yes, you suck the air out, and yes, the air leaves the keratin sheath of the feather. But
yeah,
their own weight, their own inertia, right? Gravity applies to them both at 9.8, right? 9.81. So,
well, actually, this is the whole point. Actually, hold on, let me stop you there. This is the whole point. Okay, at this point in the test, right? This hypothetical test, we don't know what the acceleration rate is. You're going to assert that on average, 9.81 meters per second squared would be what we could assume both of them will fall at.
Well, it's because it's what you can measure in a vacuum.
That's taking a priori knowledge and applying it here. If you're taking a test from base principles where all you have is the two objects, the vacuum, and the height at which you're going to drop them, and a stopwatch, okay, and you measure the rate of accelerate, the time it takes for them to drop, and you sample them at each at certain intervals in their trajectory, you can then actually measure the distances and then calculate the rate of acceleration downwards to determine a number that may or may not approximate 9.81 meters per second. Right?
I can't. Yeah, I'm trying to paint something for you, but it's coming all fucked up.
What we're working with here is anything and everything without the to determine whether these things actually fall at 9.8 meters per second squared. This is the whole point of the test, and and in this case they happen to fall at similar rates or have a similar acceleration. And the whole conversation was about why that might be the case. And it just so happens to be that they have similar densities, so therefore maybe that might be a factor. That's all this was about.
Okay.
Yeah, it just seems like you're positing that, though. No?
Yeah, did you not? Yeah, did you just get here, dude?
No.
Yeah, how long have you been here?
About 30 minutes.
So did you not see what was posted in the chat? Did you not listen to the
I did see
entire
what was posted
kind of
in the chat.
rigmarole? Okay, what did you see in the chat?
I saw Shane post calculations. I saw Miguel Sosa post a video.
Okay, so you didn't see what I actually
PDF.
Very good. Okay, gotcha. So you didn't see what I actually posted to actually, attempt to back up what I'm saying.
You didn't post a PDF?
Yeah, exactly. Yeah, you didn't see what I posted. You didn't care to look. Piss off, Ham. You're a piece of shit. Sorry for those who are not aware, but Ham is a known goofball around here. So fuck him. Go ahead, Naxi.
Nah, I was just trying to get an easy to copy math formula that I'm talking about. That's all I'm saying is in a vacuum, right? They're falling at the same time because their own mass cancels out with the gravitational pull, and they fall at the same time because it takes less effort to move a smaller object. It takes more.
Yeah, but notice what's going on in this equation, though. You have a static 9.81 meters per second squared acceleration, right? Applied to anything and everything that you put this formula to, right? We're a step before that in our test. We're trying to determine the actual rate of acceleration for a particular thing.
I mean,
right?
you could just make a vacuum and drop it, which they've done before. So that's we already know the 9.8 one.
Yeah. It tends to approach that, or
So why
surround
are you going back to
right?
square one when we're already kind of like way past like determining the acceleration?
We're going back to square one because we're because otherwise we'd be operating under the assumption that everything falls at the same rate.
So I mean, but like everyone agrees 9.81, right? Or you agree with 9.81?
Yeah, as an average, right? It's an average. This is like
at surface level. At 9.81 is average at surface level.
Yeah, but applied to everything. But the question is, why do some things not fall at the same rate? Is it the case that we have a variety of objects that
you're saying some things don't fall at the same rate in a vacuum?
This is the point. Yeah, dude, this was the whole point of the test earlier, right? To demonstrate the possibility that things don't actually accelerate at the same rate. The whole point of
we disagree at that test because it had atmosphere in the vacuum, so it's pointless.
You're throwing that in there as a red herring.
No, okay. It's because to show what you're saying, you would have to show in a vacuum.
No, you wouldn't. No, you would not.
No,
if we do, look, here's the thing, right? If we do show it in a vacuum, okay, it would just accentuate everything that we're already talking about, because there would be less friction between the objects and the surrounding medium, so the things would maybe accelerate upwards faster, I should say.
Hey, I missed that part where y'all said that there was Atmos in the the tube, the little container. Where was that?
Yeah. Apparently, Naxi posted it, dude. If you can post that again, that would be great. So the configuration of that entire setup, according to the publication, and I think from the institution that actually hosted the whole thing.
There you go. From the European Space Agency that's associated with them.
Right. So the tube, yeah, exactly. So the tube through which the capsule is dropped is a vacuum. All the air is in the giant tube, but the capsule in which all the elements are situated is pressurized to one atom. Oh, he left.
Who did?
That's punch one.
No. Oh, he asked you for an explanation. That's great.
What I want to know is, after all this, does it really tell us how much wood a woodchuck chucks?
Not really. It really started with a genuine conversation from Naxi about something about why a bowling ball and a feather fall at the same rate, and I posited maybe they have similar densities. That's all.
So does any object fall at the same rate as any object in a vacuum?
That I'm aware of.
Like the demolition ball I was talking about earlier, like versus the feather in a vacuum.
The demolition ball and the feather would fall the same if you had a giant vacuum.
Right. So if you take away, if you take away the variable of the medium that they're falling through, which would be like the resistance of air.
Yeah. Atmospheric drag. Yeah.
Well, then that would deny mass attracts mass, though, right? Because you got like this huge thing versus this really tiny thing, and they would still fall like a BB and a demolition ball in a vacuum.
Wait, real quick, 20K. So wait, Tech. I know what you're trying to get at.
And blew up my phone, so
you're not.
Hold on, Naxi. She talked back.
Well, let me just answer his, because he's already muted. It's like what I said to you before, right? Yeah, okay. You drop the feather, you drop the ginormous construction demolition ball in a ginormous vacuum. The the construction ball technically would have an effect on the feather, but it's not big enough for it to be seriously measurable or significant, right? Like you're talking like, that's like the Earth affecting the moon, right? The moon. I mean, listen, I know. Don't go to a debate about that because I'm leaving in a minute. But the Earth, right? having gravitational pull on the moon, right? And the moon having gravitational pull on the Earth, right? Like affecting the ocean. Now, it has a strong enough pull to affect our oceans, but it's not pulling us into the moon, right? So the size matters. It's just not big enough.
I mean, dude, you say you don't want to be challenged on that, but you're stacking
no,
claims,
it's just
bro.
because I don't have
go
time.
that far.
I don't have time to go through it. I have like a minute.
Yeah, well, I wouldn't say all that stuff if you're not going to back that. Now, if you have to go, you have to go.
A different day. But
yeah,
it's the same thing. It doesn't matter. That's just an example. Again, it just goes down to the construction ball. Yes, it does have an effect. Not that it matters. It's not big enough. If you made it an Earth-sized ball and the feather was next to it, yeah, it would pull the feather right in.
I mean, okay.
Well, I'm not really talking about them attracting each other. I mean, like, put them each in their own vacuum tube and put them 100 feet above the ground. The rate at which they fall to the ground, not their mass to each other, their attraction to each other, but if you put those each in their own big vacuum tube, like a little BB, a copper BB, and a demolition ball, and they're at 100 feet, are they going to fall and both hit the ground at the same exact time?
Yeah, probably. Again, it most likely, as long as they're not touching, it probably would have an almost. I don't even know if you'd be able to measure the smallest significant effect that it would actually have. So yeah, they would fall at the same rate.
Well, that's the claim, though.
Well, I don't have. I don't have. I can't drop a construction ball with it. I don't have one.
So how about you say you don't know?
Well, because you could take a bowling ball and you could take a BB in your backyard and do it. You could climb up a tree and drop it and make a vacuum.
Okay, but right, fine. So I would ask you, what are the BB and the bowling balls made of?
Again.
Yeah. If they're the same composition.
No. Again, no.
Composition. If they're made of the same elemental composition, that may be a reason why they fall at the same rate. So if you're saying a copper BB and a bowling ball, well, one's made of copper, one's made of resin, and much other shit. Right?
But one has more mass, right?
So what? We already acknowledged before that a 10-pound bowling ball and a 1-pound bowling ball would fall at the same rate, even though one weighs more, right?
Yeah.
So the differentiating factor is not necessarily the mass or the weight of the two objects, but their elemental composition and therefore their density. That's what's up in question, dude.
Yeah, no.
That's why I'm pushing back on this.
No, I know.
Because you're asserting this
I
as if
disagree
you know,
with you because in a vacuum.
Again,
well, listen, I'll just say it again. In the vacuum, right? The 10-pound ball and the 1-pound ball, their own weight cancels each other out with gravity affecting them. Outside of that, the 10-pound ball.
What does that mean, dude? Hold on. Instead of going right into the explanation, let's talk about the
weird, isn't it?
phenomenon. It is. I don't know if it's just me, Sheepdog.
I don't understand. Like, if something
you following this?
If something big is pulling something else big, the two big things should be pulling it double.
The two big things? What do you mean?
Well, like if you have two objects the same size, they should be pulling at each other double the speed.
Yeah, but it takes more pull. It takes more, right? It takes more pull to pull a heavier, denser mass than it would a feather, right?
I mean, that works in theory, but that's not like
that's the answer to that. I mean, like I said, there's.
I mean, look. I'll put it to you this way: if I have a slingshot, right?
Yeah.
And I launch if I launch a tennis ball versus a bowling ball using my slingshot, which one do you think is going to go farther before hitting the ground? We'll remove the bounce out of it. Let's just say, which one do you think is going to go further?
You said a tennis ball and a bowling ball?
Yeah, and we're
same size slingshot, same size power applied to each ball.
Same size power applied to each ball because you have the Earth gravity, right? Earth's gravity is Earth's gravity, regardless. So rubber band is rubber band, regardless. And we're just gonna launch. We're gonna pull it back the same distance, and we're just gonna launch a tennis ball and a bowling ball side by side. Which one do you think is gonna go farther? Just before it hits the ground. Like after it hits the ground, obviously the bowling ball is gonna skip and probably go even further. But
Well,
let's just say if you have force, yeah.
If you applied the same forces to both balls standing at the surface, the bowling ball would fall. I mean, the tennis ball would go way farther than the bowling ball.
Right. So then why, if there's that, if that little of a force, right, from the tennis ball, like the slingshot is launching the tennis ball that much further, it should be dead dropping the fucking feather in a vacuum, bro. If we're assuming that it takes less to pull the feather down, it should be dead dropping that feather in a vacuum.
Well, I mean, hold on. Are you in a vacuum when you're shooting these? Like in a giant vacuumed container?
We can be. I mean, I've never shot a tennis ball and a bowling ball in a vacuum chamber before.
But what I'm saying is, just because the tennis ball goes farther with the slingshot than the bowling ball, that doesn't equate to. Then they should both be falling at.
It's the same force applied. It's the same force applied.
Yeah, the same force applied to different masses and density. The same force applied to different mass and density.
Right. So you have the same forces applied to two different mass densities for gravity. You have gravity applied to a bowling ball in a vacuum and gravity applied to a feather in a vacuum, and they're both falling at the same rate because it requires less energy for the feather to come down with than the bowling ball, right? It requires more energy, so it's not, the bowling ball is not picking up as much speed. But if I launch a tennis ball and a bowling ball
if you
with the same amount of force,
yes, if you
tennis ball is going to go further.
If you in 20K were up on that test tower, right, or up in where the test tower, and you were facing down, both with the same slingshots in a vacuum, holding your breath, right, or whatever, and you applied the same exact force to both objects in a vacuum, they would end up going the same time, same distance. I mean, same speed, because it would just be equaling out the force anyway. Because you wouldn't change.
I mean, that sounds wonky, man. Like,
no,
I don't know,
dude.
dude.
What do you mean? If you're in a vacuum and you apply the same exact force, it's like applying the same exact force when you release them. If you had a mechanism, nothing would change.
Like we would have to do the inverse.
Actually,
I'm going to say this real quick, and I got to mute up.
Wait, the speed.
Well, we would have to do the inverse. We would have to launch the balls up, not down. I would be more comfortable with the launching of the ball up from the bottom of the tube.
It would be the same.
Launch it horizontal from 10 feet off the ground in a vacuum with no other variables. The only variable is bowling ball, tennis ball. Let's say the slingshot's 10 feet off the ground and you're shooting perfectly horizontal. We're going to be measuring how far it is before they first touch the ground. Obviously, the tennis ball, vacuum or not, is going to go further because the force is the same, and it would require more force to push that bowling ball at the same distance as the tennis ball. Vacuum
but
or not.
I think what's in contention though, or what's kind of weird about this whole thing hence why Sheepdog's asking is if the force pulled downwards or pushed downwards or whatever from gravity by gravity on certain objects, right, is consistent, and you have two objects that are of different masses, if you have the same force applied to one versus the other, how come they don't accelerate at different rates if they have different masses?
Well, on the horizontal,
right? The same amount of force, so to speak. But I was going to jump in and say, Sheepdog, I think the reason why this question opens up a can of worms, right, into why, for example, people have started talking about gravity is not actually a force, but rather a pseudo force. because it doesn't actually exude the same sort of properties as any other force applied to any object would. So in this case, it's like some miraculous, magical phenomena that acts like a force, but not really, and it doesn't insofar as possessing the necessity to apply a larger amount of force to accelerate something at the same rate of something else that doesn't have the same mass.
That's just a cop out to me, though, because like
I
we have
agree with you.
other demonstrations.
100%. But this is their explanation for it. It's like their catch-all or their, get out of jail free card.
That's a good way to put it.
And that's why I said it doesn't gravity when they talk about mass attracting mass. Don't the two m's cancel each other out, and all you're left with is 9.81 meters per second squared? And if that's the case, then all we're observing is a rate. We're not observing anything else.
Precisely.
That's a good point.
I would say they'd still hit the ground at the same time, even horizontally.
Do they?
Because,
traditionally,
well, I mean,
classically speaking, they would.
No, I'm assuming because it would be the same if it's the same force applied to both of them, and there's no atmosphere, they'd fall at the same rate.
Yeah, it would just be at a different, over a different trajectory, right? One would
possibly
the same rate downwards, but it would be propelled laterally further.
Possibly.
Well, yeah. I mean, you have an object that weighs 1 pound, the other one weighs 1 gram.
Yeah.
You have however many newtons of force to it.
I thought we were 10 pounds and 1 pound.
Whatever, 10 pounds, 1 pound.
Yeah.
10 pounds, 1 pound. Right? They're going perfectly 9 degrees.
You want to hear what I think their cop out would be for that? The scientists would be like, "Oh well, hold on."
Getting arrested?
No, it's just a part of town.
He's reaching.
So the cop out would be, well, we need to apply the same amount of force that would cause the tennis ball to go 90 miles an hour for the bowling ball to go 90 miles an hour, and that's how we would get the same force. Like they would come up with some cheap ass cop out to say, oh, this is how we get them to go at the same speed.
I'm sorry, I'm just imagining you like in a high-speed chase and you're like still trying to have this Discord conversation.
I'm in the same neighborhood as a titty bar, man. I'm dropping off liquor.
He's got like a girl duct taped in the back trunk.
Yeah, and he's like, but the rate which the ball falls.
He's like, the earth is flat, the ball. She's like, just let me go.
Hey, Viking. I may have asked you this earlier, and if I did, I missed the answer. Are you familiar with this Bremen drop tower test with the various elements and shit along a different rate, supposedly?
Are you talking to me?
The Viking.
I'm not.
You're not familiar with this? Oh fuck! You gotta check this out, bro. You gotta check this out. Let me tag you.
Tell me again.
I'll talk to you guys later. See.
I'm going next. You've never seen this, dude? That's crazy. I'm surprised to hear that.
Say it again. And I got Google open here.
It's a drop tower test where this guy or these guys, they took a capsule and inside they put various elements. So blocks of lithium, boron, carbon, lead, all sorts of shit. Okay. They put it in this capsule. They pressurized the capsule to a controlled pressure, right? And they took that capsule and dropped it down a tube. But this tube was depressurized, right? They basically create a vacuum, or they tried to create a vacuum with it. Okay. Inside the capsule, they put a little camera to film the objects inside. So as the capsule was falling down, they noticed that each of these elements were rising up in the frame at different rates, indicating that each of these objects are falling at different rates.
Right.
Now it's very interesting because
Bremen?
I'll tag you in the chat. Oh, Miguel Sousa posted it. At 35 minutes past the hour? Yeah, 35 minutes past the hour, there's a video of it. Thank you, Miguel. Right, so each of these things, if they're rising up at different rates, it means that, they're falling at different rates because the capsule around them that's containing them is falling. Right. So the what's being posited is, hey, shit, maybe the theory that, everything falls at the consistent rate is wrong. And that's where the conversation opened up about all the, me inquiring into the densities of all these things that were being brought up in the conversation, like the bowling ball and the feather and all that shit. Right? Because it was asked, okay, well, why do these things fall at the same rate? Bowling ball and basketball, bowling ball and a feather in a vacuum, if all these different reasons. And I asked, well, are they made of a similar composition? Because if they are, and they have the similar densities, maybe that's why they fall at the same rate or similar rates. That was the crux of the entire conversation.
I got you. It's kind of like if you're in a car going 60 miles per hour with the windows up and you got a paper airplane in your hand and you hold it directly over the center console and you let go, it's just going to fall. Like that's like by putting it in the capsule, that's kind of like what it's doing. It's taking out the factor of the speed or the wind or and you're measuring how it moves inside the capsule to see if it goes like up to the top of the capsule or remains in the same spot in the capsule. Am I kind of getting that right?
I think so, right? Because like the idea would be this: if you take a capsule, and you put some stuff in it, and you drop the capsule, if everything falls at the same rate, well, all the stuff on the inside of the capsule that's also falling would just be stuck to the bottom of the capsule the entire way, right? Because they're all falling.
Yep.
But you see in these videos, these things start fucking levitating and shit, indicating that they're not falling at the same rate.
Ah, that's interesting.
Right? So they look like they're flying up from the vantage point of the camera on the inside.
Right.
Right.
This kind of brings up, like, one of the arguments I hear flat earthers use that I think's a bad argument is like, how come you don't go up in a helicopter and the earth moves underneath you and you land again? It's because, like, you always have to play devil's advocate. So, I've done a couple experiments like with lasers to try to measure curve at the ocean. I've measured flat. I've not been able to find a curve. But at the same time, any good scientist needs to try to play devil's advocate and test the other way, right? So like the whole helicopter hovering and the earth moving underneath you can't be a good argument because, like, if it is a globe and spinning 1,000 miles per hour, the helicopter is moving the 1,000 miles per hour with the earth. So like when it takes off, it's all relative, right? Like it's just going to hover in place because the atmosphere would be moving with the earth spinning, right? So like I think that's a poor argument for flat earthers to use. They'll say, like, how can you land an airplane on a runway if the earth is spinning 1,000 miles? Well, it's because the plane is, in theory, if you're going by the heliocentric model, the plane is moving with the earth, right? So I hate when people try to use that. That just reminds me, because when we're talking about moving in the capsule, it's kind of the same thing.
Yeah, but I think.
Well, I go with this whenever I hear that. I say, well, if you're in a car and you don't know you're moving, what's the best idea of what you think is going on? You would think that you're parked. Even if everything was moving around you, you would think that you were parked, unless you could somehow get outside of that car. But if you can't get outside of that car, there's no reason for you to assume that you're moving at all.
Right. Like if the windows were all blacked out. I'm sorry?
Well, I don't think that it's necessarily an argument used specifically for that, but I think it's kind of a rebuttal to the argument of somebody talking about the Coriolis effect, right? So if bullets are they take Coriolis effect into shooting over long range, right? Like supposedly. The argument is, if that were the case, you would experience a exponential acceleration up to the maximum speed at the lateral that you're on the globe if you did take off in a helicopter. No, it wouldn't be instantaneous, like leave the ground and boom, it's like spinning crazy fast. But if the Coriolis effect was actually testable in there, it would be as you go up, once you reach a certain point where you have a density difference, right, which would also be a density or temperature difference in a layer of gas, like the Atmos, you would have a slow acceleration according to science that would slowly, like it would be holding more still relative to the spinning Earth, given the given how thin the air is at a certain point. And I'm not talking like so thin that planes can't fly and helicopters can't hover. I'm just talking thinner than it is at the direct ground, like over the stratosphere where the clouds are. You know.
Well, if you think about it in a drone aspect, in a drone aspect, or in a helicopter aspect, you're gonna even the autopilot is gonna maneuver to stay over the GP position that it's at. So I wouldn't even make that argument. I kind of tend to stay away from the whole tangential speed of the plane landing and everything like that. I'm more of a guy that I'm like, if you can't tell you're fucking moving, why would you think you're moving?
That's also like the main thing, but that I would just say that's a simple response as a rebuttal to a Coriolis effect argument as well. We don't experience it with anything that flies in the atmosphere, so why would you expect to see something flying
Well,
through the atmosphere to take account for it?
We don't account for it with projectiles either, or ballistics,
Exactly.
because when I was in the military, I asked that question. They said, "Hey, you gotta when you're shooting, you gotta take Coriolis into effect." I said, "Okay, how do you do that?" Because I wanted to be a good marksman. And they said, "Don't. We don't. Next, we're gonna move on." Like they don't account for it. Heat, air pressure, and your windage are your main contributing factors to
and
how your
also your
projectile is going to
angle.
go through.
Your
So
angle,
if you miss your target, you're not going to say, "Oh, I missed it because of the Coriolis effect, and now I need to calculate for the Coriolis effect." No, you're going to adjust for your windage, or you're going to adjust for the pressure, the temperature.
Yep.
Yeah, the temperature, like you can observe that like on a motorcycle. You're going down the road and you'll feel the temperature change maybe 5 degrees every 500 feet. Like little heat pockets and cool pockets of air, and that's going to affect the bullet thousands of times more than the Coriolis would if it existed. That's the factor, and then wind. And yeah, you would just adjust for that. Okay, I'm shooting dead center and it's hitting 6 inches to the left, so I just shoot 6 inches to the right and hope that all the factors stay the same on the second shot. It's not.
Also, the rotation
That's
of your
all it
bullet
is,
matters,
man.
how fast it's spinning, and how actually like circular it is. If it has any blemishes on it, those are all going to act as fins, and when they're spinning, you'll get an effect one way or the other. The same way when you hit a golf ball with a golf club,
Throw a football.
if you don't hit it square, right?
Even
You don't hit it
artillery.
square. Yep,
Artillery when they shoot, they don't account for Coriolis when they miss. They have a forward observer, someone who is up front and marking the grid, and they say, "Hey, you missed. You need to adjust your fire by this, and then fire for effect." That's it.
And how far does artillery shoot? Like average?
10
It
miles.
depends. It can be like 100 miles, I think, if I'm not mistaken.
I mean, even like mortars are
You
doing
know
like
what?
10 or 12 miles.
Look up 155 howitzer. Just do
155.
155. Yeah, 155 mil. Damn it. I don't
Yeah,
want
how
to
far
lose
do
that.
they
I don't want to read that because I'm going to debunk that
Because if they
too.
shoot over than like 2 to
One,
4 miles,
15
then
15 to
they don't take
19
it into.
miles.
Yeah, boom.
there
And
you go.
and precision munitions can do 25 to 68.
They definitely don't take the Coriolis effect into account when taking those shots. Otherwise, they would not be even shooting in the same direction that they're trying to hit something at.
Yeah, that's crazy, dude. 25 miles up to 68 miles. You wouldn't even hear the thing fire. You just
It would just go.
blow up.
You're just getting hit.
You'd hear one little sound about a quarter of a second before you're in 1,000 pieces.
How fast do those shoot? Like from firing to impact, how many seconds? Like how long does it take the actual munitions to get, like the projectile to
How
leave the
long
barrel to
does it?
yeah.
How long does it take for
Give it
a?
50 miles. Let's say 50
Well,
miles.
just do feet per second. What's the how many feet per second does the projectile come out?
That's not the answer we were looking for, but that's the answer we got. We're turning left at the next light, boys.
Some badass GPS, man. Help you lose the cops and everything.
Can't turn left on a globe.
So
Explain
a
that,
howitzer,
globies.
155 millimeter howitzer to reach 60 miles would be approximately 2.5 minutes, and it would reach peak altitudes of roughly 100,000 plus feet along its high arched ballistic trajectory.
It's 1,850 to 3,000 feet per second.
That's insane, dude. That's 3,000 feet per second is like some of the highest powered
So
hunting
basically a
rifles.
half a mile per second.
It's like the speed of a 30-06 bullet, but it goes 60 miles.
You wouldn't hear that before it hit you. You wouldn't hear
No.
anything.
If you hear the shot, you're still alive.
Most gunshots you wouldn't hear before it
Right.
hit you,
I
though,
mean,
to be fair.
even the 22, you can buy supersonic bullets, you know.
But for
Well, I
over
mean,
that
even then,
distance,
a
that's
22, it depends on how far you are. But like, I mean, most gunshots, if you're gonna get hit by it, you're not gonna hear it.
Unless
Or
you
if
had
it's gonna kill
a
you, at least. If it's gonna
subsonic.
kill you, at least, I should say.
If you had a subsonic rifle, you'd technically hear it if you got shot with subsonic ammunition.
Yeah, about 1/10 of a second before you're dead.
Yeah, you'd hear it crack. That's about it.
Yeah.
I got tinnitus. I wouldn't hear shit.
You just think
I don't
it's
know.
firing at you all the
Bro,
time.
dude, yeah.
I hunt
Constantly
there with
worried.
subsonic 300 blackout with the suppressors, and that's just in case like you don't want to be heard. You want to be as quiet as you can, especially if you anger a bear. You don't kill it. If you just hit it.
Speaking of shooting, I was at a friend's house today, and he had a 22 Savage that takes like a 10-round magazine with a suppressor on it, and it literally sounded like when you tap your finger on like a wooden board. Like it was. It
Were you
sounded
shooting
quieter than a BB
Were
gun.
you shooting subsonic ammo?
Yeah, and through a suppressor.
Okay, I was gonna say if you use a bigger gun or rifle of some sort, you'll pretty much just hear the chambering. You'll just hear I
Yeah,
swear
we
it
have a
sounds
firing
like
pin.
yeah, that's all you hear. It sounds like a cash register opening.
Yeah, this wasn't even that
Like
loud. I mean,
it's just like ka-chink, 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 ka-chink.
yeah, like he was shooting. Like this is out in the country, but he has a neighbor like right across the road, and they were outside, and they never even like turned around and
He
looked.
never saw it
And
coming. He got them all out quick.
yeah, they were all down.
They're the HOA hunters.
And if you use the right round at subsonic speeds, it has much higher knockdown power as well. Got to be the right ammo. I'm not saying all ammo, but
The thing about neighbors out in the country, they're probably out there shooting their guns, saying, "Hey, you want to shoot mine?"
Yeah, that's kind of how it goes.
That's how it is.
Yeah, that's the thing about living in like rural areas, bro.
I let anybody
It's
shoot
great.
my gun as long as
It
they
is.
like.
It
If
is.
if
It's
they live
nice.
around me, if they're shooting guns, I'll let them shoot my guns. I don't care.
I have a neighbor who like we used to have these chicken houses that people would put up around here, and they're like these super long buildings. They'd bring in like 100,000 chicks at a time. Well, they're pretty much all shut down now. Well, my neighbors bought this property that had 2 of these chicken houses on it, and they got one set up where they just put round bales in the end of it, and they built their own shooting range. So you're just like shooting into like 50 feet of round bales, and it's great. Like these guys are really rich, and they have like so many guns, and they just let anybody come over and when they're shooting and shoot anything they got.
I'm going to make a lot of people mad. You want to know what gun surprised me the most, and I think is actually a good under the seat weapon?
What's that?
A high point.
Hey, if it doesn't fire, you can throw it at them. Those things are a brick.
Yeah, they're
Oh,
still
bro, but
accurate if
they
you're
do
actually
fire
just
though.
throwing a baseball.
Yeah,
I've
those
never,
high point. You seen the
bro.
carbines they make? They're like $250, and
Yeah, you slide the gun up inside of it.
yeah, and those things are great, man. Like, I don't care what anybody says, they fire every time. My everyday carry is a Turkish gun called Thesis, the PX9, and it was $250. It goes into a Springfield holster. It uses Glock sights and it uses SIG magazines. And I've put probably 1,000 rounds through it with every kind of ammo, from like tool ammo, that cheap steel stuff, all the way up to like Hornady, critical attack, and never a failure.
I'm gonna say this. I know we were talking about Coriolis and it took a tangent on the guns. We kind of need to steer back towards the conversation,
Yeah, that's
or
fine.
something around the nature of Earth. Yeah.
Well, this comes from the other side of the plane, and it fires great.
If you put a Smith and Wesson in a high point in a vacuum and you drop them from 30 feet,
No, so I did like when flat Earth became like a key word, that was like in 2015 or 2016. I'm the kind of person that, like, I have to see it for myself. So I live in Tennessee, but I'm originally from Central Florida, just north of Cape Canaveral, and a guy that I grew up with owns a couple charter fishing boats. So I went down there. When I was down there on vacation, I got with him and we did a laser experiment at the beach. We got a 500 milliwatt laser. I had to order it from China because it's illegal in America. We set it up on a tripod at about 8 feet and shot it horizontal. And the way that we measured horizontal was we went out about half a mile and measured it again at 8 feet. So, it could have been off by a couple degrees, but for all intents and purposes, it was horizontal enough. And we ended up going a total of 16 miles, and we still measured the laser at 8 feet. And then another thing we did was at the inlet at the south part of Daytona Beach, there's a lighthouse at Ponce Inlet that's 175 feet tall, and it's like the base is like 4 feet above sea level, so call it 180 feet. And we went down to Melbourne, which is south of Cape Canaveral, and we went out about 12 miles. I marked it on Google Maps and then used the measuring tool on Google Maps back to the lighthouse, and it was 62 miles. And we were able to still see the light of the lighthouse at nighttime from 62 miles. So those are the two experiments I've done personally, and that's because I was a glober. I mean, when I saw the flat Earth topic, I was like, I saw everybody calling names, and I was like, nobody's really accomplishing anything on either side. So, like, I'm going to go do this myself and try to be reasonable and talk to flat earthers and tell them they're wrong. And then I went and did that. And like, then I realized the only evidence that we have for the globe argument is hearsay. It's like from a third party. So that's what really opened my eyes and ultimately makes me now part of this channel,
another thing that opened my eyes a lot was like, you see when these news articles come out, they say scientists say this, scientists say that. And they never name the scientists.
Right.
It's
Just
With
this generic
the
person.
lighthouse thing, the response from the globe side that I've heard on the lighthouse is light travels in all directions, right? Like the lighthouse isn't focused, so some of that's traveling up, and it can arc downwards through refraction. So that's why you could see it arc upwards, and then you'd be able to see the light from it, even though it's beyond the horizon, because the light's traveling over the horizon.
Right. So refraction exists, but like at that distance, you'd be talking like it's clearing like 6,500 feet or something of a hill. So the thing was, it wasn't just like the light from, like we could see like the dot that is the light source.
Yeah, that would be the light that's traveling upwards over the horizon.
6,500 feet.
Mm-hmm. Yeah, give the observer measurement. I mean, you don't have a picture of it, but if you did, we could like show it and everything.
Prove it.
That makes sense. If you have the measurements.
Prove it.
I can't if you don't give me the measurements, though.
62 miles. Lighthouse is 180 feet. My eye height was probably 10 feet.
How do you know you were 10 feet? How do you
That
know?
would be a
6'2" and I'm
refractive.
standing
That
on the
would be
deck
a
of a boat.
refractive rate of. That would be a refractive rate of 1. Can you show that in reality?
I don't think you're doing the math right because we're not talking about an observer. We're just talking about a light going up and then arcing downwards.
Okay,
So I
so the
don't know
light goes
how.
up
I don't know what
and
the
then
calculation
down.
would be, but we could go through it if you want.
The
Well,
light goes
here,
up
Earth
and
curve,
down.
Earth.
But I don't
Earth's
want to do
curve's
like this
got
random,
the.
like, oh, I think it was 30 yards away, or I
Well,
thought
you
it was
just
300 yards
you
away,
just
and
said I
maybe I was
think it.
10 feet
You
up.
just said I think the light bends around the Earth, though.
It does
Okay, prove it.
because it just depends on what the temperature inversion is.
Because it does, right?
Just depends on what the temperature inversion is. Depends if the water's warmer or the air's warmer.
Okay, so here is in the side chat. Here's the math for you. Here's the numbers.
So you don't believe that a light arcing upwards, like at, let's just say it was like 40 degrees upwards, you don't think that would be able to arc downwards and you'd be able to see it with enough refraction?
No.
I mean, in my whole life, I've never been able to see over hills ever.
You're not light though.
I mean, I live in East Tennessee. There's hills everywhere. I can stand here in the backyard, and there's a gas station across that hill. I can't see the light from it.
What makes you think
I don't know,
that
man.
light
It seems
debate, Daddy? What makes you think that light can do that?
You should be able to see a town behind a hill if that's the case.
Right. I got X-ray vision.
Yeah. What in reality makes you think that light can do that, debate, Daddy?
that refraction can bend light
at that amount.
That's just the definition.
Because refraction can bend light, therefore the Earth is a ball and light is bending around the Earth.
It's just the definition. I don't really have.
So what about my?
More.
Okay, can you
what about my
demonstrate it
laser?
doing it at that rate?
What about my laser experiment at 16 miles with the same exact height? Does the laser bend
Did you
perfectly
level it?
with the conservative?
Everyone
Yeah.
I've seen hasn't been leveled.
Yeah.
What device did you use to level it?
We measured it at each distance, like each mile all the way out, and it's the same height.
The angle of the laser, was it? Did you use a theodolite?
A 500 milliwatt laser on a tripod.
This guy, man.
Did you level it?
More like a bubble.
Yes, I leveled it. Yes.
With
so
what?
Now explain.
You leveled it by looking at both. You leveled it.
I
by.
measure how
how
it
do
is
you
off
measure
the
it?
ground where the tripod is, and it's 8 feet. I go 1 mile out, it's at 8 feet. I go 2 miles out, it's at 8 feet. I go 3 miles out, it's at 8 feet. I go 4 miles out. I can keep doing this all the way to 16, and it was 8 feet.
So you didn't measure the instrument at the location, like with respect to the ground underneath it?
I think the way I measured it's even better.
No, that's fucking horrible. That's a good way to beg the question.
Right. So the laser
How,
perfectly bent with
how do
the
you know
curve
it
of the
wasn't
Earth.
retracting around the ball?
What would be great is if you leveled it with a proper precision instrument,
Oh my
and then we
god.
wouldn't have these kind of questions because of basic inaccuracies. If you want to
What
do
would
willy-nilly
what would
experiments that don't
you
prove
lose?
anything,
What would
you can
you
go and have
use
fun in nature
to?
yourself. That's fine.
What would you use to level it to make that?
A theodolite, any
You would
leveling
level
instrument
it
would be
with
great.
a theodolite. How would you level it with a theodolite?
How would I depends on the manual that from this
How would you
specific one. Like
level the laser
I would pull
with
out the
the
manual and I would
theodolite?
read the manual on how to do it.
Theodolites don't level lasers.
It's like you're just really reaching, bro.
Have you ever picked up a level before?
Did you even do that? Like, did you even use a level?
Let's imagine I
a
pointed
bubble,
it.
like a bubble level?
Okay, so let's imagine it's 2 degrees downhill, and then let's
Debate Daddy's
imagine
like,
it's
yeah, I
2
hung a picture
degrees
once.
uphill.
Well, did you
Either
even
way,
use a bubble level? That's what I'm wondering. Did you use any level at all? Anything?
okay, so let me go back to what I was saying before I was interrupted. Let's imagine I
Oh my
pointed it
fucking
2
god, you
degrees.
didn't. Okay,
There
go
we
on,
go.
go
There we go.
on.
Yeah. So don't hear it. How would it work either way? If it was pointing up or pointing down, either way, how would that allow it to be exactly 8 feet, the same exact height at 16 miles on any kind of curve?
It wouldn't.
You're not like you could say, oh well, what if the laser's curving at exactly the
I'm
rate of the
giving
Earth
you,
and we're getting
I'm
8 foot
giving
every
you what you
time?
want.
Also, I
I'm
don't know
giving
if like
you
you're talking. Are we talking about because how wide is the beam getting at each of these points? Like how on target are we talking here?
at 16 miles, it went from being maybe 3 millimeters wide to maybe an inch wide.
Okay, did you document this?
It was 2015, and I was arguing on the globe side. I imagine I'm not even going to see it at this distance.
Hey, Debate Daddy, has anyone ever measured the curvature of Earth with a laser?
Yeah,
I don't
that's
think
fine.
lasers can take measurements
Okay, so how did you measure? How do you know the Earth's curving?
because, well, I could dump a bunch of reasons inside chat.
Okay, were you as critical with the
Like-
things that you found out? Let's go with the first one that you're going to go with. Let's see
I know
what that
that
is.
your mom is curving, though.
The thing that was compelling to me was
don't talk. So just present the first one, right? And then we'll go into it.
sure. Yeah, I have the pair of the amateur rocket and then the amateur balloon that came afterwards, where they put the strings taut in front of it to show that there's no barrel distortion. But both of them show curvature. And
okay, from what height?
This one here, this is a screenshot from the full video you can go and look at. That was 37,600 meters.
So just above a plane.
Yeah.
Meters.
Meters. Yeah, higher than a plane.
Yeah. Okay.
But you can see here.
What type of curvature? One sec. What type of curvature are you presuming you'd expect from that height?
The exact amount that you see. That's the amount that
And
you would expect to see on a globe.
How did you
is exactly what you see.
How did you work that out? How'd you work that out?
You can
what equation
calculate
did
it.
you use for that? Okay, what equation did you use for that?
There's a relationship to a sphere, but I mean I've shared it here before, right? You guys have seen it.
I haven't seen it. What did you use to determine that that's the type of curvature that you would expect from that height?
You take the height that you're at, and you can calculate how much curve you'd expect on a sphere from that height.
Yeah, and how'd you measure the distance across the camera?
You don't need the distance across the camera. You just need the
Yeah, you
arc
do,
of the
because
curve.
you need to know how much.
You just need to know the arc of the curve and the height.
Sorry, he's still there.
Yep. You just need the arc of the curve and the height.
So you need to know the distance. You need to know the distance over the camera, right? What are you seeing through that lens? How many kilometers across?
I don't know. I don't think you need to know that for the formula I use.
So
This
how
was
do you
a
know
little
how
bit ago,
much
but
How do you know how much curvature you should expect if you don't know the distance from the edge of the camera to the other edge of the camera?
I'll just post these three. That one, and then these three were the most precise. There's a paper actually measuring the curve of the Earth from a plane. There's an amateur rocket launch
The curve of the
here.
Earth from a plane.
Yeah, this amateur rocket launch goes even higher, and you can see even more of the curve in these rectilinear lens. So
okay, so how do you know? So are we moving off the first one? Are you moving away from the first one? Are you conceding on the first one, or so? How do you see? This is the thing, right? So you're not as critical with these ones as you are with flat Earth, right? So you got a double standard.
Well, you guys asked me why I believe in the globe, or what measurements I have. Here they are.
I was trying to prove a point to you.
You don't.
So you're critical about what other people have done, but you're not as critical when it comes to the globe, right?
I told you I did all the measurements here. I could dig them up if you want.
Okay, so
but he didn't even bother to do a simple level. And I've never seen a simple level on any of the laser experiments.
What's the distance from the left of the camera to the right of the camera on the ground?
I'm sure you could calculate that.
How do you calculate
but
that?
You don't need to know that. I don't think you need
do
to know
need
that.
to know that because you've got curvature, right? So are you saying the curvature in the camera is left to right?
Let me grab the formula for the relationship of a sphere.
No, is the curvature in the photo from left to right?
The curvature from left to right. You just need to know the.
So what you need to do
know the
is
height.
you need to know the difference between. You need to know the distance from the left to the right to know how much curvature you would expect from that height and that distance over that photo, right?
I'm not convinced of that. I can look up the relationship to the sphere formula.
Well,
I think you just need to know the arc.
Because
if you know the rate,
are you going to measure the?
If you know the rate of the arc and the height, you can.
How else are you going to know if the curvature is correct if you don't have the distance from left to right?
I just want to know if my laser's not level and it's pointing down, one of the results.
You need the distance to the target, but not the distance across.
What curvature are you measuring? The left or right? Left to the right? Or front to back?
I don't think the relationship to sphere is core formula is r Earth's radius, d distance to the target, and then the drops how much the surface curves away. I don't think that's the right formula for this. One sec, let me just pull this up.
Because the only thing you're looking at is left to right curvature, which you would need a distance from left to right to know that the curvature that you're looking at is what you would expect from that height on a globe of that radius. The only way you can do it. You're not that critical about that, are you? Because it agrees with what you believe.
Of the here's the thing is, if it's not physical curve, right? Because you can see the strings are taut in that image, right? There's lines drawn there, and then you can see that there's straight dots photoshopped onto it, the red dots. You can clearly see that there is a curve arcing very, very clearly.
So what? Are you talking about the first photo?
What? Yeah, like what is
which
that
one's
if
the
not?
which?
Because it's
So
not
which one's?
distortion.
Okay, so how do you know that string's taut?
Because it's straight, and I drew a line there in front of it showing that it's straight. And you see him at the very beginning of the video.
Which one's the string?
There's a yellow one and a blue one below, so 2 strings.
Yellow and a blue one. I can only see a black one.
You can see him tying them in the beginning of the video. He ties them so you know that there's no distortion going on. And the reason that he did it this way was because in the rocket launch, they didn't do that. And people were saying, oh, this is proof of the globe. And then the number one critique of that was, oh, what if it's just barrel distortion or whatever?
It's a blue string.
So
I can't see a blue string.
There's a string a third of the away from the top and a third of the way from the bottom.
If you take the blue pill.
So what are the 2 strings tied? What's the blue string tied to? What are they
It's tied. There's like on the weather balloon. There's like fasteners in front of the camera that he tied the 2 strings to in front of the camera lens. And what this shows is if there was any distortion happening, you would see the distortion in the string as well. And if you don't see it, then it's going to be either it's going to be physical geometry, like physical curve, or the only other flat Earth response I've seen is, well, you can only see so far, and you see in a giant circle around you that matches the curve of the Earth perfectly. So that doesn't. It's like even if you were partially in space yourself, you would expect to see exactly what a glober would see. Which to me, I just feel like that's kind of ad hoc. Like, who's to say that you would see in a circle if you were that high up? I just don't believe that.
So if this is curving left to right, what's behind it? Curving left to right as well?
What's behind it? Just that's the drop of the Earth.
Yeah, like if you turned 180 degrees, would you also see left to right curvature?
Yep. The weather balloon like spins around for the whole video, and you can take like any still you want. Once it gets to this height, you can see it very clearly.
And then if you turn 90 degrees, would it curve left to right as well?
Not like 90 degrees to the left or right.
Yeah.
Yep.
So how do those
you can see it spinning the whole video.
So how do the lines intersect then? If you've got 4, say you turn 4 ways, right? You turn 90 degrees, 90 degrees, 90 degrees, and you see left to right curvature. Where do the 4 lines intersect, the 4 humps?
Because you're 30,000 feet up, it just would form like a ball if you kept spinning around. It would form like a big circle around you.
But you're always on top of a ball, right?
Yes, we're on a ball, yeah.
So no matter where you look, the ball would go down in all directions at the same rate, right?
Yeah.
Yeah. So why is there left to right curvature on top of a ball? The lines don't intersect. If you draw if that's say in front of you, if that's 90 degrees of what you see, you draw left to right, and then you turn 90 degrees, draw left to right curvature, and because everything you say I'm on top of a ball and everything's going down at the same rate, you're going to end up with 4 humps because the lines don't intersect. Does that make sense to you?
No, there's no like 4 humps. I think you're confused.
Okay, so if you turned around 180 degrees, would the horizon on the other side be at the same height as the one in front of you?
It's just a circle. I don't know how to. You're. I think you're a little bit confused. You're saying.
I'm not
Well,
confused at all, dude. You're always on top of the ball, right? You're always 90 degrees above the ball. If you look in all directions, the horizon line will be a straight line around you because it's falling away from you at the same rate, right? So if you have left to right curvature, none of those lines will meet back up and they don't intersect, not completing a circle. Doesn't make any sense. No matter what direction you look in and you have a left to right curvature, you don't have lines meeting up anymore. So if you turn 90 degrees each direction, you've got 4 humps. Doesn't make any sense.
So you don't think this image is possible then?
Well, you just shown it to me, so it's.
You can look at the video, right? This is a still from the
It
video. You
doesn't
can go and
matter,
like
but it's
you
got to
could
be.
piece
Well, it's got to be
go
something, right? So, but
go
it's not
go
Earth
go to the
curve.
video and piece it together to like
That's
show.
fine. I'm driving at the
You could get a
moment, so
panoramic.
I'm looking at your image, but so
You could
you'd
get a
have to
panoramic
admit.
view from
You'd have
it,
to
right?
admit. You have to admit, right? If what I'm saying is correct. If you've got a hump in front of you,
You could do it.
left
Go
to
get
right
the footage.
curvature, you've got 2 edges that drop down. If you're always on top of a ball, then you also have other edges that are going to drop down on the other side, making humps all joining together because the lines don't intersect. So obviously, there's something happening visually, but it's not Earth curve.
I don't think so. Again, like this
Okay, so
isn't even like
explain to me, if you're 90 degrees above a ball and you have left to right curvature, explain to me how that works if you're 90 degrees above a ball.
well, number one, you're assuming that this image is level, right?
Are you on the side of the ball?
The
Is that what
balloon is
you're
like
saying?
tilting back and forth as it's going up and down. You can watch it. You can see it's spinning. It's tilting. If you looked turned around 180 degrees, it might be low. It might appear lower in frame if you held it completely like in
Yeah, but that would just
axis.
be a camera angle. We're talking about in reality,
That's
right?
fine. And you could see it spinning like that in reality. And in reality, when you watch it spinning, there's not this like
Yeah, but
weird
concentrate on the
optical
horizon
illusion.
that
You just
you're
look at the
talking
footage.
about.
There's none of this
So
weird.
in reality, would you see a curve left to right if you're 90 degrees above a ball?
Yes.
You would. Then you'd have humps.
Oh, do you want to look at the footage? Do you want me to pull up the video? Because I have the
This
full
guy.
video. You want to go to the video? We can go to the video. We'll see if there's humps. I'll show you no humps are involved.
Then the video is showing you something else. If you're claiming that this is left to right curvature, you have to have humps.
Right, this is the full video. I'm pulling it up.
I'm driving at the moment, but I'll save them.
When he starts out the video, he shows the full setup and he attaches the strings. You can see him launching the balloon. If you skip to like around 2 hours, 3 hours in, around like 2 hours and 20 minutes in, you can see the full curve of the Earth in frame. You can even seeing it. Here's just a random screenshot I went to. You can clearly see curve here while it's spinning, and you can go frame by frame. And again, this is like curving against barrel distortion. If it was barrel distortion, you would expect that it would curve the other way. So it can't be that. And there's clearly a curve there. And you can watch it spin if you go there. And there's none of this the dip thing that you're talking about.
So now it's curving to the left.
It's like a balloon. I'm watching it spin right now, spinning the whole way through.
And so how do you know
lower.
that? All right, the strings are level, right? The strings are straight, and now it's curving to the left. So that would suggest to me that the camera's slightly offline.
You could watch it. Go to 2 minutes and 20 or 2 hours and 20 minutes. You can watch it spin, spin and spin. Sure.
Yeah.
Oh, you can pull it up later.
Wobble and spin and wobble and backwards and forwards and left and right.
Yeah.
Yeah.
But you can clearly see none of the weird like the dip thing you're talking about. As it's spinning, it's wobbling a little bit, but you can see one
thing that I was talking about.
You can see one continuous curve here.
What dip thing that I was talking about?
The weird optical illusion thing you were like trying to get at with it going up then down then up then down, like wavy up and down.
What? I'm talking about the camera. The camera is going to wobble, right?
Yeah.
I didn't say it's going to go up and down.
You were saying it goes up in the middle of the frame, then lower towards the edge of the frame. If you turned, then you would expect it to go back up again, right?
No, I was saying that last picture that you posted just looks like the camera's leaning to the right, therefore making that edge go down, right? Because the strings are still straight, but now there's a curve on the left-hand side.
Are you fucking retarded?
And 1 second later, it's 90 degrees to the right, and you can still see the same continuous curve. You should just watch the video. Like this.
Well, how do you know it's level?
This convinced me.
How do you know it's gone back to level?
It's wobbly. I don't know. There's no level on it. But this convinced me. That's what the other guy asked. He said, "What was what?"
Yeah, I know. I was proving my point, and I just proved it. That you're not as critical with Globe.
They control for barrel distortion. Then they launched
evidence.
this.
Yeah, but it doesn't matter. You can control for barrel distortion, right? There's always barrel distortion.
What do you think's going on here, then?
The camera's not level, right? All of the time.
What is it?
Because
what does that matter?
Okay, I'll say it again. If you're getting a curve left and right when you're 90 degrees above a ball, then you have humps.
If the camera's level, you're saying that there would be this optical illusion thing or this weird contradiction. But if the camera's not level, then it would just dip. If you turn 180 degrees, it would dip lower, down, and when you turn 180 degrees back around, it would go higher up.
You're not completing a circle.
You can see the circle in the video. I
know you can
I don't understand.
See the circle because they complete the circle, so there must be something going on the video that's not completing the circle. Because if you've got a hump left to right, then you have humps. You don't have a complete. You don't
can see it in the video though. I don't understand. Like, there's weird. it's weird conjecture because like I can just look at it right now. I'm looking at it in the video right now, and it's curving all the way around.
Okay,
So I don't know what you mean.
Draw me something, right? Draw me something that you see left to right curvature and left to right curvature 180 degrees behind you, and show me where those lines intersect. Go on. Draw me a picture. Show me where two lines intersect, where there's left to right curvature in front of you and behind you. Should be pretty easy to do, right?
I'm not that good of an artist. I'm literally not that good of an artist. Like there's a video here showing it all the way around, 360 degrees around.
Yeah. So now you should be able to show me where left to right curvature, if you're 90 degrees above a ball, can be in front of you and behind you, and where the lines intersect.
I'm watching. If anyone else pulls up the video, it's 2 hours and 20 minutes, and you can just see it spinning around, full curvature, full access. So
yeah. That's because the lines.
I don't know what else to say.
That's because the lines intersect,
better than my drawing.
Right?
It looks like it intersects. It looks like the camera's going all the way around.
Yeah. Now show me.
I can't draw it. I'm not that good of a drawer. I'm not that good of an artist. I don't know why you're demanding
curving left. I'm getting sick of repeating myself.
I can't draw that. I don't know how to draw this.
I know, because you can't draw it because they don't intersect.
You would just draw a vantage point above it. You would just draw a big arc. It would connect. I don't understand. It looks like it's connecting in the image.
And you draw a circle with a flat line around it, right? That would be a straight line in 360 degrees. That's what it would look like from a sphere as well. No,
I don't know. It's getting late. I got to go to bed. There's the video that's compelled me. The other one did too.
Next time when someone gives you some evidence, maybe be as critical about the globe evidence as you are with someone else's evidence. All right.
The other one.
I just want to know how I would get this. If the laser was not level and it was pointing any direction up or down, how in either instance, whatever you think that would still give me the results of exactly 8 feet at 16 miles. Let's just assume it's not level and it's 2 degrees up or 2 degrees down. How is that going to affect and give me those results? How?
Well, the laser is affected by refraction. You agree, right?
Not 2,000 and something feet worth, and it's not going to curve perfectly with the curve of the Earth.
Okay, but
so let's assume there is refraction, but it's not going to be exactly the same height, like within inches at 16 miles.
Sure. So one of the critiques, in the 3 bullet points I linked above, which are still there, you can grab the barren root lineage.
I've been sitting here going through
one
them
of the
already.
One
of the critiques of that's a 1 mile precision measurement. One of the flat Earth critiques of that is that Barron he just kind of like takes the temperature like at his post, and then he like estimates the refraction. So
it's temperature, not the level.
Yeah, like temperature effect. Well, no, he's leveling it, but like he takes the site, but he accounts for refraction, but he's only taking temperature and like only at his station or whatever. So he's just estimating it. And so one of the critiques, like DJ makes, is that he's not actually doing like precision refraction measurement on the day. So he's just like factoring in whatever like estimate that he has. So he can like DJ's accusing Barron of like kind of just, doing the gerrymandering refraction to fit the curve or whatever. And what I would say, like back to you, is, well, if you're not measuring in either, you're not like doing anything better than Barron, right?
Okay,
you don't know the refraction on the day either, right? So like we don't
so
really know.
Let's say it's 2 degrees uphill. How would I get those results? Then let's say it's 2 degrees downhill. How would I get those results? Regardless of temperature, refraction. So one would either have to go through the water, or the other one would have to go perfectly curving with the Earth. How? What are the odds of
If
that? It's going to be like in the
if there was,
trillions.
who knows if there was ducting? We don't know. Like we have to rule that out.
So,
That's the job. That's your job, is to rule out ducting. Rule
right.
these things out so that they're not on the table.
Right. So let's just bring ourselves to reality. We're normal people, and let's use what we have in our hands, and let's look at those results and say, well, it's going to take a whole lot of really wild variables to give us these perfectly flat results. So it would be easy to assume it's much, you'd have to have a lot more faith in some really crazy variables to still assume that it's a curve. I mean, it's wild. I mean, it's not even realistic.
You could just believe it. It's just like you don't know that. You're just saying you doubt it, and you could say you believe in a flat Earth because you doubt that there could be refraction that could affect it to that degree. You haven't measured it though, so you're leaving
It's
it
going to
down
take
to
a lot of
probability.
faith in some
It's just
really weird
probability though, right?
factors to give me results that are so close. I mean, we're talking inches over 16 miles. What's the ratio of, let's say it was 2 inches higher? What is 2 inches to 16 miles? How many inches are in 16 miles?
I don't know.
Right. So any normal person that's level-headed and thinks realistically can say that experiment, albeit a rough experiment, shows a flat surface.
You didn't control for like the main covariates that you were tasked with controlling for, so
You
like
realize
it
how
could have been
hard you're
angled.
reaching? Like, you just like stop and look at it
No,
from the other side of your belief and realize how wild that really is.
you're just doing lazy experimentation and then expecting me to accept it. Like that's not. I'm sorry. It's not good enough. You didn't do your job.
Right. Right. So you come back with a video of some spinning around, wobbling. You don't know the measurement of the width. I mean, it's really wild. So, I mean, good luck to you, man. If that's
Yeah,
the way that
exactly.
you believe things, good luck to you in life.
Yep. Super critical of things he doesn't believe, but doesn't look at anything critical about what he does believe. It's called confirmation bias.
It's blind faith.
Yep. It's religion.
It really is.
I'll tell you what. If I were doing the experiment, I would control for it. So I
Okay.
would be critical of it.
That's pretty damn controlled, measuring it every mile. I mean, you want to say temperature. Temperature changes every couple hundred feet. Every single mile was exactly the same. I didn't see it go up at 1 mile and down at 2 miles and up at 3 miles and up at 4 and down at 5. It stayed 8 feet at every mile.
Repeat it.
Sure. I mean, I can. I'm going down there in about 3 weeks.
Awesome.
Yeah, it's been repeated many times too.
Bring a level.
Yeah.
Yeah. Is the leveling device on the FE core observation, is that good enough leveling device? Or?
How did they do it? I wasn't aware that they leveled it. I thought they just like what I was looking at. They were just like randomly moving it around, and they were like, "Oh wait, keep it there. We see it now."
So they engineered a device with a really tight screw in it, like thread, really small threads, so that they could. They called it the salad, right? And they could, every time they spin that little thread a tiny little bit, it adjusts it ever
Dr.
so
Jordan
slightly.
Peterson, I'm a big fan.
Okay, mate.
That guy's voice should be on a fucking radio show.
Sounds like Jay Tolan Media.
Anyway, I gotta go.
All right, I'm going to bed.
Good day.
Yeah.
Whatever.
It's Globe Logic.
It's insane. I mean, and you're right. I mean, those videos are pretty rough. I mean, the camera's not level, all kinds of variables that weren't controlled. Yeah, I prefaced my experiment by saying I didn't, but I did a rough leveling of measuring it at like quarter a mile at first to see it was still 8 feet, and then we literally measured every mile, and it never changed.
Why does the camera have to be level?
That's
If it doesn't suffer from the fisheye effect, it does not need to be leveled.
Why does the laser, like, what type of level do I even use for the laser?
I'm talking
The
about
body,
you guys' video, the camera you guys were talking about.
Right, and that started because I didn't level my laser. I don't even know how I would do that because the frame of the laser is wider at one end than the other. I can't lay a bubble level on top of it. I mean, I have to measure the beam. So I did that by measuring the distance from the ground where it stood, and then at a quarter mile away, and then continued to measure it at every mile. I mean, that's a pretty good way of measuring level.
Do you know who Jaren is? You ever heard of him?
Yeah, the one that was a flat earther and then became a glober.
Yeah. You know what he said about you guys? He's like, you guys aren't actually looking for truth. You're looking for your truth. Well, you know that? You know he said that?
Great. I mean, when I
Do
did this
you
experiment,
think
I was
he's an
trying to find the
intelligent
globe.
person? Do you think he's an intelligent person?
I think he's honest.
Do you?
Yeah, because he used to be a flat earther, but then like he
Oh,
got
what? Now
proven
you
wrong.
do, right?
Yeah.
So you mean you don't think he would do that for money? You don't think he's motivated by financial gain?
Why didn't the others who went? They still believe, I think, in flat earth. I think.
Maybe they're not motivated by money.
So was he always honest, or he's only just become honest? Knowledge.
There are.
Was he always?
Yeah,
I asked you a question. Was he always honest, or did he just become honest?
I think he truly believed that.
Was he always honest, or did he just become honest?
So.
He just became honest.
It takes somebody to like admit that they
It was it. Sorry, there was two questions there, right?
Yeah.
There's one or the other. Was he always honest, or did he just become honest?
He was always honest.
Okay, even when he was a flat earther, he was honest.
Yes.
And how do you know he was honest?
Because it takes a lot of guts to admit that you were wrong.
So he became honest, or how do you know he was honest before?
Well, because he basically destroyed his entire channel, right? Like, you know what I mean?
Okay, so it's because someone changed, then they were always honest. Right?
He was always honest, and the moment
how do you know
changed,
that? How do you know he was always honest?
How do I know that?
Yeah.
Because he understood, like, because he took up, like, the final experiment, because, like, you guys said for years there's no 24-hour sun in, like, Antarctica.
How does that make it? No one said that.
Yes, they did.
No, they didn't. Who said that? Did I say that?
That's why it happened.
Oh, you're lumping us in with them again, aren't you?
Now he just goes off and says that you guys don't have a model, you don't make claims, you don't do anything. Then why are you want to debate for?
Model. Why do we need to have a model? Why do you need a model of reality?
So why are you making claims? Why are you wanting to debate for?
Claims about it, the surface measuring.
If you're not in this to change academia or to
claims
change
about
the community,
surface.
what the fuck is the point of this?
claims about the surface measuring flat. Is that the claim?
Hmm?
Is that the
That's
claim
just a claim
you're
by
talking
you. No,
about?
but that's just a thing by you though.
Hey,
It doesn't
wasn't
mean anything.
Jeranism? Wasn't he the one that broke a laser and came up with the idea of poking 2 holes in styrofoam to
Yeah,
create the effect
retard.
of a laser using a flashlight?
He's the guy that says you guys are full of shit and always were.
Was that why he goes around sharing his penis to all the women out there?
Yeah, real
Why
honest guy, right?
Why did you guys harass him for and kick him out of the community when he changed?
What do you mean, you guys? We've got nothing to do with any of that. We've
He called
never
us
had
all
anything to.
liars, man. We didn't kick
We've
him out.
never.
He left.
We've never had anything to do with Jaren.
You're part of the flat Earth community, aren't you?
No, we're not a cult. It's not a cult, dude.
He said you guys are a religion. You guys aren't looking for scientific truth. He realized that after fucking going to Antarctica and saw the 24-hour sun, and then like once he said he saw it, you guys all said that he was lying. He wasn't lying.
Who said that? Who said that?
Is there a 24-hour sun in Antarctica, son?
Yeah.
Yes or no?
Yes.
Yeah, I
Okay.
knew that before the final experiment.
Okay.
Yeah.
So why did he
you're a liar.
by that community then for just simply saying that?
Don't know. It
Why
wasn't
is there a
us.
We
debate
didn't kick
and like
him
all
out,
of them keep
man.
saying that this entire experiment was fake when it's not? It was not
Don't know.
fake.
Ask
Like,
him.
nothing about it is fake.
Ask him.
It's so wild how Globers are just always like, well, so and so said, a smart scientist said, this guy on YouTube said.
Hey, bud, he said that you are a religion. You guys aren't looking for
He
truth.
said me. He said James in East Tennessee. That guy. I did what?
Huh? Said all of you.
I mean,
What's all of you? What does that mean?
Says everybody in like. Well, I mean, it makes. I mean, you guys aren't really that different than like politics, right? Like liberals go like they're not looking for truth. Neither are conservatives. Like you guys just come to these channels like everybody else just to reinforce
change
your
the subject.
fucking beliefs, right?
I don't go into the other channels in this room, man.
Well, you guys aren't doing anything different than anybody else is doing.
Why do you just come in here?
People come to us.
I went and performed an experiment to find the
a
globe.
liberal channel talking amongst liberals.
One second. Hey, Knowledge, why do you come in here and straw man it all the time? Why do you do that? Why do you do that? You come in here, you tell us what our model is, and then we tell you no, it's not, and then you go,
why are you part
you
of
have
the
to don't
debate
talk,
if you don't have a model? Then who cares
talk
about what you
because
say?
you don't need one. You don't need one.
Then what's the point of having a debate about with you?
Okay, I asked you before. I said
cannot compare any of your beliefs.
okay,
You're just making
dude.
claims
I know
about
you're
the
gonna
globe.
start spurging out because you can't argue with
If
us.
we all say the N word, will you get demonetized?
No, we're not monetized anyway. So go
Okay.
try it, mate.
Do you think?
Try it.
No, don't say.
Right. So
don't say
knowledge,
the word,
right? Knowledge. Okay. I asked you before. I said, do you want to talk about the surface measuring flat? That's the claim we make, right?
Okay. What would it prove, if anything?
That we're being lied to?
It
No,
would
it
prove
ain't. You
that
guys are just
no.
it
Just
could
hang
be that
on.
the Glovers have wrong math, like about the
Okay.
globe model. That's all it would
Okay.
prove.
What it would prove is
No, it would
that
not
the
prove
surface
anything.
measures. Okay. What it would prove. You asked me, so I'm going to answer it. So don't cut me off when I'm answering you.
Yeah.
It would prove that the surface measures flat.
That doesn't tell me anything.
It tells you that the surface is flat.
No, it doesn't.
Okay, so you do an experiment.
You could say a two-dimensional manifold is flat. That
Hold
doesn't
on,
tell
Techno
me
Viking.
anything.
All right.
You're just making bullshit claims and like without actually comparing it to anything.
Okay, what claim? What's the bullshit claim?
You said that it measures flat, like surface.
Yeah, it does. Yeah.
Okay, and
then that would make it flat, right?
No.
Okay, so why wouldn't it? If you measure something flat, how is it curved?
How's it curved?
Yeah. You claim the Earth's curved, right?
Well, like Well, you could say like the two-dimensional manifold, but like
I'm
once
not
you
talking
actually
about a
understand how big
two-dimensional
like the
manifold.
surface of the Earth is, like it may look
Yeah, I
flat.
do
Like,
understand how big you claim it is. Yeah.
yeah.
So if you measure something to be flat, how is it curving? Can you tell me that?
How's it curving?
Yeah, like the Earth that you claim.
Well, like because like I know like when we fly, we follow like a geodesic, which is like
What?
a straight line, which is it's the shortest path between 2 points, and
Oh,
it's
I
like
remember
a
you.
straight
You
line on a
claimed
curved
you were
surface.
a pilot.
That's how we
You're
know
that
that it's
guy.
round.
You're the guy that lied about being a pilot.
And we also know Einstein
Oh
was
my
correct about
God,
this.
he's
We had a
back.
whole experiment about it,
Okay. So
right?
because you see a line on a computer screen that
Hey, bud,
says this is the
who do you think's more popular in the world, like Einstein or you?
I
Who the
don't
fuck
really
are you?
care, man. I don't really care.
Einstein
But
is
I'm not.
the greatest,
I'm not.
most popular
Hey,
scientist of all time.
Is
hey,
this a dick measuring contest? Like, what are you
yeah, I
talking
know.
about, dude?
Hey, I'm not the guy that goes into flat
What
Earth.
was Einstein? What was
I'm not the
Einstein
guy that goes
doing?
into flat Earth servers and lies about being a pilot so he can make the claim about
Einstein
doing an art
was not part of
flight.
any government agency.
You're
Why?
you're an
What
idiot,
purpose?
dude.
Can I ask you a question? What was
Okay, what
Einstein's
experiment? I'll
purpose?
ask you.
Was
If he
lying?
was a scientist, what
Yes.
experiment did Einstein do?
Einstein?
Yeah,
His
what
experiment?
experiments did he do?
He didn't do it. Other people did that for him.
He didn't do any experiments. So how's he a scientist?
Hmm? You can
How's
verify
he a
his
scientist?
claims.
But
How can you
which one's more
verify his
popular?
claims? What claim is it? What claims he making?
That space and
I
time are
think he's was a
interconnected, and
theoretical physicist,
that's called
wasn't he?
warped
Okay,
space-time.
so how do you prove that? How do you prove that? Go
How do you
ahead.
prove that? It's
Yeah.
called GPS satellites. That's how we prove it. It works.
GPS
You use them?
satellites proves the bending and warping of space-time.
Absolutely, it does.
How
How do
does
you
it do
think a
that?
GPS? How does a GPS
How does it do
system
that?
work?
How does
How
it
does
do
it do
that?
that?
Yeah.
Well, like if you understand how time dilation works, do you know what time dilation is?
No. How does the GPS prove the bending and warping of space-time?
Because we know that time and space are interconnected when it's warped due to the mass of the Earth. We know that like when you're at a
How do you know
strong
that?
gravitational pull,
Wait.
we
You
know
just
that
said you
time
know
slows
that.
down.
Sorry,
That's
dude.
called
Stop. You
time
just made
dilation.
another claim inside a
Hey,
claim.
bud, do you use a
So you said,
GPS system or not?
yeah.
That's
So you said
crazy,
it
man. My
doesn't
24-hour
matter.
clock is warped.
You cannot use
Yeah.
a GPS
Hey. So
system
you
without
just made.
understanding
Sorry,
relativity.
you just made another claim inside another claim. You said you know something
Yes.
because we know that time and space are interconnected
Absolutely it is.
and
It's called a
warped due to
four-dimensional
mass.
manifold.
Okay, so how do you know that?
How do I know that?
Yeah.
Magic.
Because we know time dilation is an
Oh,
effect
we know
of
this because we
GR,
know this.
and
Yeah,
we
you're just
know
repeating
and time
yourself again
dilation is how we set the clocks, how your time on your GPS system is correct when you use it.
because of a clock. Now,
Yes.
the bending and warping space-time is proved because of a clock.
Yes, is your time correct? Does it work?
So my time being correct, which who cares if it's correct
If it
because you
did,
can just change it, right?
yeah,
My time
if
being
we didn't have,
correct in my
if we didn't
car
correct, if we didn't correct our
is the
clocks due to time dilation,
bending and
the clocks
warping
would
of
be
space
completely
time,
wrong.
right?
Mm-hmm.
So the
This
bending
is
and warping
absolutely
of
true.
space time is correct because the clock in my car is correct.
And it's also correct because we fly great circle routes, right? That's the whole purpose of it. Like the shortest path between 2 points is the
That's not
geodesic.
how they fly. That's
Yes,
not
we
how
do.
they fly. They fly in corridors and they fly the safest route. That if there's an
They fly the
emergency,
shortest path between 2 points, bud. That's
I
how it
I
works on
thought
the
you were a
ground, and it's how it works
I thought you were a
on the
pilot.
fucking how it works in the sky. It's the shortest path
I thought
between
you
2 points. It's a
I thought you
fucking
were a
basic axiom, okay?
I thought you were a pilot.
You're the one sitting here saying that you use GPS. How
Weren't
does it
you a
work?
pilot?
Does
Weren't
it
you a
work?
pilot, dude?
Yes. Do you?
I'm not the one that comes in lying on a flat earth surface saying he's a pilot, right?
I'm not the one in here saying I understand time dilation. You don't
I didn't say
understand.
that.
For being a pilot.
I didn't say I understand time dilation. You're the one that said my clock proves that the bending and warping of space-time exists. I didn't say that I understand time dilation. I don't understand time dilation. Why should
Exactly.
Why should I?
Because if you want to understand why the Earth is curved, you'd have to understand time dilation.
No, you don't. You just measure
Yes,
it,
you do.
right?
Like your whole GPS, the whole GPS system is built upon like the theory of relativity, right? Like it would not work.
Show me.
Like airplanes, like right.
Oh,
They would,
airplanes
yeah.
now are
Yes.
the bending and warping of space-time too, right?
No.
This is like actually insane. Like I'm just. It's very entertaining at this point.
And get your popcorn out because we've got fucking stupid
I'm
cunts in
literally
the
eating
chat.
popcorn right now. If you can't hear it.
Have fun with him. I gotta go.
Like
I'm a
fucking
pilot.
retards talking about. Hey, bud, why don't you Google it? Like real quick.
I'm a pilot.
Why don't you Google it real quick?
I don't have to. I'm a pilot.
Yes, I know. I bought this beautiful car doing it. Yeah, it sits in this driveway. What are you talking
Google
about?
the wrong thing. I'm a pilot.
Shut your mouth, boy. Yeah. I own the house that's in this driveway, bud. You think I just? What do you think I just fucking? This is a sports car, dude. What are you talking about?
My penis is not small. The bending and warping of space-time says so.
I know a guy from planet Vulcan. The Earth is a globe. I'm a pilot.
We are.
Spock was real.
Guys
I'm
like
a
sitting
pilot.
here doesn't even
If on my
understand how a
clock
GPS
the
satellite
hour
system works.
hand and the minute hand are bent, does that prove the bending and
Hey,
warping of
retard!
space-time?
Why don't you
I'm a
look up
pilot.
time dilation? Okay, it's called like your GPS satellite system would not work. Like its timing would be off like about like 8 seconds a day. Like if you didn't like account for
How do
it.
you know that?
How do I know that? Because we've tested it.
Right. Somebody else test.
Okay,
A
show me the
smart
test.
scientist said. Somebody else
Who the
said.
fuck are you listening to? Can I ask you a question? Like
you've said, "Can I ask you a question?" like 37 times, and you just asked the question.
Hey bud. At what
I'm not
rate
your
does
bud.
an object fall? Do you know?
I don't know. I'm a pilot. I just fly.
Yeah.
I don't fall. I got wings. I'm a pilot.
You sound scared to have this debate.
There's no need. I'm a pilot.
How do you measure curvature on a sphere?
How would you measure curvature?
On a sphere.
How would you do it?
How would I do it? I would draw a tangent over the surface of the sphere, and straight, and then I would measure the deviation over distance between that tangent and the curved line from the sphere.
Cool.
But Einstein.
But Einstein got all fucked up.
Can I ask you a question? When I mentioned
Married
the
his
geodesic,
cousin,
what do you
and
think?
then said,
What do you think
"Oh,
that
that's not my cousin. That's the bending and warping of space-time."
You just said that. So would it be fair to say, like, if I just like draw like a massive triangle on the surface, right? Is that one way we could do it? Like, right? From the North Pole down to the equator, and we can walk around like we can walk like 90 degrees, like among the equator.
That's the
right?
question.
Is that one way to do it?
Let's do it. Hey, you know what? Let's do it. Let's do it. Let's you and I get on a plane, go to the equator, and then start walking directly due south to the, or you go to the North Pole, walk directly due south to the equator, and then walk directly due east or west, and then walk back up to the North Pole. Let's do it.
And it should be easy because he's a pilot, so he can fly you there.
Can we?
No, he said we were gonna
Can we
walk.
follow a
So
geodesic?
let's fucking walk.
You don't think geodesics exist? Is every airline and like commercial like airline, are they part of the
Quit while,
conspiracy too?
just quit while you're ahead, dude.
Are they
You're
part of the
embarrassing
conspiracy
yourself.
theory? Are they part of the conspiracy?
I mean, I got a buddy that's a captain for Delta, and he's flown for 20 years, and he says it's flat.
He takes off from a two-dimensional manifold. Yeah, that's true. That's what the runway is. You wouldn't understand that.
No such thing as two-dimensional.
There's no such thing
When
as
we say
two-dimensional.
Earth, do you think the Earth is to be a flat, like there's no depth under the Earth?
Show me something that's two-dimensional.
You're flat Earth, bro.
Show me something in reality that's two-dimensional. Go for it.
What if I told you that the Earth was 1 trillion miles deep? Then what?
Oh my god, this guy said nothing is two-dimensional.
Okay, show me something in reality that's Show me something in reality that's two-dimensional. Knowledge. Go for it.
A two-dimensional manifold would be a flat Earth model.
Prove me wrong. Prove me wrong. Show me something in reality that's two-dimensional.
A map is
Show us a two-dimensional manifold
A map
of an
is
object.
not two-dimensional because it sits on a piece of paper, which is three-dimensional. Retard.
This guy's insane, man.
Dude, this guy just said that a map is two-dimensional.
With what degree of certainty do you are you
Earth
real?
is three-dimensional. Dickweed, the map is two-dimensional. Okay.
Everything in reality.
The
The map is still. The map is still three-dimensional.
A paper map is two-dimensional.
This guy's an idiot.
No, thanks.
He's lost, man. Hey, knowledge. At what degree certainty do you think that you're real?
This guy just said that a map isn't two-dimensional. Like,
it's not.
It
It's on a
was
piece of paper that's three-dimensional. Yeah, I know. Nothing in reality is. Yeah.
Why do you think that the map is distorted? Why do you think that maps are wrong?
How do you know it's distorted?
How do you know it's
How do I know
wrong?
it's distorted? Because you can't incorporate the curvature of the Earth like a three-dimensional surface into a two-dimensional.
Sorry, how do you know it's distorted?
Can I ask you a question? Why don't you Google?
How do you know it's distorted, dude?
Can you
How
give
do
me
know
back?
it's
Can you
distorted?
give me back my side privileges here, and I'll show you.
Okay, how do you know
Can you
it's
ask a
distorted
question?
if you can't? What have you got it to compare to?
The Earth, which is three-dimensional, which is curved.
Okay, so how do you know it's distorted?
Because the two-dimensional map doesn't have the curvature like built into it. That's why it's distorted.
Okay, so how do you know it's distorted?
Maps have two-dimensional maps, which is what the piece of paper is, right? They have always been wrong.
How do you know it's wrong?
How do I know? Can you restore my chat privileges in the side chat so I can show you?
Because you'd have to be comparing it to something, right?
Can you fit the Earth's curvature into that two-dimensional object? How would you do that?
There isn't any curvature.
Yeah, what curvature are you talking about?
Yeah, is it just me, or did I count like 5 or 6 claims in the last 10 seconds?
Well, can I ask you a question?
You're gonna ask another
No.
question.
We need to stick on like why a map isn't two-dimensional. This kid's a fucking retard.
It's kind of ironic that you're calling anybody
Can I
retarded.
ask you a question? Why don't you just Google it? Is our
Can
map
I ask you a
I
question?
told you. Can I ask you a question?
Can I ask you a question?
Can you Google it real quick? Just Google it.
Can you ask me a question?
Just ask if is a map a two-dimensional object. Yes, it is. The Earth is three-dimensional. You fucking moron. Okay.
Well,
If
that's
the
funny.
Earth
I've
is
seen plenty of
three-dimensional,
three-dimensional apps.
you can incorporate
Is the
that
Earth curving?
three-dimensional. You can incorporate that three-dimensional curvature into a two-dimensional object. That's
You are
why
not
it's
very
the
good
Earth
at
is
strawman
curving?
farming. You should get better at it.
So the Earth is curving, right?
I just
The
want
Earth
to
is
stick to
curving,
this.
right?
I just want to know why did he leave? Come back.
The Earth is
You
curving,
have to
right?
go, dude.
Hello, can you hear me?
Yeah.
Loud and clear, dude.
Does he have me muted? I sure the fuck hope he does.
Hey, Knowledge. Can you hear us? Can you hear Swole
Now,
Dog?
can you ask me a question?
Hey, first, we got to get this mic thing sorted out. Can you hear what he is saying?
Can you hear me?
He might have dropped out. He might have dropped out.
Can you hear me? Knowledge.
Yeah, he might not have muted you or anything. It could just be something Discord's doing. That shit happens once in a while. To fix it, you got to leave and come back. Not you, but him.
Maybe we can
I'll be
get
right
him.
back.
I'll tag him in the side
Can you
chat.
hear me now?
We hear you good, dude.
Knowledge. Can you hear what he is saying?
Can you hear show me data?
Yeah, he might not. I guess he can't hear me either.
I had $1 for every time that guy said, "Can I ask you a question?"
For fuck's sake, just ask.
Even
Like,
split
you ask
even.
him a question. You can ask if you can ask. And
Yeah.
just ask. Damn it.
Right.
Yeah, dude. Even if he had $1 for every time he said that, even split evenly amongst all of us, we'd all be rich.
Right.
Because of him, anybody that asks me that in the future, I'm just gonna ignore them.
Instead, he
Right.
should have
Tell
just
him
went
no.
ahead and been
Ask the
honest and said, "Can I beg the question?"
question. Fucking
Like, are you
retard.
a man? Or better yet,
Yeah,
next
he
time they
ducked
say,
out.
can I ask you a question? I'm like, no, you can't go pee. You need to wait. That's what I'm gonna tell him. You need to hold it. No.
Is local Kiwi reporter actually in the VC? He's in the side chat. He's canking away.
I don't see him.
Yeah, I'd advise him that the side chat is for VC participants and send him on his way if he doesn't want to participate.
Well, at least we got CB keeping him occupied there. So.
Wait, are we live?
We've only always ever been live 24/7 for like the last 10 years.
Oh, okay, got it.
Wait for it. Wait for it.
Hey, wait, can I ask you a question?
Here we go. Lagging behind there.
No.
We are live.
Welcome back, CB.
He seemed
Oh,
to
is that
think
CB that was saying that?
Oh, maybe.
It,
Maybe not.
however long you may or may not have been here.
CB?
The clock is ticking.
No, Swolog,
Bro.
it's Lats, actually.
I got another.
This is Lats.
I got another. I got another CB name for you, man. CBD.
But can I ask you a question?
Who?
Am I coming through okay though, or is my microphone all fucked up?
Wait, you didn't ask us if you could ask a question.
No, you can't go pee. It's going to end up being my default question. And then one day my supervisor is going to say, "Hey, can I ask you a question?"
Just reply, you just did. Yeah, it looks like we lost knowledge. So. All right. So, since local Kiwi reporter is refusing to get into VC, he gets the hush. How about that? All in favor?
No, don't do it. Don't do it.
No, you having fun?
Action.
Yeah, CB's having fun. Okay.
Guys, it's Lats. Come on, guys.
Still haven't seen you two in the same room at the same time, man.
Exactly.
ACB.
Lats here. Go ahead.
Have you noticed I've been honoring you by changing my name?
Shucks.
Oh shit, we got knowledge back.
Oh,
Wait, Knowledge, I just wanted to clarify something really quick. You said that you said maps are 2D, and then Timbo was talking about like a piece of paper. So I just want to clarify. Are you saying a piece of paper is 2D?
Huh. I think his audio is still fucked up.
Oh, shucks.
Oh, yeah. Too bad, eh?
Also, I loved how he was like, well, you guys don't have a model, so you can't argue anything. It's like, well, for someone who believes in the universe and the solar system and outer space, well, what does that model look like? Does anyone, can you just, post that in the chat? I don't think they could. So, what's with that double standard? That doesn't seem to make a lot of sense. And then, like, perfectly, here goes my point in the chat, right? So, do you have a model I can look at? Well, who has a model of the universe? Like the entire thing? Nobody. But when they come and talk to you flat earthers, they want to have a model of everything. What's up with that?
The funny thing is, their model, which they do have a model, doesn't pan out when you go and try to measure it.
They don't have a model, man, because their model says that the Earth's radius is an average of 3,958.8 miles. And when you measure that, it fucking measures zero parallel. And so, therefore, the entire fucking model is wrong. And I can throw it out with prejudice.
Hey, can
Wait, the
y'all hear
pilot
that in
guy
the background? Am I hot micing?
No, you're good.
Okay.
Just find it. Is the pilot guy, his mic's not working? He's having technical difficulties? Yeah, well, I wouldn't fly in that plane.
He knows to go,
He's
go find a satellite like quick.
at too high of an altitude right now to.
Come back down to Earth, Maverick.
No goose. I was inverted.
For shits and gigs, I'm going to unhush knowledge in the event that he's trying to communicate but can't.
He's not.
You don't think so? Not worth it?
No, do it.
You can do whatever you want, man. I'm not a mod.
You're not a mod? What the fuck? Okay. Well, just for shits, I mean, it might serve a purpose later on anyway. I'm thinking he might, maybe want to say something.
Maybe he had like a pocket of gravity that like messed with his Wi-Fi or something.
Mm-hmm.
I think his mom unplugged the internet.
He was like, "Shut up there."
He's like, I'm trying to make a phone call.
Why are you so loud? These flat earthers won't listen to me.
His dad barges in. He's like, are you winning, son?
You know, the best part about being a flat earther is the Glovers can't go to their friends and be like, oh, bro, I was talking to this flat earther. And like, they totally were like arguing with me and wouldn't listen to anything I would say.
It'd be like telling them you went to the elementary schoolyard and was beating up first graders. I mean, in their eyes.
Well, I mean, I guess he could do that if he was like Chris Farley on Billy Madison. Be like, no, you weren't. No, you didn't. Yeah, but you could imagine if I did.
I did find it interesting that he never addressed the pilot thing. Oh, really? You know, like, Kimbo was like, "You said you were a pilot," and he just kept moving on.
Yeah, he
Did he really say that? He said he was a pilot or something?
I don't know. I just heard what that other guy said, so I was just with it.
He's like, well,
He
how do you
definitely
think I
didn't
got
try to
this
deny it.
sports car? Yeah, he didn't. He's like, well, how do you think I got this car? How do you think I got this house? I mean, I don't know, dude. You can have a car and a house without being a pilot, so I don't think that's like a
Like,
direct correlation.
welcome to being an adult, bro.
He's like, it's a sports car.
Yeah, but
Oh, okay.
it's like you got a car for a bed. And he's like, but it's a fucking sweet car.
Yeah, he did say that. That was
Well,
funny.
I've been driving around a lot in Dallas lately, and I swear to God, dude, like every one in 150 cars is a Corvette.
One of the new ones.
Yeah, I've done seen every different color of them too. It's hilarious. Most of them are white.
It's like the poor rich man's exotic. Like
Like,
they can't
oh, this is
afford the.
close to a Ferrari, close to a Lamborghini.
Hey, I seen a good one the other day. Like I live close to the interstate, and at one of the gas stations there was a C7 Corvette that was bright red, and he took all the symbols off, and it had Ferrari symbols on it. Like, who's he trying to fool? And the dude walked out, and he looked like an Italian Guido from like New Jersey, like slick back hair, like. And
Was he wearing a
I'm
soccer
like,
jersey with a gold necklace?
yes, he actually was, dude. Like one of them shiny, slick, like sweatproof jerseys. And I was like, "Hey, cool car, man." And he was like, "Yeah, yeah, it's just one of the many I got." And I'm like, "All right." I acted like I really thought it was a Ferrari. He totally played it off like it was a Ferrari.
Okay, he's in the chat saying, remember, there's no such thing as two-dimensional.
Well, did Einstein say that? Because he's smarter than you.
Einstein
that's
said that
true. Yeah, I
math
forgot about
doesn't
Einstein.
refer. He said math doesn't refer to reality to begin with. Think about it. If you have if you have two apples, right? Those two apples aren't identical. So one apple does not actually equal one apple because both of them are going to be different. Period. The 1 and 1 works great in a mathematical equation, but if you got two apples, they're not going to be fucking perfect clones of one another.
Yeah, so when somebody says apples to oranges and then they rebuttal apples to apples, you could be like, well, wait, is it a Macintosh and a Fuji? Like, we still got
Exactly.
variants.
It's just people idealize perfection. Bunch of idealists.
But NASA said
Yeah,
my
that reminds
favorite.
me.
Go ahead.
What? Oh, he was saying like, oh, well, Jiren. Okay, so when Jiren was a flat earther, you thought he was like a clown or something? You thought he was an idiot? But now, and his word meant nothing before, but now that he's a quote unquote Glover, now his weight holds some, or
He
what he says
always
holds
tells the
weight.
truth.
Like,
Yeah.
so what?
No one gives a shit what Jaren has to say or think about anything.
That dude's kind of a schmuck, anyways. Like, even when he's a flat earther, I'm there to listen to him.
Yeah, I kind of agree with that.
Yeah.
Never thought Jiren was never was really a fan. But it is funny how they do that. They're like, oh, but Jiren's like, okay, well, if we rewind the clock 5 years, what would you say about Jiren then? Oh, he's an idiot. Oh, okay, so so now he's like he's the guy? Come on, man.
And nobody has proof for a globe except for a flat earther, huh?
Oh, yeah, that's another one, right? Oh, but the flat earther, they approved it. Oh, okay.
It kind of makes sense though, because I always thought, man, that guy is such a degen. But now it makes
It's like
sense.
he
Well, if
reminds
you
me
only
of
knew how
Aiden
much of a
Ross.
regen he was.
Oh, I know, man. I've heard some
Hey,
stories.
I have this theory going, and so far I'm bat 1,000. The more degenerate the person they are, the more anti-flat Earth they are.
It sure seems
You're
that
on to
way.
something too. Have you guys ever seen that streamer Aiden Ross?
W. Aiden Ross, I think he questions the globe. He's talked about
Well,
flat Earth before.
he's just like a loudmouth, like idiot. But that's who Jaren has always reminded me. He just you can tell he's like motivated, more viewers and more money. So whatever he can say to get more viewers and more content in front of people, that's just
Well,
kind
that's
of what
why
he does.
Harrison
But
Smith
you
did
look
the
up the
interview with Wilson.
etymology. If you look at the etymology for autism, it basically says selfism, so Jarenism. That's all you need to know.
Hey, but shout out to
And
Aiden Ross though, because he's mentioned on 2 occasions. Once speaking to Vivek Ramaswamy, potentially he was running for office for
Mhm.
president, and he asked Vivek, "Do you think the Earth is flat?" Vivek, of course, says no. Then he also um, told Zerka, he's like, "Yo, shout out to Flat Earth. The Earth is flat." Da da da. So hey, shout out to Aiden Ross, man.
Yeah, I mean that's cool that he put it in the mainstream. I mean, because he does have a ton of viewers.
well, he's
I
not the
just
only
don't like.
one. Candace Owens says it. Marjorie Taylor Greene says it. So there's a few people out there that say it.
Lately I've kind of been a fan of Marjorie Taylor Greene. She's kind of been spitting like, especially about federal income tax. She's finally like exposing the fraud there. I don't mean to go way off topic, but I like how she's actually like not afraid to go against the grain.
Marjorie against the grain, Taylor. Green.
ATG Taylor.
And knowledge is back in the side chat, by the way, chat. But for some reason, he won't answer the question about the piece of paper. He's
Here,
posting
I
this 2D image of 2D
yeah,
images, saying you guys don't believe in 2D. Like
I got
what?
you, CV. Knowledge doesn't believe that paper's 3D. That's insane.
Yeah, I really want to clarify that because it kind of seems like that's what he's saying, but I don't want to put words in his mouth if he actually isn't saying that. So, but if he actually thinks that, I think that's really bad. You know, it seemed like him and Timbo were kind of talking past each other on that specific subject. But you should have saw the look on my face when he's laughing. He's like, like, of course it's 2D. I'm like, wait, what? Like a piece of paper? No way you actually think that, dude. So I'm trying to
Yeah,
get him to say that
I'm,
I can
I'm
pick
certain
up
it is.
something
It's
I'm not
2D
seeing.
in a video game. Like you try to turn a 2D image, but then you can't see it because it's all wonky because video games. But yeah, if you're going by video game logic, fine.
Maybe he's talking about a picture of a piece of paper drawn on a piece of paper.
Oh
Yeah,
Lord.
potentially. I mean, of course, right? But I think he's trying to say, well, I don't know what he's trying to say because we go, well, what's 2D in reality? He goes, your flat Earth is. What? You think
Except
that
for the
we
mountains.
think the Earth is 2D? Hold on, no.
Well,
Then
here's
he kept
here's the
talking.
bigger problem, right? He's probably thinking that the map, the concept of the map, right? Like the idea of what you're looking at on the paper is 2D. But again, that's not reality. That's just a concept. So again, Timbo is right. Point to something in reality that is 2D.
Yep.
Something that's
Is Timbo
physical.
the Australian guy that was in here?
Yeah.
Timbo. Basically the Aussie guy, yeah.
The jacked kangaroo.
Is that what he is Australian?
Yeah.
No, he's British.
Is he?
He's Canadian.
I'm kidding. Yeah, he's Australian. Yes, he's Australian, of course.
I was going to say, dude, I swear he sounds Australian, not British.
He's a Canadian.
Yeah, Canadian. That's right. They can't get anything right, including their accent.
But
Yeah, I missed him. Whenever he's in here, I always tell him there's no Australia. It's all in Canada.
I'm in a group on Facebook. I'm like one of the admin for a biblical flat Earth group, and another one of the guys is Australian. And he always says that down there they have gravity boots and gravity tires. That way they can stick on the bottom of the ball. Shout out to Australia though. Those guys, they're pretty cool. I think they would fit in like really good with like Southerners in America. They're all kind of like wild and into guns and
Yeah, I think Australians have a name for those Australians.
what's that?
Is it like bogans? I think it's something like that.
That's like their hillbillies or their rednecks.
Yeah, basically. At least that's my non-Australian understanding of it.
Right.
I'll have to ask Matrix about it.
I know that one of my buddies is in the army, and like he was deployed to Afghanistan back in like 02, 03, around there, and his unit was teamed up with some Australians, and he said they were all like freaking just crazy, like nonstop banter, like even fighting, just cutting up all the time.
Well, that's something I've noticed too. Like now that I'm married to a Latina, like a lot of Americans are some of the driest fucking people I've ever fucking met. Man.
Oh yeah, they're like prudes.
So the younger people that are afraid to have, real life conversations.
Yeah, if it's not over text, they don't want to.
You don't gotta talk trash about local Kiwi like that, all right, guys?
Hey CB, did you hear my personal quote? Like how they have like smart quotes like the only thing I know is I know nothing. Some dumb quote like that. CB's like, no, I'm going to bed, bro.
Can I?
No, I was saying, did you hear my new quote?
You said I only know that I know nothing. That's old school. You
No,
can't
like
steal that,
people
right?
have those like dumb quotes, right? They
Idioms.
always try to come up with some dumb quote to make themselves like special, I guess, or whatever.
Yeah, all right.
Hold on. I'm about to post it because I put it in a meme, so it'll be forever immortalized. There you go. Here's my quote. It doesn't matter if people believe the Earth is a ball. It doesn't matter if most people believe the Earth is a ball. If we are basing our experience on common sense, and most people have little to no common sense, then the Earth is definitely not a ball.
Wait, say that again.
I give it like a 6, 7 out of 10.
6, 7. I have an 8-year-old. I've heard that
I
shit
put it
so
in a
much.
side chat, but it doesn't matter if most people believe the Earth is a ball. If we are basing our experience on common sense, and most people have little to no common sense, then the Earth definitely is not a ball.
I mean, this is just like a mentality that people in my generation were raised on. I think my parents would always tell me, "Oh, okay, if everyone jumps off a bridge, are you gonna jump off a bridge? Obviously not. So you don't just
How
go
high is
with
the
what
bridge?
everyone's doing just for the sake that everyone's doing it. That doesn't
I don't
mean
know.
that's the correct thing to do."
I don't know. How high is the bridge, and what's the conditions? Like, am I jumping for my life?
All right,
And
smart
how
man.
deep is the water?
No, let me quit. Let me quit. I'll shut up.
Hey, hold on. Can I ask you a question?
No.
You just did.
No, you can't be.
Oh, the goals are boring today.
No, stop. I don't consent to questions.
I do want to acknowledge Clipcord in the chat cooking right now because Kiwi
Oh,
posted a quote unquote model, and Clipcord goes, "Okay, so what does that predict?" I think the guy won't answer the question because you know how they say that models predict things. They posted some cartoon. He's like asking him for what the prediction is. He can't say anything. So good job, Clipcord. Good job, buddy. Also, I came up with that name. I think pretty sure. So WME.
Yeah, much better than the old one.
Yeah, we had to. That's if you know why we had to change his name. Shout out to you as well. That was a very epic saga. Good times.
It's funny though, because like all of you guys that knew me from the beginning of the Flat Earth saga only knew me as Gizbo, but I was always Sheepdog before I was ever Gizbo.
Is anybody new in here? I don't think I've ever spoken to Amara. They have the flat tag.
I'm not in here really often, but
I feel like I recognize your profile picture though. You've been around for a bit, huh?
yeah. I mean, I've been coming in here probably for a year or so. I'm just not here a lot.
There's J Long, Long J 9902.
What's
What's up,
up?
dog? Do you think the Earth is moving?
Who? Me?
No.
I'm here. I'm here there.
So is that a yes or a no, J Long? You think the
What's the
Earth is
argument?
moving? I'm not just asking a question.
So there's no argument.
Do you so you do think the Earth is moving or no?
What do you think?
I don't think so, no.
Hmm.
What do you think?
Why not?
Well, I don't have any reason to think that it's moving. I think we've been in the same spot. The Earth doesn't move anywhere. I don't see where it would go anyway.
There's one experience doing so.
Yeah, you don't experience any movement.
It's
I don't see any
interesting
reason to
take.
think, huh? I also look up in the sky and I see the moon moving across the sky. I see the sun moving across the sky. I see planes and birds. All those things move across the sky, but he's
Well, like
gone.
in the Bible, in the
All right,
Bible,
he's
they
gone.
talk
That was
about
easy.
like where God stopped the sun. You know, it doesn't say he stopped the earth from spinning. You know,
I like that question. I really do. Because I think we all experience the same thing. Everyone experiences the same thing. You have to convince yourself that the earth is moving. You know,
Not everybody experiences the same thing.
there he is. There he is. Knowledge, while we got you real quick. Do you
Can we
think
ask you a
that a piece of
question?
paper is 2D? Like a piece of paper, something you could pick up.
You're trying to represent like the Earth, which is 3-dimensional, into this piece of
Hold on,
paper.
hold on,
Not gonna
hold
work.
on, hold on. I don't.
It's a
You're. I
it,
don't
it
want you to talk. Hold
represents. It
on,
tries to represent the Earth, but you
brother,
can't do
brother.
that.
I understand you're trying to talk about maps. I just want to clarify very simply.
You
It
don't know
did
shit
seem
about the
like
map.
okay, hold on, dude. We're not even talking about maps right now. You're kind of talking to yourself. So when I
I
was
know.
listening earlier,
I'm the
when
only
I was
person you're
listening,
listening to.
well, not really. When I was listening earlier, it seemed like you and Timble were kind of speaking past each other, and he was talking about 3D objects in reality, whether that's a piece of paper, a
He
map, a pen, a pencil, or your computer, or whatever.
he said there
And
was no
you
such
seemed
thing
like
as
you were saying, "Hold on,
two-dimensional
no,
objects.
no,
That's what he
nobody agrees
said.
with that." Because
Yes, he
what he
did.
was trying to say, hold
Yes,
on,
he
what
did.
he was, let me clarify knowledge. What he was trying to say is that there's nothing in reality that you can pick up with your hands that is 2D. And I agree with him. But you seem to disagree. And I'm trying to get you to clarify, but you seem to not want to answer the question. So can you clarify whether we're talking about maps, a pen, a sticker, or whatever? Can you pick up something in reality that is 2D? Yes or no?
You pick up something in reality that's 2D.
Yes, it's a
Well,
simple yes
a
or no
map.
question. Can you pick up something like a map? Can you pick it up and put it in your hands, and that be 2D?
Can you do it?
No. And I agree with because I agree with what Timbo was saying, but you seem not want answer the question. You don't want to answer the question, which is very odd. You could just say yes, I think you can pick up something that's 2D, or no,
You
I
can
don't
pick
think you
up a
can pick up
map,
something that's 2D.
which you can pick up a map, like which is like
Okay,
literally.
so that map would be on a piece of paper, correct? So I'm asking you if the paper itself is 2D. Can you answer that question? Yes or no?
It tries to represent like the
No, no,
3D.
okay. I
It
don't
tries
care.
to
No, we don't care
represent
what's
like
on the
a
paper,
three-dimensional
knowledge. We
object
just want to clarify
of the
because you
Earth.
were laughing at what Timbo was
Hey,
saying,
bud,
and I've clarified what
I'm
he's actually
laughing at
saying.
you.
So what we need you to answer is whether the thing that you're picking up, not what's on the paper, because we could put anything on the paper, your
This
picture of your
this
face,
shape
a
of
map, or it
a
doesn't matter. The piece of paper, the actual physical, tangible thing that you're holding in your hand, is that 2D?
Mercator.
Yes or no? Guys,
Bud,
he
did
doesn't
you
want to
see what
answer
I
the
posted
question.
in the side chat?
We just need you to answer the question, dude.
can't.
Because this is gonna severely damage your intellectual level if you say yes, that it is 2D. So I can understand why you originally were laughing at Timbo, and now we've
I'm
clarified,
laughing.
and now you
No,
can't laugh at Timbo because what I'm saying is correct. So we need a
no, it
simple
isn't.
answer.
It's a
Okay,
shape.
fine. We need a direct answer. A physical, tangible piece of
You can pick up
paper
a
that
map.
you pick up
Yes.
and put in your hands.
Why do
Is
you
that
think the
thing you're
Wikipedia
holding in your
page
hands
says
3D?
that the map is
Dude,
distorted? Why do you think that
dude,
is?
dude. Look, I understand why
Why
you
do you
don't want to
think
answer
that
the
is?
question because it's gonna make you
Why
look
do you
Why
really
think
are
that
bad
you
is?
right
avoiding
now.
that question, bro? Just answer the question. My lord.
You can pick up a map.
Okay, so
So is
we
it
understand
2D
that
or
the map
3D?
is on the paper. Is the paper itself? That's what we're asking you because
The paper?
We're like, yeah, the paper. Is that 2D or 3D?
No, the paper. No, not the paper. Like, but it is
Is
the
the
shape.
paper 2D or 3D?
The shape is 2D.
Sorry, well, hold on.
Not the
Whoa,
paper.
whoa. The paper is the paper 2D or 3D?
The paper, they would be 3-dimensional.
Okay, great. Okay, whew.
But the
So
shape
that
is
was what Timbo was
2-dimensional.
saying. Hold on. Okay, now we can move forward. That was what Timbo was saying. There's nothing that you can pick up physically and tangible hold in your hands that is 2D. Everyone here agrees with you, or everyone agrees with that, even you. Now we can move forward.
Okay, why you keep
Now
asking
we
me this
agree
dumb
that you were
question,
trying to
bro?
laugh. Hold on, you were trying to laugh at him for saying that 2D doesn't exist. That's what he meant. Now, of course, 2D, a
No.
representation on a screen, on a piece of paper, that representation, of course, is going to be 2D. Of course. So we're not in disagreement here. There's nothing for you to laugh at, and now we can't laugh at you for saying something
How
very
about
silly.
this? How about we do like a final experiment part 2 where I use the GPS satellite that incorporates
This guy
the 3-dimensional
really likes to
curvature
talk to
into like,
himself.
and you use the paper map, and let's see who wins, right? Let's see who gets to our destination first. I guarantee it'll be us every single time that uses
All right,
the
since you want
GPS
to talk about
satellite.
maps so bad, can you post the one true map of the world in the chat for us, please?
The one true map.
Yeah, there has to be just one map, right? You need one map that represents everything, right?
It would have to be a GPS satellite image.
Okay, go ahead, post it.
You post it.
It's your worldview, dude. What am I posting your worldview for?
It's not my worldview. It's everybody's worldview.
No, because when I go outside, I don't see satellite imagery. I just see the Earth that's flat. So,
you see that it's flat.
Of course, just like you do. I live by the ocean. It's completely flat. I literally just did yoga by the ocean today. It's completely flat, dog.
Can I ask you a question? When I posted the Wikipedia, when I posted the Wikipedia definition of the Mercator projection map, right? Why do you think those distortions exist? Why do you think they exist?
Hold on, we just. Do you have your map or no?
The Mercator projection is like the map that everybody knows, right? The paper map, right? Why do you think there are distortions in there?
We get what you're trying to say, that all maps are distorted. I don't think anybody is going to argue with that.
Why? Why are they distorted?
Well, you're trying to say the Earth is a globe, and if you flatten it out on a piece of paper, it's going to look weird and distorted. That doesn't mean the Earth is a globe just because the map are distorted. Okay, we've got hundreds of maps. There's all different types of shapes of maps.
So which one's
scales and all kinds of stuff.
The GPS satellite
But
maps, or
there isn't one that's just quote unquote more correct. I'm asking you to post that one in the chat. You got nothing.
GPS satellite corrects for the distortion.
What
right?
map
because
is that called?
The GPS.
Because as far as I'm aware, every single map has a name, like Mercator, etc. What's the name of the map you're talking about?
Do you use the paper map?
I just go outside. I'll use Google Maps. I'll use Google Maps. That's fine.
So you use the GPS. Does it get you from point A to point B on time? Does it do that?
Sure.
Does it get you there?
On the flat
so
Earth?
It
yeah,
works.
of course.
So it works.
Yeah. Mm-hmm.
The fact that it works is a big problem.
That doesn't mean it's a globe. No, it doesn't mean it's a globe. No.
Those images
GPS
of flat
don't work
pieces of Earth patched together.
No, hold on.
When we talked
Everything that works currently right now on the Earth is working on a flat Earth.
What if I told you that those
Ta-da!
GPS are based upon Einstein's theory of relativity, right?
Oh,
you know that? Did you know that?
Dude, you couldn't name a single experiment that's that Einstein did
The fact
earlier.
that they work, right, is a huge problem for you.
Not for me, no. Because when I go outside,
Yes,
the
it
Earth
is.
is flat and it doesn't move. So, and
That's
anything
cool.
that works on this Earth currently, whether that be quote unquote
But you use the
satellite,
GPS
imagery,
satellite that
etc.,
incorporates
it's all
curvature.
working on a flat Earth that doesn't move. So I have really no
You don't
problem
use
here.
a paper map. You use the GPS. Why are
Not
you using?
GPS. They're pictures, like pictures of the flat plane sewn together. There's nothing. It's not
Why don't you
GPS
use
just
the
because you're
Mercator
looking at
projection map?
pictures.
Why are you using the GPS? The GPS
He's
is what,
not.
like the globe map. Those are globers, right?
Are you
Those are the
deaf,
people.
dude? Did you not hear anything I said? It's pictures. It doesn't mean GPS. It's just pictures.
Is it because the paper map is wrong, right? It's not going to get you there, right?
No,
it's
because we
distorted?
don't carry that in our pocket.
So you
So
trust?
you
So
carry a map in your
GPS?
pocket? It wouldn't surprise me. You're a fucking weirdo, anyways.
I mean,
But
basically, to be fair, Techno, he does. Everyone has a map in their pocket on their phone, so that's not really
well, he
saying
says
much.
paper. He's
But the
saying
point
paper.
is, he's trying to say that because there's maps means there's a globe. No,
Wait,
there is no globe.
but you just sat here and told me that you use a GPS satellite and it works for you every single time.
Everything that works is working on the flat Earth. Ta-da!
But the GPS incorporates the curvature of the Earth into
No, it doesn't.
like
There is no
its
curvature of
calculation.
the Earth. We just talked about Timbo
The
talked
GPS
about
says that there
this
is.
with you earlier. The Earth
What does
measures
it?
flat.
It
There is
corrects
no
for it.
curvature. There's nothing to
It
correct.
correct.
There is
See
no
those
curvature.
those distortions that are in those paper maps. They don't exist in the GPS satellite maps. They're corrected because it's able to incorporate the curvature
So is
into
your
it.
backwards engineering to fit it around a globe. Cool. Good job. You can do that. You can make the Earth any shape you want to if you want to imagine it. That's fine with me.
So everybody's lying but you?
So what's the map that they use in GPS?
Everybody's lying. No, what a lot of people do is have beliefs knowledge. Anyone can believe anything they want.
What's the name
Or
of the
you can
map
just
they
go off
use in
of you can
GPS?
just go off of yeah, go ahead.
Google.
That's what I want to know. What's the name of the
What
map
map
they
do
use
you
in GPS? I use all kinds of different maps. It depends on what I'm using. I even have a map skill in my vehicle.
Really? Does it work?
Yeah. Sure. They all work.
It works perfectly fine, doesn't it?
Yeah.
Yeah, on flat Earth, yep,
That's
exactly. On an
crazy.
Earth that doesn't move. Yeah, not crazy at all. Nope.
If you guys say then okay, but you guys are accusing the people that like work in like these fields as being wrong when you say it works perfectly well.
No,
Okay,
they just have beliefs. They're
they
allowed
would
to
not
believe
listen
things,
to me.
knowledge.
Listen to me. If they were wrong, it wouldn't work.
No,
Okay?
that's not true.
Yes, no, it is true.
No, that's not
If the
true.
math is wrong like you claim, right, then it wouldn't work.
That's not
Yes,
true.
it
Well, they're not
would.
accounting
It
for
is.
curvature. They're just flying in their coordinate.
So are you saying that the people who work at like Google and all these other people, they're part of the conspiracy? They're lying about it?
No, they believe. I've said this like 3 times now. They just believe like you do. There's nothing wrong with that.
It's not
Everyone
what they
can believe
believe. It's
whatever
how
they
they
want to.
fucking
It
program the
is.
GPS. It's how they program the GPS, bud.
Yes, you can take data and wrap it around some globe and be like, "Whoop, we
But you
corrected
said
it.
it
Now
works.
it's a
But you
globe."
said it
That
works.
doesn't mean that's
Hey,
not how it is.
But you said it
hey,
works
real quick,
But you said it works for you.
let me make a statement real quick, okay? So like I've used GPS plenty of times, and it's fucking gotten me lost. So it doesn't always work, right?
Well, so wait, knowledge. If I went and rented a helicopter, and I've got like 100 acres, and I fly at an altitude that allows me to see 1 acre at a time, and I take a picture of each one of those 1 acre picture at a time of 100 acres, and I sew them together, and now I put like 2 different points on that picture that I've sewn together. Does that make that 100-acre field have a curve? Because basically that's what you're saying. Like we're looking at Google Maps with just pictures that are sewn together from an airplane, and you're saying because of that it's got to be a sphere. It wouldn't work on a flat plane.
GPS satellites, they don't work without the Earth being a spheroid.
Okay,
If
so the
that's
pictures
true,
you're
Your
looking at
cell
on
phone
Google
wouldn't
Maps.
work. Your locations wouldn't work. Your time would be completely off because you wouldn't be accounting for time dilation, which is the strong gravitational like
You
field
absolutely
like
would. You
that
absolutely
slows
would.
down time.
You would. Like how? Tell me how it would not work on these pictures that are sewn together. Why?
Because it would be distorted, like if you didn't incorporate the curvature into the GPS system, right? It would be
Yeah,
distorted like the
if
paper
that's
maps.
true, we could just reduce
It
right
would be
down. We can
completely
skip
wrong.
past all the things you're saying and go to the Earth itself and detect this curvature, right? You're just saying, well, we have these things and therefore it's a globe. Well, why don't we just bypass the things and go to the globe? Just where's the measurement of the curvature? Well, there isn't. When we measure it, it's flat. So this idea that it only works because it's a globe, that's not true. There is no globe, there's no curvature. So we can dismiss everything you're saying. The Earth is measured flat.
Well,
Period.
that's fine.
Yeah, it's over. So everything you're saying is just out the
The
window. It's easy.
GPS, like everybody uses GPS. Even farmers use the GPS satellite systems in order to grow
Yeah,
their
and that
crops
works
better.
on a flat Earth that doesn't move. Yeah, exactly.
No, it's more accurate because it incorporates the curvature. That's why.
There is no
That's the
curvature. It's
reason why
flat right
nobody
now.
use paper maps anymore, because like those distortions have been eliminated thanks to GPS. Thanks,
But if you
Einstein.
took paper maps and each paper map was 1 acre, and I've got this property 10 acres by 10 acres, and I've got a paper map of each acre, and I lay them on the floor and put them together, it's distorted?
Damn,
It would
that's a good
be.
question. What?
It would be.
How?
Because you're not incorporating the curvature into
There
it.
is no
There is
curvature to
no
incorporate,
curvature.
dude.
That's fine. You think that.
No, we don't think that.
We
It's
measure that.
literally measured. Yeah.
Like we go outside, touch grass, and measure it, and there's no curve.
You just told
0.
me that like all maps have these distortions.
We're not talking about maps
Yours,
at this point. We're
your
talking about
if
the
you
literal Earth
mapped
outside that you measure.
did you say 10 by 10 acres? It would also have those distortions, bud.
The
What
Earth
distortion?
itself? There's no distortions on the Earth itself, dude. That's what
There's distortions in every
on
single
the
paper
Earth.
map. All of them
We're
are.
talking about the
They have
Earth knowledge. I
always
know.
every map
Look,
besides
dude, I know you're having
GPS
a
satellite
conversation in your
maps
own mind with
have
what you
always
think people
been
are saying
wrong
to
throughout
you.
history.
We're talking
Everybody knows
about
this.
the
You can go on the
literal
Wikipedia
direct
page.
Earth.
It has those distortions. Everybody knows this.
These aren't
Okay.
maps. These are pictures that are sewn together. So and we can measure it's flat. We can go one corner. There's no curve. When we do it the opposite corners, there's no curve. It's 100 acres of absolute flat ground. We sew these 100 pictures together, and we put them on the floor. And you're saying that those pictures, literal pictures of the actual ground, are distorted?
Yeah,
Well, no.
because like remember, two-dimensional is a shape, right? You're trying to put something that's three-dimensional into a two-dimensional shape. Okay, it's going to be
Ground itself
wrong.
is not 2D, dude.
I'm talking about the
Because
Earth.
you're missing somehow you're confusing the actual thing in reality for
Your
some sort
like
of
your
representation
picture
of it.
is
You're not
like
even listening to what I'm saying right now.
your picture
You're
like is
having a
probably
conversation with your own mind that we're trying to talk to you
your
directly.
picture
We're
isn't like
talking
your
about
picture is
the
just as
uh,
kind of like it's the same. It suffers
just get
from
it
the
out there.
same thing the map does, right?
Hey,
It's
knowledge.
two-dimensional shape.
Can I ask you a question?
Yes.
I
like the donut here.
Like, what kind of drugs are you on, bro? Like,
It does seem like you're like very off right now. I gotta say, I gotta agree.
yeah, like, are you drunk or?
You're talking to yourself, knowledge.
This is like
I don't
first
know if you don't
grade,
know the.
like fucking, geometry.
But you're responding to things that no one said. That's what's just weird. We're trying to talk to you about something, and you're speaking on your own conversation in your own head. It's super weird, bro. Okay, I don't know how to address. I'm trying to address it with you. You're
He's
off
gonna
in
pin me
la la
down.
land right now. Yeah. Pause.
Trying to ask dumb questions.
It's not a dumb question.
This guy
Where's
just
the
said if he
curvature in
took
reality? That's
pictures
a
of
real
his
ass
like
question.
acres, his 10 by 10 acres, like it's going to be the same thing that the map stuff. Of course, there's going to be those distortions. Like, why would it
It's
not be
not.
distorted? Just
Why
like
would it be distorted? Like, it doesn't make any sense. Where's this distortion coming from? Like, there's.
If I get out my camera knowledge and I take a picture
Listen
of
to
you
me.
with my phone, you're
The
saying that's
Earth
distorted.
has a geodesics. Okay, geodesics are straight lines in like on a curved surface. You're not incorporating those geodesics into like your
There
little
is no curve.
two-dimensional, like that
There's
two-dimensional.
there's
Sorry.
no curve, bro. No curve.
Look,
Like, let's take the acres. Let's take the acres, and
The
we'll
GPS
represent those with pieces of paper. And we take pictures of pieces of paper, 10 by 10.
What shape are pictures?
Those,
he's missing the point, though.
What
He's
shape
missing
are
the
they? Are
point
they
entirely.
square?
yeah, it's just there's just no. I mean,
Is our pictures square? Like those are
He's mixing up.
Those are two-dimensional. Anyways, you guys.
I can't understand. I can't understand like how you can be this ignorant. Like, it's just I don't know. I'm so confused.
You're actually the minority here, to be honest.
Awesome. What's that have to do with anything?
Like, we're basically arguing, like, you're basically trying to tell me that, like, flashlights, like, they don't emit light. Okay, that's how stupid
No
this
one's saying
conversation
anything like that. No one's saying anything like that.
It's what you sound like.
You're talking to yourself again. So
like
we're
when
trying to get
black people speak because they're a minority, they're by default stupid. Is that what you're saying? Like because we're a minority, people that understand the shape of the earth, the real shape of the earth. So, like, I don't get it. What does minority have to do with anything?
Good point.
This year, you guys are kind of like 0.0000 like percent of the population, right?
Okay.
Like,
yeah. So then what's that have to do with anything?
What does that have to do with anything? It's because you're trying to argue something it's largely factual and everybody's moved on from. You're trying to tell me that 2 + 2 isn't 4. It's always
We're
been
not saying
5.
anything like that. You're talking to yourself again.
No. 2 + 2 is 4, bud. It always was, always
Yeah,
will be.
we do agree with that. Go outside and the earth doesn't move and it's flat. That's 2 + 2 is 4. We're talking about the real deal Holyfield outside, and you're like, well, no, you got to correct reality and make it something different that it's not.
Yeah, you're saying like by default, a picture of something is distorted.
If you try to represent the Earth into a two-dimensional object, it would be.
Yeah, so my 100 acres
We're not doing that.
flat.
We are not
We're
doing
measuring
that.
it flat. We know it's flat. Reality says it's flat on my 100 acres, and you're saying nope, distorted.
Reality doesn't say that. You say that.
Yeah, I
But here's
just
the
said
good news.
Mainstream science disagrees with you. Mathematicians disagree with you. Physicists disagree with you. Like, it's only you saying it in a Discord server.
How do mathematicians have anything to do with the shape of the Earth?
Mathematicians? You ever heard of
Right,
Newton?
we're talking about
You ever heard of Newton?
a physical
Sir Isaac
realm,
Newton?
not numbers on paper.
Hey, bud.
I'm not your bud, but what?
Newton? Who created calculus? Who do you think did that?
What the fuck does that have to do with my 100-acre flat field? Pictures of it. Like, dude, where are you at right now?
You said, what does math have to do with this? Sir Isaac
Right.
Newton created calculus.
Right.
So
So
we have to
Isaac
deal with
Newton has
infinity.
nothing to do with
right?
my 100 pictures. Nothing. Zero.
What shape is your pictures? Are they square?
They're flat, just like my 100 acres.
That's the problem. When you try to incorporate like the curvature into like a two-dimensional
There is no
object,
There is no
curvature.
curvature, bro. There's no curvature. I'm telling you, the 100 acres is completely flat.
You fucked up earlier by telling me GPS satellites work. They work
No, we
perfectly.
didn't. Yeah,
I
they
didn't
do
even
work
talk
on
about
Earth, it
GPS.
doesn't
I'm
move.
talking about my 100 acres with a picture, 1 acre per picture. So I've got 100 pictures. Come on and you're saying they're distorted. What distortion is there? They're physical representations of exactly what is outside in the real world.
How do you know?
I measured the 100 acres and it's flat, diagonal, horizontal, every which way you measured it is perfectly flat. And I hope you understand we're talking in hypotheticals here.
Look,
All right,
dude.
I'm done. How's the
If you
weather
want to
where
say you
you
got
live
to,
at?
He said that he measured it. This is so funny.
if you want to factor, this is hypothetical. We took pictures of paper. I guess it's possible you could theoretically hypothetically measure that. If you want to say you had a factor in the curvature, why don't you just tell us where it is in reality?
Where's the curvature?
Yeah, in reality.
Where's
measured it? Where was it detected?
Do you know what a four-dimensional manifold is?
Oh, here we go. Dude, just tell us where the curvature is in reality, please.
Yeah, space and time are like interconnected, right? That's what Einstein said.
Well, you're saying
right?
that. Hold on. You're saying the Earth
like
is
mass
physically
and energy,
curving,
right?
correct?
Mass and energy, right? Like when you have like. So
Hold
like.
on. You're
Like you have
saying the
like
Earth is a
mass,
physical object that's physically curving, correct? So where is the Earth physically curving, please?
Where is it physically curved?
Yeah, where is it physically curving?
Where is it physically curving?
Yeah, you gotta ask me 3 more times for the answer, like, spell out the answer?
I'd like to repeat my Einstein quote.
No, we just need the curvature where it exists in reality. Like maybe you could point
Where
to
it
it
exists in
or show us the
reality?
measurements. How many times do you feel like you need to ask the question that I just asked you?
Wait,
Yeah,
can he ask
where is
you
the
a
curvature in
question?
reality?
The GPS exists in reality.
No,
No,
no. We just
no,
need to know
David.
The
where the
GPS
curvature
systems
is in real. Hold on.
GPS
I
systems
understand. No,
exist.
no.
Like they only work
Thank you.
with a globe.
That's
Go ahead.
secondary, but we want the primary curvature that you're referring to. You're saying, well, we have GPS and that's secondary to there being curvature. Okay, well, let's just go to the curvature then. Instead of these
Curvature.
secondary, tertiary things. Where's the curvature in reality? Yeah. Can you point to
Well,
it? Can you show us
yeah, well,
measurements
like
of
so
it?
the
Can it
time
be detected in any way, shape, or form? Yeah, go
yes,
ahead.
yeah.
Okay, go ahead.
It's
Yeah, go
called a
ahead.
geodesic. That's curvature.
Okay,
Like
so
it's a straight line on a curved surface, and
no,
every
but you have to
single
we have to find this curved surface first. So I
we have to
understand how
find it.
geodesics work. Yeah, well, I'd like you because you're saying like this is how straight lines work on a curved surface. Well, where is this
Mhm.
curved surface in reality? You're saying the Earth is a curved surface, right?
Where is it in reality? It's well,
You
you
do
can
that a lot. You
we
repeat
apply
the
from the
question a lot. It's
two-dimensional
fine.
manifold, right? Like that's how I
Whoa, we're talking about in
understand.
reality. There's no two-dimensional manifold. So in
Yes,
reality,
there
you're
is.
saying the Earth is
Yes,
a
there
curve.
is. There is a
Okay, so
two-dimensional manifold, but
in reality, on the surface of the Earth, you're saying there's a 2D manifold.
listen.
You gotta here's the thing. I want to snap my fingers and I want you to focus on not representations, but the actual Earth. The actual Earth that you can walk on, put your feet in, toes in the grass,
The
etc.
actual
You're
uh
saying that that physical curve, that Earth is curving. So we'd like to find a way to
you
detect that. But you're saying, well, in these representations, it curved. Okay, cool. We
yeah, but
understand
the
that. What
other
about in
methods
reality?
yeah, but the
We
horizon,
need
all
the
that stuff is boring.
actual Earth to be curved in reality for those representations, for you to say that the representations are correct of
Okay,
an
how about
like
this? There's a 24
representing.
hour there's a like
That
I
doesn't
think
mean the
in
surface is
December
curving.
there's a 20 yes it is.
Okay. No, that's us looking up in the sky and then assuming what the Earth is doing below us. We need to determine that the Earth below our feet, that we can walk on, look at, measure, touch, and all these other things,
How does
we
the
need to
24-hour
determine
sun
whether
work on the
that
earth?
doesn't matter.
How does it work on
Doesn't
the
matter.
ground?
Because we're looking up at the sky, we're trying to say, oh, that means the ground is doing XYZ. That's not how this is going to work. So we need to
Yes, it is.
determine that the ground will no. We need to determine
You
that
don't want to talk
okay,
about the sky.
even if
Why
we
do you talk
did
about
stare up
Polaris
at the
and all
sky.
these other
Hold
bullshit?
on, dude. We're not talking about Polaris right now. We're talking about the surface of the Earth being physically
That's the
curving, like
sky.
you're saying it
Why
is.
do you
But for
guys talk
some
about
reason, you don't
lasers
want to.
then?
That's not the sky. You're
This
saying the
guy's like,
ground is curving,
you're talking
dude.
about
Laser
the
beams.
ground, and he's like, but Polaris.
Do you
Wait, what?
understand? You're trying to tell us right now that the ground below our feet that we walk on is curving, but for some reason you don't want to talk about that.
Were you the one that talked about the compass?
Brother, I'm not. You gotta focus, bro. Get the ADD drip out. You gotta focus, man. All right.
You
You're like
gotta
You're
talk
saying
so
the
about the
far out
physical
in
Earth
compass.
left
is
field right
curving.
now.
Hold on a second
I
now,
can't
because I could
understand.
just call on any flat earther in here, and I'm gonna go. Can you talk about the surface of the Earth being flat? And they go, yeah, there's bodies of water. We got basins here, laser tests here. They're gonna talk about the surface of the Earth being flat. When we asked you about the surface of the Earth being curving, you're like, well, let's look at these maps. Let's look at the sky. Let's look at stars. You're not even trying to talk about the surface of the Earth
But
being
time
curving.
space.
Well, maybe there's a
Uh,
good reason for that because it's not curving, right? That's probably
I'm
the simple
explaining
answer. Is
you
that
why there are
there's a reason why you can't
distortions
talk about it.
within like
No, there's
maps
no distortion.
because
Dude, we're talking about the Earth,
yes they
bro.
are.
Hey,
You
I
said there
snapped my
was no
fingers
distortion.
earlier,
You
and
said
we were
there's no
going to stop
distortion.
talking about representations of the Earth and talk about the Earth that you said is physically curving.
You are losing horribly, stuff.
You have completely lost the plot.
You have
We're talking about the Earth
lost.
being physically curving, and you want to
I
talk
feel
about
like I'm
maps
winning.
again.
I'm winning.
Hey, how much
you're winning.
how much time
I said fucking up in the
dilation?
rocker.
What's the time dilation difference in
Oh no.
It's like what's
knowledge?
the shape of
What's
the
the
Earth? Well, the price of tea in China right now is
hmm,
The stars above me.
Hold
knowledge?
on, techno.
What's the time
What's the
dilation
time
difference?
dilation? What's the time dilation difference?
Yeah, what is it?
If we don't
In
fix it
24 hours? Yeah,
in 24 hours, it'd be about like
yeah,
8 seconds, something like that.
38 microseconds.
But Polaris,
Are you sure?
Yeah, for the
Just
GPS
Oh, well,
satellites.
please help us out, bro. This guy's fucking.
one time at
The
the
Oh,
global,
bandstand,
Timbo, you are back. What's
the
up, bro?
global positioning system, satellites that gravitational effects dominate. The net result that a satellite clock ticks approximately 38 microseconds faster every single day compared to clocks on Earth's surface. Where'd you get 8 seconds from?
Directly from the asshole.
Probably knows.
So it's kind of irrelevant, right? So,
You said there's no such thing as time dilation.
well, 38 microseconds.
Yeah.
Yeah, how much is that? What's a microsecond?
What's a microsecond to you?
Oh my god. What's up, CB?
Bro, am I cooking right now or what, man?
I heard you
Holy smokes.
when I jumped off. I was on YouTube and I was like, oh, I can't jump back on, but I want to go and say hello. I
I
miss
just
you, man.
don't. If we started saying, "Oh, well, the Earth is flat because of GPS. The Earth is flat because of maps. The Earth is flat because of this, that, and the other," you go, "Okay, well, where's the flat Earth?" And we go, "Well, don't worry about that."
We're
You
getting
guys would have a
tired
big
here.
problem with that. You guys would have a big problem with that. So you seem to only want to talk about these secondary, tertiary factors when we want to talk about the primary factor. For some reason, you don't
You
want to
don't
talk
talk
about
about
that. That's
primary
very
factors.
strange.
You're doing the same thing I'm doing.
Seems like
No,
knowledge
no, because I
has
said,
no knowledge of
I've only
anything.
like I
yeah,
got
you should change your name to a belief.
the only thing I got wrong this whole few-hour discussion is like the time for the time dilation. That's
Yeah,
it.
right, bro.
Everything else is correct. See, we could
You
admit
can't even tell
failure.
us where the Earth is physically curving. So admit that failure.
Where is it physically curving?
Yeah, you can ask me 5 more times, but please answer the question.
It would
Time
be
dilation.
yeah, time dilation. There you go.
Cooked. Do you have an answer, bro? Because when I went, like I said, I was literally doing yoga right by the ocean today, completely
Doing
flat.
fucking yoga, bro.
Yeah, because I'm like that.
We gonna be figure skating next?
Sure.
What's wrong with that?
I'm graceful as a swan. All right. So, but the cool part is the ocean's flat, dude, and I'm totally fine with that. But for some reason, you don't want to address the fact that the water's flat, the Earth is flat, doesn't move.
Oh,
You want to
is
talk about
that
math?
is that at the beach that we observed a plus 10 mile horizon? Is that there?
Ooh, yeah,
Same beach.
Horizon.
right here in California. Yep,
What the hell is a horizon?
Place where
flat.
the land and the sea and the sky in this case appear to meet.
I got you.
Yeah,
Yeah.
it's not the curve of the Earth.
So you mean the curvature?
It's not
No, it's flat.
just an apparent position. All your globies will tell you it's an apparent position too.
Wait, do you think that's like a hump of Earth or something? Wait. At the ocean, do you think that's a hill of water?
I don't want to do
Oh,
the book.
freaking way.
Oh no.
I didn't think so.
Is that a 2D hump of water?
Cooked. I don't. It is. You should be aware of this knowledge that you do seem to want to dodge the real Earth that's outside that you experience,
Oh, I'm
just
falling
like everyone
asleep.
else.
I'm
Nah,
just
I would fall asleep too when if I was getting cooked, I'd fall asleep as well.
I just ask another question.
Why does the Earth not move?
Why does the Earth not move?
Yeah.
You ever heard of Galileo?
Have I ever heard of Galileo? Wait, I was wondering about the Earth not moving. the Earth doesn't
Give
move.
me
You have a problem with that?
Galileo's argument.
Why is the Earth not curving? Do you like biscuits?
Holy.
I pet
Are
a
you
dog once.
okay with the fact that the Earth doesn't move, knowledge? Is that okay with you?
Hmm?
Is it okay that the Earth doesn't move? Is that all right with you?
At this point, who cares?
Oh,
I
now he
mean,
doesn't care.
you seem like you care quite a bit. I mean, you've been here longer
Did
than I
earlier when I
have.
had a full tank of gas.
Yeah, he cared enough to lie about being a pilot. So.
Oh. I was watching a debate yesterday, and the person that I thought lost kept saying things like, "I don't care. I don't give a shit. I don't care." When like he
You're a
pointed
retard.
me, stuff like that. So it's
What
okay
was
to be
the
tired. If you gotta go, that's fine.
what was the debate?
I don't think I can talk about it on here.
Okay, all right, fair enough.
Yeah, geopolitical stuff, but to keep it vague.
Gotcha.
But knowledge, I think you should change your name to belief. I think that'd be a better fitting name for you, buddy.
No.
Because you do seem like you have just beliefs. I know you haven't presented any knowledge or
You
facts.
have a belief, as Jaren said when he left the flat Earth. Yeah, these people are
He's back to
thinking.
Jaren
Fuck
again.
Jaren. Fuck Jaren. No one gives a fuck about Jaren. You thought Jaren was a clown 5 years ago. Now you think he's some hero or something? The hell is that?
I don't think any flat earther is a clown. Only like the opportunist, like the people who do it for money.
Oh, it
Well,
sounds
so
like
we're
that's
all
what
right
Jaren.
then.
That sounds like Jaren doing it for money, saying it's a glow. It sounds about right.
No,
So you like
I think
us?
he saw.
Now
I think he
now he's
saw.
some honest guy. He's really he's really an honest guy
Yeah.
now. When before you thought he was some fool who thought the Earth was flat. So I don't think his word holds a lot of weight, really.
Yeah, he's honest now because we have the same beliefs.
because he understood that, like, because he tested his belief. It's something you refuse to do.
I have
Dude, we
tested
test
it.
it every day. We test
All
our
the
belief.
Glovers were
Sorry.
predicting a 24-hour sun in Antarctica. It wasn't even a question. Like it was.
We
so
believed in the. We said it was a 24-hour sun in Antarctica as well.
No, you didn't.
Yeah, we did.
Yeah, we've been saying it for years.
Wait, when did you get involved in the topic knowledge? Was this like this year, last year, 2015? When did you first get involved?
This topic?
Yeah. Like a month ago?
Yesterday?
Not yesterday.
Like 2 months
Day
ago.
before? 3 days ago.
This year, probably.
No. Yeah, it might be.
So then you probably aren't in a position to be saying, well, you guys used to believe this. Timbo's been around for what? Almost like 8 years? How long has it been, dude?
Yeah, around about that. But on this channel,
like a
since
decade for
2019 and then maybe 18. And then before that, 2012 on YouTube and stuff. So.
Yeah, there's flat earthers who've been in here for almost a decade, bro. So you just got in here a couple months ago. I don't think you're really in some position to be like, no, you guys used to say this. No.
It was their previous arguments that like
You don't
Antarctica was
know
an ice
that. You
ball.
just got here.
Yeah, you're talking about a different group of people, knowledge.
How's come? So you're the correct flat earthers, right? Not the.
Yeah, you
No,
can say that.
we're not saying that. We just talk about things that you can measure in reality, right? So we don't go into the.
It's like when I talk to
we don't
socialists,
go.
right? Like every like 100 people you talk to have a different view about like that's the problem, right? There's no
Yeah, no,
consistency with you
that's
guys.
why it's not a cult. like you guys. You have to believe exactly the same thing, otherwise you can't believe that the Earth's a globe, right?
Well, I haven't seen you be dishonest to me yet, so I can't really say you're a cult member.
No, well, you just said we weren't a cult because everyone. You said
Only Mr.
You said everyone
DJ
thinks
has
the
lied to me.
same, right?
Not even.
You
Not
said
even.
everyone has a different opinion, so it can't be a cult, can it? But you guys can't have a different opinion.
Ooh.
Well, my belief is that, like
Your
Jaron said
belief
when he
is the
left,
same as
like
every other cult believer.
when he told Professor Dave, he's like, yeah, these guys, they're not really, they don't really, you can't really like have a scientific like debate when you don't have a model, when you guys don't actually do testing, when you're just trying to disprove like
It's not a.
you know
It's not
Angus
a.
Glober's
It's
head.
not a scientific debate.
What's the point of this discussion then?
Where's the science?
You're trying to disprove.
Where is the science
Glober.
in the shape of the Earth?
The science? What are you talking about?
Yeah. Where is the
You're
science?
the one making the claim.
We're making the claim. You guys are making the claim against your against all of your senses. You just admitted before.
It's not us making the. It's the whole world versus you, dude.
Okay. Yeah.
Okay, you're just a nut job conspiracy theorist. Okay, that's
Okay, nut
laughable,
job,
like
yeah.
Joe Rogan.
Okay, we haven't said anything. Okay, hold on. What's one thing that we've said today that's like nut job and crazy?
Saying that GPS satellites don't take the curvature, don't correct. Well, they don't correct the curvature. I mean, they don't correct the distortion. I'm sorry, I'm falling asleep, dude.
But then we asked you where the curvature was, and you wouldn't say it. So that doesn't sound that crazy to question you on that.
It's crazy because it wouldn't work. Right.
That doesn't sound very nut job to question you on
We
claims
would
that you
like
make.
if those maps worked, we wouldn't need the GPS. But why do you think we have the GPS? What do you think it's for?
Okay, so it wasn't nut job. What else did we say that was crazy and nut job and conspiracy?
I think that would be the only one.
That doesn't sound very crazy or nut job.
The
When you
rest,
make a
the rest
claim
of
and
it,
we ask
the
you to
rest, the
support it
rest
and you
of it.
couldn't, that doesn't sound very crazy to me.
I would say, well, I don't view you that way. Like you haven't lied to me yet, like DJ does constantly.
Okay, well, you're putting forward your belief. We're questioning that belief, and you don't have anything to stand on. And you're saying, well, you guys don't believe it, so you're crazy. I don't think that's very conspiracy or nut job of us to challenge you and your beliefs. And you don't have any substance below it. So
Yeah.
that actually seems pretty smart, actually, if you ask me. That seems pretty wise.
Well, retired now, so he ran out of gas.
All right, fair enough. Sorry, Timbo.
I think he left. Did you always believe the Earth was round? I mean, flat, or just something
No,
that you
I
got
don't.
into?
I think most people were just like you, dude. We believed it just like you, and then we actually went to challenge our beliefs because that's the smart thing to do. Test your beliefs to see if they hold up. And the problem is when you go to test the globe Earth belief, it doesn't hold up. It kind of starts to disintegrate pretty quickly once you investigate. But the problem is most people like yourself, they don't do a lot of investigation. They lean on their beliefs and the fact that other people also believe it. Oh, well, Einstein believes it. He's smart. Oh, Newton believes it. He's smart. So I don't need to do any checking. These guys did it for me. They believe, so I'll believe. That's not very smart to me. That sounds like a gullible person. And we're not conspiracy or crazy or nut job. We didn't fall off a truck and just start believing the earth was flat. We actually went to test the earth
Then why are
physically,
you
measure
using
it,
mathematics
etc.
and science to try to
We're just
disprove the globe?
measuring the earth, dude.
Those
And you can
measurements
very
are
easily
done by
debunk
those
the globe.
people. like they gave us like the formula. Like, why do you trust their
No, we're
formulas
measuring
but
the Earth
not?
ourselves. We're not
Okay,
trusting the formula. We're just if you tell me, hey, I'm
what do you mean you're not
knowledge.
trusting the formula?
If you tell me you're
Yes,
6'7"
you are.
tall, if you tell me
How do you
you're
know this?
6'7" and I go to measure you and you're not 6'7", it's debunked. It doesn't mean I just quote unquote like why are you believing the numbers? Well, we tested it. We're checking to see if it's true.
No, you're not.
That's exactly what happened. They said the Earth was a globe of what 3.959 miles in radius with a certain curvature drop rate, 8 inches per mile squared. You can go out and test that in reality, and
That's
it's
just a
not there.
standard.
Period.
That's just a
It's
standard
off
like
by
talking point.
it's a way off.
No,
Okay,
it's
now
not.
if you want to say, well, it is actually. We can post some measurements in the chat. You can post your observations in the chat that completely shred any idea that this number is even slightly
Why do you
close.
trust
But
these
then you would
things?
have to no, it's not. It's not, dude. You trust them and you think they are correct. We're testing them to see if they're
Yeah, I
true,
agree.
and
I
they
agree
are
with
not.
Galileo. I agree with Newton. I agree with Einstein. Like,
Okay, but
why
you haven't done any testing to
you
see if
are
they're true.
you
Why are you saying we trust them? We
you're
don't
trying to
necessarily quote
use
unquote trust or
you're
distrust.
trying
We're checking
you're
to see if it's
trying
true.
you're trying to use like the scientific like method and like mathematics to disprove something that they've already told you
2 plus 2
exists.
is 4. And we don't need anyone to tell us that. You can,
Yes, we do.
you can test this on your own. No, you don't.
It's based upon an axiom book. Okay, it's called
That
Peano.
doesn't mean the Earth is a globe, dude. 2 plus 2 being
Okay.
4.
Like,
That
do you know
doesn't
what
mean the
like
Earth is a globe.
formalism is? Like, do you know what that is?
If I have
Like
2
in
forks
epistemology,
and
like
then 2 more
formalism,
forks,
like
I have 4 forks. There's no you don't need some sort of special doctorate or mathematician to tell you that. You can just simply have 4 of something. You know what I'm saying? Like it's that simple.
well, in the formal system, you don't need any
It's not
external
about
outside
trusting or
information to know
anything
that
like
it's true,
that.
right?
But you're missing the point. You're missing the point. If on a simple terms, if you say you are a certain height and I go to check and it's not true, then it's not true. Period. And that's what happened with the
But
Earth. They said it's a certain size. We checked and it's not true.
Okay,
Period.
but you're
No,
picking and
no,
choosing what you believe.
that would mean that you then have to believe that well, what they're saying is also not true, and then maybe it's still a globe in some other size, but I don't know why you would do that. Do you think the Earth is a different size than what they're claiming? Probably not. So there's no reason to accuse us for like, well, why are you trusting the numbers? Dude, you trust them. You believe them wholeheartedly. You think it's a fact. So we're just checking to see if those facts are facts, and they're not.
Yes, they are.
Okay, well, when we check, it's not true.
Galileo
Period.
confirmed. Like, well, Galileo,
Did you
Newton, and
confirm?
Einstein.
Did
Mhm.
you confirm? Did you
Yes.
confirm?
Mhm.
Okay, how? How?
How do I confirm? Because I use
Yeah.
GPS, and I fly. Yeah.
No, that sounds like you believe, dude. Sounds like you believe.
Doesn't like, and you said it yourself earlier. Yeah, you
What?
use GPS and it works perfectly fine.
Yeah, on a
That's the
flat Earth that
problem.
doesn't move. Yes, correct. There's no problem with that.
GPS systems don't say anything about like flat Earth. It has to be they
Hold
incorporate the
on.
globe model.
Let me just put something
Can I
toward
ask you a
you.
question?
Let me just finish my point
The
first, and you can go.
GPS is the globe model.
If I were to hold on, knowledge. If I were to snap my fingers, and the Earth was flat, I want to tell you something. Nothing would change. The Earth would be the
Yes, it would.
exact same Earth. Hold on. See, that's the problem right there. Hold on, let me just finish my point here. I want to make this very clear. If the Earth, if I snap my fingers and I made the Earth flat, it would be the exact same Earth that exists outside right now. Nothing would change. Satellites and all this quote unquote stuff that you say works would still work because the Earth outside is currently flat right now.
There wouldn't be a
You have
24
some
hour sun in
idea. Hold on.
Antarctica.
No. There would be everything would be the same because of the
No, it
Earth
wouldn't.
outside that currently exists. Hold on. That's you're trying. See, this is the problem. You're trying to inject
You know there would
some
be a 24-hour sun on
ideology
your
of some. Hold
pizza
on.
on your pizza.
Hold on. This is the problem right here. You're trying to put forward some sloppy flat Earth idea in that you think exists that we don't, that we know isn't real. You have some very silly, sloppy idea of a flat Earth that you say, well, if it was this, these things wouldn't work. What I'm telling you is that the Earth that exists outside right now, where there's GPS, 24-hour sun, and all these things, that's the flat Earth. Nothing would change. That the Earth is
But the
as it is
GPS,
right now.
all of its
So when you say, "Well,
calculations, all of
GPS
its
works, therefore it's a
schematics,
globe," no,
everything is
GPS works
built off
exactly
a
how it
model.
should on the
That's
Earth right
how
now,
it
which doesn't move and
functions,
is also
bud.
flat.
It's not functioning with your model. It's functioning with the
We
globe
don't
model,
have
and
any.
it
We
works
don't need a
perfectly.
model. There is no model. The Earth is just is as it is outside right now, where it's flat, doesn't move. So that where all the things currently work, whether it's this technology of in the water, in the sky, etc., all this technology would not just stop working if I snapped my fingers and made you a flat earther right now. The Earth wouldn't change. It would be the exact same Earth right now that it's always been.
It would not
So you
change.
got to get this idea. Yes, I'm telling you, dude. I'm telling
Antarctica
you.
would be at the center on if the Earth were
No,
flat.
no, no. See, this is the problem. Nobody in here thinks this. You're
Yes, they do.
trying to take some silly, sloppy idea of a flat Earth and say, well, it can't be this thing that I made up. Well, you're correct. It's not the thing you just made up in your mind. It's the Earth that exists outside right now, which has the 24-hour sun and technology and etc. That would not change. So you got to drop this idea that flat Earth will be something different. It's not something different. When you and I both go outside, right? We're both looking at the ocean. We both see the exact same thing. I say flat, you say globe, right? It's your belief that you have that's different, not the Earth. The Earth is the same for both of us. So when I snap my fingers, the Earth doesn't change, you change. Ta-da. And Wikipedia flat Earth beliefs, dude, half of the memes on the internet about flat Earth are made by globetard idiots who try to
Yeah, like
make fun of
we
some
don't
idea that
believe
they
there's
don't
like a
understand.
big disc floating in space.
Yes, correct. And this is what Kiwi Local in the chat was posting. Oh, look, they think it's a pizza planet floating around in the solar system. I've asked them and they say that. No, they don't think that. So half of the quote unquote information about flat Earth on Google, Wikipedia are goofballs like yourself who try to say that if the Earth is flat, Antarctica would be in the center. Like, well, what are you talking about?
Where is it then on the flat Earth?
Wherever the fuck it is right now.
If you say like
Wouldn't
the
change.
shape,
That
if you
wouldn't
say that,
change.
yes, it would.
No, it wouldn't. I don't know how else to be more clear to you. The Earth
This
would not
if the
change.
Earth were flat like you say,
It wouldn't. It'd be the
it would
exact
be
same Earth right
similar to
now.
this shape.
No, it wouldn't. No, it
Of
wouldn't.
course it would, bud. If you flatten
No,
a
it wouldn't, dude.
fucking like a ball into a fucking pancake, yes, it's going to change
The Earth
dramatically.
isn't a ball to begin with. The only reason
I'm
the
saying
only
if you
place
did,
it's a ball is in your mind.
it wouldn't be the same.
The Earth would be the exact same way it
No,
is
it
right
wouldn't.
now when you go outside.
If I took the globe model and flattened
There is
it
no
into a
model.
pancake, I'm saying if I did, okay, let's just pretend that there is, right? It would like this
You
is
don't need
how
to
it would look.
pretend. No. Look, you're taking your idea that's already incorrect, some belief you have, and morphing your belief
It's
and
your
saying, well,
belief.
this must be your belief.
You're just
No, we
running
don't have a
from it.
modified version of your belief. No, we're not running for anything. I told you where I was today, outside observing the ocean. Dude, I don't have any belief about that. That's the real thing right outside. I was there. Okay. Our idea of the earth isn't some crap version of your belief, some modified tweaker version of what you think is real. We don't have a silly idea in our mind of what the earth is. We just go outside, experience the earth not moving, and it's flat, and that's it. We don't need to sit here and close our eyes and imagine what it all looks like you do. To be honest, that's really stupid because you never have that perspective anyway. You've never seen the earth from this point of view, being some sort of ball. You're only going to see that on a stream, movies, videos, or what are YouTube. Imagine if we came to you and said, well, I saw the earth on YouTube. That's how I know it's flat. You would laugh us out this TBC right now.
Are you religious, bud?
But for you, that's okay. No, I'm not religious in any way, shape, or form. No.
Okay.
But I don't see how that addresses my point, right? I'm talking about reality. But go ahead, guys. I see other people want to chime in. Go ahead. Tristan or whoever that was. But
level 2 Glober has entered the chat.
Oh shit.
First, you have to ask that as though that invalidates anything.
Oh, Gregory, what up? I genuinely think this is my biggest complaint with Globers is that their worldview only exists in their head. And they think that's true for us as well. It's not.
I remember like my
We
first
don't
day here with this Gregory guy. He told me that GR
No.
he distorted what Einstein said. It was so funny.
Gregory, the punisher of pedants.
Yeah. This is the guy who tried to say that. He said that Einstein didn't say that like space and time were interconnected.
Einstein was a
That was
fucking
such a significant
retard.
emotional event for you. You had to interrupt California.
Einstein's the stupidest person that ever lived.
Okay.
That was such a significant emotional event for you. You didn't have the self-discipline to let him finish.
It's all right, Gregory. I'd love to hear you speak. So go ahead. I'll pass the mic, dude. Shout out to Gregory.
Shout out to Gregory.
Tristan's off the henny tonight.
All the good arguments were earlier. I'm done. Tired.
I know you're tired. Hey, thanks, man. You've been putting up a good fight, I guess. So I'll give you respect for that.
Not the past hour.
I agree. You've been getting lit up a little bit. I'm really glad, though. I will say, I'm really glad that you did not say that a piece of paper was 2D. I thought you were going to say that, so I'll give you some credit for that. I thought you were going to say that. So
said that the map was, but
yeah, I know you were trying not to answer the question for a while, but ultimately you did agree with what Timbo was saying. At first you thought he was silly for saying it, but then you ended up agreeing with him. So I'm glad that we got to the bottom of that. But all in all, you really gotta drop this idea of the flat earth that you have in your mind, because we don't share that. We don't have that idea that you have, that it would be the Antarctica in the center and it'd be different and the GPS would work differently. That's horrible. You got to get rid of that. That's got to go.
Are you guys trying to abandon this model because it's been thoroughly debunked? You guys been fucking ass
We don't have a model. Whoa, dude. Again, most of the things that you see on the internet about flat Earth that are especially pushed to the front, like Wikipedia and stuff like this, these are made by people who believe in the globe and want to make flat Earth seem like some crack pipe idea. Okay, you're not getting flat earthers like people in this VC who are saying, "Here's our model, please believe it." Okay, that we're trying to tell you that there is no model. So when you're like, "Well, why don't you believe in these models?" That's not our thing, dude.
It's
Remember, you're trying to say that this idea, no, dude, you're trying to say that this idea that you posted in the chat is a flattened out globe. Why would we think that? Why would we think the Earth is a flattened globe? We don't think it's a globe to begin with. So why would we think it's like your idea but morphed? That doesn't make any sense. First of all, I don't think there's any way you could see the Earth from this point of view anyway. How are you going to see all of reality in one shot? Where can I go to see the entirety of the whole thing? You can't even do that in your worldview. There's nowhere you can go to see the entirety of the universe. So how would you know what shape it is? We can't do that either. We don't know what shape reality is. And if you really put a gun to my head and said, well, tell me what you really think, I must know. Well, I wouldn't say it looked like that, personally. Because when I go into reality, as we were talking about earlier, everything seems to be pretty irregular. I look at a tree, it's super kooky and weird shaped. A hawk, very irregular and goofy looking. Like if you look at a bird's eye view of a lake, super irregular and it's not some sort of square, triangle, circle. So I would probably assume that reality also is similar, where it's irregular and weirdly shaped. So the idea that it's like a perfect circle, I mean, possibly, I guess, but if you really ask my opinion, I don't think so. But then again, I don't think there's anywhere you can go to see the entire thing. So I don't think there's a way to represent reality in an object. Just like if I believed in the universe per se,
Is the moon
I
cool
don't
to
think
you?
that there's any. Oh, here we go. All right, I'll just.
Is the moon circular object? Does it look
I
that
don't know
way, or
what
is
the
it
moon. I
fake?
don't know what the moon is, to be fair, because I do observe a new moon also, and I don't see anything. So what kind of object disappears, right? So if you're saying it's a spherical object, well, what is the new moon? Why don't you see anything? What is an eclipse, right? So if you want to put forward this idea that it's some circular spherical object, well, what's going on with a new moon? You know what a new moon is?
When
Too
you
tired
can't
to
see it.
answer.
Huh? What's that? Too tired to answer. Yeah, it's where you don't see shit. Okay? And now name one object on the earth that does that. I'll wait.
Where you don't see shit?
Yeah, where you see it like what 90% of the time, and then sometimes it just vanishes. What does that?
I'm pretty sure we can see it fine.
I don't think so,
Like, can't you see it with Earthshine?
bro. Bro. Like the
If
Henny
you
is
want
hitting
to
too
take
hard right
over,
now.
you can. I'm
No,
tired.
I'm too stupid.
Facts. So I don't think I know you guys want
I
to
was
say
gonna
that
say
like, well, the
I was
moon
gonna say
must
your
be like a
dick
rock
is something
object,
that completely vanishes. You don't see it, right?
bro.
So when you go to unzip or take a piss, it completely vanishes.
Maybe that's true for you, dog, but
Dicky do? Your belly sticks out further than your dicky do?
I don't see how that addresses anything I said earlier, but whatever. I'm not even really paying attention anyway.
You asked me for an analogy. I gave you one.
Of what?
Something that's you can't completely vanishes that you can't see it. Yeah, your fucking dick, bitch.
Oh, you're looking directly at? What's blocking the moon for a new moon?
Your stomach?
What's blocking the moon for a new moon?
Who knows?
Yeah, exactly. So you bringing that up is completely irrelevant. Like stupid for you to bring that up. Doesn't address anything I was saying earlier. The point being that there's no way to see the entirety of the Earth to even make a model in the first place. So why don't you have a model? Well, how would you? How could you? So what we end up doing is we go off of reality, what we see and observe and measure and navigate on in reality. And that seems to be on an Earth that doesn't move and is flat. And I'm totally fine with that. And I think a lot of people in this panel are also okay with that. But you've got your maps and your GPS or whatever that in your mind only works if it's a globe. But when you go into reality, there is no globe, there is no curvature. You don't even seem to want to talk about that.
Of course, it
That
only
should be
works
a
if
red
it's a
flag.
globe because it's how it's programmed, homie. It's programmed with
That a red flag should be going off in your head that we're programming it to be a globe because there's nowhere in reality where there is a globe to begin with. You can't even address that point. You refused to acknowledge where the curvature would even be in reality. You're saying that it's in the programs, it's in the calculations, it's in the corrections. You don't see the problem in that?
I know there are distortions within the paper maps because you can't fit the three-dimensional curvature into them, right? I know that's
No, we
weird.
have to be able to determine where this three-dimensional curvature is in reality. And this brings us back into this vicious cycle where we try to point out, well, there's got to be the primary source. And you're like, yeah, but we have the
It
secondary
exists
source.
because of the fucking Earth, dumbass.
Which is where, dumbass? Which is where? Where?
Since space,
besides the
okay,
maths
space is like a
in
fabric that
space.
can be distorted. Okay, that's
The
what
curvature
gravity
of the
is.
physical Earth is in space. That's what you're saying.
Oh,
See, notice how we bring it up. You're like, oh God, you want to talk about the Earth being curved? Yeah, dude, because you're saying it is curved. You
Can
can't
we
even point
continue?
out to where it is.
Can we continue this tomorrow?
Yes, we can go
I'm
anytime
clearly
you
I'm
want.
clearly too
Hopefully
smart.
tomorrow you bring something physical for us so we can actually measure or test or whatever instead of your corrections and your calculations and maps and stuff.
You fought well, Globe Warrior.
But hey, if you're tired, man, you have
No,
a good night,
earlier
all
we
right?
were talking about like geodesic stuff when I had much more gas in the tank, but I've
What
completed
time is
out
it
of
where
it.
you are? Time dilation. What time is it where you're at?
Oh God, I'm on the West Coast.
Oh, we're on the same time then. Yeah, get some sleep, dog. And he's gone. Holy smokes. I almost set this kitchen on fire. I was cooking too hard.
I'm sitting here playing fucking Rocket League. It's like amazed at this ignorance.
I mean, can you blame him though? I mean, I don't. It's kind of hard to blame someone who believes in this stuff wholeheartedly. I mean, you have to think like this.
I mean, he
So,
literally has
mm,
faith in it like it's a religion.
what are you gonna do? You know, it's just easier to think that. Well, Einstein thinks it's a globe, so there's no way I could compete with his brain. So I must
Right.
think it's a globe too. It's just easier. It's just the default thing. So you can't even blame him for doing that, to be honest. But it is funny how they're like, "Well, you guys are crack pipe conspiracy." Oh, is it crack pipe conspiracy for challenging your belief? Really? I don't think so. I asked him to name one thing that was crack pipe, and he's like, "Well, you think GPS works?" Well, so do you. So that doesn't sound very crack pipe to me.
I've heard him get some things wrong.
Oh, like what?
I don't recall anything specific.
I see what you did there. What's up,
Well,
Tristan? Are you a globetard?
yes,
I don't know. I just haven't spoke to you in so long.
been years.
Has it been that long? God damn.
Well, over a year, yeah.
Okay, yeah, sounds about right. Well, were you a flat earther before, or a
No,
globetard, or
no. Full globe tard.
I can't tell if you're trolling through the Henny right now.
Oh, sorry, I'm like, yeah, on my honor. I've never questioned the globicity of the Earth. Not even a little bit.
It's
Yeah,
giving
that
flat
makes
earther.
sense.
It's giving flat earther. I'm not gonna lie.
Damn.
Shout out to Gregory. Shout out to Elbow. Shout out to Boogie Woods. Shout out to Tristan. Shout out to Techno. Shout out to Timbo. Shout out to the 24/7
Timbo.
live stream. Shout out to Helio. Shout out to Flatwood, right? You guys want to shout anybody else out?
Shout out to my mom.
No? Shout out to Dagaz, Hard Jelly. Pause. Shout out to Clipcord. If you're really rocking with the stream right now, you should put a W in the chat. W's in the chat.
Somebody put a W in the chat for me. I'm hushed.
Can't. I'm in an intense Rocket League match right now.
We need about 6, 7 W's in the chat for this to move forward, guys.
Oh God. Shut up.
I'll give you guys a little story. There was this chick I've been talking to. She like did this deep dive on my Instagram and sent me a message one night. And she was like, "Hey, I just want to talk. Um, I saw that you followed like a bunch of flat Earth channels on Instagram. Like, it's really not okay if you're a flat earther and stuff."
Oh no.
Hey, what do you guys think I did? What do you guys think I did? Did I tell her the truth or what I do?
I think you probably did tell her the truth, yeah. You're like, the earth is flat.
Hell no, I didn't tell her the truth, bro. What?
No way, you're
I was
like,
like,
no, I'm
nah,
just
baby. I was
joking.
like, nah. I was like, no, I'm only following them because I debate them.
Ah!
I was like, nah, I just argue those guys, but they not gonna listen to me. Da, da, da. So yeah, I played it off. It's a good move. What do you guys think? Would you tell your chick the Earth is flat?
Yeah.
Have you?
Yeah.
How'd that go?
She knows that I'm the head of the house.
Ooh, misogyny.
Damn.
I
Anybody
would
else?
curve around that argument.
You would curve around the argument. See, that's what I did. Nice.
I said the earth is flat like 20 times today.
Didn't it just feel right?
Anybody else talk to Flat Earth about talk to their girl about Flat Earth? Or your guy, or whatever. Boss. I don't know. My ex did not like this topic either. But she knew I was a flat earther though. I told her that. Now that I live in the West Coast, I do see SpaceX launches all the time. What do you think they're doing about SpaceX? What is that all about, guys? Anybody got some takes on the SpaceX stuff? Launches and what they're doing?
I think they just privatized that to take the attention off of NASA stealing all of our money.
I have a friend who says that he thinks they are weaponizing the sky.
Yeah, that's true, actually.
I think he's got a point there. Shout out to him. His name was Shereg, the Mind of God, if anybody is familiar.
Shereg?
Yeah, he's a good guy. No longer with us. Rest in peace. But smart guy, though. He was a flat earther as well. But I did like that take, though. They're weaponizing the sky. It's like our new battlefield, if you will.
They are. It's been weaponized since the 60s or 70s. When they figured out how accurate GPS was, they added error to it on purpose.
I still don't really know what they're doing with these launches, though. I took a video with my really nice camera today. Ooh, I wonder if I can post it for you guys. Actually, one second. Maybe I'll try to post it real quick.
Satellites have been used against humans for decades. State governments can see things from above. Whether or not it's from a balloon doesn't matter. They look at things from above and they use that information to destroy.
Oh, I got the video. Let me post it.
And then you got Trump talking about Space Force.
Yeah. Do you think Trump knows something, or is he in the know or not in the know?
I don't think Trump knows the Earth is a globe. No.
He said some interesting stuff. I don't think I'm not going to dig for the video now, but there was a video where he was talking to Buzz Aldrin, where he had this conference in the Oval Office, and he's like, they said, He's like, so we've been talking about going back to the moon, and they're like, well, we can't go to the moon. We gotta like circle around this thing and touch back. They were just making up a bunch of BS, and Trump's like, why? Like, why don't you just go there? I don't know. I don't know. I think Trump might know something, and maybe he's trolling with the Space Force. I don't know. I don't know. Who knows? But if I had to guess, I'd say he's probably not a super globetard. Videos in the side chat of the SpaceX thing.
Yeah, the weaponization part comes from competition between the states. Okay, when they're jostling for power of the skies, whatever those are, they will sort of destroy each other's instruments in the skies, and the space race will be back on. It's gonna suck.
I still wonder what they're doing with these launches, though. Like, what's the point of like shooting stuff up there and whatnot? Just expensive fireworks? Sometimes I think that as well.
Maybe they're like putting stuff up there, like releasing weaponized satellites. Or, I don't know. Who knows?
Yeah, maybe.
You mean satelloons?
Yeah.
Well, it doesn't have to be a balloon, though, does it? You know, it doesn't have to be a balloon. Probably not the best thing for a flat earther to say is that, like, it's only balloons. I don't think you guys do say that per se, but
Well, I'll tell you something interesting is like ISS, right? Like we can see it like with telescopes, but if you plot it on the azimuthal equidistant map, um, it follows a perfect toroidal field.
what
So
do you
maybe
think?
it's
What do you
being
think?
suspended by like electromagnetism or that.
Do you think that's like some technology that we made, or what do you think that is?
Well, they're trying to say it's the way that it works is like, it's always falling or whatever, like the way that the orbit works is like it's perfectly set up so that like it's falling perpetually and so like if you believe in some kind of flat earth, how would we explain that it's suspended up there? I mean, we can see that it's up. So I think that potentially it's like some kind of electromagnetism that's keeping it suspended up in the air, and that explains how it works without there being gravity. Or
Well, you keep saying it. And we don't. What is it? That would
ISS,
be my
the
question.
space station.
No, we know what the story is of what it is, but what do you think it is? What do you think it actually is?
Oh, fuck! I don't know. I definitely don't think it's something with people on it, like they try to show us on these live streams and shit. Because we got that model like in the space station in Texas. Which, by the way, if you go to Google Maps and you go to the space station or space center or whatever in Houston, and you go to the building that's labeled the International Space Station, and you do Street View, it puts you inside of the International Space Station. So, like, to me, that proves that it's just a studio. Like
I don't know if it proves that, but I do think it's a studio here on the ground somewhere.
Yeah, but that particular evidence doesn't seem very strong.
I mean, you
Yeah.
can like see the harnesses and shit. You know what I mean? Like,
I don't even know what comets are. Comets and meteors and stuff like that. I'm about to go to Joshua Tree in August and see like a meteor shower. I'm gonna sit there and think about what that might be. Not that I'm gonna come with any answer, but I don't know. I don't know. I think that's that's like a. So we talk about the Earth being flat, but like, what is this place? Where are we really? I think that's like the deeper question. Not that we're going to get any closer to an answer, but I do think that would be when we're amongst each other, we should kind of put our heads together and think about what this place really is. Of course, yeah, it's flat. Cool. Yeah, great. Doesn't move. Yeah.
I think it's like an enclosed realm. Like, they try to teach us like we live in this infinite void, and basically we're an accident, and we're just here because of like happenstance. But I really think like it's an enclosed system, and we are significant. We've been created with purpose.
That leads into a lot of questions like, why are we even here? It's like there's so many deeper things. Okay, once you strip away the idea that it's not a globe, we're not in outer space, we're not a speck of dust, we're not stardust, all this stuff. Who are we, and what is this? What is the place what is this place, and what is our purpose here? I think there are way more deep questions about this realm that I don't think we're necessarily going to get any closer to an answer, but it is kind of fun to wonder.
I
Oh
know.
yeah.
Let's wildly misinterpret short passages of ancient texts and build our world systems based on that.
Which is kind of what we've done, right? As a society.
Indeed.
I have some friends, and I've heard before. Actually, my friend Shrek would say that we're in we're in hell. I've heard this
Well,
before.
I agree
like
with that.
biblically, we are like we're in Satan's realm. Like our soul is eternal, and we're set here as a trial faced with temptation, and this is, we have free will and we can choose good or evil. You know, so like it is hell, really.
So then, do we want to like stay here? Is there somewhere else we should go after
Well,
this?
I believe when your body finally gives up, you as your person, your soul doesn't die, and I believe that depending on what kind of physical life, that determines where you go.
Yeah. You guys believe in reincarnation? Yes. You guys want to reincarnate here?
I question if it exists. Would I want to come back here? It depends on other options.
You cut out,
Other
my
options.
friend.
Yeah, you cut out there.
Rewind.
Oh, my bad. I said it depends on what the other option is. If that other option is truly what we're told it is, like the perfect quote unquote world. Uh, yeah, I mean, I guess that'd be better, right? So, but if not, if it's just like you exist in a spiritual realm and like walk amongst people as a ghost, no, I'd rather come back as another person.
I don't
Sometimes
think
I
I would if I
question
could.
it.
Go ahead.
I was just saying, sometimes I question it because of my daughter. Um, she just turned 8 like a month ago, and she does some really weird things that like she shouldn't know or do as an 8-year-old. Um, like I was born in '82, okay, and I have 2 older sisters, so I grew up with music. Even when I was like 8, 9, 10 years old, I was listening to stuff, and I try to expose her to like lots of different types of music and styles, and I don't try to tell her. So I play lots of different music. Well, I turned on, and she knew like every word, and she never heard it before. And I'm like, how do you know this? She's like, oh, I love this song. And I was like, where have you heard it? I don't think I've ever heard it before, but I mean, literally word for word was just singing it perfect. And I'm like, what are you doing?
Yeah, kids are kind of tapped into some. I've heard this before. Kids are just tapped in sometimes, but
Well, you know how like
that's
kids,
the mystery of
you know,
life.
you know how you're like not really conscious of who you are until you're like 5 or 6, and then it's like you kind of like wake up and realize like you're a person. Well, a lot of kids like before that, like awakening, you can question them about things from the past, and they'll have answers. And a lot of kids even will talk about like, oh yeah, I did this and thing. But then it's like when they get to that age, like 4, 5, 6, where they kind of wake up, they forget all that stuff. So it's that sometimes makes me wonder too, like are our souls like recycled and put in new bodies?
It just kind of makes me wonder about the dream realm. Like last night I had some like very vivid dreams, and like, what's that all about? Are we like in a different realm when we're dreaming, or are the kids dreaming and then they're talking about their dreams? And
So are you guys familiar with the GATE program or TAG? It started in like the 60s, I believe. It's the gifted program. Well, I was in the GATE program. Like I was in like regular classes, and then like in second grade, I went 3 weeks. On my fourth week, I did these tests, and then they put me in the third grade in this gifted class. And so I recently, like from the age of like 30, I'm 43 now. From the age of like 30 till about 2 years ago, it's like I didn't have any dreams. And about a year and a half ago or so, I started having this dream being in this like mall, and also in this bathroom that's like this huge long bathroom, but the stalls are only like 2 feet tall, and it's like dirty and the toilets are overflowing. Well, I end up seeing this video online where people are talking about this dream of being in a mall. So I start watching this video. I end up in the comments, and there's like not millions, like tens of thousands of people, Americans, that are having the same dream, and they were all in the GATE program. So then I start going down this rabbit hole. Like 85 or 90% of us all have the same hole on our left forearm. We did like these hearing tests that ultimately were like hypnosis. We had a pink drink that they would make us drink every morning. Our kids all have the same personalities. And like come to find out, the hearing test they would make us take was like a hypnosis thing. Like it plays all beeps while this guy starts talking. And like what they were ultimately looking for is the president signed this education thing. They were looking for kids that had like quote unquote psychic abilities. They used to have these cards called like Zener cards. They would lay them face down, and you had to guess what was on the next card. And it was like one of 5 shapes and one of 3 colors. And then they would like write down how accurate you were. But the CIA was trying to find, all of our parents were in the military. But the CIA was trying to find kids that could like astral project, because they wanted to make like spies where, where people could astral project into Iraq or something, right? And like see inside a building, whatever. Um, but it's this really weird rabbit hole. And it's and the same thing with all these other people. Like none of them had any. year and a half or so, and people are now starting to like document it, draw pictures, and also like from the time I was in the gifted program from the third, I have like no of like my childhood during that time. I can tell you stuff about being a toddler. I can remember like being at my grandma's house, being outside, and I can still picture that in my mind. But from like 7 or 8 till like 13 or 14, I have no memory. So there's obviously some kind of spiritual realm. There's all like another dimension, or I don't know what you want to call it, but something outside of this physical world. And it's obviously there because they were trying to tap into it. These kids, you know. And I don't know. It's a weird rabbit hole to go down. If you're bored one night on YouTube or Rumble or something, just look up Mall World or Dreaming of a Mall and start watching that, and then going through the comments. It was so weird to me, like especially the mole on my arm. I like had like almost like a panic attack as I'm reading all these people's comments and all the things we had. But what are these dreams? Like, is it another place that we're going to? Like,
I hope so.
It feels real. Like I can control what's going on inside this dream. Like I can choose to be in the dream.
I think that's sometimes called lucid dreaming.
Yeah, I think DMT's released like during REM sleep or lucid dreaming.
I've also heard that.
Like that.
It's just fucking weird, man. It like blew my mind.
I think this place is weirder than people like to let off. And you know how they're saying like, "Oh, flat Earth is holding us back from evolving" or whatever. I truly think it's the other way around. If we weren't stuck here trying to argue like, "Hey, dummy, you know the ocean's flat," like we could actually start to put some heads together and think about like, okay, where are we? What are we? What are we supposed to do? What are our dreams? Like,
It's distorted.
What?
yeah.
Let me ask you a question. Is it distorted or?
I don't get it. I'm a high level globe priest, and I don't think I would say that flat Earth is holding humanity back at all.
People do say that. People say that all the time.
They should. I mean, well, they're just wrong, I guess.
Oh, sorry, Glow Priest, my bad.
I mean, everybody that's a quote unquote flat earther was a glober. I mean, like.
No, actually, there's a guy that's been hanging out that is not. He never believed in the globe.
Like even as a child when he's taught in school.
Uh-huh.
One thing I found in common with flat earthers are a lot of them are sci-fi fans and still are sci-fi fans, like, you know, into like Star Wars or space movies.
It'd be weird to find a moon landing denier that wasn't a sci-fi fan.
You know, I think all it is like a lot of people they're told something. You know, you go to school, Christopher Columbus sailed the ocean blue in 1492, and that's just what it was. I think a lot of flat earthers are the people that are like, but why? You know, they're just like the people that are constantly questioning everything. They need more proof. They need more evidence.
Yes.
So I'm eating an ice cream sandwich at 4:00 in the morning. I'm gonna be at work in 2 hours, but we'll be all right.
Oops.
It's some sleep, dude.
I work in IT, and tomorrow I've got to install a server, just like physically install it in the rack, and that's it. So I'll probably lock myself in the server room and just take a nap. Be all right.
That sounds nice. I'd like to sleep in a server room.
It's just cold.
Probably some people sleeping in the server room right now.
Well, like you have that sound. You know, some people need like the sound fan or something to sleep. Well, like in the server room, you got like the AC running, and then the rack of all the equipment with the fans on it. So it's like this constant hum. I need a blanket though because it's like 65 degrees in there. But the rest of the factory, everybody's like sweating their ass off. I do think I'm gonna call it a night on Discord though and turn on a movie or something. Time to go, but I'll probably be back tomorrow, guys. I
Go to
appreciate
bed.
the conversation. I'm sure I'll
Hey,
run into you again.
you have a good night, guys. Well, yeah, put a W in the chat for Techno. Have a good night, dog. Get some sleep, man.
All right, y'all have a good one.
He stayed up way too late.
Yeah, I want to go into the dream realm instead of having an ice cream sandwich. I don't
That'd
believe
be
in sweets
awesome.
anyway. I don't believe in sweets, but
That would be awesome if the dream realm was real. Like if you could talk to other people in your dreams or something. You just have to both sleep at the same time and you can meet up in the dream realm.
yeah. I mean, I don't know. I have so many questions. Who's to say even what that realm is or what it's for?
I struggle to think of questions that I don't have answers for.
I feel like that's the majority of my questions I don't have answers. Those are the most important questions, I think, are the ones that don't have answers. Like, what is a meteor? What is a comet? Oh, what are dreams? What is this realm? Even though it's flat, what's that's not the end of it, you know, in terms of like being a truth or whatever. Knowing it's flat, that's not the end. I think it's a step, but you don't stop there. Okay, it's flat, we're done. Okay, it's flat, but like now what? So I would say the majority of my questions are the ones that don't have answers. I don't expect to like look to my neighbor and him have the answer, you know? They're like questions for the creator. Why did you do it like this? What was the purpose of this or that or whatever, you know? So I have lots of questions like that. Anyway, it was fun jumping on here and cooking for a little while. I appreciate you guys giving me the mic. Shout out to 20 Cups. Shout out to Tristan.
You.
Shout out to everybody in here, man. Shout out to the live stream. I think I'm gonna head out as well. Head into the dream room soon. And I'll catch you guys on the flat side.
Sleep tight, CB.
I appreciate you guys. All right, cool. Well, you guys have a good one. Keep the show rolling. Peace.
Welcome. to 24/7 flat Earth. Welcome to 24/7 flat Earth.
It sounded just like the dude. If you have any questions, please feel free to ask.
Yo, if you believe the Earth is flat, if I drive straight forward, will I fall off?
I don't know, do it.
Nah, I'm not gonna do that, but like
How
based
does
off your opinion, would
like
that be the presumption that happens?
it depends on how your car handles like the ocean.
Okay, what if I had okay, there are cars that can drive on water, but like they're like $1 zillion. I don't have that kind of money, but like okay, let's say I bought a boat, right? And the second my car can't go on land anymore, and then I went forward, 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 and then what happens? My boat falls off the earth?
Don't know.
And I'm not saying like the North Pole or South Pole because obviously you can't go past that because the military sanctioned it or whatever. I don't even know if there is any military out there like presently 24/7 just guarding it. You know, I don't really think there is. So, yeah.
It's cool. But yeah, nobody here is claiming to know, what the overall shape of this realm is.
Yeah, I
O-
mean,
Only that it's
I'm just
not a
talking about
sphere.
flat specifically. I mean, if it was an oval, triangle, I mean, obviously you can go all around it then that problem doesn't really happen.
They're just saying there's no curvature.
Yeah.
Measurably so.
Because if it was flat like a pancake, couldn't you fall off?
You flat like a pancake.
Yeah.
If you didn't go to the edge, I don't think that would be a problem, do you?
No, of course not, but like is it all surround like if you go to like the west, is there a west pole and a like this does the North Pole really cover the whole earth?
What?
You know what I'm
Look,
saying?
man.
Like instead of going up or down to the North or South Pole, is there a west pole? Or does it just loop around?
Well, there's actually 3 magnetic poles, like
Okay, but
just
that's not
according to the
is that like
magnetic
a giant
fields.
ice thing? Or
Is
no?
a magnetic pole a giant ice thing? No, I wouldn't say so.
Okay, so then you can go past it. There's no big ice wall, right?
Nobody here is claiming any of that. Only that the surface does not curve at the rate required to form a sphere.
So you could go a loop around the world if you wanted to.
Are you talking about east or west circumnavigation?
Yeah, like a circular around the world
Yeah, that's
from
no
east to
problem.
west.
Yeah, you can walk around your neighborhood, end up where you started, right?
Yep. Yeah. Right. Because I can go to Russia and then go all the way around back to Russia.
Yeah, there's no problem with that.
But you can't do north to south.
No, nobody ever has.
Is that like the hollow Earth theory? Because nobody's ever did north to south. Like there's a hollow hole in the middle or so. You know.
No, it's because it's not a sphere.
Well, if you're able to do the west to east thing, why is it not? How does that make it not?
You realize that east and west are circles, right? Even on a globe.
Yeah.
So, like I
So
said,
we can
you can
confirm
walk
that it's like
around
a
your
ring,
you can
like a
walk
ring.
around your house, right? You can set a center point at your house that say, "Hey, this is the magnetic center," and you can walk east or west around your house according to that pole is north, and end up right where you started, can't you?
No. What do you mean?
East and west are circles. Walking around in a
Yeah, like a
circle
ring,
and ending up where you
right?
started does not make the ground a sphere.
I don't understand how that would be possible. Wouldn't you walk right into like the west or the north?
Man, you need to
Or
look at a
not the
map, bro.
Yeah, man. Okay. North, you have this designated place, this magnetic north. Picture it as a pole. If you were 10 feet away from it and you had a rope tied to it, see, look, somebody posted something for you. And you will always have to keep altering. You can't go in a straight line if you want to maintain west. You can't go in a straight line if you want to maintain
Oh, there's no
east.
true west. Is that what you're saying?
No, it's that you have to update based
Mm-hmm.
on your position, based on north. You see?
The compass will always like loop around. Is that what you're saying
Right.
if you want to go
I'm
west?
saying east and west are circles.
Yeah. So like my circular globe understanding of that is that it would go around the circle, right? Like a ring. But you're saying if it was a flat disc, it would just go around the circle.
It's exactly the same
It'd be like
on a
the ring of a
globe
tree.
or on a globe or on a flat earth. It's exactly the same. East and west are still circles.
So the only way to test that would be to go straight north.
North and south circumnavigation, which has never been done. There's been a couple people that claimed it, but if you look at the actual path they took, they did not.
It wasn't like true north or something.
They just kind of went somewhere and turned around and came back.
Well, couldn't you do like halfway journeys, go to north and then go to south? Like fly there, fly back over there. I'm sure that's been done. You know, kind of like
I
the
have no
halfway
idea
point.
what you're trying to ask.
Okay, so right, you can do a full loop, but can you do half?
Can you think of any time that you could do a full circle around something but not do a half circle? Like, what are you asking?
Wouldn't that still prove that the Earth is a globe if you can do half circle?
Rodney, man, what are you smoking, bro? What are you talking
Nothing,
about?
dude. Do you understand
Yeah,
what I'm saying? How do I explain this to you?
No.
Like,
I don't get it
okay,
either.
so look at that picture in the side chat. Instead of going around, go straight up, right? But don't go all the way up and then come back.
Up?
Yeah, that compass.
Up as in lift the compass up off of the map? Is that what you mean by up?
Yeah, like flying. Yeah,
No,
like we have
bro. You
airplanes.
mean south. You mean south. You're
Can you
thinking,
translate this stuff for me, Tristan?
The South
yeah,
Pole, South Pole
yeah.
and North Pole. If you were to do half of each.
See, that still makes zero sense, dude.
No,
Half of each.
he's imagining flying from the equator over the South Pole and back to the equator, and that
Yeah.
being like the half of the flight.
Boogie already said
Uh,
that. He said circumnavigate the globe north to south.
yeah, no one's done that. I mean, that would only leave the part of the
Yeah.
trip left that would be easy, right? No, nobody's done that.
Yeah, bro. Yeah, there's fucking poles, man. You know, only if the ice were all. Oh, it'll all melt eventually. You know.
Okay. So, what's the main reason? What's the biggest reason that you think you live on the outside of a spinning ball?
Oh, like a globe? Yeah. I mean, curvature doesn't really change anything. I mean, I don't really have any valid evidence because, right? I'm just like theorying, making theories. That's all I do.
Yeah, that's all there is, man, when it
That's all
comes to
anyone can do,
curvature.
because nobody's actually,
No, we can go out and observe and measure things in real life, actually.
Yeah, but anyone can do that, right?
Yeah, but not find any curvature while they're doing it.
I mean, there's curvature and anything doesn't mean anything, right? Like I can go down a hill. That doesn't mean the earth is flat. You know what I'm
Do,
saying? That
are
doesn't prove
spheres,
anything.
do spheres have curvature? Do all spheres have curved surfaces?
Yeah.
Then if the earth is a sphere, we should be able to measure this curved surface, right?
I mean, shit. No, I don't think it's humanly possible unless we grow like a gazillion feet tall,
What are you talking about? You
Like you
believe in
wouldn't be able to
science?
see it, the distance. I know there's like some sort of camera that can see the distance of
You
the curvature.
you believe in like all the science and stuff, but you don't believe we have the ability to measure like the circumference of the Earth or anything?
No, no
For
person
the
without
curvature?
without technology, no.
Well, we have technology.
Yeah,
That's
the
the cool
camera.
thing.
That's what I was talking about. Yeah.
There's a lot more technology than that. So, how can we use this technology to maybe measure some curvature, measure some drop over distance?
Right.
How do we know how much there should be, and how do you think we could test for it?
Right. You can just like measure the what is it? The distance of like the photo using the camera, right? And then if it's like flat, and if it's like straight flat like over the ocean, you're like, "Oh, wait, so that means everything from there on is flat." Right? And then it's like, "Oh, that proves that the earth is flat," right? That's like the solution that you probably say, right?
I'd hope not.
Oh shit.
But
Well,
how
what do
about
you think?
how about we go to some water? Would you agree that water is, has got to be consistent? If you probably think water conforms to a sphere, right? All the oceans they must
Yeah.
curve to form a sphere, right? Because we're what
Yeah.
71%
That's why
water.
they use like the P8 camera and everything, right? Because it's a good reference. It's like basically the ruler of the world.
A PA camera.
P8 something. I don't know. There's a lot of flat earthers that talk about this certain camera because it's a good tool to use to measure, you know, because
I
Did
mean,
you
it's
yeah,
able to capture a distance farther than the human eye can see.
yeah.
did
Well,
you know the
yes, that's
camera that
part of
they
it.
use, but you couldn't conceptualize the northwest, east, and south thing?
What?
Like you've listened to enough flat Earth content that you know the camera they use, but you couldn't conceptualize the like south and east on a map.
To be fair, you got the camera wrong.
Okay.
No, 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 no. I mean, I did. I was just saying like the half circle theory, right? But like nobody's ever done it. We came to that conclusion, right? I thought somebody could have.
Yeah.
I thought somebody could have done
Well,
like a half journey.
hey, dude, you just started to say something that made sense, and I was really excited. Let's
Oh,
let's continue with that thought that you had
okay.
about seeing too far.
Yeah.
Seeing too far than the globe should allow, right?
Yeah, the Nikon. Yeah.
Yeah. So how far is too far? How do we know how far? What where would the curved surface of the earth start to block my vision? How can we tell?
I mean, if you see out far enough, it would start to like go down, right? But it with the Nikon, you just see it just keeps going forward, right? It's just like straight ocean,
Yeah. Yeah, I'll help you out a little bit. For
right?
for somebody that's 6 foot tall and we're at the edge of the water, we should only see about 3 miles.
Right.
So anything past that 3 miles should be physically obstructed by a big mound of water, right?
Yeah.
But we can see magnitudes of time way too far. And there's something even better than observations, and that's the laser transit tests. Lasers are a pretty good way to determine what's straight. That's why they're used in construction so much. And
True.
there's a ton of these laser transit tests. And over 10 miles of water, there should be 66 feet of drop. Over
Right, the
20 miles,
curve. Yeah.
yep. And
Yeah.
over
Well,
20 miles, there should be
I went to put my living room
266
and
feet of drop.
they fucking kicked me out. Imagine that.
I wonder
That's
why.
tough, man.
Shit. What room is this?
You're in the best
Flat
one.
Earth.
I hope this is like a Jewish or a Catholic or
Nope.
like a
No.
non-Muslim
Just
one.
science, I guess.
24/7 flat
Empiricism.
Earth.
Yeah, listen to the duck. He'll tell you.
Yeah, I see these camera videos. Yeah, so using these lasers in the camera, there's like every time they record it, there's like it's just straight.
Every time. So when this laser should be 266 feet up in the air, it
Yeah.
hits a target just 4 foot off the water. And it leaves the lake on the other side just 4 foot off the water. Now,
And they're pointing them north, right?
why would compass direction have to do for measuring convexity of the surface of the water?
Right, because you said if you do west to south. Wait, no.
Oh no.
No, north. No. West. No. West to east. It would just be a circle, right?
This is your team, Tristan.
I'm laughing really hard.
Bro, wouldn't it just be
Yeah.
a circle then if you do west to east?
Bro, you need to join the army and see if you can even get in. I'm pretty concerned.
Bro.
I don't know
Are
how
you
far
all,
you got
are
in
you all
that.
right, bro? Like, have you breathed in a while? You got any oxygen up in that
Bro,
brain?
you just posted that picture with the compass going around the pole, right? If you were to do
Yeah.
that with the laser, what would happen?
I'm sorry, I wasn't listening. I was laughing too hard. What was your question?
Bro. Bro, just listen, bro, please. Okay. You see that compass thing, the North Pole circumnavigation with the compass going around the pole? If you were to do that with a laser, right, it would be straight, right? It'd be the same thing if you do north to south, right?
Oh my god.
Compass going around the pole. Are you talking about the third picture in the chat?
Yes.
Okay, that's not a compass going around the pole. That is just telling you how to measure the curvature of the ball.
Oh. So you're saying that you could go around then, right?
No, the image is just telling you how to calculate what the drop should be. It has nothing to do with the direction, like north, south,
So if
east,
you
or
were
west.
to start going west, like forever, it would eventually tell you you're not going west anymore and that you're going some other direction, like to north or
Holy
south.
shit.
Unless you're turning, yes. Unless you are making circles. Now, this is if this is some new troll, man, I like it. Like, cause you sincerely sound lost, man. But you're all right.
Well, I never try to like imagine a flat Earth and do that. You know what I'm saying? I'm always imagining a circle. So
I
maybe
got you.
it's just like bad multitasking. I don't know.
Just you're good, man. Just calm down, man. Just slow your mind
Right.
down a little bit. You'll be all right.
Yeah, but anything about the lasers and shit, right? You said it'd be the same, right? If you're to do it west, right? Like it'd be
Well,
straight.
we were measuring the convexity of the top of water, so we weren't concerned with cardinal direction.
Yeah.
I have a question. Is there a study to show? I mean, I guess just over a long enough distance, but like to show that there is zero convexity, like in the middle of a huge. Yeah, no, never mind. Answer my
I
own
mean,
question.
yeah, wouldn't you say that water would have to be consistent, right?
Yeah, and you could always just put the laser super close to the bottom, to
Yep.
the ground.
Over a 20-mile lake, the laser should be pointing 266 feet in the air. It's like a 26-story building. That's how high the laser should be in the air. And we can't. And this isn't like, hey, one time we went and shot a laser across the lake, and this one time it hit the target at the same height it left at. No, this is what happens every time.
Yeah.
every time. And there's no laser transit tests that show anything close to the amount of drop or any drop really.
Has it been recorded that there's giant ice walls at the South Pole as well, not just the North Pole?
Nobody here is claiming anything about ice walls, and I've never heard anybody claim that anyone claimed there's giant ice walls in the north, so that would be a new one on me.
I mean, wouldn't that be a one way why we have never done that? Never went north to south around in a circle, right?
Or it's not possible because it's not a globe that connects in the way that you've been taught.
So you're saying if you were to fly straight north forever, you just fucking fly off the earth, right?
As soon as you went past the North Pole, you would no longer be going north, correct?
You'd be going to space? Where would you be going? Down? Where? What would happen? Gravity would still apply to you, right? Obviously. Hmm.
I just don't even know how to reply to you, man.
Well, because these are questions probably no one's ever asked. Who knows, man?
I guarantee that.
Right. So what would happen if you were to went off the North Pole? What would happen?
No one is claiming to know
No, like
the
as a theory. I know
perimeters
no one's ever done it,
of
but
this
what do
realm.
flat earthers think would happen?
I do not know. You're asking me to speculate. What would happen
Yes.
if you would go? What would happen if you went to the outer reaches of the universe and you kept going? What would happen?
Well, you just keep going, obviously.
To where?
Like an object in motion keeps in motion or something. It's like the laws of physics or something.
Well, it's complicated at the edges of the universe, but yeah, sorta.
Right. So if you were to go off the North Pole, you just keep going off the North Pole and keep flying into space eventually? Or like
If you were to go off the North Pole, you
yeah,
need to
go
break that
past
one
it.
down for us. If you went past the North Pole,
Yeah.
you would be headed south. Okay. And nobody knows
Hmm.
what is past a certain, you know, we're not even allowed to freely explore in Antarctica. Okay.
Well,
Not
I
only
know it's the
that, do you know
military,
how
right?
difficult it, even if there was nobody down there,
Yeah.
this is a tall order. There is no 7-Elevens. There is
No.
no place to refuel. It is way colder than it is in the north. And you have no idea where you would be headed. That's probably why there's a lot of people that haven't done it.
Wasn't didn't Amelia Earhart almost do it or something? Wasn't she supposed to be the one?
Do you get your information from Family Guy? Like that's what I
No.
picture when you ask these questions. I picture like these weird comedy skits like I can barely put together like what's going on.
Okay, but like people have attempted this before, obviously. I mean, this sounds like something that we should have done the second we started to invent planes and shit, right? It's kind of like map out the world and start fucking doing geography, right?
Yeah, believe it or not, people did that a little bit before planes were invented too.
Right, but it'd be a little hard to swim across the fucking ocean to go to the North Pole, right? I mean, boats
That's
are
probably
good and
yeah,
all,
the
but like
boats. There you go.
they're not very good when it comes to like flying over giant ice walls. You know what I'm
No,
saying?
boats are subpar in the air. I agree.
Yeah, the air, nothing can touch you. You know what I'm saying? So planes are better for
Yep.
geography.
Unless it's one of those boats off of Mario, which that might be real, right?
Yeah, really, you just turn it into a plane. Who cares, right? But anyways, right. But people have attempted this before, right? But they failed, obviously. Who knows when, right? Because they've run out of fuel, get hungry, get sick, whatever, right?
I mean, there are claims that people have traveled to Antarctica. I mean, people definitely have. There's people in Antarctica now. That's not.
But yeah, there's scientists there and shit. Yeah, we have. There's a bunch of different countries that have like stations there, of like just people there doing research and all that.
Yeah, sure.
Nobody owns it, but there's people there, of course. Yeah.
Yep. And
Yeah.
but no matter like See, if you want to like rebuke or rebut these laser transit tests, you're going to have to show drop over distance. You're going to have to show some kind of curvature. So, like stories about did people do this or did people do that or what are these lights in the sky doing or anything of the sort, none of
Lights
that
in the sky?
ha-
What do you mean?
has the ability to change the surface, right?
I don't know. Ability to change the surface. Yeah. You mean
Like
like
if somebody did claim to circumnavigate north to
yeah.
south, that wouldn't change these laser transit tests, would it?
I mean, no. No, it would not. I mean, I guess it'd still be
Yeah.
flat, but then you still went north to south, you know?
Who knows, All we know
I
is it's
just
not
don't
a
I
sphere.
don't understand how that would work on a flat surface though. I'm not gonna lie.
Who knows?
Yeah. Did you ever hear about like the Admiral Byrd thing? Like back during World War II? Didn't he supposedly do that?
Yeah, Admiral Byrd traveled to the Arctic and the Antarctic, and it
Yeah, but he
had
had some
nothing to do with.
crazy ass story. I mean, if you just kept it kind of straightforward, you know what I'm saying? It just would have been a regular story. Like, yeah, I traveled, you know?
He supposedly had some journals that people question.
Yeah, about like aliens and shit. Yeah, I don't know, man. But whatever. But like, apparently, he really was a pilot, and he really did go over near the Arctic. What he saw over there, did he just go around the Earth and come back and say a bunch of that shit just for attention, or did he actually just have a regular trip around the Earth? You know, like, who knows? Maybe like there's like some sort of like magnetic effect on his brain that like maybe like he was going under some sort of what is it, hallucination, right, while he was flying. You know, that could be an explanation.
Suppose.
Yeah. Because if no one's ever done it, maybe there's something stopping people from doing it from like something to do with our anatomy. I mean,
See,
that it affects us in a certain way.
I'm gonna tell you something, man. We live in very interesting times, and you can find a million explanations for everything.
Right, right, right.
Everything. So it might be important to start to learn how to distinguish explanations from evidence at one time, huh?
Let me tell you
Yeah.
about butt to boobs.
Get out of here.
But okay.
Say you confuse our friend, but I don't know if that's really a worry.
Nah.
I didn't mean
He's
to
good.
confuse. I just meant to be
You're good, bro.
silly. Butt to
It's alright.
I
boobs
know.
it was like
I,
an inside joke. It's a specific evolutionary hypothesis that's rather old.
Oh, okay. Yeah, wait. Did anyone ever dig down like far enough to see the bottom if it was a
Yes,
flat
let
Earth?
us tell you about the Kola super deep borehole.
tell us
8
all
Uh-oh.
about
miles
it, Tristan.
down, and the drill bits started getting soft, made of super hardened steel. They could not stand the pressure.
Uh-oh. What does that mean? There was like nothing under it?
It means it gets hot.
Yeah, like the Earth's core and stuff, the crust. I mean, yeah.
Well, on flat Earth,
Does a core work on a flat Earth or no? Or is it like a podium?
it's just question marks below 8 miles.
Question marks.
Nobody
So,
knows.
I mean, no, we know about the core, don't we?
You've been given an explanation, but do you have any evidence to
Of
support
the
it?
core?
Of
Yeah, the what he just
sure,
said,
yeah,
starts getting hot, right? The temperatures start rising.
yeah.
And the temperature
Right.
goes down when you go up. So what?
And hot things can only come from spheres?
I mean, yeah, right? If it was like in the center of it. But if it was on a podium, let's say on a flat Earth, and you start going down, and you hit like this lava and all this other heat up stuff, right? And then the core eventually, right? I mean, yeah, I mean you could have it on a flat Earth too, but then it'd be like a podium thing, right? There would have to be more than just like this flat disk of an Earth, right? It'd have to be more like a podium Earth.
One
Like
thinks
there's
the Earth is a
like a
disk.
mountain underneath of crust and core.
No one,
You
no
know?
one thinks the Earth is a disk. And when people first come across this, a big problem they have is they try to replace the ball Earth and the heliocentric model we're given with a little flat disk. Okay, that is not what's going on here. Nobody believes that. Okay,
Yeah, space is
that
fake.
yes,
Yeah.
space is fake. Earth is all that there is. This realm is all it is.
You
Okay,
don't believe in space, really?
No, not as
Oh
we're
man.
taught. Not as we're taught. It
Damn,
is
man. Then what the
not
hell are
not a
stars? I mean, what's
vacuum.
the shit you see then? What is that
Don't
stuff?
don't know. Looks like lights in the sky to me. That maintain
Right.
a eerily, strict cycle to them. You know, they haven't changed in a long, long time.
Yeah, I thought stars do change their trajectory when they explode or when they slightly move somewhere over here, over there, right? Or the planets, right? Like as Mercury, you can see it like once every so often. You can see that it changes where it can be seen, right?
Yeah, they move, but
Right.
as far as the constellations and their patterns that they make have remained unchanged for at least 5,000 years.
So the stars have not changed within 5,000 years, you're saying?
Correct.
Well, it's gonna take a second for them to update. Remember how things work when you look at something from far away? It hasn't like reached the Earth yet when we're looking at it from that far away.
How do you know they're far away?
Uh, I guess using telescopes, right? Technology tells you they're far away using like space lasers and shit, right?
No,
No. Well,
no.
because you don't believe in space. Then what are you lasering at when you laser upwards? Then, right?
The same lights, luminaries,
Or
planets
use
that you
sonar,
see.
right? Because sonar is way better for like sending out messages into space. If you send out like a sonar to like the closest star and it bounces back at you, wouldn't that tell you that that star is a physical object?
Do you think this is something that somebody has done?
Yeah. Don't they send out space signals into space and they bounce back, right?
Sort of, but not sonar, brother.
Or like to
Sonar
like
is
the moon,
No.
sound.
for example. I think they bounce things off the moon and then bounce
Yes,
back.
they claim to bounce things off the moon, but that was done well before anybody went there. Also
True, right? Because we
claimed
had
to
sonar
go
before we
there.
had rocket ships, right? Yeah.
But you just like interchange words for words, and it's really hard to like make out what you're trying to say.
Oh.
But we're trying,
Okay.
and Tristan, I mean, he helped translate a lot, but
Yeah,
yeah,
sonar. That's what I'm saying. That's what I'm talking about.
No.
I it's that's not what's going on. It's
Oh.
Right.
do you understand that well, Tristan? You want to tell him about how much of his signal is returned, and have you ever looked into that?
I do. Yeah, I do know a little bit about it, but like at
I gotta
least I
step away
know.
for a minute if you want to tell him about it. I appreciate it. I'll be right back.
Indeed. I would tell you at least that sonar is not what you're thinking of, hopefully, because sonar uses sound waves.
Yeah.
You can use sonar underwater, and it works by emitting like very high frequency sound waves that travel through the water and then bounce back to detectors on the vessel that's using the sonar, right?
Yeah, like dolphins when they use echolocation. Yeah.
Exactly. Yes. So do you understand what is happening when they're doing that?
They're bouncing things off to see what's in front of them,
Yeah, but
like
like
with the sound.
what's bouncing? What is sound?
Um, It's like stuff that comes out when you make a noise. It's like shit, man. I don't know if it's not physical, but
It is
um,
physical. It's a
sound
pressure
is
wave.
physical, really.
Yes,
How do you observe sound then?
it's a pressure wave in air. There's different ways you can observe it. You can observe it as the pressure gradient over time, and you'd recognize that as the waveform that gets outputted to your speaker, right?
You know, that makes sense because those sound pads in the room, right? It's bouncing off the sound pad because it's a physical thing, right?
Well, it bounces less off the sound pad. That's why the sound pad's able
It
to
muffles.
absorb. Exactly.
Oh,
Yeah. So sound, it's the air shaking. You can, like, to put it very simply, sound is the air shaking, or in sonar underwater,
right.
it's the water shaking. So how would that work in space?
Hmm. Right, because they use the giant satellite. They shoot a beam of sound, right?
Okay, so
Directed at the moon using
what
calculations and all that.
what's shaking?
What's shaking?
Yeah.
I guess the giant sound beam they're blasting? I don't know.
No, there's no air in space, so there's no sonar in space.
Oh, yeah, right. There's no sound in space when you're on the moon. These astronauts are on the moon. They don't hear nothing, right? Hmm?
Allegedly, right, in the globe model, but in flat Earth, no one's been to the moon, and
Well,
we
then
don't.
maybe they're not bouncing sound off these satellites. They're bouncing something else,
Yeah,
right? Like radiation or
they're
something, some crazy
definitely not
shit.
bouncing sound. That's right. They're bouncing electromagnetic radiation. And
That makes more sense.
like Boogie said, they've been doing that since before we landed on the moon. We've been able to bounce radio waves off of it. You can actually get a license and learn to do it yourself.
Yeah. Oh, couldn't you do that to like measure the Earth and see if there's any curvature? Can you technically do that? Use radio waves? Or no?
I think you could do a rudimentary triangulation by bouncing a radio wave off the moon to another station.
Yeah.
It may require coordinating clocks, but
Yeah.
I'm not sure. I am
It'd
not
be really
a
complicated, but I think it'd probably be possible, you know?
well, what I'm imagining is not complicated at all. But I am not a radio expert, so I don't know. But
Yeah.
all that would be doing is it would be measuring a triangle, right?
Triangle.
Yeah, you'd be bouncing it up to
That
the
wouldn't
moon.
prove anything. That wouldn't prove the Earth's a circular.
Not that single measurement. No, that's very good. It wouldn't because
You
it's
would have to
just
do a bunch of triangles now.
Mm.
Like in all different directions, like a bunch of triangles. Right?
You could try something like that. Yes.
Yeah. And then eventually you'd kind of map out like this giant sphere of something, right? It's either a flat disk. And I think it'd probably be easier to do that on a disk, right? Put a bunch of triangles on well, not a disk. Okay, let's say something different, right? Because not every flat earther believes in a disk, right? They believe in something more of like a oval, flat oval, maybe something. I don't know.
No, you have to zoom out your cosmology. There is no space. It's
Okay.
just it's just Earth. It's
Like a
just
podium, right?
no. There's no
And
podium.
what would it look like?
You go outside. That's what it looks like.
Right, right, right. But what is flat Earth? What is it? What is it? Has anyone ever created a model of it?
No.
No shite, really? Yeah. Then why is it
Not a,
called flat Earth, chat?
what do you mean?
Because majority of what they measured on those Pike Nikon cameras and lasers is flat. Like what?
Well, yeah, they shine a laser over a lake and it
Okay,
goes farther than it should geometrically.
right. So
And
from what they know, just using their tech is flat. But that doesn't
yes.
rule out everything else that they haven't done.
That rules out the Earth being a sphere with curvature.
Yeah, but there's stuff they haven't done with their laser, right? Like fully did their laser at the North Pole, all the way around to the South Pole, right? Because I don't think there are lasers powerful enough to do that. Maybe there are like military lasers, but no civilian can do that. It's bullshit.
Yes, there are a lot of things that haven't been done with lasers. That doesn't bring the Earth back to a sphere with curvature.
Right. Yeah, but you were saying, right, if I were to do like, oh wait, no, that's only with, okay, radiation waves, right, instead of the sound waves, right, because there's no sound in space, like all around, couldn't you technically like map out like a Earth and what it would look like? Because the duck guy was saying that. He said that you could technically do it, but it'd just be really kind of complicated.
Maybe portions of it, but yeah, you're asking for something that nobody's done.
I mean, shit. He said you can do it yourself. You can get a license for it. Like, how come no one here has done it? Apparently,
He was referring to bouncing something signals off of the
the
moon.
moon. Yeah.
Yeah.
Yeah. So you can make a triangle, and you just take. It's kind of like quadrants. You quadra these triangles geography around the whole Earth, and then eventually you'll get something. Using triangles.
Well, whatever we get, the surface of it will be horizontal, flat.
Well, no one's ever done it, right? I mean, why doesn't someone do it if it's something that a civilian can do?
Do you understand that water must be consistent?
And the way it so it has to be like perfect conditions for it.
Do you understand if you lived on a spherical ball that
Yeah.
was 71% water, that the water would uniformly curve around this sphere?
Yeah, it'd be flat, right?
What?
In real life, that's what I'm saying. Like using
Yes.
lasers. Yeah.
Yes.
Yeah.
The water must curve if it's a sphere. Nobody has ever found any water that does anything but lay flat.
Right. But only using lasers and cameras. No one's ever done it using radio waves.
Not that I'm aware of.
And this is something that anyone can do.
Yes.
Yeah, that's been done. There's world
Oh, it
records,
has
but
been done.
the globe side will just say that there was a duct present, and that's how it must have reached 800 miles.
Damn, so when they used the radio waves, was it flat or was it curved?
Well, the signal's reaching the target that's just above the level of the ocean.
Yeah.
700-800 kilometers away.
Sure. But what did it
If
come
you
out
type
as?
in LoRa, LORA, line of sight world record, it'll come up with a bunch of long distance radio wave tests. But yeah, they'll just say it's because there's an anomaly and there's a ducting situation, and that the signal's just bouncing through the duct, following the curvature of the Earth to perfectly make its way to the target. It's the similar
So if there
excuse they
was
give with the
curvature, it
laser
wouldn't.
tests. They'll say the same thing with the laser test. They'll just say, "Oh, the laser must have somehow been just the right amount of refraction where it bends around the curvature of the Earth to make it to the target every single time."
Like the freaking DVD thing hitting the edge of the TV screen. Like it just so happenly bounced there, right?
It just so happens that there's just the right refractive index that the laser hugs just above the curvature of the Earth, and it
Yeah.
will curve like 400 feet perfectly around to
Perfectly
hit the
bounced
center of
back.
the target. And then we'll do it again in different conditions, in a completely different location,
Right,
completely
because you're
different weather, and
bouncing off
it'll.
the moon, right?
No, we're talking about like the long distance laser transit tests where you
Oh no, I'm
set
not talking about lasers, dude. I'm talking about radio waves, like radioactive radio
yeah,
waves. Yeah.
yeah. I'm not sure about the radio waves moon thing.
Yeah,
We
so
don't want radioactive waves. No, those are bad waves.
yeah, so nobody has done that, but this is something you could do. Shit, man. Y'all should step on that shit. You know what I'm saying?
Yeah,
Start hitting
lots
them
of
lasers.
assumptions are going to have to be made when it comes to the moon, right? What
Right.
is it actually bouncing off of? What are you actually getting back? It gets super
So we can
sketchy, and there's
confirm the moon is a physical object, right?
you can't confirm anything about the moon. You can't go and check the moon. They didn't
How
go
come
to
it
the
bounces
moon.
off of it then?
Well, what's it actually bouncing off of? How have
Obviously
you
an object.
confirmed that it's bouncing? How have you confirmed that it's bouncing off the moon?
Using radio waves and it bounce back and you get the signal back. You can just bounce it straight, use those giant uh radio waves. You bounce them off from the giant radio thing and it bounced back
How
right
do you
back
know?
at
How
you.
do you know it bounced? Yeah, okay, all right. Have you looked into that? The accuracy of that, and what are they actually getting back in comparison to what they're sending, and that
Yeah.
kind of thing.
I
I
don't
mean,
know.
it sounds pretty technical, something that you would have to take a deep dive into. But this is the raw hard fact, right? If the Earth's a globe, then gravity would have to be pulling all of everything towards the center of mass, right? And that means the surface of the water would have to be curving at a specific rate. So
Right,
if you get
we have to
any,
map it out,
yeah,
right?
but if you get any 20-mile body of water, it would have to have around 266 feet of curvature over that 20 miles anywhere on the Earth. If it doesn't have that, if it doesn't have the curvature, then it can't be a globe. That would debunk how people claim gravity works on a globe, because you would
Right.
have to have that 266 feet of curvature. So let's say we go to a 20-mile lake, for example, and we set up a laser at 5 foot above the
Oh, dude,
surface of the
fuck
lake.
these lasers, dude. No, 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 no. Dude, come
We
on,
can
dude.
just use
Use the
our
radio shit.
eyes. No, you don't need to use radio shit, right?
I feel like, because I explained to these
Okay,
guys,
so
there's nothing you can do with
okay,
these
we
lasers.
don't hold on. The laser, we can see the laser beam traveling straight. We can take
Yes.
side views of these laser beams. We can see that they're
Yes.
not curving. So how's the laser beam hitting the target? And why can we zoom in across the lake and see the shoreline on the other side of the lake when it's 20
Yes,
miles
dude.
away and it should be hidden behind the horizon? Physically hidden behind the horizon by hundreds of feet. But we can see it, and we see flat water the whole way across the lake. And then we
Right, you'd
test
be
it
like,
again, and we
yeah.
test it again, and we test it again, and it's consistent that we can
It's
see
only
these huge
13 feet.
distances.
You said 20
Right.
How
miles.
can
It's only 13 feet. There's 8 inches of curvature per mile.
No, dude, it's 8 inches per mile squared. So over 20 miles is 266 feet of curvature. So basically,
You
if
would
there was
have to
like
see something, right? At that point, you would
yeah,
have to see some sort of dip, right?
yeah, 200. Yeah, so there would. Okay, so what are the byproducts of the curvature? A geometric horizon, right? A physical horizon. So if you set up a camera, right? Let's say we just set up a zoom camera. Don't worry about lasers.
Okay.
In fact, hold on a second. I'll pop an observation in the side chat. You can have a look at it. So this is a 21-mile lake. So
Is it the
over
Nikon
21
camera,
miles,
bro? Bro, don't even
it's
tell
a
me.
yeah. That's
Oh
the
my
best.
god, bro.
Do
Bro.
you, okay, so do you think the Nikon camera allows you to see through the physical curvature of the Earth?
Dude, there's people that
Dude,
debate this Nikon camera, be like, oh, but it,
there isn't a more powerful zoom camera than that you can get
right,
that
civilian
has active
technology,
zoom.
right.
Yeah, so
But then
you
you
can
use these
zoom in. You
military
can
cameras
zoom
and you
in,
get
bro.
different
Listen,
results, right?
no, they don't get different results. There's not a single long distance observations with any other type of camera where all of a sudden the curvature of the Earth appears. Right? You use a better camera. If there is a better camera than that you can use, you'll just get a clearer view of the shoreline on the other side of the lake. Cameras don't allow you to see through curvature. The Nikon isn't a magical camera that flattens out 266 foot of curvature over a 20-mile distance. It's just a camera. It's just a camera that has optical zoom of 125x. And you can't get a more powerful consumer grade zoom camera than that you can actively zoom in. Like, you can probably buy some giant lens, right? Some giant focal length lens and attach it to like a $10,000 camera, but it's still not going to have the same amount of zoom as the Nikon. In post production, you might be able to take some super high megapixel picture and then zoom in later and get a decent picture. But the Nikon, you can just actively just zoom in and see it in real time and record it.
Right.
But this is the thing, right? Like if the horizon on a globe, due to gravity and due to the size of the globe, the horizon would have to be at 2.7 miles if you set up your camera at 5 foot height. The physical geometric horizon, any water beyond that would be physically hidden behind the curvature of the Earth, physically. And it would have to be that case because of the way gravity works. Right? It's not like all of a sudden gravity is not there anymore. So just have a look at this observation. Okay, this is just some bits I took out of a video. So I can post the full video, but just have a look at my little presentation first. All right, so here's the camera set up. It's 5 foot above the surface of the water. Here's the location. So this is a good location for doing long distance observations because it's in Utah and it's a very dry atmosphere there. So you can see longer distances because there's not a ton of humidity in the air. It's cool temperatures as well.
Wait, so there's nothing beyond that, right? That lake?
Yeah, so this is the observation. So we're just going 21 miles across this where this yellow line is. Right, this is the distance markation tool on Google, and this is 21 miles distance.
Wait
Right,
a
so
minute.
on a globe.
No. That doesn't prove
What?
anything. Wait a minute.
Okay, all right. So how much curvature is there over 21 miles? I'll
Of
tell you.
course there'd be nothing for there, right?
It's 294 foot of curvature, drop over distance over 21 miles. Okay, so that means that if there was a 25-story building on the other side of the lake, right, like a 25-story skyrise building, you wouldn't be able to see it. It would be completely hidden behind the curvature of the Earth. Right, that's a huge building. Okay, if the Earth's a globe, that would have to physically be hidden in entirety behind the curvature of the Earth. Or if the Titanic, right? Let's say the Titanic, right? You know, the giant ship, that's like 175 foot tall.
Yeah, it'd be like a
And
hill.
it would,
Like, be like, oh, I can't see it. Yeah.
right. So
Now you're saying,
if the
yeah.
Titanic was parked next to the camera, docked next to the camera, and it started to sail across the lake, that once it gets beyond 2.7 miles, the bottom of it should start to disappear. By the time it gets to 10 miles, the bottom 50 feet or something like that would be gone. And by the time it gets to the other side of the lake, you wouldn't be able to see the Titanic at all. Right, now have a
How
look
did
at
you
this.
assume that's the amount of distance when a curvature would happen, though?
Because that's, okay, based on the radius value, right? So the radius is 3,959 miles. Okay, we know that water is level, and on a globe, gravity would pull everything towards the center of mass. So any large body of water anywhere on the globe over 21 miles would have around approximately 294 foot of curvature. Elevation would make a few points difference, like 294.6 feet or something. If it's at a higher elevation, for example, or a different latitude, it can change by a fraction, just a fraction. So approximately 294 foot of curvature over any 21-mile body of water has to be there, right? You can't have a single 20-mile body of water anywhere on the globe that doesn't have curvature. It would have to have 294 foot of curvature. Now,
Yeah. Okay, so anywhere, right? Like any lake,
anywhere,
any
yeah.
everything, right? Yeah.
Any lake, any body of water.
Even land, right?
Even a
That's not very
bathtub.
good for it.
Even a bathtub or a cup of water only
Land,
shares the
yeah.
radius of the Earth.
Yeah, if it was a
It's more
21-mile
difficult,
cup of
but
water.
sure.
A big cup. But have a look at
Right, because where
at
you
this
would be
picture.
standing right now, it looks flat, right? Am I wrong? Or
Yeah,
am
it
I
is
right?
flat. Yeah.
Right?
Yeah,
But
yeah.
if
So
you were
where
to
he's
look at it
standing,
from
so
like a really
let me
far
present it
away.
really quickly. Let me present it really quickly. Okay, so he's going to be standing behind this camera, and you can see in the next image below, he's going to be looking across where this yellow line goes, and the target is the image below that. That's the shoreline on the other side. So he's got a friend over on the other side taking some footage. In the video, you can see him panning around with the camera, just because we want to get a nice clear picture of the target, because when you're zooming over 21 miles, it's not going to be perfectly clear because you're looking through a shitload of fog and I mean not fog, just atmosphere essentially. Right. So anyway, take note of the shoreline. Take note of the big giant white building there, the smokestack in the background.
Yeah.
Now, Now he does the observation during the daytime, and then he waits again at nighttime, because when it's nighttime, there's a whole bunch of lights along this shoreline as well. So have a look at the zoom footage at the top there. 1 second, I'll be back.
Lasers.
Yeah, no lasers. Don't worry about lasers. So this is just what we can see with our eyes. That should be hidden behind the curvature. It's not super technical. It's just what
Right,
we
you're
can
just
see.
using like a telescope, Nikon, same bullshit, right?
Yeah, you could use anything, but this is a good camera for the job because it's got a record button on it and it's got 125x optical zoom. It's great for this type of task. So look, if you have a look at the zoom footage there, now I'll show you some better screenshots in a second, but if you have a look at the zoom footage, when he zooms across the lake, first thing we notice is we don't see any sign of that geometric horizon, right? The horizon should be at 2.73 miles. Now here's a line I drew at the 2.7 mile mark. So that's where the maximum distance is that you should be able to physically see the water on the globe. The rest of the water across the entire stretch of this 21-mile distance should be physically hidden behind the curvature. Physically hidden. It would have to be, right? It can't not be if the Earth's a globe. Now, when he zooms in, we don't see any sign of that horizon over the entire 21-mile distance. It's just flat. Okay, and 1 second. All right, so let's
Wasn't
just
that
have a
just
look
like
at
a
some
flat body
comparison.
of water? I mean, if you were to look at it
You
with
can,
your eyes without even zooming on it, it'd look flat to you, right?
yeah, of course. Oh, yeah, water is flat on the surface. I mean, to the point where, like, look at this. This is a cool image. When there's no waves, no wind at all at this lake, this is what it looks like. It's like a perfect mirror reflection, and it's called a specular reflection, and we can actually see a perfect reflection of the mountain or the sky basically off the water.
Right.
But anyway, so that would, you would have to be claiming that, oh really, that's curving 294 foot over the 21-mile distance, and this shoreline that you can see here should be this shoreline should be hidden because the camera height's 5 foot, right? So when we take the camera height into account, that means the shoreline on the other side should be 223 foot obstructed. So basically, if you draw a tangent line from the camera to the surface of the Earth, the tangent would meet at the surface of the water at 2.73 miles. And if you continue that tangent line straight, by the time it gets to the other end, the distance from that tangent line down to the surface of the Earth would be 223 feet. And that's how much the shoreline should be down, right? It's called a hidden height. So here's a screenshot from an Earth curvature calculator just to show you. Right, so you can just go to Google if you want to check any of these and just type in Earth curvature calculator and it will just calculate. So the first thing
Yeah, that'll tell you when it's supposed to hide shit, right?
Yeah, so you put in 5 foot observer height and then your target distance 21 miles and then hit calculate and it says the distance to the horizon is 2.73 miles and the target hidden height is 223 feet.
Yeah.
All right, so I'll just put some side-by-side images. So this is the close-up and then this is from 21 miles away, this next one. So first thing we can notice is that we can see the shoreline. We can also see the entirety of the White Tower.
Right, you're not supposed to see it, technically, right?
No, well, yeah, exactly. So you should just see a water horizon. So you should see where the horizon is, where the water and the sky appear to meet. And then you should see if there's big things beyond that, you should see them sticking out from behind the horizon.
Right, because you should be so dipped down on the curve that you wouldn't be able to see it, right?
Right, you would only be able to see the top of the tower,
Yeah.
right? The top portion of the tower and the mountains, right? Okay, so he did it again at nighttime. So he did it again at nighttime here. It's even clearer at nighttime, and it's good because there's a whole bunch of lights at the bottom of the tower. So at nighttime, once again, we can not only can we see the whole of the tower, we can see the shoreline, and we can even see the lights reflecting off the water. And if you have a look into how the law of reflection works, you have to have a line of sight to the reflection for the angle for that light to be able to bounce off the water and get back to the observer. So that light that's bouncing off the water, right, that should be hidden behind the curvature of the Earth by a huge amount. That should be sort of bouncing off something that's angled
It's
away
hitting
from
the
you.
shoreline.
Yeah, it looks like it's actually bouncing off these. If you have a look at this close-up picture again, there's like little streams or puddles of water because it's like a big giant shoreline, and you can see those puddles of water on the shoreline. Or maybe it's just reflecting off the lake water. But anyway, it's reflecting off some water. You shouldn't be able to see the reflection. And look, here's an even closer picture of the. So this is the same. This is just a cropped version of the one above. So have a look at the bank. We can see where there's like a black line where the bank is. And then you can see the bottom of the tower and that kind of thing. So here is from the zoom footage, from the nighttime footage, because it's the clearest one. So we can see the bottom of the tower. We can see the lights under it, and then we can see the bank, and then we can see the shoreline below the bank. So this should all be hidden behind the curvature of the Earth.
Okay.
And then after they do this, I know you didn't want it as interested in the laser tests, but
Yeah.
it's like an icing on the cake, right? So they shoot a very high powered laser from 5 foot height. You can see a
And it
picture of
hits
it
the tower.
transiting here. It doesn't hit the tower. So he's got his friend on the other shoreline. So his friend's got a camera set up. So you want to try to shoot the centroid of the laser beam into the sensor of the camera. And then they get a direct hit. So this is a picture of that same laser from the
What
other
is he
side of
hitting?
the
The
lake.
shoreline? What is he hitting?
No, it's hitting the sensor of the camera. And that on the underneath there, that's actually the reflection of the laser on the water.
How would he set the laser up in such a way that it hit the camera if the water's bouncing and he's on a boat? I mean, the boat would have to be so still, and
No, there's
the
no
boat never
boat.
sits still.
There's
What
no
is he
boat.
on? The other
Just on
side of
the
the.
bank. Yeah, on the
Oh, he's on
bank.
the other side of the bank.
Yeah.
I was like, he just set
Yeah.
up
So
like a
that
tripod and has it sitting there.
Yeah. So he's got a camera set up on a tripod. And then at the other side of the lake, he's got the laser beam set up on a tripod, 5 foot, both 5 foot above the surface. And then he's just angling the laser until it hits the camera, and then they
I'm
get a
sorry,
direct
how
hit.
wide is the lake again? I'm sorry.
Sorry,
I just got
Brandon. It's
in,
21. It's 21 miles, Brandon.
Okay.
A quick question.
I'm sorry,
So
I
the
just got
camera,
in, so
the
You're right,
camera
man.
is on. The camera's on Antelope Island, looking towards Salt Lake City.
Yeah, here is a so you can jump on Google Earth if you need to.
Yeah.
So I did that. And here's a picture. So that's basically where the camera's set up. It's
Okay.
actually the legs are just sitting in the surface of the water. But yeah, it's across that line of sight there that you
So
can
that's where
see.
that guy was standing on that dot.
Yeah, so if you look at the full video, you show him like arriving and setting up the camera, and he pans around. He shows you all around the area, so you can see exactly where he's standing, and then you can have a look on Google Earth and see that that's a match. And he shows you his coordinates at the time on his phone, showing the like the map coordinates. I think I've got a screenshot of the exact coordinates as well. Oh yeah, here it is. So you can put in the exact coordinates. That's what I did. That's how I found the exact location on Google Maps. Just put in these coordinates that are written here. And then in the video, he shows you the coordinates of the observer on the other side as well.
Yeah, the other dude. Yeah.
The other dude, yeah. And here's like another one with the color adjusted a little bit, just so you can see it's brightened.
That much is supposed to be hidden.
So the shoreline should be 223 feet hidden height, and
Yeah.
if you do the math on the tower, I think it's about I forget what it is in feet, but I think it's about the bottom 50 meters or something of the tower should be hidden.
All right.
And his camera was ground level, or was it like up high? Or
It's 5 foot height, 5 foot observer height. Here's the picture of the camera setup again. So we're taking into account the height of the camera. So the height of the observer determines the distance that the horizon should be away. So with the 5 foot observer height, the horizon should be 2.73 miles away. So any water beyond that should be physically blocked behind the curvature. So this is essentially a horizon test, because that's one of the easiest things to test for, because on a globe you would have to have that geometric horizon, and then things that are beyond that horizon should be obstructed by a certain amount.
How tall is the tower?
It's huge. It's like 1,200 feet, I think. I've got the math on the tower, and so it's basically the shoreline that was supposed to, it's just a shoreline to shoreline observation. The tower just happened to be in the background. It's a good like landmark to look at. But I do have information about how much the tower should be hidden and all that kind of thing.
Do we know
All right.
the
So
elevation of the base of that
Mhm.
tower above
Sure.
the
Yeah,
salt flat itself?
I've been
Because
over
I'm
all of this. So,
okay.
all right. So the tower is 44 meters above the lake's surface elevation, and at this distance, the geometric horizon. 1 second. So the tower should be partially obstructed by the curvature of the Earth. The hidden height should be 67 meters. This means that about 23 meters, roughly 77 feet of the tower's base should be missing from view, with only the upper portion of the structure extending above the horizon, and which the horizon should be water, obviously, because it should be at, 2 to 3 miles. The visible portion of the tower. Yeah. So the horizon should be 2.73 miles, and then you should see basically the tower coming up from behind the horizon, and the bottom 77 feet should be missing, which is quite a bit. 77 feet. It's like a 7-8 story building. If you picture a 7-8 story building in your head. But not only do we see the base of the tower, we can see everything that's below the tower down to the shoreline leading into the water. Here's a couple more images, just of like a close up of the area that's leading up to the tower. You can see it's not super high above the lake. So here's a closer image, just from the internet. And here's like a side view. So that shoreline should be 223 foot obstructed. And I'll just post the full video if anyone wants to watch the full video.
Did you ever? I know you didn't say anything about that, but did you ever try to do a test with radio waves before?
I haven't personally done one with radio waves. I've done similar tests like this one myself on Lake
Yeah,
Macquarie in
but
Australia. But
I don't remember what the counterpoints to these
radio
are
waves. See, if when
exactly.
you're talking about doing tests over much longer distances,
Yeah.
you know, there can be all sorts of different things that you would need to take into account, right? Like
Right. It's more
the
complicated.
weather.
Right.
Yeah, way more variables to to try to account for. When it comes to a 10 or 20-mile long distance observation, we have much less to deal with. We can actually
Easy
see what we're
peasy.
looking at.
Yeah.
Yeah, so
Anyone can get a
that's why.
camera, anyone can get a laser. You know what I'm saying? Like this is the easy peasy stuff. Why there's like so many
Yeah,
debates on like the Nikon. I don't remember them exactly, but from what you said, I mean it makes sense, right? But I think there's
yeah.
counter arguments of like the camera's bullshit. You know, there's like a zillion different things that people say that
Well,
what you're saying is bullshit. You know?
we can say the camera. Yeah, so that would just kind of be a cop out argument from if they were to say the camera's
Right.
bullshit, because that would make the camera some sort of magical camera that can see through a hill of water,
Right.
and flatten the water out somehow. So it's a pretty cool camera if it can do that. It works for flat earthers, I guess. But if we shoot a signal with a like a radio wave signal and we hit a target that's say 800 kilometers away, the globe side can easily just say, oh, it's just must have gone through a duct. There must have been a tropospheric duct, and that's the reason that it hit it. And because it's very difficult to accurately take measurements of the refractive index vertically the whole way along an 800-kilometer stretch over the ocean or something like that. It's very difficult for either side to get to to know exactly what was going on with the
But I mean, that's
atmosphere along
something a
that.
flat Earth like. I know there's like committees and shit. Like that's something flat earthers should work on. You know what I'm saying? Like getting longer distances, not just playing around with cameras and lasers, man. I mean, you can map out the whole Earth with it, but it would take forever. You know?
Right. So yeah, exactly. I mean, we all experience the Earth as flat in the first place. Even if you think it's a globe, they tell us that, oh, because we're so small and the globe's so big, that you just experience it as flat. So that's kind of like the starting point or the baseline. Now we get taught while we're growing up that actually, although it seems flat and feels stationary, really it's curving and it's flying through space at millions of miles per hour in all these different directions, blah, blah, blah. Okay, but we don't experience any of that. So I think that if someone wanted to make a claim that goes against our direct experience in reality, then the burden would be on them to have evidence to back that claim up. We can't just have a story based on some mathematics and say, oh yeah, well you experience it as flat, but really there's 266 feet of curvature over that flat looking lake. It's like, oh, really? It looks flat and I can zoom in and see the shoreline. It's like, but you claim that it's curving and that really that shoreline that I can see is hidden behind the curvature of the earth, but I can see it. Do you have any evidence for that? And when we dig into the evidence from the globe side, we get extremely disappointed because quite often people will see these observations. They'll be like, oh, that's interesting. Maybe I'll go do some tests myself. And then after doing all of this investigation, you'll be like, well, hold on a second. Surely with all of the governments and all of these, years of research and claiming that it's a globe, surely thousands of people or hundreds of people, or at least a bunch of people have gone out and actually physically done some empirical measurements of the curvature of the earth. And that's when you'll start to get disappointed once you start looking into that, because that's when you're not going to find that empirical evidence. You're going to find calculation, right? You're going to find faith-based evidence, calculations based off assumptions.
Right.
And you're going to, if you type in who measured the curvature of the earth, it's going to come up with some ancient Greek guy that we can't even prove existed. And he wasn't even trying to prove if the earth was a globe. I don't know if you've heard of Eratosthenes, But if anyone, like every day we hear about Eratosthenes because people type into Google, oh, who measured the curvature of the Earth? And it's every single time Eratosthenes, Eratosthenes. This
Eratosthenes.
Eratosthenes. Yeah, Eratosthenes. It's like some Greek guy that lived hundreds of years before Jesus, apparently, and he basically he pre-assumed that the Earth's a globe. Apparently, right? There's no evidence that he ever did this test. It's just a story, but people think
If
it's
he
true.
existed.
If he existed, exactly. Yeah. And so what he did was he pre-assumed that the Earth was a globe, and he wanted to check how big it was. So what he apparently did was there was one location where he was at, and there was a well. And he noticed that when the sun is directly above him at midday, there's no shadow inside the well. Now, apparently he had some other guy, don't know what his name was, 500 miles away at a different place, and he had a stick. Okay, and at midday, somehow they communicated with each other. I'm not sure how this happened, but anyway.
Using messengers to go back and forth between them, like on a
Yeah, it's
camel.
like a can, like they had like a can with a really long string.
I mean, technically, would that work? I guess maybe, right? Wouldn't that work?
I don't know about
those
500
work, right?
mile string, 500
Yeah.
mile string
Sound
can.
can travel like that, right?
Yeah, that's pretty cool if it does. But anyway, right? So there's this other guy. So at the same time, this other guy apparently had a shadow, right? So the stick was casting a shadow, but at point A, there was no shadow. So he's like, all right, so there's a 7.2 degree shadow at this other location. And if we assume that the Earth is a sphere, we can calculate based on that shadow angle the circumference of the Earth. But he also had to make another big assumption. He had to assume that the rays from the sun are coming in perfectly parallel. So he assumed that the sun is such a far distance away that all of the sun rays would just come in perfectly parallel. So first thing he assumed was that the Earth's a globe. Second thing he assumed was that the lights are coming in parallel. And then he also had to somehow get the distance correct. Don't know how they did that. But anyway, he did some math based off that spherical assumption, and he was able to calculate that the circumference of the Earth is 40,000 kilometers, which is close to what they say it is now. And everything basically regarding that number traces back to Eratosthenes. Try to find someone else who's measured it beyond Eratosthenes, you're gonna run into similar situations where there's a bunch of assumptions being made, a bunch of guesswork, and just calculations based off these pre-assumptions. So it's not like empirical measurement. He wasn't trying to measure the curvature of the Earth. He wasn't trying to test if it's flat or a globe. He was just pre-assuming it's a globe and then doing math based off those pre-assumptions. And it's a very flawed test, right? So basically, I could set up the same test inside my house in a room, right, with two sticks and a light source on the roof, and I could calculate the circumference of my flat floor if I assumed that I'm standing on a spherical surface and that the light rays from the light on my ceiling are coming in parallel, and I did the exact same method as Eratosthenes, I could just calculate, and then I would be like, oh, I'm standing on a 2-mile globe or whatever, right? And even though my floor is measurably flat, observably flat, obviously flat, I could calculate the circumference of it just based off making some erroneous assumptions. So it's not good. Like, it's not a test that's conclusive either way, because the Chinese were flat earthers up until the 1700s. The Chinese did a similar test, and they came to the conclusion that the Earth is flat, but they made a different set of presuppositions. They pre-assumed that the Earth is flat instead of being curved, and they pre-assumed that the lights from the sun are divergent, right? Like, if you have a light source, the rays come out in all directions, not just parallel to the Earth. So they came to the conclusion that the Earth was flat. But both methods are flawed. So
right.
Most of the evidence for the globe is kind of like things that you can't test yourself, things that require you to just trust and have faith, right? Like pictures from the Apollo landings, for example, or that kind of thing. Pictures from space is most people's best globe proof is pictures from space. And I don't even need to say, oh, they're fake or anything like that. We can just say,
Yeah.
okay, you can't confirm those. You have to have a certain element of trust that you're being given correct information. And if they wanted to deceive you, it wouldn't be difficult, right? Like I could show you pictures from the Artemis mission just recently, and then pictures that we made in Photoshop or in CGI or AI of the Earth, and you wouldn't be able to tell me which of the photos are from Artemis and which of the photos are from the CGI, because it's not possible to tell the difference. They look exactly the same.
Well,
So
not
if they
nowadays.
wanted to,
You know, like
yeah, yeah,
did they have the AI that we have nowadays back in like the late uh 70s? You know, like around Kennedy's time. You know what
no,
I'm saying?
they didn't.
Of course
They
not.
didn't. And the footage that they showed us back then was terrible. I'll show you a couple of clips of it. But this
Right,
is the
the
thing.
Kubrick footage or
People,
whatever. People say it's Kubrick, the guy who made The Shining, did it, or you know.
yeah, maybe that's a
Right.
speculation.
Right.
But the pictures of the globe from space. Now, people for a long time have been able to paint um hyper realistic pictures to the point where I could show you pictures, paintings of people, and you wouldn't be able to tell if it's a painting or if it's a photograph.
Right.
Now my wife has a master's degree. She specializes in that super accurate type of painting and that kind of thing. And I showed her a picture of the 1972 blue marble, which is the globe from space from the Apollo mission. And I said, would it be possible to paint this and make it look realistic, and then put it in a studio with a dark lit background and take a photo of it? And she's like, "Oh yeah, that's easy. That's nothing." And then she showed me all of these crazy
That's a type of
paintings
art
people do.
format. That is a thing that people do. That make realistic art, like of an apple. You can do that with anything.
Yeah,
You can paint anything and make it look realistic. There's an art form of that. I don't know what it's called, but that's a certain type of art that people do.
yeah. I forget the name of it. It's like a
Yeah.
hyperrealism
Yeah,
painting style or
hyperrealism. That's
something.
probably the name of it. Yeah, hyperrealism art. Yeah.
Y-
There you go.
Yeah.
Pretty broad
Yeah,
term.
there's some really cool stuff, but so yeah, look, so they could easily fake this stuff.
Right.
But the footage, the actual footage of when the lunar module's orbiting around the moon and stuff like that, I mean, I find most people haven't seen it. Um, but I'll show you just two clips really quickly. I'll put them in the side chat. And most often when I show people these clips, they don't even believe that these are actual NASA clips. Usually people laugh and they're like, "No way is that from NASA." Because it's kind of laughable. It kind of looks like you be the judge anyway. So this clip, this is from Apollo 16, and this is supposed to be after the astronauts. Right, so this is the lunar module docking with the orbiter, or something like that. I forget exactly, but this is from Apollo 16. It's the lunar module docking. So to me, this kind of looks like something done in a studio with models and miniatures, and they were basically obsessed with making models of everything to do with the moon landings. They had models and replicas of everything back then. They would make up
Shit, I mean, knowing
giant.
old cameras, maybe this is real. I honestly think this looks real to me. Like when I think of like the
You
60s
think
or the
that looks real?
70s, yeah. When I think, not using modern cameras, of course. They didn't go up there with their fucking iPhones and shit. You know. Let's see. Yeah,
Yeah,
yeah. Using the
I,
cameras they had during that time, yeah, that does look real.
you
Everything looked
reckon
really
the
foamy.
movement, right? The sparkles coming out as it's taking off, the different colored sparkles. There's no like jet or anything like that on the bottom of the
Yeah.
lander. It's just kind of looks like a little thing in a studio, and it's being pulled up by a string or something. I'm not sure. And this next one, I mean, just the movement,
Propulsion.
how it's able to move and then stop, and then move and then stop. Like it's meant to be in a vacuum. How's it doing this? Surely they'll have some kind of explanation for how it's doing it.
I mean, I'm sure there's technologies they never talked about with
No.
these things. To not encourage Russia to make these things or China. You know what I'm saying? There's a lot of national security when it comes into these type of things. You know. And I'm
Right.
sure on the public side, they're like, okay, well, this is a rocket ship and this is how it works, and we're gonna tell you what the Chinese and the Russians already know, and everything else in these videos that you might not be able to explain are obviously things that we don't want to tell anyone. You know what I'm saying? Because this was the Cold War during that era. You know.
Yeah, so I mean, I think that that NASA faked all of this footage to win the space race.
Really.
I think they committed, right? They told the public that we're going back to the moon, and then I think they realized that they couldn't do it, and then they decided to fake the footage. But it doesn't really matter. At the end of the day, that doesn't prove if the Earth's flat or a globe or anything like that. That just means that they are or are not lying about what they did when they went to space. And I think that most people that work at NASA, right, they're not trying to cover up flat Earth or anything like that. Most people that work at NASA genuinely probably believe that NASA is doing all of the things that they say they're doing. So I don't think there's a big grand deception that NASA's trying to cover up flat Earth, although I don't know for sure. But that's why I like to stick with things that we can actually validate here on the Earth, so we don't have to rely on assumptions and faith and trust and conspiracies. We can just test the surface, and it's been tested hundreds, if not thousands
Right.
of times now. And every time that we test it, we're not finding the curvature that should be there if it's a globe.
Yeah, I know, but I don't know. I just don't personally. I don't find the Nikon thing very good. Like I've heard like compelling arguments. I've had someone convince me it's something to do with refraction or something, or there's a billion people
Right.
who will
So
say
so
billion
that
things
would
against you.
Just
Who sound
to
smarter than you. You know what I'm saying?
just
so just quickly,
something about the
just a second, Drudic, just before you jump in, I'll be done in a second. So look, that's the
Yeah.
only rebuttal to these is saying that the light is bending in such a way that it makes the Earth appear completely flat in all of these
Not
observations.
entirely.
So you would, yeah, zero detection of any curvature. Now,
So I found a problem with this one.
yeah.
So I'm
Hold on
looking
a
at this.
second. I'll be done in
Okay.
a second. Right. So
All
I'd
right.
love to go over your problem in a second. Okay. So look. So you need to take a deep dive into the refraction topic. I've done that. I've read countless papers on it, and I've studied it in depth. Now, once you learn how refraction works, what are the limitations of it, and what happens visually when we have heavy refraction, right? Heavy refraction essentially is heavy destruction optically of what you're looking at. We're going to start seeing superior miraging effects. We're going to start seeing fata morganas. We're going to see inverted images. We're going to see chaos visually, optically. That's what happens when we have very heavy refraction. When we have mild refraction, they call it standard refraction, and that's about 15%. It's a refraction coefficient of 0.13, which is basically what they do is they increase or decrease the radius of the globe. So standard refraction would increase the radius by about 15%. So that means that instead of the horizon being at 2.73 miles for that 21-mile observation, it would be around 3 miles or something like that. Okay, but we're not seeing the horizon over the entire 21-mile lake. So if you actually reverse engineer the math to work out how much refraction would be needed to see what we're seeing on a globe, you'll find out that it's an unrealistic amount of refraction. It would be refraction coefficient of 0.99, which is basically so much refraction that the Earth would appear completely flat. But nobody's going out measuring these levels of refraction with accompanying non-distorted visuals, if you know what I mean. Once you might be able to measure very high levels of refraction, but you're going to have high levels of destruction, miraging,
Yeah.
and that kind of thing. And
And
obviously, we wouldn't use that. But
yeah.
you respond to what I said quickly, but I want to let Drudic.
Oh, go ahead. Let that
answer.
guy go, and then we'll rotate. Go ahead, man.
So, yeah, so initially when I was looking at these screenshots you posted, I thought I was looking at the base of this smokestack from roughly the same angle, right, or heading as the picture below it, like the one you have circled in blue here. That looks like the base of the tower with the smokestack. that little pipe coming out, but it's actually not, because if you go on maps and you measure the distance from that exact location, just northwest of White Rock Bay, and you look down, you can actually see that there is basically this hill that they've dug out of the side here, that has, I guess, contains this industrial facility that's like to the northeast of the tower. And if you look at the I-80, if you look at Street View on the I-80 near the Great Lake or Great Salt Lake State Park, you can see directly into the complex, right? But from the
You can
position that
see
this was
here's
shot,
screenshots I didn't post before. Just have a look in this side chat. So this is what you
sure,
can see.
yes, you can't, that particular, that last picture, you can't see that from the position of that camera, right, on Antelope Island, because the base of the tower would be physically obstructed by that black mound to the left. So you actually have to go north on the I-80 to find the exact position where that LOS, that line of sight, would intersect with Antelope Island. So I actually looked
Well,
up the
look,
base of the tower
well,
above sea level. It's
okay,
only
all right.
29
Look. Here's a
but
picture from the line of sight, though.
let me
This is a
finish.
picture from the shoreline, bro.
Let me finish. Like,
What you're saying is not correct.
it is correct. So
Well, here's a picture from the line of sight, and you can see the base of the tower. This is from the
okay,
shoreline.
that's not the same angle. That's impossible, because the hill, that black hill to the left, should be obstructing the view of the base of that tower from the position that this camera
What
is
hill?
supposedly located. That
What
black
hill?
hill to the left in this picture that you posted, right, of Street
No,
View.
it shouldn't. It shouldn't be
Yes, it
blocking
is.
it, and it's
Yes, it
clearly
is.
not blocking it. It's clearly you don't even see the hill in
So
the
in the
footage.
picture, so in the
Yeah, where's
picture,
the
the last
hill?
picture, that is not the same angle. That's not the same angle.
What?
That isn't the same angle. All you have to do is go look at Google Maps.
You can see it right
right?
here. You can see
Draw
that
your
there's no hill.
Draw your own line. Use measure distance tool. Draw your own line from that
Yeah, I
position
did.
on Antelope Island, and what you will see is it intersects with this black. I mean, it's basically like, it looks like a cliff. If you drop Street View, it's got to be. It's tall. It's really, really high. So
Dude, you
I can see these
see in the
lights in
footage.
the nighttime footage. I can see these lights in the nighttime
Yeah.
footage. That's the top of that black hill. Those are the lights on the buildings, right, that are at an elevated position up on this.
Sorry, where's the black hill here in the blue circle? Where's the black hill in the blue circle?
I'm saying the lights that you see are on top of that hill. That's what I'm saying. That is
On
not the
top of
base
the
of the
hill?
tower. The base of the tower is below
It's
that.
just everywhere.
It's below
Fan
that.
the
It's
sky.
physically obstructed. It's physically obstructed by that
Oh my god.
geographic. It is. It
Look
is.
at his.
Like,
Look at
draw
him
the
zooming
line.
in. Look at him zooming in real time.
I don't have the ability
He's
to post
everywhere, ban the
screenshots in the chat, or I would. I put them in.
Bro, look at him zooming in
put a
real time in the
screenshot.
chat right there.
Yep, it's a totally different
yeah.
angle than these
Yeah, that's
pictures
what
you can
I
see him
understand.
shown that were taken
No,
on
look
the
at him zooming
on the
in real
southern side of the
time.
lake. I understand
Look in
that.
the video, you can see him zooming in real time. There isn't a hill there.
I understand that. I'm saying you can't see it because it's obstructed. If the Earth is in fact curved, you cannot see it because it's obstructed, but you can't see the base of the tower either. You think that you're looking at the base of the tower, but you are not. So, and if somebody has the ability, if someone has the ability to post screenshots, they can pull it up and maps.
You can
use
see
the
what's
measure
below the
distance tool
tower.
to show me exactly what I'm saying. Right. I
Right.
can't
So
do that. I'm
what
not able to post.
what should the bottom 77 feet of the tower be obstructed by?
The bottom 77 feet.
Yeah, the bottom 77 feet.
I thought it was more than that. Let's look at our
No,
calculator.
the tower's at 44 meters elevation above the surface of the lake.
The base of the
so
tower.
That means the base of the tower.
Yeah, and you see how the hill is higher than that. in Google Maps. Like you
Yeah,
can see
so
how
so
it's
the
sitting
bottom
up,
77 feet
right?
should be obstructed by the horizon. The horizon should be at 2.73 miles.
Right. And I'm saying you can't even see halfway up that hill. And we already know it's at an elevated position
You
above
can
the
see
surface of
all
the
of the
lake.
land. You can see all of the land that's below the tower. You can see the shoreline, and you can see the lights
You can't
reflecting
you
off the
can't see
water.
the shoreline. You cannot see the
Yes, you
shoreline in that
can.
clip. No,
Yes,
you
you
can't.
can.
No, you
All
can't.
right,
Wait,
well,
no,
I'm
no,
going to
no.
show
He's
it to
right. Hold
you.
on. Yeah.
I can't post screenshots right show you.
I'll
If
show you.
somebody
I'll
wants to
show
do
you.
that
Yeah.
in maps, you can see that hill is in the way.
It's
It's
right
like
there.
right under the circle, right under the blue circle.
Yep, that's it right there. And it's pretty tall. I don't know exactly how tall, but I'm looking at the pictures of this hill from the I-80, and it sits well. You can see all the buildings on top of it. It's probably like, I mean, that's a tractor trailer right there. So it's got to be 200 feet. It's like a cliffside, basically, and it's already at an elevated position above the surface of the lake, right? And yes,
It's
we can
not
see the base of the
visible.
tower
It's not
itself is
visible in the
slightly lower.
footage. It's not visible in the footage at all.
I'm telling you, if it's not visible, that looks like what that line is, right there. That's
Yeah,
what it looks like.
you're
I'm
saying
seeing.
there's some 200-foot hill there that's invisible in all of the
What do you mean
footage.
what do you mean it's invisible?
Show me a line of
I
sight that shows me where this hill is.
I'm looking at
Show
the
me
last
the
picture.
elevation. Show me the elevation
I
on
can't.
Google Earth.
I don't have
Hold the
permission
mouse
to
over.
post. I can't.
Okay, have you
I
got
post
what I
screenshots
asked?
right
Have you
now.
got what I asked for?
Yeah, I'll post. Here, I'll just send it to you. Just, So yeah, I found the position is right here. I made sure too. It said 21 point.
Dude, this picture
21.03
that's
miles.
posted in the side chat here, this is right next to where the line of sight is. There's no hill anywhere there.
It's not.
In front of
It's
the
not
tower.
though. It's not. That is.
Okay.
It's not. That is not the
So
same
this
line of
is
sight. It's not the same direction.
It is the same line of sight because he shows you in the video exactly where he's standing. That's where the laser beam is detected on the other side, right there where the guy's standing.
I can see.
Okay,
I can see
all right.
the
This
line
is
that
all you need to do.
I can see the line that I'm
This
drawing
is all
is
you need to do.
intersecting with that hill. It crosses right over the hill, right, like a couple
What
hundred
hill?
feet down the
What
I-80.
hill?
The black one that we can see in Google Maps in Street View.
There's no hill there, bro.
Are we looking at
So
the same?
where the hill is in this picture. Apparently we're not, right? Because you can see a hill that nobody else can see.
Okay.
Yeah. All right. So
we're not looking at the
anybody,
same thing, I
right?
guess.
Anybody can. Okay. So look at this.
This.
Right.
Do you
Look at the
do you see
tower.
what's on the
Where's
left
the
side?
hill?
Do you see what I just replied to? Do you see on the left side of the screen that hill? That hill. The giant black chunk of shit.
Okay, so that's
on
not
the left
blocking.
side of the screen.
Yeah, that's not blocking.
Yes,
that's
it
not
is
blocking the line of sight, dude.
I promise you.
No.
I swear to God, I'm looking at it right now.
Dude,
in
this
Google
is
Maps.
a
It is
next level
blocking the line
cope,
of sight.
bro.
Dude, I would fucking post screen
It
these right now,
absolutely
but
isn't.
I can't.
Look how high that is. You wouldn't be able to see. Dude, you think
the base
that
of the tower? Correct.
you
Yes,
think
the base
that
of the tower.
that giant hill, and we can see this much of the tower.
Okay,
we
who do
can
I
see
send
this
this
much
to?
of the tower.
Who do I send this to so they can
Send it
post
to me. Send it to me, dude. Send it to me. The hill's not in front of it. That's a giant hill. It's to the left of
Do you
the
see
tower.
that?
It's not.
No. Do you see that? That's the LOS from the video, from the exact position that he says he's at, and then that's the tower, right there. That's the tower.
Where's the hill here? There's no hill here.
Do you see the bro? Do you see the black line?
There's no hill.
Do you see the black line right next to the freeway? Do you see that? There's a line right there, and it intersects with the line drawn by Google Maps. That's the hill.
Not that hill that you're talking about.
Yes, it is. Yes, it is. That's the one in question. It's right there.
It's not there. You're looking at a top view. You don't see any hill there.
Post it in chat. Post it
Dude,
in
you're
chat.
delusional.
Post it in chat. Post it in the sidebar.
Yeah. I'm gonna post it in chat, bro.
This one?
Yes. Yes, that's
Oh,
it.
well, there you
And
go.
and it obstructs the base of the tower.
Yeah.
Yeah.
From that
By a
angle,
lot.
because remember we were talking about different angles, right?
Yeah,
Because
so
of course, if
the
you go
angle that
behind the hill at a different angle, it's gonna obstruct the tower, of
the
course.
the angle that allows you to see into the complex easily, that is not the same direction. That is definitely from the south. It would be from the southwest.
Yeah,
So you'd
check
have to go
all
down
you
the
have to do, dude,
highway.
is just check the elevation of the hill. Check the elevation. Just hover the mouse above it and check the elevation of it.
Can we
Of that hill
talk
that you're
about
talking
whether
about.
are you gonna post it? Are you gonna post the thing I sent? Should I
Yeah,
send
yeah.
it to somebody else?
No, I'll post it. What elevation's the hill that you're talking about in the line of
I'll try
sight?
to
Show us the
figure that out in a
elevation.
second.
Yeah.
Yes, so we can see you can see it right next to the freeway. There's a line, and then that you can see that road leading into the complex. So off to the left side, top left, that's where those pictures were taken, showing you into the
Yeah,
complex.
check the elevation of the base of the tower and check the elevation of what you think is a hill in front of it.
I'll try to see if I can get information on that.
Ooh, just go on Google Maps and hover the mouse above it. Google
But is it
Earth,
going
I'll
to give
do
me
it.
a height?
It'll take 2 seconds. Yeah, it'll give you the elevation.
So just so I know, who's for flat Earth and who's against it? Just so I know where the conversation's going.
I mean, out of every single person in here, or what? I'm for it, and the guy I'm talking to is against it.
Well, I thought this was initially quite compelling, and we would have to examine like refraction and go into that whole thing. But then it turns out it's like
Oh, I'd love
the
to.
base of the tower couldn't possibly be visible in that video that this guy took. It couldn't possibly be visible. It must be
Wait,
obstructed.
what? Okay, but it's not obstructed. You can see it's not obstructed in the video.
It is though, because the LOS, right, where he's filming from, right, you can't see the base of the tower. You'd have to be at a very, very elevated position, like up, in a plane to see the base of the tower, because there's a giant fucking hill of what looks like slag or some sort of industrial byproduct, right, that they've built up, and you can see all those buildings in the top. Those are up at elevation. Those are higher on the right side by a lot than the base of the tower is.
So flat Earther, do you believe gravity exists?
I'll be back in just a second. My wife's asking me a question.
So any one of you guys, you can go on Utah 201 on the state road right next to it, and you can see there's a giant fucking hill in your way, and you can't even see but about halfway up the tower that's 1,200 feet tall.
Durek. Okay, so there's another rebuttal that people are saying that okay, it's just you're saying that it's just or they're saying it's just curved enough where it'd be like a super Earth instead, right? Because they're using coordinates that will say that okay, if I go this far away, everything will be hidden, right? But you're saying that the reason it looks like that is because it's a super Earth, and that
No,
you need to go even
saying
further away in order
I'm saying
for
they
it to
did the
be
math
hidden.
wrong. No, I'm saying they did the math wrong.
Yeah, that's what this Yoder guy's saying. So then, Mr. Yoder, you're wrong in the chat. So there you go, man.
It says so the hill is 10x further than the globe curve should be. No, it's what did we say? It was like 200 some odd feet. I'll have to go back to the calculator.
So what happens if, like, let's say you walk in a straight line, like there's no water or anything like that, or there's always going to be a bridge in front of you, just if you're crossing water.
21.03 miles.
Where do you flat earthers think you'll be? Do you think you're going to hit an
5
ice
feet.
wall or something like that?
So target hidden height 223 feet, right? And that's what you're seeing in the video, right? That's the horizon is at 200. There is the base of that tower is obscured by a lot, right? Like at least 180 feet. You think you're looking at the base of the tower. You're not looking at the base of the tower.
I don't know,
You're
Conrad.
looking
You
at
should try
a
it.
couple hundred
Dude,
feet
you
up
are
the base of
looking.
the tower.
The shoreline on the other
You can't
side
see
of
the
the lake
shoreline.
is what should
You
be
can't see the
obstructed.
shoreline.
You,
It
you
is
can see the
obstructed.
water
You can't see it.
reflecting off. You can see the lights from the town reflecting off the water, and you can see the shoreline. You can see the bank.
The lights from that complex. You can see it in the picture that's right above
You're
it.
meant to be getting the
Right?
elevation of this
This
hill
one.
that you're claiming is blocking the bottom of the tower.
I don't know how to do that without like getting
Go on
USGI
Google
topographic
Earth.
maps.
Go on
Okay.
Google Earth, right, and type in Kencott smokestack. It'll take you right to it, and then hover the mouse, and you'll be able to see the elevation of any way you hover the mouse. You can take a screenshot.
Can I do this without? Yes. Okay. Apparently, you can just do it on a web browser. Okay. Cool. And it'll give me topography. I've never used the web browser version. Okay.
So I've just done it, and there's nowhere that's a higher elevation in front of the tower. You need to check that for yourself.
We can like physically see that that's not the case. And Street View.
Okay, so all right, so I guess there's a big conspiracy, and Google Maps is lying to you now. You can go on the USGS elevation profile finder as well if you want to double.
Yeah, it definitely does. Just looking at the 3D view, it definitely does. It covers up the pipe completely just from looking at it. Yeah, in the 3D view.
And you're looking at it from that same angle with the hill? From, was it south or
Yes.
something? Yeah.
Yes. So yeah, so if you go south down the I-80,
Bro, get
you
the
can see
elevation of the
directly.
hill. Get the elevation of the hill.
I don't know how to do that. I don't know how to do that.
Oh. Does anyone have it?
Right. Oh, I have it, but I'm just helping my wife with something for 2 seconds. I'll take a screenshot of it and show you in a second. I'll be back in 2 minutes.
This is why we use lasers.
Lasers.
So what do you guys think that the Earth is? Is it like a disc? Are we in a dome? What's like your guys' thoughts?
It's 100% not a sphere.
100% not a sphere. Okay.
So could it be a triangle?
Maybe it could be anything. Maybe we're just in a cloud. Who the fuck knows? Aside from
Theoretically.
people who's actually seen it.
Well, we can measure the surface and tell it's not a sphere. That's what we're working with.
Yeah, but the guy just disproved it that the way you're measuring it was wrong.
He didn't disprove anything, right? He's
Oh.
just making baseless claims, and he's pretending that there's some big hill in front of it when the smokestack's not even part of the observation.
Guess what, bro?
Okay,
Guess
all
what?
right. So I'm gonna. This is what I'm gonna do. This is what I'm gonna do. I'm gonna draw.
No, I got it.
Bro, listen.
No, I got it. I got the elevation.
All
It's
right.
89
It
meters.
better be within the line of sight. It better be
It's
within the
89
line of
meters.
sight.
It's 89 meters.
All
Yes,
right,
it's
show me.
above the
Is
horizon
it
at 21
is
miles.
it in the line of
It is.
sight? Is it in the line of sight?
Yes, it is. Yes, it is.
All right,
I already
I'll
showed
double
you.
check
I
that.
already showed you in the picture that you posted that I sent you in DMs.
All right,
That's the line of sight.
All right, I'll double check to confirm. Okay.
It's like,
So then let me ask you guys this. Why is it that you know, we in America might see the sun, but over say like Europe or Asia, it's night over there. What's your guys' explanation for that?
The sun goes away from you.
The sun goes
Yeah,
away
in
from
the
them.
globe model, the sun's many times larger than the globe, right? It's huge and it's 93 million miles away.
What's the
Flat
name of that
Earthers,
tower?
bro, did you not just hear me mid-sentence
Posted in
talking to
chat.
someone else?
It's posted in
Did you
chat.
not just hear me mid-sentence talking to someone else?
I'm sorry. What's the name of that tower?
Did you not just I was just mid-sentence talking to
yes,
someone else.
yeah. I
Bro,
apologize.
so come on, man. It's
I'm
called
sorry.
it's like Kennecott and Garner smokestack. If you just type in Kennecott smokestack, just type it into Google, it'll come up, and then you can get the correct spelling and that kind of thing. But don't worry, I just got the line of sight. I've just done the accurate line of sight, and now we're going to check for this so-called high elevated hill in front of the smokestack.
That would be awesome if we had like a super high resolution telescope that we could just steer around and do long distance observations with.
I mean, we do.
Okay, so this is just the line of sight over the from the smokestack leading out over to the point of the lake where the guy is observing from, specifically attached to the exact spot where the guy was standing for the observation. So somewhere along this yellow line in front of the tower. Now we're going to check the elevations. I'll do that now.
Yes, you can see how it cuts through that hill.
All right, so unfortunately you're out of luck. Now I'm going to post the screenshots. Okay, so here's the elevation of the bottom of the smokestack. So we can see it is 4,325 foot above sea level.
Yes.
Now here's the hill that you're talking about and the elevation on the top of the hill. Right, so the top of the hill is only 4,307 feet, so it's lower than the base of where the tower is.
There's no way. There's no way. There's literally no way.
Okay, right. Well, you
How's
can
that
check this on
possible?
any elevation mapping service, and you can even see in the images that we
Okay.
can clearly see the bottom of the smokestack. So now you're in a conspiracy where you're saying that the elevation profiles
this is
are
wild.
incorrect, and Google Earth is lying.
Just
you
look
can
at
check
Street
it on
View on the
USGS
I-80.
official.
Just look at you can see that the
yeah,
pipe
he's
is not
right.
visible.
I posted the elevations with the pins based off of his decimal coordinates, and then I did the smokestack. You can check my photos.
It blocks it. Yes.
Yeah. What do you not see there? Wait, what?
He was
Google
he
Earth
was
will
trying
have
to
good-
deny this hill existed. I'm
Google
like,
Earth
that
will
one.
have good
No, I
That one
didn't
right
deny the
there.
hill existed. I said the top of that
And
hill.
you were like,
The
what
top of that
hill? And
hill
I'm
is
like,
lower
that
than the
one.
base of the towers. The top of the hill is
How
lower
is
than the
that
base of the
possible? What's
towers.
covering it?
It's
I
not
don't get
covering
it.
it at all. It's not covering it all.
Sitting on top of the hill then?
It's lower. It's lower.
It's not. It's
How
lower.
could a
It
hill be
is.
lower
It's
if it's
literally
covering
lower.
it?
It's It's 4,307 at the top of that hill. The base of the smokestack is 4,325. It's actually way higher than that. That's why we see straight over the top of it. It's not blocking anything. In fact, that whole hill, so let's check if that hill should even be visible. Okay, so we can do the math, and you'll find that that entire hill that you're talking about should be completely hidden behind the horizon. Completely hidden by a huge amount as well.
And you can see from the I-80, you can see there's buildings that are probably 150 feet high, right? In the complex to the left.
You're just
And
guessing numbers.
Those are the lights. Those are the
So
lights that you can see.
I had the smokestack base
Look how
elevation
much
at.
taller it is.
I
Like,
had the elevation of the smokestack is 4,329 feet.
Yeah, so on Google, on the what I posted, yes, okay, so let's go with that. 4,329 feet. Yep.
Okay.
Okay, now
The
here's the hill.
so the position
Here's a
at
screenshot
40.
of the hill showing the elevation.
So the position at 41 degrees 0.037385 north and 112.278570 west is 4,193 feet.
Where's that? That's lower. That's way lower.
That's the coordinates that you provided.
Yeah, so you can see here, it says 4,307 feet. So it's lower, so it's not going to be blocking the bottom of where the smokestack is, just like we see in all of the footage.
I don't know. Maybe I'm missing something. I don't know. It doesn't make
I-
sense.
Well, you just made a mistake and you thought that there was a hill blocking it, but the hill's lower. That whole hill should be completely hidden. You shouldn't be able to see any of that hill at all.
The smokestack is at a higher elevation.
Right. And he's saying it's being blocked. We can't see the bottom of it because it's being blocked behind a hill that's higher than it. And the hill that he's saying it was is a giant hill that's off to the left of the smokestack. And it would be blocking a huge portion of the smokestack if it was there. But it's not there. It's not in the line of sight.
What?
No, but why
Yeah.
wouldn't you be able to see the bottom of the smokestack if it's like 200 feet higher?
The bottom, because you look, okay, so he's looking across the lake and he zooms in 21 miles and you can see the bottom of the smokestack and there's not a hill
higher.
blocking it because the hill's lower than it. No, it's lower.
No, the
I just
smokestack's
showed you
higher.
exactly. So there's not going to be something blocking the bottom of it.
So what's the
If you've got
problem?
a fence in front of you, and then there's something beyond the fence that's higher than the fence is not going to block it. Duh.
How does this prove the Earth is flat?
Yeah, so the bottom of the smokestack should be hidden behind 77 feet of curvature. This entire hill that you're talking about should be completely hidden behind the curvature of the Earth. It's not. And he tested it during the daytime, and then he tested it during the nighttime, and he also got a direct hit from 5 foot to 5 foot across 21 miles over the
you tell
surface of the
me,
lake with a laser.
How tall is that building?
1,200
hill
feet.
to the left.
1,200 feet, the smokestack.
No, no, the building. Right.
Which building?
Okay. Let me just. It should be directly to the northwest. Right. You see, there's a whole complex, and there's a very tall building in the center. It's like like the plant main building, right? Primary building.
The smokestack? Why don't we just
Yes,
concentrate on the smokestack?
just look on maps. Look on maps. Do you see the pipe that's running into this building? I want to know how high that is, because what I'm saying is when he zooms in at night, the lights that you can see off to the left, you can see the outline of that building. You're claiming it's the shoreline.
No, I said it's the bank. And you can see the lights reflecting off the
bank of the
water. You can see the lights reflecting off the water, dude.
This picture.
All of that should be hidden behind the curvature.
I'll find the first one.
So that hill, right? So now it seems like you're deviating away from your hill argument. now that you know it's at a lower elevation. Do you concede to that, or do you want to keep going on that?
I want you to tell me how tall that building is off to the left. How
Why are
high
you
above
deviating away
the
from the
ledge
hill? Your whole gun
Because
ho
I'm
argument was
saying
that there's a hill blocking the bottom. Are you abandoning that?
there is. You shouldn't be able to see the base of that tower.
Why? So
You
it's
shouldn't
blocked
be
by
able to
a
see
hill.
it.
How high is the hill? How high is the hill? Because I know the height.
I can't measure it. I don't pay money
Okay,
for
well,
Google Maps.
so do you think that the
Google Earth.
elevation on Google Earth is incorrect?
That one. I don't know what
Do you want
you're.
me to go
I
on? Do
think
you want me to go
maybe
on a different mapping
what you're
service?
giving.
Do you want me to go on a government
Yeah, it's covered.
USGS one?
It's covered. Like
it's not covered.
literally
You can
this.
see that it's not covered. You can see it's not even a big hill. It's just a bank. It's just a bank. It's not high. That's why you don't see a hill when you look at the footage. It's not a hill.
Okay. It is a hill.
Okay, well, it's lower. It's lower
Like,
than
I
the
don't
base
understand
of the
what
smokestack by a
you-
huge amount. By a huge amount. I showed you proof of that in the side chat.
DJ, if you were to hide behind that hill, could you see the smokestack and look
Look at it from
directly into the
street
hill?
view.
No, it'd be covered,
Look
right?
at it. Look at it. It's like covered
Yeah, but
halfway
you're
up
looking at it.
from the
You're
I-80.
looking at it. You're looking at it from 21 miles away.
No, I'm looking at it
It's
from
higher.
the I-80.
The base of the smokestack is way higher than the hill. If you're 6 foot tall and you're standing right with the hill in front of
From
you,
the
obviously it's
interstate?
going to block everything in the distance. But you're not looking. You're not doing that. You're 21 miles away.
But it's covering it up just looking from the interstate.
It can't cover it up because it's lower than it.
It does.
It's lower than it.
It does.
It's lower than it by a huge amount. It's not just a little bit lower. The whole hill should be hidden behind the curvature. Let's just use the hill if you want. Let's just do the math on the hill and we can calculate how much that hill should be hidden behind the curvature of the Earth. Because you've already admitted that we can see the hill, right? Great idea. All right, so the lake surface is 4,200 feet. Now this is 107 feet above sea level. Okay, so I'm going to bring up the math for that. And I'll get the exact distance to that hill, to the front of the hill. Okay, 20.9 miles. .21.1. All right, let's do the calculation.
Sorry, while there's a brief pause, I just want to understand. So, what is so important about a hill and a smokestack? I came in the middle of this, and I'm
Oh,
very
okay. Yeah, I'll explain it. So basically, if the Earth's a globe and gravity is pulling everything towards the center of mass, that means there should be a certain amount of curvature. And if we look over the surface of a body of water, we can calculate exactly how much curvature there would have to be if the Earth's a globe. So we're doing an observation over a 21-mile lake. Now, the shoreline on the other side of the lake should be hidden. Yeah, the Great Salt Lake, yep. So the shoreline on the other side of the lake should be hidden by 223 feet behind the curvature of the Earth. So the horizon should be at about 2 to 3 miles distance. And that's the maximum distance you should be able to see the water. All the water beyond the horizon should be hidden behind the curvature of the Earth. And then the shoreline on the other side should be hidden by 223 foot behind the horizon. And then that smokestack that you can see that we're going over now should be hidden by 77 feet. The whole bottom 77 feet should be missing. But this guy's saying that there's some hill blocking it. So I'm
Yeah,
just
I'm claiming that. I'm
just
claiming that it is.
debunking that claim. So now I'm going to show him that that entire hill that he's talking about should be completely hidden behind the curvature of the Earth. So I'm just doing the math for that now.
Well, of course it wouldn't, because
Okay,
of the
okay.
refraction. It would just look like a straight line, like all the other Nikon videos. You know what I'm saying? Like, there's no need for any of this. Literally.
What's that?
Okay. So you know how like every single one of these other things, like, even the tower itself, it looks straight, right? If you were to do the same thing with
Mm-hmm.
the hill, it'd be the same thing. Like doing this is like repetitive and useless. You just tell
No,
them
no,
that
no.
they're not.
It is useless, right? So it's not. It's okay. So it is useless because obviously there's no curvature, right? But
Yeah.
these people think that there is curvature. So right now we're showing them that the curvature that would have to be there if the Earth's a globe isn't there. So the Earth cannot possibly be a globe, or you would have to throw gravity under the bus, throw curvature under the bus, and have the only thing you could do is say the Earth has a radius of hundreds of thousands of miles to
Right.
be able to allow for this observation to work.
If it
So
worked
that,
for option A, why wouldn't it work for option B? Like what sense does that make?
what's option
Well,
B?
fortunately, I can do this.
The
You guys
hill
can see it.
and the tower.
So since I can finally
It
post
doesn't work on
something.
a globe.
Now look at that
It's
picture.
impossible on a globe.
Look at that picture.
I'm doing
That's
the math
what you're
quickly. I'll
seeing.
look at it.
Let me see.
That's what you're seeing, right? You can see. You can see like there's an administrative building in the way, right? There's
Yeah.
this very
No.
tall
Okay,
processing
get
tower.
the elevation. Get the elevation of the
I can't.
administrative building.
I don't know how to do that.
Dude,
I don't know
oh
how
my
to
god.
do that.
Okay, so do you know how to
Aren't these?
follow basic instructions? So go
I
to
can't,
Google
dude. I
Earth.
can't. I don't.
What
I
you,
don't
gonna
have
tell
that.
you.
how
He's
do you
gonna tell you
not
how to
I
do
put
how
on
do
the
you
contours
so,
tool. It says want to
stop for a
create a
second.
contour.
Stop talking for a second and listen. Okay, anyone can just go to Google Earth. Just go to Google and type in Google Earth and then click the link. It'll take you to Google Earth. Then
Yes, I
type in
understand that.
Great Salt Lake, Utah, and then go to it. Okay, and then hover over the spot that you want to know the elevation of exactly, and it will tell you the exact elevation of what you're talking about. It's extremely simple to do. I've just done it and showed you. Right? And
I can't
okay,
do that.
what are you giggling for? What are
Because
you
I need the
giggling for?
contours. Because I need the contours tool to get to topography, and when I click on that, it says want to create a contour data layer. Upgrade now. See plans. So I have to pay money.
No, it's free. It's free. It's completely free. I'm doing it for free right now.
What
It's
tool are
free.
you
Just
using?
you got to make sure you hit satellite view as well if you want to get the elevations.
You mind if I ask you a question?
Can I just?
Yeah,
I just
sure.
want to. I posted a
So
picture of the line with the measured distance. And listen, I'm a glober. I don't believe in the flat Earth. I'm taking this guy at face value, using the exact coordinates he provided. I posted all the pictures with the elevations and at the smokestack. Now it is 22.2 miles. It's not 23. But
I
I
didn't say it
posted.
was 23. I
It said
said it was 21.
21.03.
Okay.
21.1.
Okay. I
Oh.
thought I saw one at one point. It said 23. But all right, at the top, like screenshot.
Yeah, I mean you can see like.
So like
So
I'm
my
like I'm not on like the flat earther side, and I'm taking this guy at face value, and I literally just posted all the elevations at his specific coordinates and the smokestack itself. I
I
don't
know
know.
that you're against and he's for, so I understand that.
I'm just fact checking, right? Because it seems like initially what he was presenting, it seems very compelling. It's like, yes, you should not be able to see this. It's really not that high up. Because that was my first question: is this on an incline, right? And the bottom of the tower doesn't appear to be, right? But when you look at it from different angles, it's like you can't even see that pipe, that white pipe sticking out from other positions like on the freeway where there's many different camera angles
Yeah. So,
looking
okay,
towards the
listen to
facility.
this.
So that's just confusing to me.
Okay, this is why it's confusing. right? Because if you stand close, if you're at a low elevation, right, like the Google car that's taking the pictures at Street View, if there's a bank, right, like a little hill, like the thing you're talking about, right, and you're close to it, and it's way higher than you, it's going to block everything off into the distance. If you move further away from that, okay, something in the distance that's elevated higher than the fence, you're going to be able to see it now because there's not something blocking, there's not something right in the way of it, right? Just like if you put your hand out in front of you, just in front of your eyes, and there's a giant mountain in the distance, your hand's going to block the entire mountain. Now, let's say you could keep that hand there, right? And you're going to back away from the hand 100 meters. Now, obviously, that hand is not going to block any of that mountain anymore, right? You're just going to see a little hand there. But when you're close to it, now it's going to block the entirety of everything that you can see. It's the same thing with the hill. If you stand close to the hill, right, it's like standing in front of a fence and the fence is higher than you. It's going to block everything beyond the fence.
Yeah,
As you start to move further away, now you're going to be able to see things that are beyond the fence because of perspective. So the hill that you're talking about is a huge amount lower than the base of where the smokestack is. That's all I'm trying to point out.
Yeah,
These
I think
these
I agree
buildings
that too.
though, these buildings though, they're hundreds of feet. They're like the top of this processing tower. Like we should be able to see that very easily,
You
right?
shouldn't be
So
able
I
to
don't.
see. So the bank that you've
Where
admitted
is
that we
it?
can see, you shouldn't be able to see it at all.
You can't see the bank. Can't see the bank.
You just said the bank is what's blocking
These
the bottom of the tower.
from any. Are you talking about that hill? What I'm calling
The
a hill.
hill, the hill, the hill that you're talking about. So I'm posting the math now, and this is right. So we can get. So this is the killer right here. Okay, so here's the Let's go over this. Okay, so that hill should be hidden behind the horizon. The hidden height's 224 feet. Okay, now let's check out how high the hill is. Okay, the surface of the lake's 4,200 feet above sea level. Now, the top of this hill is 4,307 feet, so it's 107 feet. Okay, so
wait, you're just measuring with the measuring tool?
That's just to get the distance between where the camera is, right? Because we wanted to know what the line of sight is, because you were saying over the line of sight, this hill's blocking the bottom of the tower. Okay, but the hill's lower than the tower. So what we're doing right now is we're checking the height, the elevation. You don't use the measuring tool to check the elevation. You hover the mouse over the top of the area that you want to know the elevation for, and it comes up with the elevation on the bottom right-hand corner there. It says 4,307 feet. That's 107 feet above the surface of the lake.
Okay.
Right? But there should be 224 feet of hidden height. So so not only should you not see any of that hill, right? But even if there was a 10-story building, right, on top of that hill, you still wouldn't be able to see that. That's how much this should be hidden behind the horizon, behind the curvature of the Earth, behind that horizon that we see no evidence of whatsoever in any of the footage here. So that's it.
So I got a difference in elevation of 136 feet. And you're saying how much should be hidden? 220?
Yeah, so the object obscured part, right? So this is what I put in. 21.1 miles is the distance to the object. The camera height is 5 foot. The distance to the horizon's 4.41 kilometers. Whoops, I put metric in there. So 2.73 miles. And then object hidden obscured part, right? The hidden height's 224 feet. Where that hill is. And that hill is so the hill is 107 feet above the surface of the lake, the top of the hill. But it should be 224 foot hidden. So not only should you not be able to see any of the hill, which we see the entirety of the hill, but even if there was a 10-story building on top of the hill, you wouldn't even be able to see any of that 10-story building. And this should all be blocked behind the horizon, which is made of water.
So like 90 feet, like you should only be able to see like 90 feet higher than like those positions. So what was the temperature, humidity, all that other stuff to account for refraction?
Yeah, so would you agree that we don't see any miraging effects? We don't see any heavy refraction effects here?
No. I just want to know the
Really?
condition.
So, yeah, so
There's
we don't
definitely
know
some
the
refraction going on. So
really. Well, there's always some refraction going on. So what do surveyors do when they calculate for refraction? They use a refraction coefficient of 0.13, right?
it depends on the conditions.
Oh, really? How
Yes.
would you measure the conditions?
You can have a barometer and a temperature gauge.
Okay, do you guys do that when you're out on the field?
Yes.
Yeah, who does that? That's not what they do. They have 0.13 refraction coefficient. That's standard refraction. That's what they add into their
I
formulas.
absolutely put in the temperature into my data collector when I do my
The
measurements.
temperature, okay, the temperature where? You're taking a
Well,
vertical temperature, pressure, and humidity gradient reading along the line of sight?
So I'm on Long Island. So I'm basically at sea level. Like basically the highest I go is like 200 feet. So I don't need a barometer for that
Oh, really? Why not?
because it's negligible the amount of
Okay, so
difference for
so
that.
what? Right. So what
Oh,
refraction do you
but
account for?
I do need to put in the temperature.
And how would the temperature let you know the refractive index?
It has has an internal calculator. It's programmed.
Okay, so let's say the temperature was 3 degrees Celsius. How would that give you any indication what's going on with the vertical refractive index gradient between point A and point B?
I don't know off the top of my head. I'm not a calculator like that.
Right. Right. It wouldn't help at all because it's all about the change in the optical density of the air, the refractive index, right? So it's about the vertical refractive index gradient. You would have to know exactly what's going on with that between point A and point B. Right. And it's not logical, right? That people are going to have temperature, pressure, humidity sensors placed vertically throughout the entire distance of every observation that you're making or any observation that you're making, because you would have to take all of those readings at the same time. And then you would have to use something like the Edlin equation so you can get the refraction coefficient. And then you would be able to work out what the little k was for that day, right? And then you would have an estimation of what's going on with the refraction, but that's not what surveyors do. Surveyors don't do that. You would know that you guys don't do that.
So that's because we don't take measurements of like 21 miles just using a total station and like a reflector. That's not how we do it.
Right. Right, but we can
know about
see
that,
drastic
so-
but we can see drastic refraction effects just over a few meters.
When you're like maybe on surface level.
Well, even if you're up in the mountains, right? If you type in mirage in mountains, you'll see that even at high elevations, you can have crazy amounts of refraction to the point where you're getting insane in superior mirages and inverted, images and all sorts of crazy stuff happening, right? You can have heavy refraction anywhere. But the thing is, right, he took the observation during the daytime and then he repeated it again at nighttime. And it looks exactly the same during the daytime and exactly the same during the nighttime. And then after that, they also did a laser transit test as well, which hit the target 5 foot to 5 foot. So we can add in a amount of refraction if you want, but I've already done all the calculations on this, and I don't. Do you know what the refraction coefficient is?
Not off the top
Like
of my head, no.
Well, 0.13 is standard refraction. So it basically the way that they simplify the calculation is that they increase the radius value. to compensate for the light bending downward.
Uh-huh.
Now, that increases the distance of the horizon by 15%. Now, what they consider heavy refraction is when you get up to a refraction coefficient of about 0.3, and that's considered like even according to Walter Bisland's website, that's considered heavy refraction. And once you start getting heavy refraction, like it says even on Walter Bisland's Advanced Earth Curve Calculator, and during their Rainy Lake experiment, they show examples of this is what it looks like when you have heavy refraction. This is what it looks like when you have low refraction. Low refraction looks very clear. 1 second. My wife's asking me a question.
So how is this light diffraction thing like disproving or approving?
Sorry. Sorry, I
Because
didn't mean to interrupt you. I was just saying I'll be back in 5 minutes. I gotta go help my wife with something. Sorry.
is there
Well,
any other
it's
flat earthers
important to
here?
know. It's important to know about the amount of refraction occurring because let's just say there's about like 50 feet. Like now
Mhm.
we're down to like only like a 40-foot should be hidden, and I don't know if you can really clearly see from that picture like what exactly is going on there.
Are you for flat Earth or are you against flat Earth?
Uh, I don't believe in the flat Earth.
Yeah, so I just looked. So since you explained it, it does actually show you the elevation in the bottom right corner. You just like click on it and it shows you. But yeah, the top of that administrative building or whatever that building is off to the left is 291 feet. So it's above this Earth curve calculator target hidden height of 223 feet. Right, so that's what you're seeing in the nighttime pictures. You're seeing the lights on the top of those buildings. I don't know anything about refraction.
So
Did
do
I?
you,
I just explained that like we should be able to see that building even with curvature. Like
do you
the
go
tops of
shooting?
those buildings should be lit up.
Do you shoot?
Shoot,
Yeah, do you shoot guns?
sometimes. Why?
Do you ever go shooting long range?
Not really. That's like not really something that I've invested a lot of time and energy into.
Because I like
So
to go shooting. So
yeah,
there is something that you have to consider, and this is my challenge to flat earthers to explain this. But how do you guys explain the Coriolis effect?
they just don't usually. That's kind
Yeah.
of
Because like if you were to account for wind,
yeah. Here,
friction,
you can literally see it, and I just replied to it. Can I forward? Can I just forward his shit? Yes, I can. Fucking Discord. This. And no, I can't. Attachments are yeah, I can't because you won't let me. Yeah, whatever. I
like,
replied to it. You can see that fucking building off to the left, right? You can see it. You can literally
I
see the
can't
lights at
look
the top.
I
That's the building, right?
can't
So
look
you
at
can
what you're
see
seeing.
everything that you're seeing. It's not the
Yeah.
shoreline, it's the complex on top of the hill, right? And yes, he was right. That um what he was calling a bank, the hill is obstructed. You can't see it in the picture,
Yeah.
right? And all of that
But
stuff is
not a flat
above
earth.
250 feet. All of it is. We all agree on the elevation at this point. So that's what you're looking at, right? So yes,
Believe you, I'm
there's a
not a flat
significant
earther.
the freeway, the state park, right? Like part of the facility down on the road, all of that is obstructed below the water line. You can literally see it in the picture. So it's
It's just like I like I want to. I believe I'm not a flat earther. I'm a glober. You know,
I want to
just wanted
believe
to come in
the Earth is flat.
here and see what
I like conspiracies. I especially like denying like things. It's a lot of
Earth
fun.
is not a
it'd be
conspiracy.
Well, the flat Earth is a theory about a conspiracy of globers that
Flat
lie.
Earth is not a theory.
Okay, well, you don't understand.
It's true. It's proven.
The theory. The theory
What's
is about
your what are you
globers
saying?
deceiving, which is
It's a
absolutely component
hypothesis
from
at best.
You
All
know,
we've ever
because
experienced is a flat, stationary Earth. That is how it measures to be. That is not a belief. That is not an idea. That is not a conspiracy. That is not a theory. That is observed and measured reality.
It is
Congratulations on
absolutely
being
designed, measured,
completely
flat.
like just not listening to what I said.
yeah.
Flat earthers, they claim that there's a conspiracy of globe chills that are
No, we do not.
keeping them from the truth. A lot of them doing it.
So
No.
he's talking about something he can observe. So why don't I can ask him this? So if you believe that everything that we do is observable, why is it
This is why.
that
Why
the
would you
stars
just
that
put
we look
those wild
at?
words in my mouth? Did I say
Well,
everything that we do is observable? Is that something I just said? Like, are you deluded? Like, where does these things come from?
no, I'm not deluded. What
One of
I'm
the
going to
things
ask you is why is it that the stars that we see? I don't know what part of the world you're in, but why is it that, let's say here in the United States, I'm in Arizona right now. Why is it that I could look up to the stars and see constellations, but if I go to South America or Africa, I can't see the same constellations?
It's because you are really far away, and there are a different set of constellations above that area than there are the previous area you were at.
But the thing is, if we were on a flat Earth, we should all be able to see the same stars, but we
Why?
don't.
Why are you assuming this?
I'm not assuming it. This is a proven fact.
Do you ever listen to yourself speak? So you're saying flat Earth that isn't real. If it was that, it must be that way, and that's a proven fact.
Yeah.
Bro,
Yeah.
you should really listen to yourself. The good thing this is recorded. You can go back and listen to it.
Yeah,
It's fine.
Okay.
You can record me. I don't care, but that's my question. Why, if we were on a flat disk or whatever you think it is, why can't we see the same stars? I should be able to see a constellation, because if everything is so far away, like these
Hey, there we go.
stars
Now we found
are,
part of the problem. Why are you assuming the distance of everything? And how could you even start to claim how far these objects are?
because we can measure how far these stars are.
Oh, really?
Yes.
Dude, inform us.
It's just sunlight wavelengths. We're bombarded by them.
Sunlight wavelengths allows us to
Yeah,
measure the distance to the stars. How so?
that's just how we do it. It's called an astronomical unit.
Can you show us any sources on this?
Yeah, you can just look it
Sweet.
up on NASA
No,
or a book,
you can share it in the
or
side chat there.
I can't. I'm driving.
Ah,
I just want to
unfortunate.
understand how
So
you guys
because
think.
sorry, go ahead.
I just want to understand how you guys think. That's all I'm really trying to say. I
Well,
don't believe in
check
flat
this out.
Earth,
Check
but I
this out.
want
Are
to
you
know.
ready? Are you
Sure.
ready? We are all separate individual people who might have different opinions on reality. You believe that? Isn't that crazy?
Then facts don't exist.
no, I guess they just.
What?
I don't think that's what he's
Yeah,
trying to say.
facts.
Um,
Facts exist,
Okay,
yeah.
I do have a question. Why do you say it's measured flat?
Because it is
Oh, there's
measured flat. We
No,
do.
like why do you think it is measured flat? Like
Hold on
where
one.
are you getting that?
These laser transit tests, okay? If the Earth is a sphere with a radius of 3959, we can calculate the rate of drop that will be present over a certain distance, correct?
Sure, but that's not really addressing my question. Like when you say it's measured flat, like I'm assuming you're talking about like maps that are being made.
Hey, guess
Are
what?
assuming are
There's more
are
there's more to
trans-
come to what I was saying. We know the amount of drop that would be on a sphere with a radius of 3959, right? Yes.
sure.
Well, check this out, man. We can form a tangent with a laser at the edge of a lake, the surface. And we can shoot this laser across the lake, and we find no drop over distance every single time. No matter where it's done, no matter the temperature, no matter the conditions, when there should be 66 foot of drop over 10 miles or 266 feet of drop over 20 miles, that never shows up. No one has ever found it. The laser runs parallel along the surface of the water and hits the target.
Okay, but I want to talk about like actual measurements that are made by like you say like it's measured flat, and I'm assuming you're talking about like people that actually make maps and distance like measurements and
Check
like
this out. You don't have
do
to
like
assume
say for
anything.
example make a
I just
township
told you.
like make a township or make a quadrangle. No, like I'm talking about the people that actually measure it. Why do you say they measure it as a
N-
flat Earth?
Nobody actually measures surface curvature. If you think they do, you are welcome to share those measurements and how they were obtained. Thanks.
Have you have you ever looked up a township measurements, like the actual survey of the township?
You're roboting real bad, Bo.
Yeah, you could look at the
I
British
got into
grid
a bad service
system.
there.
It's all based off a flat Earth. British grid system, British ordnance grid system, I think it is. Maybe Yoda can share a link or two about that.
So no, but like have you ever looked into a township like in America, like how it's measured?
Well, does it
Yeah.
have to be America? Why does it have to be America?
Because
About
it's a very good
Britain.
system. Like the PLSS, like a really, really good system.
Yeah, look, over say 100 square miles, it's like 99% flat or something like that. So when you're doing these triangulation surveys, you only have to make slight adjustments to be able to fit it onto the
I
globe
don't think you
coordinate
understand what I'm
system.
talking about. I'm not talking about a triangulation
All right.
survey.
Well, what do you?
Like,
Yeah, what are you talking about then? Sorry.
so have you guys ever looked at because like you guys keep saying the Earth is measured flat, like and like a
No,
really
I
good
don't say
system is the
that. I don't
PLS
use that
system.
terminology. I just say that we all
Okay,
experience.
fair enough. The other guy did though. So I'm just
By
wondering if you guys
default,
ever
it's not a
looked
globe.
into I'm just wondering if you guys like for the other guy that says it's measured flat, have you ever looked into how they actually measure it?
We can use
Measure
lasers
what?
and things like that to test for the
The
curvature. And
Earth.
when we take measurements using lasers, we don't detect any curvature. So by default, if there's no curvature over a large surface, the default is that it's flat. That's what flat means. It's a surface area that doesn't have curvature. And you can use lasers to measure things, right? And if there's no curvature, that would be measuring the Earth as flat.
You know that light bends, right?
Yeah, we do, but we can also take side views of the laser and we can see that the laser is not bending. Now we've got a guy called Dr. John D, who's an expert in optics, and he's actually gone out and done years worth of tests using different spectrum lasers. He's done over 350 hours of laser tests, and he's never seen a laser bending downward. And we've never been able to find any footage of a laser bending downward over a large distance through the medium of air over land or water. Occasionally, you can get a laser that's seen bending upward, right, due to like inferior mirage conditions, but not downward. He said they either go straight or they can bend upward because they're very, very powerful lights. They can push through the air very well. So yeah, sure, light can bend, right? Refraction exists, but like for example, when there's hundreds and hundreds of feet of missing curvature consistently, right? We're not finding the curvature, right? All we can see is the flatness, and all we're detecting is flatness. We can't find any curvature. So by default, if there's no curvature, it's a flat surface.
So
and yeah, go ahead.
Yeah, so I'll explain how the PLS. So basically, you have an initial point, and that you create a principal meridian, and you go. I'll just talk about like one section of the quadrangle, not the full thing. So like you go south 1 mile, and you place another marker, and then you go south another mile, and you place another marker, and you do that 6 times. So now you have 6 miles south and a mile marker at each point. And then from there, you do another 6 miles west from like that bottom point. And you have these markers there. And then when you create the actual township, like with each section being 1 square mile, you create another monument at like from 1 mile north, and you go up and you create this like grid system. And the thing is, when you get to section 6, which is like because you push all the times like where you don't get the full mile to the west, and you pull all the times you don't get a full mile to the north, because you create mile markers for the first like 25 square miles on the south and to the east. So you have perfect 25 square miles there. But all that error, when you get to the north, when you hit those original markers, you never get a full mile anymore. And as you go west and north, that's where all that error gets pushed. And this is why it's because the Earth is spherical. So that's what that happens.
No, you're doing these tests over terrain that has constantly varying elevations. So you could do it over a section of land that doesn't have any curvature. And then obviously you're not going to get that result. If you're doing it over a section of land that has negative curvature, right? Like concavity, for example, right? There's like a slight dip in the center over a 25-mile distance. That's why we like to do tests over a level surface. You're not doing tests over a level surface, and you're doing plane surveying, and then you're taking that math and then you're fitting it to an ellipsoid. You're fitting it to a datum at the end of the process. And
you're just using
if you talk to Yoda about that, over 100 square miles, the difference between a flat Earth and a globe Earth, it's like 99% flat or something like that. It's the tiniest little difference. And that's why you guys use standard refraction, which falsely assumes that light will be bending downward at some standard rate, which absolutely is not the case. Right, and then you're using slight instrument error and refraction to fit this data onto a reference system. I mean, that's your job to do that. It doesn't prove that the Earth's a globe. And if you have a particular test, you didn't even know what the refraction coefficient was, and you're a surveyor. That's crazy. How could you not know what a refraction coefficient is, and you're a surveyor? And then you're trying to tell me about like observations.
Did I say I don't know what a refraction coefficient is, or did I say I don't know the standard thing off the top of my head?
How do you know your location on the Earth when you're putting your markers down?
I explained to you, you put the mile markers on the outside of the grid first, and then when you go inside to make the internal, like 1 square miles, you for the first 25 miles south.
How do you know it's a mile away? Sorry, how do you know it's a mile away, and how do you know its exact location?
They use chains, like they use physical chains when they did this, like in their early days of survey.
So a mile-long chain. How did they know their exact location? What did
No,
they
it's not.
reference it to?
It's not a mile long chain. It's
Okay, you
80
said a chain.
chains is 80 chains is half a mile, so it's 160 chains to the mile.
Okay, that's lovely. How do you know your exact location? What's that reference to?
The initial point that you create.
Okay, and how do you reference the other points and their exact location? So you reference it to any particular coordinate system, sir? Are you using longitude and latitude, for example?
Like, yeah, like you can translate this to latitude and longitude, but
No, I'm
I'm just
asking
talking
you
about
if
how,
you
like,
are, not if you can. I'm asking you what you are exactly doing.
no, like when you do surveying, typically you're referring to like a file map and stuff like that. Like you
So you
like
are
that's how like
referring it to something
I'm
already.
talking.
Yes, no?
When you make the initial map, when you make like we create a principal meridian. That's what it's called. So you have an initial
Principle,
point which
yeah.
creates a principal meridian, and there's lots of principal meridians like in America.
Okay.
These
And their
principal
exact
meridians
location, sorry, dude, it's like you're not
created.
following me. And their exact location is known how? It is here. Where's here? What's that reference to? Has it got numbers attached? Is that a longitude and latitude coordinate? Come on, mate.
What do you mean, come on, mate?
I'm asking you to hurry
Come
up,
on.
dude. I thought you knew what you were talking about, so I'm asking you very precise questions. How do you know your exact location? What reference system, coordinate system are you using?
You're being way too general. I'm talking about a specific time,
All right,
like
sorry,
in
mate. I was
location.
trying to follow on the conversation. I'll pass you back to DJ.
So let me ask you this. Yeah,
Mhm.
I'm obviously not the Brit because you guys don't shoot guns. But do you shoot guns? You don't sound, or you might be a Brit. I don't know.
No,
You shoot guns
I don't
in
shoot.
here, dude. What the fuck?
Oh, what's that?
What's your point with the guns?
Well, I was gonna say when you shoot a gun at a long distance, if you account for wind, friction, gravity, and all that kind of stuff. Have you ever heard of something called the Coriolis effect?
What, the apparent drift of an object because you're on a rotating reference frame?
I mean, it's the Earth is moving under the object.
Okay, so
Instead of
the
just
object would appear to drift.
yes.
Okay, can you show the appearance of it drift, not the calculation of it drifting?
No, I don't. If you were able to shoot, I'd be able to show it. In fact, you can.
Really?
Yeah.
Okay. The fuck? So what would happen is I'd take a shot, let's say I'd use a sniper rifle and I was shooting over a kilometre. With all the factors involved, you'll be able to show me that because of my direction that I was shooting, there was Coriolis effect. Let's say I was to take 4 shots, north, south, east and west. There'll be Coriolis effect in all 4 shots, right? You'll be able to predict the Coriolis effect and that shot would also, hit that prediction every single time, right?
Well, if you take in the Coriolis, if you didn't take in the Coriolis effect,
No.
then you would miss.
Without all of the other factors that you brought in, like friction, like the air temperature, like all of these other things, right? The drop of the bullet because of the gravity, even though the thing's going down, you're going to say to me that the Earth is spinning as well.
Yeah, I mean it is.
It is.
Yeah, there's spins.
Okay, so how would you prove that it is then, without you begging the question or sometime trying to affirm that it is in a shot that you're taking? How would you prove that it is to me first?
Well, I mean, if you didn't take it in, you'd miss. If you did take into it, then you
Okay,
wouldn't miss.
so before we started taking Coriolis into effect, we missed, right?
Yeah, if you're shooting over a
Show me
long
that,
distance.
please. Show me that.
Well, I can't, not in front of you, because
Dude,
you're
come on.
all the way on the
It's
other
like,
side of the
think
world.
about this for a second, dude. You're saying that before we took Coriolis into effect, we missed. When did we put Coriolis corrections into ballistics? When did we do that?
When we started shooting over 2,000 or 2,000
Okay, so
meters.
show me that then, and show me the comparison as to beforehand, as we were missing an awful lot.
Go look at a YouTube video. I can't
No,
show
don't
you.
tell me to go look at a YouTube video. That would be your evidence that I'm going to have to go find that needle in a haystack for.
Well,
How about you go and grab the
it's
fucking
not a
needle
needle
for
in
me
a
and just show it to
haystack.
me and prove me wrong?
Just look at a YouTube video.
No, I don't need to just go and look at a YouTube video, sir. I need this person not to talk through me. And then what I need you to do is this person not to talk through me. And what I need you to do is just go and provide the evidence that you've obviously seen before to make this reasonable deduction.
Oh, it's not that I
Have you
found
seen
it.
this video before that you want me to go and try and find on YouTube?
Yeah.
Okay, go and
Just
get it
look
then.
up what just
He
look up
says,
the
sorry, I
Coriolis.
do apologise. I've been away for 3 weeks and I wonder why I start these conversations. But yeah, high-tuned fucking voice doesn't make me confidence that you've seen the fucking video that you want to go me to hunt for. Go and get the video, dude.
I can't because I'm driving, so I can't.
I tell you what,
I
my
wanted
name's
to.
Jedi. Dude, my name's Jedi. When you pull over, could you DM it to me, please? I'll give you 12 hours.
Okay,
No.
Qui-Gon Jinn. You know, I'll
Dude, just shut
fucking.
up. Just shut up. I'd rather talk to the other
Some
person.
Jedi. Okay, but what do you believe? Do you believe that we're like a disc floating
No.
in space, or like
No,
what is
I'm
it
not making a
that you
claim
guys
to the
believe?
shape of the Earth.
You just don't know what it is.
At the moment, you're saying that the Earth is moving because of a calculation. I'm asking you to prove that the Earth is moving. Just you, reasonably, to me, without a YouTube video, without some kind of affirmation from something that you may have seen on a YouTube video or something you might have a recollection from the military. How about you prove to me, reasonably, that the Earth is actually moving?
I mean, do we see the same stars when we're in different places, or why is it that the sun goes over the horizon?
No, that's a question to me. How about you prove?
How
You
about you
make
prove to
a
me that the Earth
claim,
is
you
flat?
reach a logical conclusion with your logical claim, and you prove to me at the end of your logical claim that it is sound.
I just want
And
you
ask
to
me a question.
explain to me. I just want you to explain to me what kind
No,
of shape or what are we? Are we just on a
no.
plane of
It's not me
existence?
for it to explain. You're running away from proving to me that the thing that we're standing on is moving. Do that.
I mean, I used to throw rockets up in the air. You
Okay.
know, that's what I went to school
I used to
for.
kick balls up into the sky really far until they came back down. How does this prove that the Earth is moving? What are you trying to demonstrate to me by you used to throw rockets up in the sky?
I've seen it. I've seen through a camera
Okay.
attached to a rocket that after, like, when it goes above 50,000 feet, you can see the curvature of the Earth.
No, that's not moving.
Okay,
Why are you not following along,
comes,
dude? I'm asking you to prove that the thing
if
that
it
we're
comes
standing
straight
on. Shut
down,
up, you're driving, dude.
if it
Shush.
comes straight down,
No,
shush.
not straight back down. I caught it again, thanks.
Hey, bro,
You took me up in a rocket with a camera to show the curvature of the Earth. That's not what I'm asking of you. I'm asking you to prove that the thing that we're standing on is moving.
God, you flat earthers are so funny. This has been a
No,
very
you
entertaining
made this claim. You
conversation.
jumped into a conversation with me and somebody else to talk about the Earth
I told
moving.
you they won't address
Coriolis
the
effect,
Coriolis
you
effect.
said. So we're going to
They
be
won't address
talking
that.
about the Earth moving.
The Earth is
So
moving.
prove to me that the Earth is moving.
Prove to me that it isn't.
Oh, for fuck's sake. I'm going to go away for another 3 weeks.
Yeah. Bye-bye. Thank you, guys. This has been a very entertaining conversation.
Yeah, it was fun. So. We proved everything
Yeah,
you
good.
see.
Hey,
That video is normal. So you boys have a nice day.
yeah, good chat. So look, Druid, the hill that you thought, right, the hill that you were saying was blocking the bottom of the tower should have been completely hidden behind the curvature of the Earth by over 120 feet below the curvature of the Earth. So I mean,
I think he left.
oh, he's gone. Yeah.
Yeah.
All right. What about the other guy Jedi was talking to? He's gone as well. All right. Yeah, Rodney, it's kind of useless. I mean, just posting walls of AI text. I mean, I could just copy paste that into my AI and say debunk this, and it'll do that, and then you can copy
I mean,
that,
it
and then
does
it'll
it
go back and
though.
forth.
It does it. I mean, it's kind of lame, but it does it. You know.
Well, it will if I just copy your text and then just put it into my AI and say
You'd be
debunk
like, how
this.
is
It'll
that
just
wrong? Right.
well, then mine will debunk yours, right?
Right. And
And
then
then
when
you
does
can
it ever
copy
get to
my
a stop?
debunk into your one. It's
Right.
it's not going to. It's not going to stop. It'll just keep going back and forth. It's just a computer. Also, they butcher information all the time. Like it's completely wrong a lot of the time, and
I
it's
know. I
just
have to redo it. I have to be
mixing.
like, yeah.
It's just mixing bits and pieces together that it's finding, and once you really like get into the nitty gritty details, like I noticed this when I talked to it about refraction stuff, right? It butchers things. I'm like, what are you talking about, right? I'm like, you got that back to front, and it's like, oh yeah, I'm so sorry, blah blah blah. Or you type in
Right.
things like flat earthers, right? So if you type in did flat earthers debunk themselves using a laser, it's going to say yes. And then it's going to completely hallucinate a
Well, there's a
scenario.
video on that, isn't there? It's not an AI video. I think that's a popular video on YouTube.
Yeah,
I
yeah,
swear I saw that.
yeah, but it's not what it seems, and it's not a laser test. And AI will tell you that it's a laser test over Lake Pontchartrain, and
I'm
they
not
never
talking
even
about
went to Lake.
AI at that point. I'm talking about that video.
Well,
Yeah, there's a
oh,
video
yeah,
on that.
yeah, it's
That's
52
where you
seconds
know
of
how it pulls
footage.
information,
It's a
right?
no, it's not a valid test. It wasn't done correctly, and it was misrepresented by the mockumentary. So basically, it was a hit piece about flat Earth to
Right.
tease flat earthers. So they found some really dumb flat earthers, and they tricked them into going on what was supposed to be a neutral show. Now, that test that you're talking about, it shows 52 seconds worth of footage, right? That was supposed to be a laser test, but they broke the laser or something like that. So they're like, oh shit, it's already nighttime. What are we going to do? They're like, oh, we got a flashlight, right? So they set up some pieces of cardboard where they cut some holes in the cardboard and they spaced them apart at nighttime. They didn't show us any of the setup. They didn't show us any of the confirmed heights of any of the pieces of cardboard or the location or anything like that. It's just a few close-ups of the dopey looking guy's face, which is effective at making people think flat earthers are stupid because people are visual like that. It's just it's a mockumentary. Okay. And it just shows 52 seconds worth of footage. Then it shows you some math, and it's like, oh, see, it proves they debunked themselves. They got all the math wrong in that anyway. It's ridiculous. And that's it. And then people see that on YouTube and they think, oh, flat earthers debunked themselves. But we have tests that have been done, like proper tests. In reality, that you can see the whole test done start to finish. It's done by people that know what they're doing, using expensive equipment over huge distances, and it blows that out of the water. So yeah, that test, although it does exist, it's crappy. It's useless. Apparently, everyone that was there at the time, even including the globe earthers, they all walked away from that, was saying, "Oh, that was a big waste of time. It didn't do anything." It didn't prove anything. And apparently they went back the next day and they were like, oh shit, there was a big tree that could have been blocking the light. So it's like, what? You guys are setting up a test in the dark and you didn't notice there was a big tree there? So the whole thing's just ridiculous, that whole documentary. If you watch the documentary, it's called Behind the Curve. It's kind of funny because they're just mocking. It's just mocking flat earthers, basically, the whole
Well, of
thing. It's
course
a
it's a smear
mockumentary.
piece, and I mean that's the point of it. When you make something like that, I mean you're not gonna say positive things unless you're like some weird documentary. But yeah,
Well,
when you
apparently it was
understand
supposed to
why they did the
be
things, you know what I'm saying?
well, this is the thing, right? It was supposed to be
Right.
a neutral
Oh, really?
presentation of the flat earth arguments versus the globe earth arguments and that kind of thing. And apparently the producer attended a flat earth conference during the filming of the video, and he noticed that there were kids at the flat earth conference, and he got triggered by that. He's like, oh, they're brainwashing the kids. And from that point on, he decided that he was going to start taking it more towards the side of making flat earth look bad instead. And then they had an agreement with the flat earthers before they started filming that they would hand over all of the original footage, basically. So they would have access to all the footage, so they couldn't lie about anything and misrepresent them. At the end of filming the video, they refused to hand over the footage. And then there was a lawsuit. The flat earthers took them to court, and there was an ongoing lawsuit to try to get the footage, because if they were able to get the full footage, they would have been able to show that they edited it in such a way that's disingenuous. Unfortunately, one of the flat earthers that was in it, Bob Nodell, he passed away, so they're not pursuing that anymore. But yeah, it wasn't anything that debunked flat Earth in that film, but it was effective at making people that haven't looked into the topic think that flat earthers are stupid. And the guy that was in that, Jaren, yeah, he's a moron. He's like some stoner, right? And he's the same guy that went to Antarctica. If you type in flat earther debunks himself, it's just always this one guy. A lot of people speculate that he's like a plant or something like that. Anyway.
Yeah, if you read the advent for that Behind the Curve, it's like meet the growing worldwide community of theorists who posit the exact verbiage, like posit the world as flat, while living in a society that vehemently rejects it. So they kind of tipped their hand. They're like, hey, we're going to do a documentary about humanizing this group of people, because a lot of people aren't doing that. And there's a lot of like anti-flat earth content. If you humanize the topic rather than dehumanize it, it'll be better. It's very liberal, Netflix, like, let's showcase that these are people too. These are your neighbors. And they couldn't help themselves. They were so incensed. So quite ironically, and what they should do next would be like, what's the other minority group that they could do that for? It was going to be like a whole running shtick where they do vegans and atheists, polyamorous people. Like they're going to all these like sort of like fringe groups that do things that aren't illegal. There's nothing wrong with it. Just that society has a problem with it. But after they did the Netflix one, the Flat Earth one, all the other groups were like, "Fuck no!" Like we saw what you did with the Flat Earthers. You think You think anyone's going to participate with you now? You're a scumbag liar. You've manipulated and twist things around. Like, what the hell's wrong with you, dude? And then the court case content, like, you said you'd release it. You give us editing rights. You didn't do that either. That guy, I can't think of his name right now. It's like Raphael, something with an R, right? Like Raphael or whatever it is. He had a basically a springboard, just springboard into this long-lasting Netflix special where he just one after another, like a beginning of a long fruitful career, and he tanked it because he got triggered. I just looked at Googled it, and it's those names. I can't remember the guy's name, but these ones aren't jumped out to me. Carolina Clark, Nick Ambert, and Daniel Clark. It wasn't. I don't think it was Caroline or Daniel. They sound like maybe they're married, but doesn't like Nick Ambert doesn't sound right. Okay, yeah, they're not married.
You have any more questions about anything, Rodney?
Yeah, I mean, I'm just playing around with AI. Obviously, it tells you like that. Oh, that the other person's wrong, saying that if you tell them to put something into AI the reverse, the AI wouldn't tell you that. It'll tell you that like it'd be breaking the laws of physics if you tell it to counter that point.
Yeah, that's not right. So it's not breaking the laws of physics. It's the fact that your AI has only been programmed with a certain amount of information, and it's programmed to push the globe narrative, right? And it doesn't always get
Oh.
things correct. So look, I could do it right now. So I can copy paste that test, and I'll just post it straight into my ChatGPT, and I'll
Okay.
say, right. So what's the general, without me having to read everything that you posted just here? What is the point
Radar
of
proves the Earth is round.
Okay, all right. So I'll show you my prompt as well. So I'll type into my ChatGPT. All right, I'll see hit new chat, and okay, a guy is saying that this AI response he posted is proving that radar proves the Earth is a globe. Right now, paste it. Right, so I didn't even ask it to debunk it or anything like that. I literally just typed exactly what I just said then.
Yeah.
So it's giving me a massive response here. So I'll just copy it and see if it'll let me paste this much text into the chat. All right, it's trying to give it as a message. It's so long, so I can post it in sections. Or should I ask it to summarize, make it shorter, or do you want the
Yeah,
full
make it do that.
lengthy?
Smart.
Okay. All right. Can you please summarize this into a paragraph?
We'll set the
here we
two
go.
bots up arguing and come back next Tuesday and check on it.
Yeah.
Exactly, man.
This is fun. I like this.
Dude, I have AIs that are like that talk naturally. It sounds like they're people, and I can actually bring them in here and run them through my mic, and you can debate them. Flat
Okay.
earthers can debate them. It's kind of fun to do that as well. If you have good flat earth arguments, they lose every time. If you have bad flat earth arguments, then they'll call you out on it. It's a good way to test your arguments. But yeah, here's the response in the side chat here. The response does not.
Radar.
You want to maybe?
Instead, it argues that radar is consistent with other accepted systems like GPS, lunar laser, ranging spacecraft, telemetry. Same as demonstrating that radar is uniquely required as a spherical rotating Earth. Yeah, see, this is the same thing with the assumptions. It relies on like these effects, the blah 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 effect and the blah 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 effect, and this proves that using these effects, you know.
Yeah, there's
See,
always a
so
bunch of assumptions when it comes to
and
these things.
right,
Now, I
and then
didn't
I
even
told
read
it.
this. I just pasted it without even reading it. So I didn't ask it to debunk it. I literally just said exactly what I typed.
I
This
did the
AI
same
prompt
thing.
is.
I did it. Okay,
Yeah, yeah.
so because I did the same thing with what's his name, Boogie Woods, right? Boogie Woods said, "Oh, but the only way you can prove this is with assumptions, using like scientific assumptions." But
Mhm.
I told it to prove the scientific assumptions. Like, how can you prove an assumption? And there's like all these tests on them. Of course, if it's a known like effect, obviously there's been tests on it, right? And these tests date back to the 40s, 50s, like maybe even a little farther back, you know, when we were doing like rudimentary like rocket tests, like just sending rockets up, you know, like really, really long ago. But like
Mhm.
these assumptions are like so dated back and so researched and almost like, you know, we know them inside and out. Like how is it so easy to just throw them out the window? You know what I'm saying? Like that's what I find hard to believe with a lot of flat earth people, that they're able to just throw these things out the window, even though we've done like thousands of
Yeah,
tests like these.
but like what in particular? Like we agree that you can launch rockets up into the sky.
Yeah.
Yeah, that I mean you
Hold
can.
on. Actually, it's in my text, but I'll just like kind of go back and read it.
Mhm.
That okay, consistent speed of light, right? It assumes that the speed of light is constant and known, a verified singularity, and in the atmosphere or space, the calculated distance and Doppler shifts, see Doppler shifts, would be invalid. See, it's another effect. It's another
Why would
effect.
the light speed? So they don't know the one-way speed of light. They only know two-way speed of light, and they're
Right.
making assumptions about what's happening up in the sky. Right? They're making assumptions that that's a big vacuum.
How do you
Vacuum up
prove
there.
that though? How do you prove two-way speed of light? How do you do that?
Two-way speed of light. I forget the exact method, but you calculate basically how long the light takes to get back after it reflects off something, how long it takes to get back, or something like that. I haven't looked into the technical explanation of that. I do have a bunch of information on it saved, but I haven't researched it correctly. But it is generally the accepted mainstream thing that yeah, they know what the two-way speed of light is, but they don't know what the one-way speed of light is. So basically they just assume a two-way speed and then halve it. But apparently
Right.
that's not an accurate way to do it. And then they're assuming what's happening. If you're talking about space and things going on in space, you're having to make assumptions about the medium, between point A and point B, and what happens to that light as it travels through that so-called medium. So we would ask
Right.
people to prove. So we would just like kind of like take it back to the core fundamentals of the argument, or the core claims. Is like, okay, so on
How
the
do you
globe,
prove one way,
they
right?
well, not even to do with that. Just the fact that how can you have outer space as it's explained to exist on the globe model in the first place, because it's claimed to be a vacuum, like a 10 to the negative 17 torr, extremely powerful near vacuum. And where we have a gas pressure system that we're breathing right here, we have 14.7 psi at sea level, and you can't have gas. Firstly, you can't have gas pressure without a container. Secondly, you can't have a gas pressure system inside a vacuum without a physical container to separate the high pressure from the vacuum. And any time we test these, right, and this actually aligns with gas laws, the ideal gas law, and many different gas laws, right? Every time we try to test these types of things on a small scale, obviously you can't have a gas pressure system inside a vacuum chamber. That's just ridiculous to even suggest that you could have such
So
a thing.
you're saying when we send a radar radiation wave to space, how is it not getting sucked up? Is that what you're saying?
No.
By the vacuum of space?
There's yeah. I that's not what I'm saying. I'm saying if you think that
Oh.
there's a vacuum of space in the first place, and that we're on a ball, right, that's covered in water and gas inside a vacuum, that's not possible. There's no evidence that that's possible to exist. It only exists in the form of a theoretical mathematical concept known as the heliocentric cosmology.
So what are you saying, like in layman's terms? Like, what does that mean?
Basically, that what we get told about space is pseudoscience and fiction.
Oh, like how do you even prove space in the first place? Like that? Because I know a
Yeah.
lot of flat earthers are like, "Oh, we never even went to space. How do you prove we went to space?" You know, you showed me those videos earlier. Honestly, I thought they looked
Yeah.
real. I know you don't. I don't know if you look at a lot of like 60s, 40s like camera footage. Things really do be looking like that. Like that is how the cameras used to look back then. Like even it looks unbelievably fake, but yes, that
Not
is.
many people have that. Not many people have that opinion.
I
Like
love
99.
that time, and I love those cameras. I've watched like tons of like footage with these cameras. And, yep. I mean, because not many
Yeah,
people
yeah.
are watching old footage. You know what I'm saying? People are used to watching 4K, HD, everything stretched on our fucking flat screens. We don't even use CRTs anymore, which
But
have
you
zero
can tell
delay.
when
You
you
know?
see things in old footage, in
Right.
reality, it looks real. Like if you're looking at cars driving around,
Right.
or planes or whatever, boats, it looks realistic.
Right.
It
Like the
looks real.
Kennedy
You can tell.
assassination. That was around the same time, right?
Yeah, exactly. Whereas this NASA footage looks like some paper mache miniature model that's moving in weird ways that you wouldn't expect something to move around in the vacuum of space. And the special effects, it looks like they're dangling little things around in like a studio using some type of animation techniques or something like that. That's what it looks like to me. You can choose to believe it. It's one of those things where you choose to believe it or choose not to believe it,
Okay.
because you're never able to really validate it anyway. That's why we like to stick with empirical evidence. Yeah.
Sure.
Someone want to jump in, man?
Go ahead, man.
Is that you, Prime Minister? Mr. Prime Minister?
Yeah.
Did you want to jump into the conversation, or?
No.
Okay. Welcome.
Okay, bro. Yeah.
So yeah, a lot of
Yeah.
a lot of the evidence is faith-based. I mean, you have to choose whether you want to trust them or not. And I think the Artemis footage was very unimpressive. A lot of people were very pissed. They thought that they were going to get some amazing footage from the Artemis mission. And people were like, what the hell? Like most of the footage was just them like showing like how you can spin food around in front of you and stuff like that. It's like, look, here's my soup and I'm spinning it around. This proves
We
we're in
can prove
space.
zero gravity, right? We can do that. We have zero
No,
gravity chambers on Earth, right? Don't we?
no, we don't. There's no such thing. The only way that you can
I swear.
simulate there isn't such thing. If there was such thing, then it would make it even easier to say that they faked all of the footage from the ISS and stuff like that. if there was such a thing as a zero gravity chamber. But
It
what they
pressurized the
have,
gravity out of a room, right?
no, they no.
Crush it.
The
No.
only thing they have is like some giant fan, right? And the fan's like on the ground and it's blowing upward, and you put on this like skydiving suit, and the fan blows you up, and you're kind of like floating there for a while. But it's crazy. It's like it's nothing
And
like zero gravity.
doesn't
It's
the
just blowing you up.
military do something like that? Like with the
No,
zero G with
no.
the fighter jets and shit?
So this is all they have, right? So you can take
It's a squeaker in
zero.
here. Stop squeaking, man.
You can someone squeaking. Oh yeah, sorry, it's my fan in the background.
No,
One
the other
second, I'll
guy.
turn.
The other guy's a squeak. No, the other guy's a squeaker.
Oh, cool, bro.
Oh.
Thanks, man.
Yeah, zero G flights. So they go up in a plane and they do a parabolic arc, and it gives you about 30 seconds or 40 seconds of weightlessness. So you're falling down at the same rate as the plane, so it gives you that illusion that you're in zero gravity.
Yeah.
And then you've got the things like the Virgin Galactic or the Jeff Bezos Blue Origin, where it's the same type of thing, except you can get like 3 minutes of weightlessness or something like that, because it's like a longer time that you're in that.
It's to kind of
But
prepare
it's not
them,
it's
right?
not really zero gravity. So even on the ISS, a lot of people think that once you get up to that height, like they're claimed to be at on the ISS, that you float. That's not true. So there's this almost the same amount of gravity that's here on the Earth at that height, and they would just walk around like normal on the bottom of the floor, but they say that it's falling around the globe constantly at a rate that makes it feel like it's weightless up there. So that's, once again, that's not even zero gravity when you see them floating around on the ISS.
Okay. And
So yeah,
why does space disprove around Earth?
space, it doesn't disprove around Earth.
Okay, then why do a lot of flat earthers disprove space like immediately in order to clear their bases?
Well, NASA's says that they're sending things up into space, and they're sending us back pictures of the Earth as a globe, and also just basic critical thinking and exposing pseudoscience. So if
Okay.
people want to, it goes against natural law. So you can't have a gas pressure system inside a vacuum.
Right.
And they claim that you can. They claim that everything exists within this big giant space vacuum, right? They say the universe is flat as well, which is kind of weird, right? So they say there's this big giant flat universe, and it's a 10 to the negative 17 Torr vacuum, which is, oh, 1 second, I gotta go on mute. I gotta recharge my internet. It's about to die.
Okay.
Well, he's there for a second. You mind if I give you my little viewpoint on what you were just talking about?
Yeah.
So we're talking about like space and disproving space. So for me, I'm nowhere near as smart as some of these guys, but like I have my senses, of course, and things that make sense to me and things that I refuse to believe. When they're told me, I'm like, no, I'm just not going to believe that because it doesn't make sense. But one of the things that got me about space was like parallax between the stars. So we're told in the model, and I've told this growing up, that we're spinning around at 1,000 miles an hour, and we're rolling around the sun at 67,000 miles an hour, and the sun is going around the Milky Way at like 500,000 miles an hour, whatever. The Milky Way is going through the galaxy or whatever or the universe at like 670 million miles an hour, and the universe is expanding all the time at like nearly the speed of light. And all the stars of the constellations have absolutely zero parallax movement recorded in the last 6,000 years. I'm going to refuse to believe that model right away. That is just not possible. I've done the math. Tycho Brahe did the math for Giannis Kepler stole his stuff, but he did the math and said we should have half a moon width, 5 degrees in 6 months.
Yeah, but that's the
6,000
perspective
years is
of a
zero.
past perspective. Maybe there's a new
Yes, yes, yes,
perspective
yes,
because
yes.
you
Yeah,
understand
I
what I'm
know.
saying?
Yeah.
Yeah.
Yeah, no, I know. Yeah. What I'm saying is for me as a
Yeah.
person, when I'm told that, and the funny part is I never looked at it, dude. I just never looked at it. I was taught that, and I was like, "Oh, cool," and went about my
Yeah.
day. And I felt like a dumbass when it was pointed out to me. That was pointed out to me. I was like, "How did I not like get that? These are on the same repeat. The constellations are on a same repeating cycle with zero parallax for 6,000 years. That does not compute, and I refuse now to believe
I
that
mean, we've
stuff."
seen stars
So that's where I
die,
come from.
right?
But yeah, I know, man. I know there's all that. I'm just saying. I'm not going to get too deep into it because I don't argue and stuff, and I don't debate.
Yeah.
I'm just letting you know where my perspective is
Why you think?
on that too.
Okay, yeah,
Just some
I've
explanation
heard
because
this.
that's what you're asking. You're like, why do they
Yeah,
clear
yeah.
their bases with that? And I'm like, well, that's why, man. Because I'm not going to believe somebody who's going to tell me that's happening because it's not. I'm not going to
Right.
distrust my experience, my reality, my eyes, because those two do not match. And so that's where I start from. That's what really got me. So I
Shit,
just wanted
I
to
mean,
let you know
you
that, just
haven't
so you
lived
have some
long
more
enough to
understanding of like
understand
from a
that, though. You know what I'm
what's up?
saying? You haven't lived long enough. You haven't lived 6,000 years, and you don't know how the time warps over that time. Maybe it takes longer now for stars to move. You know what I'm saying? Because it's been
Oh
over
yeah, dude.
6,000 years.
Yeah.
You know? Yeah.
100%. Yeah, yeah. There's so much, and trust me, dude. I've been around long enough
Yeah.
to know that time is a weird thing, man. So
Yeah.
it's weird, but yeah. So I'm
Right.
just saying that's where I'm coming from, and there's
Especially
much
when
more
things are
evidence.
far
There's much more things
away.
that
You
yeah,
know?
yeah, and there's much more evidence and stuff like that, and things we could go into. There's other things, of course, that I just refuse to believe. That's just a
Yeah.
starter example based on the topic you were directly on, just to give you some perspective of where. Because you guys are like, why do people do that? Well, for me, that's the starting point for me. Makes no sense. I refuse to believe it after that, and then we can go on with all the other discussions and other evidences and things I don't believe and blah blah blah. But I just wanted to just give you another human perspective. DJ is great at this, and he's got all the info. I don't have the stuff that he has and info and all that. I just want to give you just a human perspective, bro.
Yeah.
Made a good point in the side chat there as well. For the globe, the absence of evidence becomes evidence. It's a good point.
I mean, that can be for anything. That's like a bit
Right.
broad.
So if someone claims something to be true, and then there's no evidence of that being true,
Right.
and someone's questioning, it's like, hold on, right? You don't have any evidence of that being true, and they just keep making all of these claims about all of these different things and not providing evidence. That itself is evidence that what they're claiming to be true isn't true.
Okay.
Yeah. But yeah, when it comes to space, I mean, a lot of that it's just going to require you to believe it or not believe it. It's not able to be tested.
Yeah.
You know, when it comes to the theory of relativity and things like that, they say, oh, it's the bending and warping of space-time fabric, and then they worked out, oh shit, the math's off by like over 95%. So then, rather than throw out the math, they decided to just invent a placeholder. So they invented dark matter and dark energy, in which they have no evidence for whatsoever at all, nothing, um, to make the math work again. And they're telling us crazy stuff. Like, imagine if you came in here and
Yeah.
the globe earthers weren't making any claims about space. They were just saying, we know it's a globe because we test it and we measure curvature over the surface of water. And here's all the tests, real world tests. We can show you that it's actually curving. And when we go and test for the curvature, right, here it is. Now, the flat earthers are claiming to know everything about how everything works up in space. And when we go out and test the earth, we also test that it's curving. And we say, oh, maybe it's just refraction that's making it look like it's curving. That's why it measures like it's curving, but really it's flat. And all of these things up here in the sky, we're going to tell you a big, giant story about it all, right? And there's this one planet called Uranus, and it rains diamonds on Uranus. And this other one, this light over here, this one's called Neptune. It also rains diamonds on Neptune, but it doesn't rain diamonds on Mars. This is a different one. This one we're going to send up our little helicopter and a buggy to. And then
What do
we
you
have
think those things
black.
are then? Like those other, like
We don't know.
the planets that you can see. with your
Yeah,
own eyes? What do you
I'm not
think?
sure exactly what they are. I have no idea what they are. I mean, what we see
Okay.
is like little blurry dots through even through the best telescopes. We see some little blurry lights in the sky. I don't know what they are. The ancients used to call them wandering stars. And I think the sky acts like a big clock. You know, the cycle of the sun resets every 365 days. That's why we have years. And then we have months or months because the moon's cycle resets every, once a month, every 28 days. And then we have all of the stars taking like a kind of uniform looking cycle where you could go out, you could mark a star up in the sky tonight and you could go out at that exact time the next year on the same day and that star's going to be back in the same position again. It's like a big clock.
Well,
It's all
yeah, like
like a
the guy was
uniform
saying earlier.
cycles.
Actually, what's his name? D-Town was saying the same thing, right? Every 6,000 years, the stars are supposed to change position or move a little teeny bit, right? I mean, that people have apparently right, studied that and they proved it right, but now when you do it again, now it's wrong. Why was it right before and now why is it wrong now, right? Maybe there's some warping with time that proves obviously the same equation doesn't work twice in a row over a different period of time of 6,000 years, right? Because we're simultaneously moving away from the sun or moving closer to it, either one, I don't remember. But right. So using that time scale, time would work differently, wouldn't it? So maybe you have to add another 7,000 years or onto that. You know what I'm saying? Like it's kind of
Yeah,
like
a lot of the
a
claims they
very
make
thing like that.
Yeah, a lot of the claims they make are based off mathematical models and a whole bunch of assumptions. As they'll tell you all sorts of things.
Okay.
And once you dig into it, you'll be like, oh, okay, they haven't like really tested that. It's just based on
Well, you
mathematics.
can't. You can't until you find out the new amount of time to track when a star would move, right?
Yeah, you know the North Star, Polaris,
Right.
doesn't really move. And there was something called the Georgia Guidestones. And in the Georgia Guidestones, there was a little hole. And you could look through the hole. But so they were there for a long, long time, like over 50 years or more. And you could look through that little hole every night. You would see Polaris directly through that hole.
Well,
It's
50
never
years
not there.
isn't very long compared to these stars and how they move and the distance away from them, right? Because when you look at something from far away, you're not seeing it in that period of time. You're seeing that thing from a long, long time ago, because that's how distant works. When
Yeah,
you
this
look
is
at
what they
things,
do. They kind of confuse people by making distances and times so large that it's very difficult for our brains to comprehend
right?
how
Because like
far
another
and
planet far away sees
yeah,
the dinosaurs, right?
You guys believe in time dilation, right?
time dilation. I think there's been a lot of flaws when it comes to the tests that were done uh, that refer to time dilation, like the Heffel-Keating tests. There's a lot of variables that weren't controlled for. And when we're talking about tiny, 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 tiny little changes, right, the confounding variables that weren't accounted for could more uh, than enough cause these small errors. And then there was also a whole bunch of results that were basically discarded. And a lot of other scientists were saying this is completely deceptive. And it wasn't found out for a long time later that he'd actually discarded a whole bunch of tests that didn't match his predictions. So I don't know. It gets sketchy. If you talk to Dr. Yoder about that, I don't know if he's available to talk at the moment. He's in the side chat. But yeah, he can go deep on that topic. I don't know a ton about time dilation, unfortunately.
Well, that's why I don't believe the age of the Earth or age of the universe or whatever they suggest, because that reason
Yeah,
right
yeah.
there.
Yep. Yeah, there's a lot of crazy claims. I mean, don't they say if you can go fast enough, you could like reverse your aging or something like that? You could go back in time. I don't know the exact details, but yeah, outer space is like a crazy, so many crazy claims.
Yeah,
Black
that's a claim I
holes
would
and
fucking do though. Hold up.
yeah,
No.
yeah, yeah. They
Although my
make it
skin would
very
probably melt off
mystical.
and I'd probably be skin and bones and probably be on fire, but I'd be young. Yeah.
Yeah, it's intriguing. That's why they push it so much. It's very intriguing and yeah, I don't know. I like to stick with what we can actually validate rather than things that just require a whole bunch of assumptions. So yeah, I
Do you
don't know
believe in
exactly
Hollow
what.
Earth? Do you believe in Hollow Earth?
I try not to just believe in things. There's probably places in the earth that are hollow. I mean, there was
Yeah, I believe in
civilizations,
like
wasn't there?
underground bases and civil. Yeah, I do believe that.
Yeah, I'm not sure to what extent they are, but yeah, like there's interesting historical uh whatever, stories about that
I'm
kind
sure
of
you've
thing.
seen
But
testimonies of whistleblowers saying they went into bases hundreds of miles in the
yeah.
caves and mountainsides and stuff like that. So it's not something
Yeah.
nuanced, but I find it interesting. I don't believe in the heliocentric model and the globe model, but I also am not under the impression that it's like completely flat like a disc, if that makes sense.
Yeah, yeah, I'm definitely not claiming it's a flat disk, and I definitely don't claim to know the shape of the Earth or the size of the Earth. But when we just go out and test over the surface of water, the amount of curvature that would have to be there if it's a globe, it's not there. It's absolutely not there. So
Do you
whatever
think
we're
it's
on,
circular though? Do you think it's like circular?
if it was circular, it would have to be freaking huge, right? To account for what we were able to see in these observations. You would have to have a radius of a huge amount, and even then that would just be another claim. So if when we're testing it we don't find any curvature, you could argue that if it's a giant globe then it could still be a globe. But that then we would just say, do you have any evidence of that? And um and then there wouldn't be any evidence of that.
I think the evidence would be the firmament, meaning the circumference of like, when you look 360 degrees, how it's like a dome, shaped like a dome, if you will. And that shape would kind of give the idea of a circumference of a circle, right? Or a radius of a circle.
Yeah, but I think that's very easy just to explain with the way that our perspective works. For example, if you go out, so we see in a dome shape. Our perspective works that way. And the way to think about it is, if you picture yourself, you go out into the middle of the ocean. Let's say you're on a canoe and you can only see water around you. Now, if you look around 360 degrees, and plot out imaginary markers, the maximum distance that you can see. As you go around 360 degrees, you mark that out. It's going to be a big circle around you. So that's your circle, or your azimuthal circle of vision. Now, let's say that now you're looking straight ahead and there's a plane coming from the horizon, like a commercial plane, whatever. Right? It's going to come up and it's going to it's going to look like it's coming up from the horizon, and it's going to go up, and you're going to watch it get higher. It's going to go over the top of your head. And then you can turn around and watch it. It's going to do the exact same thing as it goes away from you. Even though that plane is staying at the same altitude, due to the way that our perspective works, it looks like it comes up from the horizon and then it converges back into the horizon. Just the same as when we look down a street, when we see streetlights converging downward, or even in a hallway, when we see the top of the hallway, it looks like it goes down and meets at the floor if it's a really long hallway. Same thing happens with the plane. Now, if you imagine you turn 1 degree to the right and now another plane comes over, okay, and you just make an imaginary line of the path of that plane, it's going to make a big arc over the top of your head. Now, if you plot that out the same way as you did with the circular horizon, it's going to make like a big dome over the top of you, and that's the way that you see due to perspective. So we do see the sky that way. The same thing happens with the stars and the sun and the moon and the planets. We see everything in this sort of grid of vision that we have, that's local to each individual person, where each individual person is standing at the center, and then you have a horizon at equal distance all around you, and then you see everything in like a big sort of hemispheric dome of vision above you. It's not a real dome, but it's just due to the way our perspective works. So I
Yeah,
think
but
that's.
because like let's say a ship on the horizon, like you mentioned, it doesn't just
Mhm.
straight away appear out of the midst, right? It comes from the bottom up. So you're seeing the ship rise up over the curvature because there's a curvature, and our perspective, right? We don't have that perspective. It's curved, right? So we're seeing that curved perspective on the horizon as the ship comes up from the bottom up, right? So that would give to me, that's evidence that there's a curvature to the Earth. I don't know to what degree,
or how circular it's shaped, because I don't believe the NASA models. But I do believe when a ship is coming from the bottom up from the horizon, that would prove that there is some form of curvature or circularity to the surface. Does that make sense?
Yeah, yeah, it's a logical argument, but upon further investigation, um, that actually doesn't happen most of the time. It does happen sometimes, and I'll explain why it happens. But most of the time, what happens is the boat, right? Let's say we got a giant boat close to us, and it's going to sail away. Most of the time, what happens is it will just get smaller and smaller and smaller until its angular size becomes so small that the human eye can't resolve it anymore. And then it looks like it's gone. It didn't disappear bottom up, it just disappeared due to angular size. And if you take a zoom camera, you can zoom back in and see the ship again. But eventually, it's going to fade off into the haze of the natural haze of the atmosphere, because you can't see forever through the atmosphere, right? It's like 20 miles out or something. You're not going to be able to see it anymore because it's going to fade away. Now, that's what happens most of the time. There's tons of footage of that, tons of footage. And I've personally witnessed that so many times. But sometimes it can look like as the ship goes out, the bottom of the ship starts to disappear, and then more and more of the bottom starts to disappear. And that only happens if you have certain situations, right? And the first situation is when you have ocean swells. So let's say we're standing at the beach and there's, say, 5-foot waves. As you look out beyond the waves that are close to you, what they're called are swells, right? So once the waves are out in the ocean, they're called ocean swells. And when you're looking over the top of all of them, it looks kind of flat out in the ocean. But as the ship sails away, it gets smaller and smaller and smaller. But those waves are still in your foreground. They're still close to you. So as the ship's reducing in size due to perspective as it's going away, those 5-foot waves in the foreground are going to start to block the bottom of the ship because the ship's starting to get smaller. So it might look like the bottom of the ship's starting to disappear behind the curvature of the Earth. Right? This used to trick me when I would take my little boat out into the ocean. I would look out and I would be like, oh, it's nice and calm out there. And then I would take my little boat out and I'd be like, whoa, this is crazy. I'd be going up and down these giant ocean swells. But from the shoreline, it looked like it was nice and smooth and flat out there. So if there's a boat going out, right, it's going to look like the bottom disappears first. Now, let's say there's a day that there's no waves. So we could rule that out, right? Rule the waves out, because obviously the waves can block the bottom of the ship. But let's say there's
I
no
think the
waves.
swells is a good explanation, though. That I think that's pretty
Yeah.
much the strongest case against like the curvature argument.
There's even a stronger one as well, because sometimes it can happen when there's no waves. And then they would say, oh, look, there's no waves, so therefore it must be the curvature of the Earth. But there's certain situations where we can have certain atmospheric conditions that cause that exact effect. And it's actually a well-known effect. It's called sinking refraction. And all that's happening is that when the light's bouncing off the ship and it's making its way back to the observer, it's actually just bending up a little bit. The light's bending up a little bit, just because the air is colder up higher, and colder air is more dense. So basically, the human brain assumes that light travels in straight paths. So it tricks the human brain into
So it's like a
thinking that
mirage, basically.
it's like a mild version of a mirage. Yeah, it's actually a mild version of a mirage called an inferior mirage, where it looks like you get that like puddle of water on the ground, or like a mirror
The
layer on the
ripple
ground.
effect. Yeah.
Yeah, it's like a mild version of that. So it doesn't take a big temperature gradient to cause it to happen. But what it does, it tricks the brain into thinking things are sinking. And the definition of it, if you looked up right now on Google, what's the definition of sinking refraction? It'll basically say when things that would normally be visible appear to be obstructed bottom up behind the horizon, even though the geometric line of sight is completely unobstructed. And that's a well-known effect. So if someone wanted to claim its curvature, there's things that they would need to take into consideration, that it could be this, or it could be the ocean swells, it could be the sinking refraction, or there's other things as well. We don't need to get into too many of the different reasons, but the sinking refraction, we can just replicate that on a flat surface really easily, and just here, I've got two screenshots that I took from a video yesterday. So this is showing sinking refraction happening on a flat surface on a small scale. So if you have a look at this is just someone's flat floor, and they've put the camera down on the floor at the other end of the room. Can you see the side chat?
Yeah, I see it.
Yeah. So see the yellow bit at the bottom of that object on the right?
Yeah.
Just imagine if that was the bottom of a boat, for example. Now, what they do is they let cold air into the room, and light will bend towards the colder air because colder air is more dense. So as the light travels through the air, it'll bend towards the the more dense air. So if you have a look at the next screenshot, so they actually set up thermometers. If you look at the red gauge on the left, that's they're taking 4 different vertical temperature heights. So they showed, okay, we're letting in cold air. So now we have a layer of cold air above the surface. And then all of a sudden, it looks like the whole bottom of that thing completely disappears behind the horizon on a flat surface. And that's an example of sinking refraction happening. Same thing happens out in the ocean. And if we take time-lapse videos of ships that look like the bottom's missing, over time, you'll see that they come back into view again as the sinking refraction effect starts to like go away, right? Like as say that the temperature warms up during the day, and that cold air is now not cold air anymore. Now it's warmer air. Now the light's not bending up anymore, and now we can see the whole ship again, for example. So yeah, that's another effect. So I mean, you won't be able. There's only a handful of videos of ships disappearing bottom up on YouTube anyway, and most of them you can blatantly see that there's either a miraging effect or there's big ass waves out there, and we don't know the observer height, we don't know the distance to the ship, and all of that kind of thing. We don't know what's going on with the atmospheric conditions, so they haven't accounted for the possibilities that could just cause that to happen. And then we've done tests where we actually know the observer height, we know the distance to the ship because we tracked it on marine tracking. And we say, okay, this ship's 22 miles out or 22 kilometers out. And how much should that ship be hidden behind the curvature? And it's like, okay, that ship should be hidden by 80 feet behind the curvature of the Earth, but it's not. We can see the whole ship. So yeah, it's not it does seem like a good argument at first glance, but once you dig into it, it's actually not a good argument for the globe. It actually is a good argument to use against the globe. And sometimes the ship just fades off into the horizon as well. Like the horizon can look nice and clean, right? Look at this next screenshot. Right, this is a nice clean looking horizon, and people will think, oh, that's the curvature of the Earth. If anything goes beyond that, it'll start to get hidden behind the curvature of the Earth. But this person is about to watch a giant cruise ship. This cruise ship, right? This is a freaking huge cruise ship. Here's a close-up picture of the cruise ship. Look how little the people are on that front balcony. You can barely see them. Giant ship. So anyway, he watches this ship sailing out, and as it starts to sail out, it doesn't start to disappear. It actually just fades off, and it slowly just fades off into the opaque air because you can only see so far through the air. You look up the weather report, it'll say, oh, the visibility today is 10 miles or 20 miles or whatever it is at the time. But yeah, here's the pictures, and then all of a sudden it looks like the ship's gone. You can actually see a silhouette of the ship. It just keeps going off and off into the distance. So someone watching from the shoreline, they'll watch the ship go out, and then the ship will disappear, and they'll think, oh, maybe it's gone beyond the curvature. Well, actually, no. This is, once again, it's just an atmospheric condition, making it look like the ship's gone. Now, if you had sinking refraction on this day, then the bottom of the ship would look like it's missing, and they would say, oh, curvature of the Earth. But we don't have the wave issue on this day, so no one can say, oh, it's the ocean swells. And plus the camera looks like it's elevated above the surface, right? So now we're just looking at atmospheric conditions.
So I assume you believe that there's basically, uncharted territory or uncharted land like Antarctica, for example, where people say that there's the ice wall and there's footage of it and everything like that, apparently. So do you believe that we haven't explored or have gone to the extent of the surface of the Earth?
Yeah, I'm not sure exactly. I would assume it just based on logic. The logic being that if you have a large body of water, there should be a shoreline. So if the world ocean is like a big body of water, then there should be some kind of shoreline at some point. Exactly where that is, how far away that is, what that is, I wouldn't know. When it comes to the so-called ice wall, it's just the shoreline of Antarctica is literally referred to as a wall of ice, like an ice wall by the government as well, because it's Antarctica is something like 8,200 foot on average above sea level. So it's freaking huge. That's higher than the biggest mountain in Australia, just the average height above the water. Now, I believe in the ice wall, as in the coastline of Antarctica is a wall of ice. But is Antarctica just a continent? It could be just a continent of some kind.
What I'm saying is we don't know the extent of how far
Yeah,
or
yeah,
where the corner of the Earth stretches, right? That's I
yeah.
guess what I'm trying to say.
Right. So this is what I would say. I would say that I don't know. And the reason I don't know is because let's say you start at the magnetic north and you've got a compass. Every single direction away from the north is south. So let's say you went south in a straight line and kept going south. If the Earth was a globe, you'd just come back around. You'd go over Antarctica eventually, and then you'd come back around to where you started, and then bam, the Earth's a globe. Flat Earth debunked. But no one's ever done that. No one's ever kept going south. And so no one's ever done a north-south circumnavigation. They've done pole-to-pole circumnavigations where they go from one pole to the other pole and then they turn around and come back. But no one's ever done like a big loop, a circle, a circumnavigation north to south around the globe. Tons of people have done it the opposite way, east to west, because east and west would work just fine on a flat Earth as well. But if you keep going south on a flat Earth, you would never get back to where you started, right? If you went east on a flat Earth, you can do a circle because east and west are circles, right? So you would just do a circle, you would come back to where you started again. You just do a circle around the pole and come back. But if you go south, you would just go away from the center and then, or not the center necessarily, but the magnetic point. So you would go away from that, and then no one's ever done that. So what would happen if you kept going south? I have no idea. There could be more land. There could be just tons of ice, and it could be completely impossible to sort of travel through. I'm not sure. It's a big mystery. It's a big speculation, and it's super interesting to think about. There's tons of speculations about there being like more lands beyond the ice and that kind of
Yeah, I
thing.
was gonna ask, have you ever researched into the old world maps?
Yeah, yeah, I'm fascinated with all of the old maps. I think they're awesome, and there's old maps that show Antarctica without ice, and they were able to map out the shoreline of Antarctica. These are maps from I think before the 1600s or before the 1500s even, and they show no ice. A lot of these old maps they show no ice anywhere on the Earth, and the temperature records as well show that there was like a warm period throughout a lot of uh, a portion of history. Anyway, the maps that show the shoreline of Antarctica um, turned out to be accurate because it's all ice. They didn't know what the shoreline looked like until apparently something like the 1950s, where they went and actually dug down into the ice and they were able to map out the shoreline to some extent. And it turned out that it actually apparently matched the old maps. And it's like, how the hell did they know that there would have been no way for them to know that the shoreline was like that, but they got it all right. So yeah, I don't know. I think a lot of our history is bullshit, and I think there's been some crazy worldwide weather changes and cataclysms in the past, and I think there's been a lot of cover up of certain things, and yeah, there's some interesting stuff on the old maps that that's fascinating. So yeah, but I don't know if there's extra land. I would assume that there probably would be, just based on basic logic. But
I personally think they are because the government will not allow you past certain airspace. So if the government isn't allowing you, why is that? That's the question I would be asking. Because
yeah,
that's the
so
reason why they haven't gone that down south, right? They wouldn't be able to.
um,
They'd be
well, I'm not
shot down
sure.
by the Air Force.
Yeah, I'm not sure exactly what would happen, but yeah, like in the 40s and the 50s, they did Operation High Jump, and they went and explored Antarctica, and then
Yeah, I
Admiral
was gonna
Byrd came
ask you
back.
about
And
that. Yeah.
yeah, he said that they discovered more land beyond the South Pole, 180 miles beyond the South Pole, that was bigger than America, that didn't have ice, and it was rich in resources, enough coal and resources to power the entire Earth for a huge amount of time, and that it would be the next battle to see who could regain control or gain control of this unfounded land and blah blah blah. And then all of a sudden, they came up with the Antarctic Treaty, and they're like, "Oh, we're all going to agree. All of these countries that are apparently enemies are going to agree that nobody's going to touch Antarctica, basically." And then they have the Antarctic Treaty, and then you need to get a permit through the Antarctic Treaty, or a country that is working through the Antarctic Treaty to be able to travel beyond 60 degrees south, which is not even where Antarctica is, right? It's ocean. So you can't freely travel beyond 60 degrees south without a permit. And then you look into how to get the permit, and it's extremely expensive. It can be rejected, and apparently you don't get your money back. And then also there's all of these crazy regulations that go along with it, which make like some sort of deep exploration mission pretty much unviable, um, for many reasons. So I don't know. It's kind of crazy. I'm not saying no one has explored it all. I'm not saying no one's kept going south, but nobody that I can verify, nobody that we can publicly verify, and people that have tried have been turned around, put in prison, all sorts of different things. I think it was a Norwegian explorer that tried a whole bunch of times to go and take his own boat to Antarctica, and he got jailed. He got turned around. I think he ended up having his boat sunk or something. I'm not sure exactly on that story, but it definitely happened in the sense of he was trying to go there. So yeah, it's kind of crazy. I don't know.
Yeah, I don't really consider myself a conspiracy theorist, but that to me is a huge conspiracy. For all countries to just come together in wartime like that, that is just a major, major red flag. I don't know. There's something extremely suspicious there.
Yeah, they did the same thing with with this with the sky as well. So they basically put a perimeter around us. It's like, oh yeah, so you civilians, you can only go out to this point and freely explore. And then they did the same thing in the sky. So you can only go up to a certain height. Um, you're only allowed to send cameras up to a certain height. You're not allowed to launch rockets up past a certain height. It's not even that high. It's like 100 kilometers or something like that. And you're not allowed to film past a certain height. You can't send your own satellites up or anything like that. It's called the International Outer Space Treaty. And once again, that was signed by all the countries back then as well. So if you want to send up a satellite, or if you want to send up a rocket, or you want to send something up into space, you have to hitch a ride on an approved government rocket, basically.
Hey DJ, can I ask a question?
Yep.
I don't know if that was a no or yes.
Yeah, of course, man.
Oh, yeah, I can hear you. Thank you. I had someone make a point about I don't, and I thought maybe you guys could clarify. Someone said that there was like 6 or 7 like flat earthers that went to like Antarctica, and they recorded like the daytime there and like how long it's like the daytime there, and it's like 24 hours.
Mm-hmm.
How does that
Yeah.
fit in with like your concept of a flat Earth, where you have areas where it's daytime 24/7?
Yeah, so it was 3 flat earthers, some girl who nobody really knows who she was, but then 2 sort of more prominent flat earthers. One of them was called Jeranism, who's the same guy that got tricked in the Flat Earth mockumentary as well. Not a big fan. Most of the flat earthers from 24/7 have not been a big fan of Jaren for many years, right? He's kind of clings to this model of flat earth. And I'll get back to that in a second. And then the other one was Austin Whitsitt, super smart guy, goes on a lot of debates and stuff like that. So Jaren claimed that you cannot possibly have a 24-hour sun in Antarctica. He claimed you could have 24-hour daytime, but not a visible 24-hour sun in the sky, because he clung to a particular model that he called the flat Earth model, which is basically he has like this globe map called an azimuthal equidistant projection, which you've probably seen as the so-called flat Earth map, right? The round map with the ice wall going around the outside. That's actually a spherical coordinates. Yeah, that's actually a globe, right? That's a spherical coordinate system projection based off the celestial sphere. But flat earthers, a lot of flat earthers are saying, oh, this is the flat Earth map. And then the Antarctica wraps all the way around the outside. I don't agree with that. And many flat earthers, most of the flat earthers in here, some might, but most don't agree that that's a flat Earth map. It's obviously, it's based on latitude and longitude. It's just a globe map stretched out. So anyway, he thought that, okay, this is the flat Earth model, right? So he basically has that map, and he pictures the sun and moon as these little like physical objects that circle around the top over the surface of the Earth. And based off that particular model, you wouldn't be able to have a 24-hour sun in the sky in Antarctica. You would be able to have a 24-hour sun in the north, because as the sun takes its cycles, as it's spinning around the center, it goes like between the tropics. So when it gets closer towards the north and takes a path around, it never gets far enough away from the north for the sunlight not to be able to reach it. So you could explain on a flat Earth that you could have a 24-hour sun in the north, but you wouldn't be able to explain how you could have a 24-hour sun in the south, in Antarctica. So he said, if he doesn't see the 24-hour sun, that will debunk his model, and therefore he thinks that the Earth would have to be a globe if his model is incorrect. Whereas most flat earthers, and I would say flat earthers that aren't like Jaren, I don't rate Jaren that highly, right? Most of the flat earthers will say the sky, the movement of things in the sky are independent of the ground. And if we can test the surface of the Earth and measure in all of these different locations using different methods that the surface of water isn't moving, right? You can confirm that the ground is flat. It's not curving, right? Just like you could measure your floor as flat, and it doesn't matter what your lights up on your ceiling do. It's not going to change the fact that you've checked and your floor is flat. Same thing with the Antarctica thing. Whatever's happening with the lights up in the sky, the sun, moon, planet, stars, is irrelevant to the shape of the surface of the Earth. The shape of the surface is what it is when we test it. Now, because he had a particular model that he would cling to, he said that you can't have a 24-hour sun in the south. And part of the reason that he thought that as well, because there was no footage of a 24-hour sun in the south, no time-lapse footage, which is kind of crazy. Why wouldn't there be footage of that? Then all of a sudden, some footage started to appear of a time lapses of the 24-hour sun in the south, and they were analyzed, and they were turned out to be faked, right? So for some reason, people were faking this footage, and they were like looping it, and you can see at the end of the footage, it's the exact same clouds as at the start of the footage. So it had been looped. So there was also people that worked in Antarctica that said that they were there for 18 months and there isn't a 24-hour sun in the sky. So people were taking this information and saying, all right, well, there's no footage of the 24-hour sun. There's faked footage of a 24-hour sun. We've got this particular model that we think is the flat Earth that shouldn't have a 24-hour sun in the south. So if they go to Antarctica, that would debunk the flat Earth. And that's what happened. So they went there and they did see a 24-hour sun in the sky, apparently, right? I can't debunk it. I think that it's not a good argument, that none of the arguments saying that it was fake a very strong argument.